Okay, so welcome to Euron everyone. Now I have a announcement for all of you. So those who would like to learn RAG, a Retrieval Augmented Generation, and that too in a modern way. Now a complete dedicated course is available on a Euron platform. So now let me share my screen and here. So you will be able to find out RAG Masters. And in this RAG Masters, I'm going to talk about everything from a very scratch, starting from a definition of RAG and all the fundamental concepts. So which are basically like a document parsing or maybe a vector databases, a LangChain, LangGraph, tools, agent, all of these things I'm going to cover. I have already covered it. Apart from that, so obviously I'm going to cover a prompt engineering part as well, that in what manner you should do a prompting or how you should like curate your prompting at the end of the day. Apart from that, so I have already covered evaluation and re-ranking of our RAG application, and we have covered a two small but very amazing project which you all are going to enjoy, that with the real-time chat interface. And everywhere, so we are using a URI API so that you don't have to go anywhere else. You will be able to use a URI API, and based on that, you all will be able to complete this entire RAG application. No need to look into anywhere, any places, right? Even framework wise, we have used a LangChain, LangGraph, and all of these frameworks are technically compatible with the URI API or URI AI SDK that we have launched, so that your life will be pretty much easy. So please, you can try to go through this entire lecture. Let me know about your feedback, and hopefully all of you are going to enjoy it. All of you are going to love it. So with that, thank you so much, everyone. Take care. In this lecture, I'll be talking about what is RAG. So I'll try to explain you RAG in a very simple way, by the way. Not by giving you a heavy example, so just by taking some sort of a lightweighted example, so that all of you will be able to get an understanding about RAG, Retrieval Augmented Generation. And believe me, it's not tough. It's a very simple concept. And even when you will start building this RAG kind of a system, so it's not going to give you much of pain. We have built a lot of system, a lot of projects you will be able to find out on Euron platform as well. So where we have shown you that how to build a different kind of a RAG system. Now, so what technically this RAG is? So I have already prepared a beautiful documentation, so where I can give you a demo and I can talk more about RAG, but let me give you one context before like jumping into those documentation. So let's suppose, guys, you are trying to use a ChatGPT, maybe a Cloud, maybe a Perplexity. So any kind of a LLM you are trying to use. Now, so if you are going to ask a question based on the data on which LLM has been trained till a particular date, obviously it is going to give you an answer. Now, Perplexity kind of a system, so even can do a web search, even a ChatGPT. So OpenAI is giving you a web search option, or almost everyone is giving you a web search option. Even URI is giving you a web search option. So you will be able to do a web search, and even you will be able to get a real-time information. That is also possible. And then based on the knowledge, obviously all the models is going to give you a response. But let's suppose in my company, I have a knowledge base. Knowledge base means I have a lot of documentation. Maybe HR department is having a lot of policies, and then there is a finance department. They have a lot of other documentation. There is a tech department, so they have a different kind of a documentation. Plus we have a sales department, so which is having a multiple documentation again. Now, if you are going to ask a question with respect to those departments, like a HR department, finance department, maybe a sales department, maybe a marketing department who is holding a lot of document, they are generating a lot of document, or you can say a lot of data on a regular basis, your LLM will not be able to give you an answer. That is a problem, right? That LLM can provide you an answer on a data or till a date on which it was till a date when it was trained, right? And whatever data that you have fed till that point of a time, yes, LLM will be able to give you an answer. But I'm looking for some real-time answer. I'm looking for some dynamic system, so where I will be able to get an answer even for my private data, my sales data, obviously my HR documentation data, my finance data maybe. So I need a system where it should work on even my private situation, my private scenario, and it should be able to give me a generation in a beautiful manner. It should be able to do any kind of a search. It should be able to, understand the context, and it should be able to rephrase each and everything and give me the final outcome. Now, so this is where RAG, a retrieval augmented generation, comes into a picture. RAG comes into a picture. Now, if you are going to ask me that how exactly this RAG system is going to work, let me share my screen, and I'll try to explain you by drawing some of the things over here. So see, whenever we are talking about a RAG, so let's suppose I have a private document, right? So let's suppose I have a private document out there. So I have a box, so where I'm keeping my sales data, let's suppose, or maybe my finance data I'm trying to keep, maybe my marketing data I'm trying to keep, or maybe my tech documentation I'm trying to keep. Now this data set is completely a private data. Yeah. Now, if you are going to ask any kind of a question from a LLM with respect to these data set, it will not be able to give you any kind of a response, because LLM is not aware about these data set. It is just aware about the data that was publicly available, or maybe the data that LLM has scrapped at the time of a training. But still, I want my LLM to understand. I want my LLM to interact. Now, what I will do is that I will try to store this entire data, into some of the databases. Yeah, consistently I'll keep on storing it, and that database is called as vector database. Now, in case of vector database, there are different kind of a database you will be able to know. There is something called as Facebook AI Similarity Search, FAISS. There is something called as ChromaDB. There is something called as a Pinecone, BayesVector. So there are a lot of vector database which is available in a market. So what we do in general is that we try to store a complete data into a vector databases. Now, what vector database does? So it will try to break down your data into a small chunks. Depends upon the chunks that you are going to decide. So you have a full control over there, by the way. So it is going to divide it into a chunks, and then in a chunks it is going to store into a vector databases in a numerical format, right? In a vector format. Vector is nothing but a numerical format. And those who are not aware about it, so you will get to know about it like in detail, in depth. So as we are going to move into the classes, so here it is going to store all of those data into a numerical representation by breaking it down into a small chunks. Okay. So now I'm able to store it. Now what happens is that whenever you are going to send a query, right? Let's suppose I'm writing a query. I'm sending a query to whom? To my LLM, let's suppose, right? To my LLM. So what it will do is that whenever you are trying to send some sort of a query, but this query is maybe related to this private data, right? That you are trying to store. So what this query will do, or what this entire system will do, is that it will try to, instead of hitting this LLM directly, so what it will do is it will try to basically connect with a vector DB. It will try to check that the query that we are able to form, right? So query that we are able to form and the data which is available over here. So whether we have some sort of a data based on the query that user is trying to perform. So for example, if I'm going to ask that how many courses my team was able to sell yesterday, right? So obviously it will go into the vector data. It will try to check that, okay, so whether there is something which is available with respect to yesterday's sales, right? And it will try to pull the data from a vector database. It will try to pull out the data from the vector database, and then it will try to give it to the LLMs. Now LLMs is going to rephrase it again. It will try to pull out what? A K top record. Now what is this K? So maybe 2 top record, 3 top records, 5 top records, whatever you are going to configure. So again, it's a configurable things, right? And here, so as we know that this is my vector DB. So here data is available into a numerical composition, into a numerical format. As simple as that, right? It's available into a numerical composition, numerical format. So whenever we are sending a query, so eventually this query will be converted into a numerical format basically, and then it will try to check the similarity. So there are multiple different kind of a similarity check algorithm. So maybe a cosine similarity or equidistant distance we are going to check, something like that. So we are going to compute, and then k top record, it is going to return to my LLMs. Now based on this k top record, my LLM is going to rephrase it, and then it is going to give you the final answer. So ANSWER, answer you will be able to get. Now this is called as retrieval augmented generation, right? So we are trying to retrieve the data, we are going to augment the data, and finally with the help of LLM, so we are trying to generate a data, and it's called as RAG. In every situation, so we do the same thing. So now here in this way, doesn't matter whether your LLM is been trained on your private data or not, but still it will be able to give you the responses, right? Still it will be able to give you the responses. Now based on that, so I have prepared a beautiful documentation for all of you. So let me go through this documentation. So what is this retrieval augmented generation, by the way? So basically retrieval augmented generation is a hybrid architecture, right? Architecture that combine a retrieval based information access, which we are storing into a vector DB, by the way, with a generative capability of the large language model, right? Large language model. I think this is what I have told you. So here, whenever we are trying to send a query, so whatever data we have inside the vector databases, it will try to do a similarity search kind of a things. And based on those similarity search, it will try to pop up a couple of records, a k top records, you can say, based on the ranking. And then finally, with the help of LLMs, we are trying to generate some sort of a responses. So this is called as retrieval augmented generation. It's a very simple concept. It's a very basic concept, nothing much, or I would say it's not a rocket science, by the way. And like I said, guys, so there are multiple projects based on RAG, which is already available inside a Euron dashboard. So if you will go over here, right, if you will go over here, you will be able to find, just search for RAG, right? You will be able to find out a lot of courses, a lot of projects with respect to just an RAG. Even in my generative AI with NLP, agentic AI with fine tuning. So I talked about a lot of projects, and I'm still talking about a lot of projects when I'm recording this video, by the way. And again, in a RAG master, anyhow, I'm going to talk about a lot. Lot means literally a lot. But it's one of the very simple and basic system that you will be able to create. Now, many people ask me a question that it's completely fine, we are talking about RAG, but why can't we go ahead with the fine tuning? Means the LLM that we are using over here. So why can't we give this entire data? Why can't we give this entire data to this LLM and fine tune this LLM itself? Yeah, eventually you will be able to do that. There is no doubt about it. But my data is incremental in nature. So every day my data is increasing. Every day my sales team is generating a data. Every day my finance team is generating a data. Every day my marketing team is generating a data. Every day my tech team is generating a data, right? Now, how many times you are going to fine tune your model? How many times you are going to train your model? Practically that is impossible, right? Practically that is impossible. And again, even from a cost perspective, I don't think that it's a viable approach, right? It's a viable approach. So fine tuning is not an option for this kind of a situation. I want some of the retrieval, and then based on I want some sort of a generation. So RAG is a best suited approach in this particular scenario. As simple as that. Yeah, as simple as that. Okay, now moving ahead. So here key characteristics, I believe I have already talked about it. So user query, whenever you are going to send a query, so it is going to retrieve the data based on the relevant context, and then based with the help of this LLMs, it is going to reformat it, and then it is going to give you the final information, right? Same thing I have mentioned. Now, so RAG versus a closed book LLM. So what if I'm not going to use RAG, if I'm just going to use LLM? So obviously LLMs will not be aware about my private data. It will be aware about only those data on which it was trained till date. So I have mentioned all of these things over here for this, just this documentation, so that you guys can refer, right? My roles and responsibility is to make you understand this entire things and then give you this documentation. So I'm attaching this documentation. Now, what kind of a problem that we can try to solve? So PDF based question answering. So whatever data that you have, store it inside the vector DB, and whenever someone is going to query, so it will go to the vector DB first, try to bring the data, and LLM is going to give you the final answer. Document assistance. So with any kind of a real-time support, I believe I have already given the example for that, right? Search bot with the contextual answering in a real-time search, multi-agent system. So RAG system architecture overview. So again, there will be an input layer, there will be a text splitter and checker. So where we are going to split the text, entire text. There is a embedding generator. Now, so the major part that you will be able to find out with respect to RAG is generating a embeddings, because embedding means converting your data into a numerical representation. Now for a embedding generation, we have already given you embedding models over here. Plus we have given you the endpoints, because embedding is necessary. It is required. Without embedding, you will not be able to generate, or you will not be able to build a RAG kind of a system as simple as that. Even in a class, or even the project that we have already discussed, or even the project that I'm discussing inside my live classes, you will be able to find out that without embeddings, it is not possible. Yeah. So that's the reason. So we have given you one of the best model access with a 1536 dimension vector, so that you will be able to generate the embeddings. You will be able to store it. How we are going to generate it, how we are going to store it, that is a part of a discussion, obviously, and we are going to talk about it, right? So what we do, so first of all, we take the data, whatever data that we have from a different department, or whatever the nature of data is. And then we try to split the data and keep small chunks. By the way, to do that, we can write a custom Python code. We can use some of the libraries as well. And then embedding generator. So you can use OpenAI, you can use URI. Yeah. So URI is one of the best thing that you have, or Hugging Face, and convert it into a embeddings. And then you can try to use any of these databases. So Facebook AI semantic search, you can host it locally, you can Dockerize it, and then you can host it anywhere that you want. Now ChromaDB, so again, you can try to host it locally. Pinecone, so if you will go to Google and if you are going to search Pinecone vector databases, so you will be able to find out this Pinecone vector databases, which is basically a hosted one, and you can try to access this data and just try to connect it, and you will be able to pass your embeddings, and you will be able to even do a semantic or similarity search operation in between. So Pinecone is one of the option, and then there is something called as Baviet. Baviet vector DB. So here again, this has been used to store the information, to store the data. Even MongoDB, right? Many people must be aware about a MongoDB so far. So MongoDB is a document-based databases, and even MongoDB nowadays giving you a vector-based storage. So you can even try to use that, because we are using MongoDB even for a vector-based storage, and for our job system, right? For our job system, so we are using it. So I can tell you that even you can go ahead and use a MongoDB, one of the most popular, one of the most trusted databases from a NoSQL document-based database segment. But now they have started providing you even a vector DB. Otherwise, a Baviet, Pinecone, Facebook AI similarity search, or maybe you can go ahead with the ChromaDB, and anything of these things is completely fine for all of us. Okay. So this one is required vector database you have to choose, and so that you will be able to store the data the way I have designed this diagram, right? So you have this data and you have to store this data into some of the databases. So vector database wise, Facebook AI similarity search, ChromaDB, Baviet, Pinecone, maybe go ahead with the MongoDB. And there are other tens and hundreds of databases which is available. So who is supporting vector based storage nowadays. So you can opt for any of these databases, and in your class, in your curriculum, I'm going to talk about all of these databases in very detail, in a very depth way. Now output layer. So obviously whenever I'm going to send a query, so it should generate it should try to bring a similar kind of a data, which is similar to the queries that I'm going to ask. And then I need a LLM, so which will be able to format it as per the context and finally give me the answer. So output layer, so responsive response display, UI or APIs, and can include a source document store or the traceability. So these are just an additional feature that you can try to add. But yeah, so I believe you are able to get some sort of a understanding with respect to the RAG. Now tool for building RAG system. So you can try to use maybe a LangChain, maybe a Llama indexes, maybe a OpenAI API. With the help of that, I will be able to build it. Maybe you can try to use a Pinecone, ChromaDB, or Facebook AI semantic search for storing this data and building the RAG. Now I'm going to show you all of these things. All of these things means literally all of these things I'm going to show you. So whether it's a ChromaDB, whether it's a Facebook AI similarity search, or whether it's a Pinecone, OpenAI API, Llama indexes or LangChain, I will be showing you each and everything, means literally each and everything. This is what I'm doing even in my current live classes. And same thing I'm going to do it even in this particular RAG Masters curriculum. Yeah, and you can check out the curriculum. So I'm going to talk about each and everything as and when these things will come, that how with the help of LangChain or even a LangGraph, even a Llama indexes or even an OpenAI, so how I will be able to build a RAG kind of a system which is going to query my private data, which is available in my vector databases, some of the vector databases, and then eventually it is going to give me the formatted response based on my private data set. So with that, guys, thank you so much. Take care and see you again in my next lecture. And let's get started with the RAG Masters. For sure, you all are going to learn a lot, but it is going to be a practical oriented learning. It is not going to be much of a theoretical oriented learning. I don't even believe in a lot of theoretical based understanding, because we are not in a school and colleges. We are applying for a real world job. We are going to build something real. So in that situation, obviously a real thing is required, and this is something that we are going to see. So with that, thank you so much, everyone. Take care and see you again in my next lecture of RAG Masters. Take care, everyone. Welcome to Euron, guys, and welcome to a lecture of RAG. So in this lecture, guys, I'm going to show you that how you will be able to build your own RAG pipeline. How you will be able to take any kind of a data means any private data about which LLMs are not aware about, by the way, and how you can convert those data into a small chunks, and eventually how you can convert your data into an embeddings, and then you can query it with respect to any kind of a LLMs. Now, in this entire process, you need two things at least. One is an embedding. So unless and until you don't have an embedding model, you will not be able to convert your data into its equivalent embeddings, and then you need an access of LLMs. So again, if you don't have an access of LLMs, you will not be able to query your RAG. So whatever like private data which you have converted into an embeddings. So each and everything I'm going to cover in a step-by-step manner, so that you all will be able to understand things in a best possible way. And I'll be talking about obviously chuckings. I'll be talking about obviously a use of LLMs. I'll be talking about a use of embeddings in a step-by-step manner, which is a building block for any kind of a RAG application that you are going to build. And this entire simple demo has been designed in such a way that it will give you a complete understanding, a complete idea about embeddings and chuckings and LLM operation, and finally RAG operation. So let's move ahead and let's try to understand RAG. So first of all, let me draw a pipeline. So as we all know, guys, that RAG is all about querying a private data, a data about which my LLMs are not aware about, right? So this is the whole idea. So here, RAG pipeline. So RAG pipeline. Now for any kind of a RAG pipeline, any means literally any kind of a RAG pipeline. So you need a data. So unless and until you don't have a data, you will not be able to perform RAG operation. So obviously these data set must be a private one. Your LLMs are not supposed to be aware about it, right? For example, if I'm talking about maybe a Euron data, if I'm talking about some data which is like very much personal to me, so that kind of a data I'm going to consider over here. And then this particular data, right? This particular data. So what I will do is I'll try to convert this data into a chunk. So convert this data into a chunk means into a small pieces I'm going to convert this data into. Now, once I will be able to convert this data into a chunks, then I will try to do what? So I will try to basically convert this entire chunks into a embeddings basically. So embeddings is nothing but a vector representation of any kind of a textual information or any kind of a data that you are going to consider. So I'm going to convert everything into an embeddings. Now, once I will be able to convert everything into an embeddings, then I will try to prepare my query. Yeah, then I will try to prepare my query.
So here I'm going to basically write a query, and this query, right? So this entire query will go to LLMs. This entire query will go to an LLMs. But before this query will go to an LLMs to like a ask or for execution, so what it will do is, so it will try to, right? It will try to check even my embeddings that I have created. So it will try to check my embeddings that I have created, that whether we have some sort of information with respect to this particular query inside this embeddings that we have already created from my private data. And then it is going to combine a query. So combine a query plus embeddings, and this will go into a LLMs to get an answer. And this LLM is going to give me an answer in a complete formatted manner. So here I will be able to get my answer. So this is the complete flow, guys, that we are going to create one by one, one by one, one by one. Now, the major part over here is that access of embedding models. Unless and until you don't have access of embedding models, models which will be able to convert your entire data, your entire information into a vector space for a respective dimension. So you will not be able to perform this RAG operation. The second part is you need an access of LLMs. So unless and until you don't have access of LLMs, again, you will not be able to perform this kind of a operation. Now, the good part is that you don't have to go anywhere to access LLMs, or you don't have to go anywhere to access embedding models. You have each and everything inside a URI system, which is a part of Euron itself. So let me show you that first of all, that how embedding happens and what will be the result that you are going to receive eventually. And then I'm going to show you even LLMs. And then I will start building this entire flow, the entire flow that you are able to see over here. So I'll start building this entire flow one by one, one by one, one by one. And then even I'm going to show you that how you will be able to productionize this one, how you will be able to deploy this one on a variety of a platform. Okay. So first of all, guys, what you have to do is you have to open up a VS Code so that we can start building things. Yeah. So here I'm going to open up a VS Code, and I'm going to create a folder somewhere. So here I'm going to create a folder RAG pipeline demo, right? Pipeline demo I'm going to create. Now inside this folder, I'll be doing each and everything which is required. So here I'm going to create a file called as RAG pipe underscore demo.ipynb. You can try to execute this entire things even on a Google Colab or even on any kind of a Jupyter notebook. That's completely fine. And at the end of the day, I will be converting a same code into a modular fashion. And eventually I'll try to convert this entire things into an app. But first of all, I'll try to show you in a step-by-step manner. Now, as per this diagram, right, as per this diagram which I have shown you, you need embedding models so that you will be able to convert any kind of a data. So whatever data that you have in your hand, so any kind of a data into its respective embeddings. Now, many of you must be confused about the embeddings still, right? That how embedding looks like and what is going to be the embeddings, and many more questions you must be having. Now, so to answer to those questions, so let's do one thing. Let's go to Euron platform, and inside that, let's go to URI platform. Inside that, let's go to API platform. And here, so you will be able to get an access of lot of models, right? Lot of models. So lot of LLM models, you will be able to get an access, including a GPT or Gemini or Llama or maybe a Mistral or Quinn or DeepSeek. Apart from that, so we are giving you even an access of this text embedding model from a OpenAI. Now, what it does, so as you will be able to see that it converts all the data, whatever data that you are going to pass into a 1536 dimension vector. Means, let's suppose if I'm going to pass any kind of a sentence, it will try to create a vector, right? It will try to create a vector, and it will try to represent those textual information or any data that we are going to pass. So it will try to represent those information into 1536 dimension vector, a numerical space it is going to convert. And that is something which is required. Now, for this, we have even given you a code example, a Python based code example. So if you will come over here, so here embedding generation, and for embedding generation, we have already given you a code in this particular place. So just copy this place, copy this code so that I will be able to show you a demo, by the way. So here, I'll try to copy this code, and let me select my kernel. So any kernel which is available to me. And here, so this is a code which we have given to you, a pre-built code which is available to all of us. Now, I think I have copied this code multiple times. I don't know, but yeah. Let me remove one. Okay. Now here, so you will be able to find out a function called as generate embeddings, and which is calling my URI endpoint for our embeddings, as you can see, right? Now, this is a payload. Payload means this is a data. So whatever data we are going to pass over here, it will try to take a help of this model text embedding 3 small, which is a OpenAI, one of the powerful model for embeddings, and it is going to convert your data into a 1536 vector dimension. Okay, so let's try to do it, and let's try to convert it. So if I'm going to execute this particular part, but before execution, so you need a key. Unless and until you don't have a key, you will not be able to perform this operation. Now to get a key, you can click on this authentication tab, right? Authentication tab, and here is your API token. Yeah, here is your API token. So I'll just try to copy this API token, and instead of this static, so I'll try to place this copy API token over here. Okay, so that this entire thing is going to work. Unless and until you are not providing an API token, it is not going to work. Now this is a data, guys. This is one single line, and eventually I'll try to use it for converting a multiple lines as well. But here, so I'm just trying to use this particular line, a single line, and I'll try to call this function so that I will be able to convert this particular line, which is a default line given inside a URI platform for our embeddings, into a vector space. So execute, and bearer token unlimited string literal detected line number 9. So let me check what is a issue. So I believe I have missed this one. I have to close this one. Okay, execute once again. And now if I'm going to call my generate embeddings, so this model is going to work for me, and this model is going to generate embeddings, and this is the embeddings that we are able to receive, guys. Yeah, this is the embedding that we are able to receive. Now this embedding, right, this embedding that we are receiving, so this embedding is required for any kind of a RAG application, because whenever I'm going to fire a query, so it is going to take a query, it will try to extract a respective embeddings, and then query plus embedding will go inside my LLMs, and then LLMs is going to give me an answer, right? Then LLMs is going to give me an answer. So here we are able to convert our data into an embeddings, and if I'm going to check, let's suppose if I'm going to hold it in some variable, so embed embed variable, and I'm going to call this generate embeddings, right? Generate embeddings. So this is returning me embeddings in between. So we are trying to print something which is not required. That's completely fine, just for the showcasing purposes, right? So give me like a top 5 value of the embeddings. But yeah, so if I'm going to do this, so here I'm going to call embed, and if I would like to check what is the size, what is the total length of this entire embedding, so it's a 1536. Means we have passed this particular line, just this line, right? Just this line, and it is converting my entire data into a vector space of a size what? So vector space of a size 1536. So embedding model is very much required. Now, this embedding, what we do is, so we try to save it or we try to store it into any of the vector database. So here I will be using, in this particular example, I will be using a Facebook AI similarity search, FASI, basically over here as a vector DB. Going forward, so we have a huge chapter about other vector database. If you will check your syllabus, so we are going to talk about that as well. But here, so I will be using a Facebook AI similarity search. Now here, successfully I'm able to convert my data into a embeddings, and there is no question about it, right? There is no question about it. Now, I can try to use this embedding, the embedding that I have generated, so while doing a query for our LLMs. Now, how I will be able to access LLMs? So separately, I'm able to access embeddings. So that's completely fine. So we have tested it. Now, let's go ahead and try to basically test, right? Let's go ahead and try to basically test a LLM model as well, separately, right? Separately, so that I will be able to query and I will be able to generate some sort of a response. So for that, you can come to a code example, and here, so you will be able to find out that as well. So here, we can try to execute this particular piece of a code. Now this code is trying to do what? So this code is going to hit my LLM. So here I'm going to use a GPT 4.1 Nano. Let's suppose if I'm not looking for a 4.1 Nano, so in that case, maybe I can try to go ahead with a GPT 4.1 Mini, Gemini Flash, or maybe a Gemini Pro Preview, or maybe a Gemini 2.5 Flash Preview, Llama Scout, or maybe a Maverick, maybe a Llama 370 billion parameter model, or maybe a DeepSeek, whatever I want. Now, the only thing that you have to do is that replace your model ID. So everywhere we have given you a model ID, right? Everywhere you will be able to find out a model ID. So you have to just replace your model ID, and then it is going to hit that respective LLMs, right? That respective LLMs it is going to hit. How? I'll try to show you. So here you can try to even set what is the number of a token that it should generate. You can even try to set a temperature over here. So if temperature is going to be close to 1, it simply means that your output will be more random. It will hallucinate more and more. If temperature will be less, let's suppose a 0.1, because it will be in between a range of 0 to 1. So if it will be close to 0, it simply means that it will try to give you more accurate result. Now here, to execute this one and to get any kind of an answer out of this, so you need again an API key. So you can try to come over here and same API key you can try to copy. So there is no different API key, same API key, and then instead of a static, right? Instead of a static, so you can try to place your API key over here. So this API key over here, and then you can try to execute. Now after execution, so what is the response that you are expecting? So this is the content that you are going to pass. Write a poem about artificial intelligence, right? So write a poem about artificial intelligence. And once I'm going to execute it, right? Once I'm going to execute it, so it is going to give me some sort of a response. And as you can see, it has given me a content in a circuits woven, silent through take flights, mind of the code, and then this is the entire poem which I am able to receive over here, right? This is the poem which I am able to receive over here. Now successfully, right? Successfully now I'm able to test my embedding models, as well as I'm able to test my chat completion model, means LLM models. And here, like I said, so you can try to pass any model ID. For example, so let's suppose if I don't want to use this particular model, so maybe I can try to use maybe a DeepSeek model, right? So I can try to copy a DeepSeek model ID over here, and then I can try to hit, I can change this model ID. So GPT 4.1 Nano instead of that, so I can try to use a DeepSeek R1 distilled llama model and execute it. And now this time it is going to hit a DeepSeek model, and from a DeepSeek model, I will be getting a response. I will be getting a poem, right? A poem about artificial intelligence. This is the command that we have given. Now, this is going to give me a poem. See, this is again giving me a poem, a beautiful poem, not in a formatted way. So obviously when I will try to show you the final response, so it will be in a formatted way. But here, so yes, it is able to give me a poem. So in this lecture, we are able to achieve two things. One thing is, we are successfully able to test our embedding models, which is already available. So you don't have to do anything, and it's pretty much required for our RAG application. I'm going to use it in the next lecture. Plus, I'm able to test my LLM models, which is again very much important to build any kind of a RAG application. Yeah, it's important, right? It's very much important. So with that, thank you so much, guys, and see you again in the next lecture. Okay everyone, so in my last lecture, so I was able to test embedding models, and I was able to test LLM models with respect to like all the models which is available on a URI. So now in this lecture, I'm going to show you that how you can try to prepare your own private data. So where I'm going to create my own TXT file as of now. And then what I will do is I'll try to convert those data into a small chunks. So this is where a concept of chunking comes into a picture. So where you take a huge amount of the data, and then as per your defined chunk size, I can try to control that chunk size. So based on the own defined chunk size, so I can try to break it down into a smaller pieces, smaller chunks, and for those chunks I'll try to convert it into its respective embeddings. So let's go ahead, and I was trying to show you this example, right? So what I will do is I'll try to start from here this time. So I'll try to start from data. So I'll try to like create my own data set, and so that my RAG application will be able to give an answer with respect to own private data about which any LLM models are not aware about. So now how I'm going to prepare my own data, let's try to understand that particular part. So here, if you will go to Euron, so there is a page called as founder story page I have created, and inside this founder story page you will be able to see a little bit of story about me. So I'll be taking this data, and obviously any LLMs are not aware about this data, that who is Nanshu Kumar, what I have done, and what is my background, what I have built so far. So obviously LLMs are not aware about it, and whenever I'm going to ask a question, so LLMs are supposed to give an answer. So I'll be considering this textual information. You can try to consider any kind of a text data of your choice. That's completely fine. You will be able to execute this entire application in the exact same manner. Okay, fine. So I'll be adding things in the same one. So I'm not going to use anything different over here. So here, let's do one thing. So let's create one new file, and founder story, founder_story.txt file I'm going to create. Yeah, .txt file I'm going to create. And then I'm going to keep all of these data in an unstructured way. Again, this data set is completely unstructured, right? This data set is completely unstructured. So I'll be taking this entire information, I'll be taking this entire data, the unstructured data from this particular page, so that it will be aware about me a little bit, right? It will be aware about me and then rise and through the rank of tech world. So let me copy this data, and then let me copy this entire data, right? This entire data. So this is the data which I have prepared, and as you can see, this is a completely unstructured data. There is no structure which is available inside this data. I have just copied and pasted it. Okay, fine. Now what I will do with this data? So we are here basically, right? So we are able to prepare our unstructured data. You can try to copy and paste any kind of a data of your choice. That's completely fine. And as we are looking into a demo, so obviously we need some data. So here is my data set. Now, after creation of this data, I will have to convert this data into a small chunks. Now, what is the meaning of this? Very simple, right? Very simple. So maybe I'll try to take hundreds or 200 data together, means a number of words together, and then I'll try to create one chunks, or maybe 100 indexes of data together, and then that I'm going to consider as a single chunk. Now, how you can do that? So let me show you that particular part of the code, that how I will be able to convert my data, convert my information into a chunks. Code is going to be very simple. It's not going to be difficult at all, and you all will be able to understand it. So here, before converting my data into a chunks, so what I have to do is, so I have to basically read a file. Yeah, I have to read a file. So here I can write a code that with open, a simple file reading code that we are using since an ages in a Python. So here I can try to read out basically my founder story, story.txt file. I'll try to open it up in a read mode, and then encoding is equals to UTF-8. So means a simple plain English in which I'm going to read. So UTF-8 as a file, and then file.read operation I'm going to perform. So whatever data will be available, it will be able to read it, and then I'm going to store it inside a raw text information. Okay, fine. Execute. Now if I'm going to show you a raw text, so this is how my raw text looks like. So line by line, it is able to read all the information. So whatever data was available inside my founder story.txt file, so it is able to read each and everything. Yeah, it is able to read each and everything which is available inside my data set. Now, so once I'm able to read this raw text, I have to break this data into a small pieces, equivalent pieces, by the way, where I can try to say that, okay, so in this particular piece, only this many number of the maximum word comes into a picture. For that, I have already prepared a function called as a chuck text function. So here I'm going to create my data into a chunk. So what it is going to do, so it is going to take this textual information, whatever data that you are going to provide, whatever data that you are able to read. So we are going to provide that particular data. And then I'm trying to say that, okay, so whenever you are trying to create this chunking or the small piece of data, so always make sure that maximum number of word inside this data is going to be 100. Now, once I will try to read this data, so I'm trying to split this data, so it is going to return me the list. And then I'm trying to write a loop over here that, okay, so for this particular loop, start from 0 till the length of the entire word. So whatever word that we are going to pass over here, and you have to, right? So you have to basically go till a maximum word at any point of a time. So you have to go till a maximum word, means you have to jump till a maximum word. Now, what is the meaning of this range? So I think we all understand and we all know that how range is going to work. So range is going to basically take this particular range starting from 0 till a length or till a total number of the information which is available inside this word. And every time it will try to take a jump of maximum word, means in a first iteration, it is going to consider 0 to 100, then 101 till 200, then 201 till 300, then 301 till 400. So this is the jump that I have defined, that okay, every time try to take a jump of this one, and then one by one start creating a list. A very simple Python operation I have written, so where I will be creating a multiple list out of the single data. So where inside one single list, max to max, right? Max to max, a data size should be not more than 100. Okay, fine. So let's execute it and let me show you that how this actually looks like. So here I'm trying to call my chuck text. Here I'm trying to call my chuck text. So where I'm going to provide my raw data. So this is the data that I have read from my founderstory.txt file. And then I'm going to get a return as a chunk. So I can try to even check that how many total number of chunks do we have. So here, if I'm going to check what is the length of this chunk, so total number of data, total number of chunks that I'm able to create is equal to 7. Now from chunk CHU, CK. So from this chunks, maybe I can try to access a 0th data, and maybe I can try to check how many data set is there inside this one. So again, length, and it is basically total 674. Yeah, it is total 674. Now, so you can ask me a question that you said that there will be 100 number of a maximum word, right? 100 number of a maximum word. And then it is trying to show me chuck 0 size or length of this chuck 0 is equals to 674. Now I can try to check same thing for my chuck, basically chuck 1. So again 677, so not equivalent to the previous one. Then again I'm going to check for maybe a chuck and here, so 2 and 641. So somewhere we have 674, 677 and 641. Okay, that's great. That looks cool. Now let me do one more thing. So instead of using 100, so let me make it 10, just for the explanation purpose, right? Just for the explanation purpose. So now if I'm going to access my chuck 0, just for the explanation purpose, guys. So chuck 0, if I'm going to access, so how many words do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So 10. Now, so how many words do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. This is the total data that we have. Now, whenever I'm trying to check with the length, so it is trying to give me a total number of the space which has been occupied by this data. So never get confused. We are creating a chuck of 10. And when we said that chuck is equal to 100, so in that case, there will be 100 number of the words. This is what it means. So 10 number of words as of now, right? 10 number of words, and hope we are able to prove our point that from where we are getting 59 or maybe a 66. So it is trying to show me the total number of a space or total number of the character, including a space available in between the data, because we know that if this is the string, right? If this is the string, so a string will be having a indexes, and a string will try to store all the data from starting from 0th indexes, 0, 1, then 2, 3, 4, 5, and so on. So in this manner, it is going to store the data. It is going to store the information. Okay. So now let's move back and let's make it 100. I think we are able to understand what is the meaning of 100. So in one single chunk, there will be 100 words. This is the objective. This is the whole idea behind doing this particular chunking operation. So we are able to create a chunks, guys. So we are here now. We are able to create a chunks. Now the next step is going to be a embedding. So we will try to create a embedding in a next lecture. Okay everyone, so welcome to lecture once again, and in my last lecture I was able to create a chunks of a data. So I have taken my own custom data, and out of that I was able to create my own chunk of the data. Now in this lecture I'm going to show you that how we can try to perform this particular step, embedding step. I believe we have already done that in a lecture number 1. So where I was using a URI embeddings, and out of that I was able to convert my data into a vector space of dimension 1536. Means any data you are going to pass, right? Any data you are going to pass, it is going to return you what? It is going to return you a numerical vector. Yeah, it is going to return you vector, by the way. Obviously vector will be having a numerical values. So it is going to return you the vector, and the size of that vector is going to be 1536. Again, so that depends upon a use of the model. So if I'm going to change my model, so again vector size is going to be different. It is not going to be same. So now in this step, what I'm going to do is, so we will try to create a embedding, guys. Yeah, we will try to create a embeddings, and I will be using a URI embedding API to convert my data into a respective embedding. So let's try to understand how we can do it. So here, let me do one thing. So let me open up my VS Code, and let's try to write a code in little bit structured way. So here I'm going to call import request, by the way, request request, so that I will be able to request to my URI for my embeddings and even for my LLMs. This is where this request will be used, by the way. And then import numpy, so just for the data manipulation, so numpy as np. And then so we are going to create a variable over here, so URI underscore API underscore a key, so that I don't have to do it again and again, copy a key again and again. So I'll be using just this variable, and here so I'm going to keep my URI API key. So here, go to authentication, copy it and then keep it here, so that wherever key is required, I will be using this key. It's the same key that I have used, right? It's the same key, nothing different. But yeah, I'm just trying to create a variable over here. Going forward, I will even try to show you that how you can try to keep your all the secrets, all your credentials into a environment file. And then even at the time of deployment, so what kind of a measure that we have to take in terms of our deployment. Okay. So this is something that I have done as an import. Now let's go ahead and let's try to convert my entire data into a embeddings, means into a numerical vector space. I will be using a same function, right? Same function. So precise function we have like a created over here. So where, as you can see, this embedding function, get embedding function, you can try to pass your data, right? You can try to pass your data. This is the model name. Now this model name or this model ID is coming from where? So this model ID is coming from here. This model ID is already given to you in this particular place, the highlighted one. So this model ID is coming from here. So I will be using this particular model, and what it will do? Same thing, nothing different. So whatever code that I have given to you inside a URI application, so we are using same thing. So this is the endpoint. This is the embedding endpoint that we have created from a Euron side. So whenever you are going to hit, so it is going to hit this particular one with a API key. So here URI API key. So URI API key, I have already stored it in this variable. So I don't have to copy and paste again and again. So URI API key, it will try to take, and then here it will try to do a main operation. So input as a text, so whatever data you are going to pass, and then model as a model, this model name that you are going to pass. So this is going to be the payload, and then request.post. So it is going to post with this URL. So where my URI is hosted, and header is equals to basically this authorization header. It is going to pass, and then it is going to pass a payload. So as a part of payload, so it is going to pass a text and the model. Now this code is coming from a URI itself, right? This is how you are supposed to hit a URI. Okay. Now, so whenever you have to convert your entire data, into a chunks, so what you can do is you can try to call this model, right? You can try to call this model, and then you can try to pass your chunks. So chunks 0, if I'm going to pass, just for the testing purpose, I'm trying to show you. So chunk 0, if I'm going to pass. Now, what was chunk 0, by the way? So let me show you that once again. So chunk 0 is nothing but one line of information with the 100 words, right? 100 words. Yeah, this is the information that we have, as you can see, 100 words. So here chunk 0 I'm going to pass. Now what it is going to return me? So it is going to return me basically a embedding. Execute it. Yeah, execute it. So here, if I have to show you that how this test embedding variable data looks like, test embedding data. So this is how it looks like. So it has converted my entire data. It has converted this entire line, as you can see, right? This entire line over here, it has converted this entire line into this particular data set. So where the dimension of this entire one. So if you are going to check what is the length of this entire vector. So length of this entire vector is 1536. And again, we are trying to print a shape anyhow, right? We are trying to print a shape over here. It's the same thing. So this is how, guys, it is able to convert my data into an embeddings. This is how it is going to convert my data into a embedding. So we have now a embedding function. I just have to pass a data over here one by one, one by one, one by one, one by one, and then one by one, one by one. So it will start converting my data into its respective embeddings. As simple as that. It's a very simple operation that we are trying to perform. Okay, that's a very simple operation. So now we know that how I can try to take my own chunk and then eventually I can try to convert my own chunk into a respective embedding, which is a very simple and plain operation, right? Which is a very simple and plain operation. So I will be using this function, by the way. So going forward, I will be using this particular function. I'll just try to pass my data, maybe call a loop, and one by one, because we have a multiple chunks, right? We have a multiple chunks. So if I'm going to check how many data we have into a chunks, how many chunks we have. So in total, we have 7 number of chunks as per my data. Maybe you will be having a 7,700,000, whatever it is, whatever is the number. So one by one, one by one, one by one, I'll try to run through the loop, the chunk data, and then I'll try to pass it inside the embeddings, and eventually I'll try to convert those entire data into a embedding. Very, very simple step, very, very simple approach we are going to fulfill. So hope all of you are able to understand that what is the meaning of a embeddings. Embeddings means converting this entire information, as you can see, in this particular vector space of size 1536. 1536 is a return that my model is giving. I can try to use maybe some other model, some other different embedding model. There are tons of model available on a Hugging Face, which you can try to use for embedding purposes. But just to avoid those hustle, just to avoid those a hard work, we have already given you a best of best embedding models. Again, best of best embedding model selection is very much important for any kind of application that you are going to build. Okay, fine. So we are going to use this one. Now, in my next lecture, what I'm going to do is, so I'm going to use this embedding function. So I'm going to use this embedding function, and then I'll try to convert my entire chunks into its embedding, a respective embeddings, one by one, one by one, one by one, one by one. And then I will try to store all of those things into a vector database. Now, let me talk about this vector database a little bit. So vector database is a kind of a database, right? It's a kind of a database. So where you will be able to store this information, this particular information you will be able to store. Why we are storing it? We are storing it so that whenever you are going to fire any kind of a query, any kind of a query means literally any kind of a query whenever you are going to fire to an LLMs. So what will happen is that it will try to convert your query into a embedding vector again, right? Embedding vector again. It will try to check with all the existing embedding vector which is available inside your vector database. And then it will try to extract those information. Then it will try to attach query plus embedding and send it to my LLM. This is what I have written over here. So whenever you are going to query, so here after embedding, what I'm going to do is, so I'm going to attach. So I'm going to attach over here a vector database. So all of these embeddings will be available where? So all of these embeddings will be available inside my vector database. whenever I'm going to query, so it will convert this query even into embeddings, and then it will try to do a similarity check with the existing embedding inside my vector database, right? Vector database, and then it will try to fetch the information of our embeddings. It is going to attach with the query, and that will go inside the LLMs. So in a step-by-step manner, we will move so that you will be able to understand how in a real-time RAG application can be built. So with that, guys, thank you so much. Take care, and see you again in my next lecture. Okay, so welcome back once again, guys, and now in this lecture, so I'm going to show you that the embedding that we were able to create, a function we were able to write, and where we were using a URI embeddings, and inside URI embeddings, so obviously we were using OpenAI model, OpenAI small model, and it was able to convert my data into its respective embeddings. Now, in this lecture, I'm going to show you that how we can try to use one of the available vector database in a market. One of the best one, by the way, obviously, I'm going to show you because we have a lecture about detail, like in very detail, we are going to talk about a vector database in your upcoming session. So if you will go through your entire lecture, so you have that lecture as well, where I'll be talking about each and every operation with respect to a vector database. But as of now, what I would like to show you over here is that how we can try to store this embeddings in one of the vector database. A vector database which I can configure in my local system immediately just by doing a pip install, and then inside that I will be storing the entire embeddings that I'm going to create with respect to my own data set. So let's go ahead, let's try to do it one by one. So I believe my screen is visible to all of you. So here what I will do is that I'll try to take the help of this function, so get embedding function, and I'll try to convert my entire data, the chunks which I had already created, and chunks is coming from my founder story.txt data, and then I'll try to store it inside a vector database. Let's do it in a step-by-step manner. Believe me, you all are going to enjoy it. So which vector database we are going to use? So we are going to use a Facebook AI similarity search database. So as of now, this database will not be available inside your local. So what you have to do is, so you have to do pip install, install install, and then FAISS, Facebook AI similarity search -CPU. So just try to execute it, and it will be able to install. In my environment, it's already installed because while creating a material, I have already tested it. But yes, in your environment, it won't be installed. So please try to install this one. This is important. Now, once you are able to install, because in no time you will be able to install this one, then try to import. Import what? Facebook AI similarity search. So just try to do the import so that I will be able to use it. Now, this vector database is basically going to work in your local system inside your memory itself, and it is going to hold all the vector. So whatever data that you would like to store, it will be able to store all of those information locally as of now. Going forwards, I'll be using a Pinecone, I will be using a Waviet, I will be using a ChromaDB to perform a exact similar kind of operation going forward, right? But as of now, let's try to use a Facebook AI similarity search, which is going to help me out in terms of, storing a data. Now, how this vector database works internally, I'll try to give you a glimpse. But like I said, so we have a separate lecture for all of these vector database itself. So going forward, obviously, I'm going to teach you in very, very depth about all of these databases and its respective functionality. So now, let's do one thing. So let's try to basically create embeddings, and then one by one. So let's try to store all of these embeddings into a vector database, which is a Facebook AI similarity search that we are going to use over here. Okay. So let's do it. So here for that, what I can do is maybe I can try to write a small piece of a code over here, right? A small piece of a code over here. So let's try to write down the small piece of a code. So whenever we have to store any kind of information into a vector database, I have to tell that, okay, so what is a size of your embeddings? Yeah, what is the size of the embeddings? so that it will be able to, create that kind of indexes internally, and then it will be able to store your information. It will be able to store your data inside a vector DB. How we are going to do it? So if you remember, so here we have done this test embeddings, right? We have done this test embedding. Now, if I'm going to show you this test embedding, right? Test embedding. So this was my one of the sample embedding which I was able to create. Yeah, sample embedding which I was able to basically create. Okay, that's cool. Now, so out of this, if I have to extract a dimension, so maybe I can try to write a shape over here. So shape is going to be this one. Now this is a tuple, so I have to extract 1536 out of this tuple. So I can try to write a 0 over here. So this is the vector dimension. This is the vector dimension that I was able to create. So let's try to store it in a variable called as dimension variable. Okay, so this is the dimension. This is going to, this number is representing. I can hard code it, this number. That's completely fine. I can even hard code it, but I'm just trying to keep it dynamic. So 1536 is going to be a dimension of your vector space. Now what we can do is, so we can try to call a Facebook AI similarity search over here, and then there is a function called as index flat L2. So this is something that I'm going to call, and inside this I'm going to pass a dimension. So this dimension that I have created, so that it will be able to understand that, okay, so whatever indexes or whatever data that we are trying to store, what is the size of that data? What is the length of this data? What is the shape of this data? It will be able to understand in this way. So I'm going to create a indexes, because inside the indexes, I'm going to store all the information. Okay. Now here, what I will do is, I'll try to create basically one variable. So chunk chunk underscore MAPPING, chunk mapping. And this is just going to be the empty list as of now, right? Empty list as of now. Now, my responsibility is to convert the entire chunk, the 7 chunk that we had. So one by one. So convert those 7 chunk and then store it inside this particular database. That's my whole responsibility. That's my whole idea. Okay, so let's do it. So here what I will do is, so for like a chunk in chunks that we have created, the original one. So one by one, try to fetch all of these chunks. So 7 chunk that we have. And then try to call a get embedding function, and just try to pass a chunk one by one inside this. So this is going to return me what? This is going to return me the embeddings, 1536 vector space. So embedding it is going to return. Now once it is going to return the embeddings, I just need this one, right? So you can try to do what? So index of Facebook AI similarity search indexes dot add. Simple, right? Dot add. So add this indexes one by one inside your vector database. So whenever you are trying to add some of the indexes inside the vector DB, for example, a Facebook AI similarity search, so here you have to basically convert this entire things into a NumPy array, and you have to define basically a data type for that. Then only you will be able to insert it. So here I'm going to call NumPy array. This is just a provision which has been defined. And it is going to take embeddings basically. So whatever like embeddings one by one that we are trying to generate from this get embedding function, the function that we have already written. And then data type is as type I'm going to define, and data type should be float, float 32. Yeah, float 32. So it is going to add one by one everything inside the indexes. As simple as that. And here, so maybe I can try to like call chunk mapping, which is nothing but an empty list for me, and then append what? So append all the chunk one by one, try to append all of this chunk over here. Now this operation, only this operation, I would say only 2 line of operation will be responsible to store this entire information, into a Facebook AI similarity search vector DB, where it can store, where vector DB has been designed to store all of these embeddings. So if I'm going to execute it, it is going to do its work. As you can see, it is trying to like take some sort of a time, because it is trying to call my URI, right? It is trying to call my URI, it is trying to get the embeddings one by one. If you would like to print those embeddings, you can try to print those embeddings as well for the verification. So embeddings one by one, it will start printing. See, for the first, second, it is able to create the embedding. For third, it is able to create the embedding. For fourth, it is able to create the embedding. Fifth, and then sixth, and then for a seventh, it is able to create the embeddings. This is something that we are trying to store where? This is something that we are trying to store inside my indexes. Yes, inside my indexes, the indexes or the object that I have created inside my Facebook AI similarity search. But still over here, you will not be able to see any kind of a database. So to do that, you have to store this indexes. You have to save this indexes. You have to persist. As of now, it will be available inside your RAM, inside your main memory. Okay, fine. So if I have to store it, how I will be able to store it? So simple, Facebook AI similarity search, just try to call and then try to call a write index function. So whatever indexes that we have created, we can try to write it down. So we can try to give a file name over here called as index.faiss. Any file name like you can try to give over here faiss with the extension index.fuzzy. Now, object index flat to faiss, I have to keep it as a string. Okay. So now if I'm going to execute it, you will be able to see a file. So it has created a index.faiss and yeah, so this file is basically, if I'm going to open it up, you will not be able to understand this particular file because it is trying to store it in its own object format, So successfully we are able to invoke one of my vector database, which is a Facebook AI similarity search, and then I'm able to store all of my data, which is embeddings inside this particular database. This is how easy it is, guys. Again, so if I'll talk about a ChromaDB, if I'll talk about a Waviate, if I'll talk about a Pinecone going forward, you will be able to find out that it's very simple. It's just a database, right? So just like a SQL database or NoSQL database where we try to store a different kind of an entity as per the definition of the database. So here we are trying to store what? We are trying to store this one. Yes, we are trying to store this one. Simple. Yes, simple. We are trying to store this particular one. So hope all of you are able to understand that how we can try to invoke our vector database, and then I can try to store my entire embedding which I am able to create from my embedding model into a vector database. Simple, right? Simple. Now, what is our next step? So next step is going to be, so as of now, what we are able to achieve? So we are able to convert into our embeddings, and now all of these embeddings are available into my vector DB, right? So we are here. So all these informations are available, my private information, by the way. So whatever data that I have taken, so my private information is available inside a vector DB. Now, what is our next step? So next step is to perform a query operation, right? To perform a query operation. Now, whenever I'm going to perform a query operation, right? Whenever I'm going to perform a query operation over here, so it should convert my query. It should convert this particular query into a embeddings, right? Into an embeddings, and then it should search where? It should search inside the vector database, right? It should search inside a vector database. So top K rank value or top similar search, it should be able to extract, and then it should pass this one to the LLMs. This is what we need. So whenever I'm going to query anything, it should search into the vector database. This is what I have written even over here, right? Even this flow is going to do the same. So we are going to search into a vector database for any query. So we are not going to hit our LLM directly. Generally, when we do a chat with a ChatGPT kind of a model, so what we do, we just write a query and we are hitting a ChatGPT model, and ChatGPT model will start generating a response, but not here, not in case of a RAG. In case of a RAG, whenever there will be a query, right? Whenever there will be a query, so it is going to convert those query into a embeddings, the way we have converted our data into an embeddings, and then it is going to search into a vector database that with respect to this query, what is the information which is available, because it has to answer with respect to my private data, right? It has to answer with respect to my private data. So it is going to search into a vector database, by the way. It is going to search into a vector database. Now, vector database is going to give you a return, maybe a top K value. It is going to return means as like a top 3 similar result, or maybe top 1, top 2, top 5, top 10, whatever that you are looking for. So top result, it is going to return, right? It is going to return. So we are going to attach our query plus we are going to attach the return that we are able to receive, the embeddings that we are able to receive. We have to add it as I have mentioned over here, add symbol. So we have to add it, and then this will go, right? This will go inside my LLM so that my LLM will be able to do a formatting and it will be able to give me a final answer, right? Final answer. So this is something that we are going to do in my next lecture. So till then, thank you so much. Take care, everyone, and see you again in my next lecture. Hope all of you are enjoying this lecture. Okay, guys, so now coming to a final part of this entire operation that we were trying to perform. So we were able to take our own data. Eventually, we were able to convert our data into a chunks. Then we are able to convert our data into a embeddings. And then we are able to store our data into a vector database, which is a in memory I have taken. Okay. Now, so the next step is going to be query that particular vector DB that we have created, the indexes that we have created, and then try to retrieve some sort of information out of this one. And with the help of LLMs, let's format the final result and then show it to you. So this is going to be the final step, and this is where we are going to understand end-to-end how RAG is going to work. A retrieval augmented generation is going to work. So what is the meaning of a retrieval? What is the meaning of augmented? And then final generation, you will be able to understand all three words in a sequence. Okay. So let's move ahead, and this is the structure which I was talking about, by the way, right? This is the structure which I was talking about. So let's try to do one thing. So let's try to create a query, and then I will try to query my vector DB. So whenever we try to do a query, generally we try to do a query with respect to LLMs. But in case of a RAG pipeline, so in case of a RAG application, so we are not going to do a query directly to the LLMs because it has to give a response from my private data, right? A data about which LLMs are not aware about. So what I will do is I'll try to query a vector database, and inside a vector database, I have a embeddings which is available, right? So I have a embeddings. All of these embeddings means my information is available in a layman way. Yeah, my information is available basically in a numerical format. In a numerical format, my information is available. So what I will do is I'll try to query this Facebook AI similarity search database, and then based on my query, I will try to extract a top result, maybe top 1, top 2, top 3, top 5, whatever, right? Whatever I want. So I will try to retrieve those information, and then those information which I'm going to retrieve, right? Those information which I'm going to retrieve plus the query which I have sent. Again, remember this, guys, this is very much important, right? And many people get confused over here. So whatever information which I am going to receive from my vector database, whatever top information which I'm retrieving, plus I'm going to append my query. Yeah, plus I'm going to append my query together, and I will send those entire information to whom? To my LLMs, right? To my LLMs, to my large language model, so that it is going to format the entire response. It is going to make it polished, and then you will be able to receive a final structured response. So now let's do one thing. So here is a very small function I have written, a retrieve top k. Retrieve top k means what? So query, you are going to send any kind of information. Maybe you can try to ask that who is Sudhanshu Kumar, because the data set was all about me. Data set was all about a founder story. So who is Sudhanshu Kumar? So what it will do? So it will try to convert this query into an embeddings, means into this particular format of size 1536, because that's what this embedding is going to return, right? This function is going to return. So it is going to basically give me a embedding, and then you are going to do a search. Where you are doing a search? Index.search. What is this index, by the way? Index is my Facebook AI similarity search database object. So it is going to do a index.search, and it is going to search this query, and then it is going to return you something, right? Then it is going to return you something. So what is that something that we are looking for? So see, what it does is that inside that, based on the cosine similarity, or based on the Euclidean distance, or based on any other, right? Any other like a similarity check algorithm. So where it will just try to check the distance. So in a layman way, so unless and until I'm not talking about this, how search actually happens and what are the algorithms which is available, because there are multiple algorithms which has been supported by even Facebook AI similarity search in terms of matching the data. In terms of matching the data means we have this vector, right? We have this particular vector and we are trying to create again another vector. So we are trying to check that, okay, so which one is nearest? Which one is nearest, right? So in a layman way, if I have to explain you, right? So maybe I can try to explain you in this manner. Let me, open up this one. So see, let's suppose if I have given you two coordinates. So I have given you basically two coordinates. So here basically it's a x1 and then y1, and then it's a x2 and y2. I have given you this coordinate, right? I have given you this coordinate. Now, if I'm going to ask you, this is point A and this is point B. Now, if I'm going to ask you that what is the distance between these 2 points? Now, this is also vector, right? This is also vector because it is representing a magnitude as well as it is representing a dimension, right? In a dimension in a 2D space. So if I'm going to ask you that what is the distance between these two, so maybe you can try to choose maybe a Hamilton distance, maybe Euclidean distance. So here I'm going to use Euclidean distance. Euclidean distance is what? So x1 minus x2 square plus y1 minus y2 square, right? So this is going to give you a distance between point A and a point B. Simple. This is going to give you distance between point A and point B. Now, similar kind of operation is going to happen even over here. So whenever I'm going to fire my query, right? Whenever I'm going to fire my query, so it is going to convert my query into a embeddings. Now, this embedding, right? This embedding will be checked with the embedding which is available into my Facebook AI similarity search database, because even inside this, what we have, so we have eventually embeddings of my original data, right? So it is going to check, basically like a top 10, top n, or maybe top 3, top 2, whatever you want, right? So it is going to check that whatever query which I'm going to fire, so with respect to this query, what kind of a data set we already have inside this vector database, right? Vector database, and it is going to return you a top result. It is going to return you top result. Now that top result depends upon me. That top rank depends upon me. I can look for 1, I can look for 2, I can look for 3, I can look for n. That completely depends upon me, that what is the top result. So similarly, so the nearest one, it is going to give you in a first place. The second nearest one, then the third nearest one. This is how it is, right? This is how it is. So this is not a rocket science, by the way, that we are trying to learn. This is a very simple fundamental concept that we are trying to learn over here. Not a rocket science at all, means literally not a rocket science at all that we are trying to explore in this particular place. So here it is going to like get top 1, top 2, top 3. So the nearest one is going to be top 1, then top 2, then top 2, top 3, and top n. It is going to return. You can try to do an experiment to make your RAG better and better, more contextual. So it is going to return it, and whatever it is going to return, let's suppose it is going to return this top 3 values. For example, I'm trying to extract top 3 values. So with this top 3 values, I'm going to attach even my query embeddings. So query embeddings, I'm going to attach. Now this will become my whole data. This will become my whole data. Now this data I'm going to send into the LLMs. Now what is the roles and responsibility of LLMs? So roles and responsibility of LLM is to format this entire information, whatever information that we have, right? Format this entire information and give me in a polished way. Give me in a way so where human will be able to read, I and you will be able to read, as simple as that. But it is giving me all the responses based on what? Based on my own query and my own data, which I have stored inside my vector database. Simple, right? Simple. So even LLMs, how LLMs, forget about that. So that's a different story. Maybe I'll not try to open up that story now. In the future, I'll try to open up that story. Okay. So here, what will happen is that it is trying to retrieve a top k, right? I have given k is equal to 3. I can give k is equal to even like a 4 over here. So top 4 nearest embedding vector, it will try to like extract, and then it is trying to return me what? So it is trying to return me basically a chuck mapping for that one. Chuck mapping for that one means what? So if you remember what we have done, so we have basically CHUCK. CHUNK chunk mapping. Chunk mapping was what? This one, right? The final list that we have created. So where we had all the chunks available to us. Yeah, all the chunks available to us in a original format. So one by one, one by one, one by one. So it is going to give me like extract it, and then it is going to return me this one. So for like a top k is equal to 4, whatever that we were looking for, right? So it is going to return me this entire information. Okay, execute it. Now, so this is done. Now what we have to do is, so we have to prepare basically a prompt, right? We have to prepare basically a prompt. So here what I'm going to do is, so I'm going to write this very simple function. So inside that it's a string. As you can see, this entire selected part is basically a string. Now this string is a formatted string. It is taking what? So it is trying to take a couple of input, right? It is trying to take basically a couple of input over here. So I'm just trying to build the prompt over here that whatever chunk that we have received from my vector database, right? Whatever chunk that we have received from my vector database, and then whatever query that I have, right? Whatever query that I have. So accordingly, try to build a prompt. So use the following context to answer the question. So context is what? Context is something that we are getting from the chunks. Means from my vector database, right? So we are trying to extract the embeddings, and then eventually we are trying to find out that, okay, for this embedding, what was the total, like what was the line basically, right? What was the line? And then the question, query I'm trying to attach. So this is the whole string I'm going to prepare. Just a string, just a plain simple string we are trying to prepare. We are not doing anything much, right? We are not doing anything much. So this is my build prompt function. And then what I will do is, so I will try to call, right? I will try to call basically a chat completion function that I have introduced you in a very first lecture. So calling my LLMs, guys, by the way, nothing different, right? So calling my LLMs basically, so that I will try to pass my entire message. I will try to pass my entire prompt, and then I will be able to get the response. So I have just manipulated my temperature. Maximum token is 500. This is the prompt it is going to take as an input, and then I can change my model over here. So I can try to use maybe a llama, maybe a DeepSeek, or maybe a Maverick, whatever I want. I can try to use it. I have an access of a multiple models inside URI, and URI API key already I have given. So this is going to like hit it with my prompt. What is my prompt? Prompt is nothing but a plain string, but inside this string, I have two things. I have my query, and I have a retrieval data from my retrieve data from my vector database, right? Retrieve data from my vector database I have. So, okay, execute it. So all these functions are done. Now what I will do, I'll try to prepare my query over here. QUERY query I'm going to prepare. Now I'll try to show you the demo. QUERY query. So query is equals to tell me who is Sudhanshu. Yeah, it's because I have taken a founder story data. So tell me who is Sudhanshu. Now, whenever someone is trying to fire a query, right? Whenever someone is going to fire the query, you have to follow what approach? You have to follow this approach. So you have to convert that into a embeddings, and then you have to extract a relevant information from a vector database. Okay, fine. So whenever someone is going to fire the query, so I'm going to call basically a retrieve top k. And then inside this, I'm going to pass my query is equals to my query over here. So I'm going to pass my basically query. QUERY query I'm going to pass. This is what it was taking, right? It was taking a query, and then k is equal to 4 I have given, means just give me 4 similar, like a 4 nearest result, as simple as that. So k is equal to 4. If I would like to manipulate, I can try to manipulate it. So this is going to retrieve, right? This. So once I'm going to execute, as you can see, it has given me 4 lines, right? It has given me 4 lines. It has given me basically 4 lines. 4 lines is coming from where? So 4 lines is coming from my vector database, index.search. It is trying to search the indexes, and eventually I'm doing a mapping over here, a manual mapping, right? That whatever indices it has returned. So just try to do a mapping that this belongs to which one. Means I'm just trying to show you like a result in an English format, readable format. Otherwise it will be available into a vector format. Okay. So I'm able to like extract this entire like a result. So this is the result of the retrieval top k. Now, if I'm going to write k is equals to maybe like a 2, it is going to give me only 2. So it is going to query, and it is going to give me only 2. So 2 sentences it is trying to give me, as simple as that. So like as of now, more is better. So here I'm going to like write maybe 4. That's completely fine. So 4 things it is going to retrieve. Now I'm going to store this information into some of the variable. So top chunks. Okay. So top chunks I'm able to receive. Now, whenever I'm going to receive a top chunks, I have to call what? I have to call a build prompt. So now let's try to build a prompt. Yeah. Now let's try to build a prompt and pass the prompt inside my LLM. Simple. So here I can try to call my build prompt, and here, so what I can do is I can try to pass my top chunks. and a query, because this was taking what? This was taking basically a query, means top chunks, whatever chunk that we have, plus query, right? Plus query, so that my LLMs will be able to understand a question as well as the data that we are trying to retrieve. So here a query. So I'm just going to pass the query altogether. So this is going to return me what? This is going to return me basically a prompt. Now you can see that prompt, you can check that prompt over here. So use the following context to answer the question, and as you can see, whatever it has retrieved. So, and plus the query, who is Sudhanshu? Tell me who is Sudhanshu, right? Just tell me who is Sudhanshu. It is trying to append each and everything, and then it is like trying to build the final prompt. So this is my prompt that I'm sending to my ChatGPT, my GPT model, by the way. Yeah. So here prompt I can try to write, and then this prompt I will be sending where? So I will be sending in a generate completion, so that it is going to hit my URI API where I'm calling my GPT 4.1 Nano. Yeah. So here, basically it is going to call a generate completion, and inside that it is going to hit a prompt. Prompt is equals to prompt, by the way, and it is going to give me a response. So now this is called as final retrieval augmented generation. So Sudhanshu is an accomplished technologist, entrepreneur and educator who hails from Jamshedpur, Jharkhand. Overcoming financial hardship, he pursued a degree. So see guys, this is not the exact word which I have mentioned anywhere, but this LLM is helping me out, right? This LLM is helping me out based on what? Based on the data that I'm trying to pass and a query, right? Now I can try to ask a question over here that what was the company Sudhanshu has established. So I can try to ask any kind of a question with respect to, and the company's Sudhanshu established is Euron. Yep, simple, right? It is able to give me an answer the way I was looking for. So this is the beauty of RAG. You can try to what is the birthplace of Sudhanshu? I can ask any kind of a question. I can ask like whatever I want, the way I want, and Jamshedpur, Jharkhand, India. Yeah, Jamshedpur, Jharkhand, India. Simple, right? So this is the beauty of RAG, guys. So now my LLM is able to answer based on my own data, right? Based on my own data. So that's the beauty of LLMs, and that's the beauty of RAG that we are able to achieve. So retrieve, augment, and then generate it, right? Retrieve, augment, and then generate it. So end to end, we are able to perform this kind of operation. So with that, thank you so much, everyone. Hope all of you are enjoying it. And then in a next lecture, I'm going to convert the same thing I'll try to use, not different. I'll try to convert this entire things into a modular coding, and then what I will do is that I'll try to like host it somewhere. I'll try to deploy it somewhere. Yeah. So with that, thank you so much. Take care, everyone. See you again in my next lecture. Okay, so welcome to Euron, guys, and welcome to lecture once again. Now we are able to see a end-to-end RAG pipeline, and we are able to build it inside a Jupyter notebook. Now it's time for all of us to make a code modular, a same code that we have written. So make a code modular, and then let's try to deploy this entire code into a Streamlit platform. That is a part number one. Then we will try to deploy this entire code on a render platform, and then I'll try to show you to deploy this code inside AWS Elastic Beanstalk in a phase-wise manner, step-by-step manner. So we are going to move, and we will try to do each and everything. But yes, code is going to be same. It is not going to be different at all. So let me share my screen, and this was a Jupyter notebook file that we have created. So where we have tested each and everything end to end, end to end, end to end. And again, so we have a data set over here. Now what I will do is I'll try to make this entire code as modular as possible. So to do that, let me create a fresh folder over here, and I'm going to write Euron _RAG _ application. Yeah, application. Now inside this folder, what I will do is I'll try to create a app.py file, so which will be an entry point for my UI. I'm going to create not a complex UI, it's a basic Streamlit based UI. So where you can try to input something, and then you will be able to get a final result. So fine, so app.py file. Now inside the same folder, so I can try to create a utility file. So utility folder, first of all, utils, that's a norm. So whatever utility that we are going to create for an embedding, checking, retrieval, prompting, or completion. So we are going to keep all of these files inside this particular folder.
So now inside utility file, so what we are going to keep? So we are going to keep basically embedding.py file. So inside this utility file, so let's try to keep embedding.py file. Now, so inside utility once again, so let's try to keep a chucking.py file, so which is going to do a chucking for me. Inside utility, so let's try to keep a retrieval.py file, small modules, all of these modules. Now inside this utility, let's try to keep a prompt.py file, not here. So inside the utility, let's try to keep a prompt.py file. Now inside this utility, so let's try to keep a completion.py file. So here itself, so I'll try to keep a completion.py file. Now let's close everything. So we don't have to keep it open each and everything. So yeah, let's close it. So we have basically this particular folder, Euron RAG application, and then inside that, so we have a utility. Inside that, we have created all of these 5 small utility file. Now, as of now, I'm not trying to keep a code over here. So I'm just trying to create the structure. Simple, right? So utility. Then app file we have over here. Now inside the same main folder, main project folder, so we can try to create maybe a data folder. So where I can try to keep my data, and here, so I'm going to keep my founder story.txt. So this particular founder story, so I can try to maybe keep it here. Okay. So I'll try to keep my founder story.txt. So where I had this unstructured data, so I'll try to keep in this particular place. So data file is done, utility is done, app.py file is done. Then inside this main folder, I will try to create basically a folder. So where it is going to keep all the indexes for a vector database. So here I can try to keep index file, basically index.facebook AI similarity search, and then chuck mapping. So the original data that we have, so we can try to keep it everything here. Inside this particular folder itself. So inside in pickle file, we can try to keep it. And then finally, so we can try to keep a requirements.txt file, so which is required to set up a complete environment. So this is the requirement.txt file. So where I will be keeping each and everything. Yeah. Okay. So once this folder structure is created, where we have a data, where we have a vector, where we have all the utilities, and we have a main entry point, which is a app.py file, and we have a requirement.txt file. So now one by one, so we can start putting up all the code. So first of all, we'll try to start from a requirement.txt, because this requirement.txt will be even required while doing a deployment, so that it will be able to install all the required things. Otherwise, your code is not going to work. So inside this requirement.txt file, so I'm going to keep Streamlit, and then Facebook AI semantic search CPU, NumPy, and then request, so that whenever I'm going to spin my environment, whenever I'm going to deploy this entire things, it will be installing this entire things inside that particular environment. All these 4 files, all these 4 pip, it will try to install, or all these 4 packages, it is going to install it. Okay. So requirement.txt is done. Now, coming to basically a very first file, so which is a app.py file, which will be responsible, right? Which will be responsible for, extracting data, or doing all of these things, checking and completion and embedding and prompting and retrieval. So we can try to call all of these things inside my app.py file. But once I will be having all of these things, checking, completion, each and everything, once I will be having, then only I can try to perform that operation. So let's close this one, and let's start looking into the utility files. Yeah, utility files in a very first place. So the very first thing which I'm going to do is embedding. So which is going to convert, or which is going to create a embedding for me. So here is a code, and it's a same code that we have written inside a Jupyter notebook. It's a same function that we were using inside a Jupyter notebook. We are trying to pass a URI API key over here, right? So we are trying to pass a URI API key over here. Apart from that, so we are not trying to perform anything else. How we are going to pass a URI API key? Because it will be required here, as well as it will be required inside my LLM. So this is the embedding. This will try to generate the embedding. That's it, nothing much. So how we are going to pass a URI API key, we'll talk about that part as well. But one by one, let's try to fill up the code which is available inside my IPYNB file as well. So here, the second code which I am going to fill is a chucking. So chucking means it is going to take the text, and then one by one. So it will try to convert that one into the length of 100 words. As simple as that, right? So embedding is done, chucking is done. And then I'm going to fill this retrieval.py file. So which will try to retrieve my entire embeddings. So from where? So from obviously my FASI store or my vector store. So it will try to extract all of these information. So I'm going to keep it here, same code that we have used, and then we are going to fill a prompting, so which will help me out in terms of preparing the entire prompt, which will be a combination of my query plus the context it is going to retrieve for my vector database. And then there is a completion which is pending. So this is going to help me out in terms of hitting my LLM. So as of now, model wise, I'm giving this one. You can try to change your model as per your requirement, as per your wish. So now once this entire things will be done, once this is available, now I can come to, once this 5 files are available to me, then I can come to app.py file, which is a main file, which is going to call each and everything. So how it is going to call, see, so it is going to call utility.embedding. It will try to like do a get embeddings utils, right? UTILS. Let me change this folder name. So here by mistake, I have done that. So UTILS. Okay. So now it will be able to recognize. Fine. So here, what we are going to do is, so we are going to call basically our get embedding, or maybe a chuck text, maybe a load FASI and retrieve chucks, and then build a prompt and then generate a completion. So this is something that this app.py file is going to perform. And then it is going to build a simple small application. So where it is going to ask you to enter your question, a very simple like a UI we are going to build. And once you are going to enter your question, so it will start calling like a load FASI indexes, then it will try to retrieve the chunks, and then it will try to build a prompt, and then it will try to generate a completion the way it was doing it with respect to my IPNV file. And then finally, you will be able to show the answer, right? So whatever answer that you are able to retrieve from your private data with the help of this entire RAG application, you will be able to see that particular part over here. Okay. Now, so what is next in this place, guys? So the next part is, okay, so now the next part is basically we have to run this entire project, and we have to basically test this entire project, and we have to check that whether it's working in my system or not, in my local system. And once this will be working in my local system, then what I can do is I can try to deploy this one into a Streamlit app. And once that is working on a Streamlit, maybe I can try to deploy it on a render, and then eventually on a AWS. So back to back, we will try to do these things. Okay, so code wise, it's nothing different. So here I have just added one Streamlit app, and I believe you all are aware about it because this is what I used to teach even in my Python classes, right? It's a very simple app, a Streamlit app that we are trying to create. Now, what I will do is I'll try to execute first of all a requirement.txt file, because inside this requirement.txt, all the installation is ready. For any project that you are going to create in your local, it's my sincere advice to all of you that please try to create a separate Python environment. That will help you out not to maintain the entire environment, but even it will help you out in terms of removing any kind of a dependency conflict or version conflict between our different packages. Because what happens is that when you are trying to run everything in one single environment, because of some package conflict, some of the application is not going to work, and they are going to give you some sort of a dependencies issue, some sort of a version issue, by the way. So just to avoid it, what I can do, I can try to create a new environment. So I'll go to my command prompt, and then here I can try to create my new environment. So I can try to write over here that conda create -n, and then Python is equals to 3.10 and above, anything is fine. And yes, installation wise, just try to do all the, sorry, I forgot to give a name. I think it should not work. So conda create -n and then Euron _RAG. This is the environment name I'm going to give, guys. Yeah. So that it will be able to create the environment for me. Okay, so environment is created. Now what I can do is I can try to activate this environment. So conda activate your environment and then RAG. So let's try to activate this environment. Now let's do dir. This entire folder, right? So Euron RAG application folder is available over here. Yes, it's available over here. So I'll go into this Euron RAG application folder. Now if I'm going to do again a dir, it is going to show me all of these files, app.py file, which is going to my entry point, then data folder, then this Farsi store, then requirement.txt, and then utility. So first of all, I have to execute this requirement.txt and I have to install this requirement.txt. So here what I will do is I'll try to write like a pip install -r requirements.txt so that it will be able to install all the requirements, whatever I have mentioned inside my requirement.txt file, and it is going to prepare my environment. Now, same thing is going to happen when you are going to deploy these things on a real time on any cloud platform. So this is where requirement.txt comes into a picture. It will try to prepare your environment because any cloud environment is going to give you a similar kind of a compute, right? Similar kind of a compute or a storage or maybe a RAM main memory. It is going to give you, depends which kind of environment, what kind of environment you are going to choose. So pip install -r requirement.txt, now hit enter, and it will start installing each and everything that I have mentioned inside my requirement.txt, as you can see. Yeah. So just wait for some time and we'll test our application once it will be done. Okay, so looks like environment setup is done. I can try to clean my environment, clean my entire like a CMD, and here we can try to close my requirement.txt file. Now, if you remember, inside this embedding and inside this completion, right, chat completion, so we are using URI API key. Yeah, we are using URI API key. Now, I'll even try to teach you that what is the standard way to keep a API key, by the way. Fine, API key, by the way. And I have added these two lines of a code just to load an environment inside my local system. Otherwise, it is going to give me an issue. So here, URI API key, and I'm going to keep a URI API key into a main folder, this particular folder. This is the project folder, so I'm going to keep it. How? So I'm going to click on this file, and then I'm going to create a .env file, .env file. Now, once I'm going to create this .env file, inside that, so I'm going to keep a URI API key, by the way. So here, this is the variable, and then equal to, and inside this, I'm going to keep a URI API key so that in a runtime, it will look into the environment file and then it will try to obtain a secret. So how I will be able to get a URI API key? Same. I think we have been using it since a long time. So this is my URI API key, by the way, guys. So here, from here, it will try to like load the URI API key. Okay. So even environment file is done. Now close everything. Now my completion and my embedding will be able to get a URI API key and it will be able to execute it. Next is what? So next is, let's try to test the application. So let's try to test our Streamlit application. And if there will be any bug, if there will be any problem, so we'll try to resolve those bugs. We'll try to resolve those problems. So here, to execute a Streamlit app, so you have to like check first of all that whether app.py file is available or not. So yeah, it's available. Now I'll do CLS. Yeah, I'll do CLS. And then I can try to call a Streamlit, 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 and app Streamlit run app.py file, and then hit enter. Now, once you are going to hit enter, it is going to pop up this kind of application in your local system. Yeah, in your local system. Now here, so enter your question. So who is Sudhanshu? So I can try to ask maybe who is Sudhanshu, and it is giving me this issue with respect to indexes. Okay, so maybe it is not able to create a proper indexing. I'll try to fix this particular issue. Okay, so there was a small issue with respect to a retrieval.py file. So it was not able to like build basically this indexes, and it was not able to store it. So now I have done that. I have rectified that mistake. It was a small one, not a big one. So where it is supposed to read the data, and after reading a data, so it should be able to, create indexes, and it should be able to store chunks inside a file. So that at the time of like, hitting my queries or hitting my entire RAG application, so it should be able to give me a response. Okay. So now just do one thing. So let's close each and everything. We have some sort of a data over here. Let's close each and everything. Now I have a clean build, and then let's try to execute the application. So Streamlit run app.py file, and let's try to test it. And hopefully everything should be up and running. So here, tell me about Sudhanshu, right? So now if I'll go and check my VS Code, so it must be doing something. So let's see. So here, tell me also Sudhanshu. So answer is Sudhanshu is this. And the chunk which it was able to retrieve was 3. As I have given, top k is equals to 3. So if you're going to change it, so it obviously this chunk is going to be different. Tell me about birthplace, about birthplace of Sudhanshu. Yeah. So it should be giving me, yes, this is my birthplace. This is the answer, and it is able to fetch all of these answer from all of these 3 different kind of a chunk. Okay, so now tell me about company established by Sudhanshu. So it will be able to give me some answer. So let's just wait. So yeah, it is able to give me like the provided context is specific company established, highlight that personal journey, but there is no information about him founding a company. Okay, maybe that is not available as a part of my data. What was a company Sudhanshu was working for? Maybe I can try to ask a question in this way. So yeah, whatever data is available, so obviously based on those data, it is going to give me a response. It is going to perform this RAG operation, retrieval augmented generation operation. Now, once all of these things are done, right? Once all of these things are done, now it's time for us to deploy this application, to make this application public so that anyone and everyone will be able to access this entire application. Now, the very first deployment which we are going to see is a Streamlit platform itself. So a Streamlit platform provides you a place for a deployment. They are going to give you an environment for a deployment. Then our next deployment is going to be a render.com, and then our next deployment is going to be a Elastic Beanstalk from AWS. So here I can try to click on deploy and let's see. So what it is going to pop up. So it is going to pop up like a Streamlit Community Cloud, Snowflake for Enterprise or other platforms. So I'll be choosing this one. So I'll be choosing this particular one. And yeah, so unable to deploy, close it. And then let's do one thing. Go to Google and try to like search for Streamlit and Streamlit Cloud maybe. And it is going to show you a Streamlit Community Cloud. You have to go and you have to create an account for the very first time. So maybe you can try to click on free. And then it is going to ask you for a sign in. So let's try to do a sign in over here, sign in with the Google, which is the easiest one. Okay. So it is trying to set up my account and then continue. So I'm not doing much, just continue. Now here you will be able to find out this kind of an interface. Now this kind of an interface is going to help you out in terms of doing a Streamlit app deployment. So here I can just click and just try to create an app. Create app option is given to me. So create an app, and then here it is asking you to connect it to a GitHub. So technically you have to push your code inside a GitHub, and from a GitHub you will be able to connect your Streamlit, and then eventually you all will be able to do a deployment. As simple as that. Unless and until you are not connected with a GitHub, it is not going to allow you for a deployment. So I have to go to GitHub. I have to do a login inside my GitHub, and then I have to push this code which is available in my local directory to a GitHub, and then it will be able to do a deployment happily. Okay. So let me do it. I'm going to unshare my screen because I have to do a deployment. Sorry, I have to do a login into my GitHub. I don't want to like show the credential. So let me do a GitHub login, and then I will start sharing my screen once again. And I believe we all know how to log in into a GitHub account. So let me extract my GitHub credential. Okay, so I'm able to find my GitHub credential. Now I'll just go to GitHub login and I'll try to do a login over here, and then I'll share my screen, guys. So I have applied an authorization. So authenticator. Okay, so now I can share my screen. I have already logged into my GitHub. So this is my GitHub, and where I'm going to create one repository. So create a repository, and maybe I can try to click on your repository, and then I can try to click on this new, and this is going to help me out in terms of creating a new repository for me. So here I can try to click, and I can try to write like a RAG demo application. So this is the repository which I'm going to create, and rest of the thing is as it is. Now create a repository. Now this repository has been created, and this is the command to push my code from my local to a GitHub repository. So one by one, I'll executing this command. So just come to this local installation or local like a file where you have, and inside this, right, inside this, so let me do dir, and here is my all the application which I have to push inside my GitHub. So cd Euron app RAG application, then I can do a dir. Now these are the files which I have to push, right? These are the files which I have to push inside my GitHub repository. So here what I can do is I can try to do a git init, so git init. So I'm just trying to initialize a git, and as you can see, all this color has changed, right? It has changed. Now after doing this, I can try to write maybe a git add, and add everything which is available over here. So it is going to add each and everything. Now once this is done, right, once this is done, so I can try to call my commit. So git commit, same code, and maybe I can change my message for a commit. So git commit for first time RAG. Okay, so it is going to commit, and then what we are going to do, so then we are going to call this git branch main. So fine. Then we are going to execute this git remote. So, okay, fine, adding a remote. So where it is supposed to do a check-in, and then finally I'm going to push the code. So finally I'm going to push the code. So if everything is going to be well, so in that case, it is going to push the code, and looks like it is able to push the code, right? It is able to push the code. Now, if I'm going to like refresh this GitHub repository, right? If I'm going to refresh this repository, I will be able to find out the exact same structure. Each and everything is available to me now. Yeah. One more thing. So inside there is a file called as git ignore we try to create. So where we try to like mention that which file you are supposed to ignore. For example, .env kind of a file we should not check in inside my GitHub repository because it is holding my credential. It is holding my API key. But as we are doing it for the very first time, and I'm not worried about API compromise, you can try to use my API key. That's completely fine. As you are also a part of Euron, so you must be having your own API key access. You can use mine as well. I don't mind, by the way. But yeah, going forward, so I'll even try to show you that how to add a git ignore. It's a very small file .git ignore. We try to like add it, and inside that we can say don't add this environment file. So that whenever it is trying to do a commit, it will not try to add your .environment file or whatever file that you are going to ask for a ignore. Okay. So once this one is available, again, I'll go back to my Streamlit app. So because my code is available now inside my GitHub, I'll go to my Streamlit and then connect to GitHub. Now it is going to pop up a screen. Yeah. So deploy a public app from a GitHub, deploy a public app from a template, or deploy a private app in a Snowflake. So I'll be choosing this very first option, this one. Now here, so a repository, Sudhanshu Kumar Tech repo, and here I can try to paste my GitHub repository. So whatever GitHub repository in which I'm holding a code, whatever code that I have. So this is my GitHub repository, right? RAG demo application. So maybe I can try to search for a RAG demo application. This is the application, and branch is basically a main branch, the main branch, right? And main file path. So my app.py file is basically an entry point for a Streamlit. So I can try to select this app.py file because this is my entry point. Yeah, this is my entry point, and this is the URL which I will be able to receive. If I would like to change this URL, so maybe I can try to change this URL rag underscore demo underscore application. Whatever I want, I can try to change it. But here they have a restriction over here. So based on those restrictions only, you can try to give this name. Yep, give this name. So rag demo application.streamlit.app. Now there is an advanced setting. You can try to click on advanced setting over here, and you can try to pick and choose the Python version. So maybe I can say 3.10. This is the Python version that I have. And then if you would like to like define some sort of environment things, right? So some sort of a credential for a databases or any other credential, you can try to define it. Although I have already checked in my .env file, but still in a ideal way, the ideal approach is to keep your credential. So just copy and paste this one. So keep your credential here. So maybe I can try to keep it here and then click on save. So my secret is also save, and then I can try to click on deploy. So let's see. So if everything is going to be like work fine for me, then it is going to deploy, and now my app is going to be public. If there will be some error, then we'll fix it anyhow, right? It will take some time, maybe like 1-2 minutes of time, not more than that. Depends upon the application, that how many things you are trying to set up in a requirement.txt. So looks like my app is up and running, and check my URL. So now it's a URL which is a public one. It's not running in my local system. It's a HTTPS URL that we all are able to see, and it's a public URL. Now I can come over here and ask a same question, that who is Sudhanshu? And if I'm going to add this question, it should give me some sort of a response. It should give me some sort of a reply. So yes, I'm able to get a reply. So our app is public, guys, and successfully we are able to deploy it inside a Streamlit. Yes, inside a Streamlit. Now, next time I'll try to show you a deployment even inside a render. How to deploy this entire things inside a render. Render is also a cloud platform, so which is going to give you like all the feature and facilities with respect to this kind of a app deployment. So we'll try to show you that part as well. But yeah, till then, so I believe you can try to practice this, and then in the next section, let's push it inside a render.com. With that, thank you so much, everyone. Take care. See you again. Okay, so now welcome to the lecture once again, guys. And as we are able to deploy our RAG application in a previous lecture into a Streamlit, so now we will try to deploy the same thing in a different environment, and that different environment name is a render.com. Again, deployment is going to be a easy peasy stuff. I don't think that you are going to face much of challenges, and if you're facing it, obviously we have a URI to help you out at any stage. So let me share my screen, and my code is available inside my GitHub, and here is a Streamlit app which is up and running, right? The way it was expected. Then what we can do is we can again go to Google, and then we can try to search for a render platform. Yeah, a render platform. So render.com, cloud application platform. I can try to click over here, and then if I don't have an account, so maybe I can try to create an account. If you have an account, then it's a simple like a login, right? It's simple Google login that you can try to do. So here, what I will do is, so this is my like an environment which will look like in a very first beginning. So I can try to click on this new tab. This is the new tab, yeah. So I can click on this new tab, and then I can try to choose a web service over here. So choose a web service, by the way. And then what we are going to do is, so connect a Git provider. So we are keeping our code inside a GitHub. If we are keeping a code inside a GitLab, then obviously I'll try to connect from a GitLab or else into a big bucket. So here I'm keeping all of my code inside a GitHub. I can keep it anywhere. That's completely fine. So GitHub, I can try to choose, and it will try to authenticate with my GitHub, and here is the application. So after authentication, so I'm able to see that RAG demo application. So this was the application which I have pushed inside my GitHub. So I can try to select this application, and then name of the application. So you can try to like choose a name of this application. Python language, Python 3 I'm going to use. I don't have anything else. I can even deploy it as a Docker image, but yeah, as of now, let's try to choose this one. So branch wise, main branch, region wise, fine, whichever is going to give me like a free. Root directory is a default one, and then build command. So build command is basically a command which is going to set up my entire environment. So by default, it's a requirement.txt. So I'm going to choose it. And then there is a start command. So as I have a Streamlit app over here, so I can try to give a Streamlit command, a Streamlit run, and my Python file, entry point. So my Python file name was what? My Python file name was app.py file, right? This is what we have created, app.py file, which is an entry point. So I'll try to give this one. I can try to choose a free over here, a free option, right? So they're going to give you a limited resources. If you are going with the paid one, obviously you will be able to access our resources. Not just that, so scaling and zero downtime, many things they are going to provide you with the paid one, but with the free one, these are the things that you will be able to get. Now environment variable, so I can try to mention environment variable in a production in this way. So from a env, URI API key is a variable name. URI API key is a variable name, and then what is the value? So value is my API key. So this is my value, by the way, API key. So I'm going to keep my API key over here. Okay. Now advanced, so I don't have to go into the advanced section as of now. I don't have to use anything. So I can try to collapse this advanced section. It's completely fine. Now these are the only setup, guys, that you have to do. Right, port number automatically it will try to choose. I have not hard coded any of these port because it has to run on some of the port. Now once I'm going to click on this deploy, it will take some time, maybe 2 to 3 minutes of time, although it's a very small application. So keeping that in mind, 2 to 3 minutes of time it is going to take, and if there will be some error, obviously I'll be able to see that error. And here is the URL, guys. Here is the URL reg-demo-application.onrender.com. So this is the URL. Now at this URL, I will be able to access my application. As of now, it's in a building phase, right? As of now, it's in a building phase. And one good part about this one, or maybe even a Streamlit, is that if I'm going to make any changes into a GitHub repository, I can do a setup of auto deployment. So whatever changes you are going to do continuously, let's suppose you are trying to deploy something, you're trying to write a code, you're trying to push that code, automatically it will keep on sensing that, and it will always go for the first deployment. As of now, as you can see, it is trying to go ahead with basically a deployment. So installing all the things which I have mentioned inside my requirement.txt file. So technically it is trying to prepare my environment, right? A simple thing is it is trying to prepare my environment, as simple as that. Now here on your left hand side, you will be able to see a scaling option, which is one of the very good option you will be able to find out in terms of hosting an application for a huge traffic. Plus you will be able to see a log option or matrices option. So you will be able to see all kind of a log. So who is going to hit, from where people are hitting your application, all this detail. And if you are trying to do something like some logging manually. Matrices, so it's not available for a free version. You can try to click over there and it is going to ask you to do some sort of a payment. Now looks like my build is successful. It is able to build the entire environment, and now it is trying to deploy, means it is trying to allocate a URL and a port number basically. So just wait for a couple of more minutes, maybe just one single minute, and I'll just leave my screen as it is, so that when you will deploy the same application, you will be able to find out the similarity. So running a Streamlit app. Okay, so it looks like it's running, and it's running. Still, it's in a building phase. So once it is going to finish, I will be able to click on this URL. So your service is live. Okay, amazing. So I can now click over here and let's try to check whether my service is live or not. Looks like it's live, guys. Yes, looks like it's live. Yeah, now I am able to get a tag, right? So live tag. So now I can try to come over here and then ask a question that tell me about Sudhanshu, right? And hopefully it should be able to give me a final response. Okay, amazing. So here is a response, RAG response, which I'm able to get. And now this application is available on render.com. Yes, render.com. So this is a second deployment that we have done back to back. So after Streamlit. Now in my next lecture, I'm going to show you that how you will be able to deploy the same application on AWS Elastic Beanstalk, so that you will be able to deploy it even on AWS. I can going forward. So I'll be showing you not just AWS, I'll be showing you all major cloud platform deployment, Azure and GCP, CI/CD, many more things. We have other lectures as well, right, around same thing. So obviously at the end of the day, I wanted to teach you not just like something which is running in a local, but yeah, end to end, so that when you will be building something, you will be doing the exact same operation. So with that, thank you so much everyone. Take care and see you again in my next lecture. Okay guys, so as we are able to deploy our application on a Streamlit cloud platform and a render, so now it's time to deploy this application on a AWS platform. So let me share my screen, and we'll have to do a couple of changes with respect to AWS deployment. So I'll try to show you those changes as well. So here, just try to go to Google, and then from here, so you can try to search for AWS console login. And here, so just try to log in into your AWS account. So if you don't have an account, so please try to create an account first, then only you will be able to log in. So let's click on sign in, and yeah, so I'm going to sign in using my root email address. So I'm going to select my root, and I have my credential with me, so which I'm going to use to do a sign up. So my email ID. Okay, so this is my email ID. Then next, and I'm going to put up my password. Obviously, password won't be visible to any one of you. So here, and again, I'm going to call a sign in. It is going to ask me for my MFA code, multi-factor authentication code. So I'm going to pass, which is running in my mobile. So here, okay, so let me pass this one. And yeah, so I'm able to log in inside my AWS account. So this account login is required. So unless and until you don't have a account, you will not be able to perform any kind of a operation. Now just come on this search tab and then search for Elastic Beanstalk. So ELASTIC, Elastic Beanstalk. So here you will be able to find out application called Elastic Beanstalk. Now what Elastic Beanstalk does is it is going to help you out in terms of deploying any kind of a BIV application. So as you can see, Elastic Beanstalk is an easy to use service for deploying and scaling a BIV application and a services deployed with a Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker on a familiar servers such as Apache, Nginx, Passenger, and IIS. So this is something which Elastic Beanstalk is going to do. Now you have to click on create application. So first of all, you have to create an entire Elastic Beanstalk environment. Basically a container, or you can say a system you have to spin with respect to a Elastic Beanstalk. Then only you will be able to do a deployment. Otherwise, you will not be able to do a deployment. So I'll try to create this environment first, and then I'll try to tell you that what kind of a changes you have to make inside your code to deploy it. So I'm going to deploy inside this Elastic Beanstalk as a Docker file. Yeah, as a Docker file, I'm going to deploy it without even Docker file direct as a Python application. I will be able to deploy. There are multiple ways of doing a deployment, but yeah, so I'll try to show you the easy approach. So here application name I can try to give, and application name is basically RAG underscore app underscore Euron. Maybe this is the application name I'm going to give. Yes. And then I can try to leave a domain so that it will be able to give a domain automatically, or maybe I can try to give a domain name over here, RAG app hyphen Euron, and it is going to check that whether this domain is available or not. So looks like this domain is available. So at the end of the day, so this entire app will be available on this particular domain. So whatever I'm going to deploy, it will be available over there. Then you should come over here inside the platform section, and you have to choose the platform. So which platform you are going to use. This is very important. So here I'm going to use a Docker. Means I'm going to convert my entire file as a Docker image, and it's a very simple step. It's not a very a different step, difficult step. I'll try to show you that part. So here I'm going to choose a Docker, and then Docker anything. So this one I can try to choose platform version recommended, this one, and then I can try to click on next. Leave everything as it is. Don't have to do any kind of a changes at all. Okay. So click on next. Now these two things you have to set. A service role you have to set, and a instance profile you have to set over here. So if you are logging for the first time, or if you're trying to deploy for the first time, so you can come over here and then you can try to create a new IAM role, which is going to help you out or help your Elastic to access the things. So here click on next, and then click on next basically, and then click on create role. So it will end up creating a role, and here you can try to give a name. So Euron RAG application, right? Euron RAG application, and then create role. So with this Euron RAG application, it is going to create a role, and that role eventually you will be able to use it so that it will be having an access for services. Now, so I'm going to refresh it, and here, so Euron RAG application role is now visible. It's a very minimal step, right? And then here, so EC2 instance profile. So choose IAM instance profile, which manages policies that allow your EC2 instance to perform a required operation. So here I can choose my existing profile, or I can just go over here, and then just by doing next, I will be able to even create it. So Elastic Beanstalk for compute. So I can try to do next. And by default, it is going to create it for me. So by default, it is going to create it for me. So role AWS Elastic Beanstalk EC2 role has been created. So I can try to use this particular role, right? So here I can just click on refresh, and AWS Elastic EC2 instances role I can try to select. Okay, that's great. Now click on next. Yeah, click on next. Now after this, you don't have to do any kind of a setup, just next. Leave each and everything as it is. You don't have to do anything for this application. So click on next. There are so many setup that you can do for a real-time application. But yeah, so here I can try to click on next once again. And with a default setting, I'm just going ahead with that. So click on next once again. And everything is ready. So it is going to give you an environment detail, each and everything over here, and then click on create. Now, once you are going to click on create, your Elastic Beanstalk is going to take a couple of minutes of time. So maybe 3 to 4 minutes of time in general it takes, as per my experience, right? So 3 to 4 minutes of time it is going to take. And here, this upload and deploy, the options, just see my cursor. So upload and deploy option that you are able to see, it will get activated. Means you can try to upload your application, and then eventually it will start deploying your application. Now to do that, I have to make some sort of a changes into my application. So as I have chosen environment is equals to Docker, right? So basically Docker running this one. So I have to convert my application into a Docker. And what is a Docker, by the way? So maybe some of you must be aware about a Docker. Those who are not aware about a Docker, let me tell you in a very simple definition, that Docker is nothing but a kind of a system you are going to create in a layman way, right? Kind of a box you are going to create. So where you are going to install the operating system, and you are going to install each and every requirements or dependencies, and then same thing you can upload anywhere. And it is going to work. So it will be technically a system independent. If it is working in your system, it is going to work in other system as well, right? Now to convert my application, this is my application, right? Close everything. Now to convert my application, this Euron RAG application as a Docker, I have to add a couple of things, and then I have to test it. So here, what I will do is that I'll try to add a couple of requirements over here, right? So the very first thing that you have to add in this particular place is called as the main file, basically. So in this application called as D capital, again, always capital, DOCKER, Docker, and then FILE, Docker file. And you will be able to see a symbol. By the time you are going to write Docker file, you will be able to see the symbol. So system will be able to recognize that, okay, fine, this is the Docker file. And then inside that, you have to paste this particular code. Now this file is helping me out in terms of creating the whole environment, and then in terms of deploying it, right? Only this file will be responsible. So this file is going to convert everything into a Docker, as simple as that. It's a very basic file that you all will be able to find out. Now here, so I'm writing from Python 3.10 Slim. So Slim means basically just try to add a lightweighted version of the operating system. And then inside that, try to install a Python 3.10. Then here I can try to give a URI API key. So it is going to override my actual API key. So here I'm going to give my URI API key, all the secrets. I can try to remove my environment file if I want, so that it will be able to take it from here, right? From this one. Then inside this image, or inside this container, or inside this operating system, you can say, because even you are working on operating system, right? Maybe a Linux, maybe a Mac, or maybe a Windows machine. So every time we try to create a folder, so similarly, it is going to create a folder over here, and then whatever file that you are going to pass, whatever file, except this one, whatever file you are going to pass, it is going to copy all of this file inside its own folder called as app folder. And then what it will do, it will try to install the way we are installing requirement.txt. So obviously Docker is nothing but it's an operating system, right? It's a lightweight operating system. It will try to install. So inside that, it will try to do this requirements. And then we are trying to open up this 8501 number port where I'm going to run my Streamlit application internally. So final command is going to be Streamlit run app.py file at this particular exposed port number. And then this is the server universal address. So this is going to eventually a Docker file. Now this file is very much important in terms of deploying any kind of an application that we have. Yeah, that we have. Okay, that's great. So maybe what I can do is, so I can try to use this file and then I can try to deploy this application. So how I'm going to deploy this application? So here, okay, now this environment successfully launched. So my environment is ready. A Docker based environment is ready. Yeah. Now here we have an option called as upload and deploy. Now what I'm going to upload. So whatever folder in which you have all of these code, including a Docker file, so you have to convert this entire file into a zip, right? It's very simple, right? Convert this entire file into a zip and then upload it, upload that particular zip file. Automatically, it will try to unzip and it will try to perform all the operations. You don't have to worry about anything. Let's do it. Let's see. So whether we are able to perform that operation or not. So I'll try to go to this folder. So where I'm keeping all the files. So let me remove the previous zip file. So delete it. Yeah, so delete it. Now inside this folder, as you can see, I have everything. Docker file, requirement.txt file, everything I have, even my app.py file is available over here. Now I'll try to do right click and then I'll try to convert this into a zip file. Simple, right? So once I have a Docker file inside this, I have created a zip file. Now I'll try to go to my Elastic Beanstalk, AWS, and then upload and deploy. So here it is giving you an option, choose. So I'm going to choose from a directory. So wherever I have that file, so Euron RAG application, this is the file that I have. I can try to click on open. So it is going to upload this particular file, right? This zip file, it is going to upload. And version, you can try to give your own label. Otherwise, system will give a label automatically and then click on deploy. If everything goes fine, then it will be able to deploy. And if there is some sort of an issue, then obviously it is going to throw an issue and you will be able to check inside this events and then even inside the logs, we'll try to fix those issues. So as of now, if you are going to expand this one, so Elastic Beanstalk is updating your environment to cancel this operation abort. I don't want to cancel as of now. So let it create the environment and let it deploy this entire things. It will again take like a couple of minutes of time for all of us. So sit tight and let's see. So if we are going to get some sort of a issue. Okay, so it is telling me that command failed on instance running code output engine execution has encountered an error. Instance deployed fail for instance C engine log, instance deploy, both Docker file and Docker AWS is missing in your source bundle, include at least one of them. Okay, I think there is a file. It is telling me that Docker file itself is missing, but here we have a Docker file. Okay, maybe I can check the cross check just for the cross verification. So dir and my Docker file is available over here. So why it is telling me that my Docker file is missing, include at least one of them to deployment. My Docker file is already there. So docker. I hope I have not made any kind of a mistake with respect to naming, not at all. It's like a symbol it is able to recognize. So my Docker file is available. Okay, I'll try to fix it. This is what I do all the time. Okay, so there was a minor issue. I have just zipped this entire folder. So instead of doing that, what I can do is, this is the file inside my folder, right? These are the files which is available inside my folder. I can just select all the files, right click and then compress to a zip file. So now this is the zip file I will be looking for. And this is the zip file I will be deploying, not this folder, because if I'm going to unzip that file, so there will be a Euron RAG application inside that zip folder. And that is the reason it was telling me that it is not able to recognize the Docker, right? So now it's ready, and choose an application, and then from here, so I have this application, Euron RAG application. So I can try to click, and then I can try to click on deploy. Now let's see. So if there will be any issue, I'll try to fix that issue, but I hope that there won't be any kind of issue I'm going to face now at least. Okay, so still it is trying to update my environment. Environment update is starting, updating environment, this, fine. Let's wait for some time, guys. Okay, so instance deployment failed. For detail, the instance deployment failed, build a Docker image, deployment fail. Again, I have received, but this time the issue is different. Last time it was not able to find out a Docker file, so which I have already fixed. This time, so it is trying to give me this issue. So I'll try to fix this particular issue. Environment was reverted back to the previous configuration. Okay, so let me fix this part now. Okay, everyone, so I'm able to fix the issue. The issue was, again, the second issue that we have received was with respect to a Facebook AI semantic search, like a similarity search database that we were trying to like configure. And because of that, it was giving me an issue. So we have added all the dependencies with respect to a Facebook AI similarity search. So here, these are the line which has been updated. And now if I'm going to bundle it up, so here, I'll just try to delete the previous bundle which I have tested. So Control A and then right click and then compress to a zip file. So now if I'm going to bundle, and the same updated code is available now with all of you. So here rag underscore app underscore like a Euron. So this is the zip I'm going to create, and I'll go to my Elastic Beanstalk and then upload and deploy. So choose and then rag app Euron, the zip which I have created just now. So open and then click on deploy. Now once I'm going to click on deploy, it will take approximately 3-4 minutes of time, and then it is going to finally deploy it. And on this URL, I will be able to see the final deployed one. And the code is already available inside your dashboard. So whenever you are using it, so you are going to use a updated code, the final version. So where I have fixed all the issues, and without any kind of a hassle, you all will be able to deploy. Apart from that, so little bit of like a small change into a Docker file. Apart from that, there is no changes that you will be able to find out. So just wait for some time, guys, 3 to 4 minutes, and then our app will be up and running. Okay, so looks like almost it's on a verge of completion, and just wait for a couple of more seconds. Environment health has transitioned from OK to info. Application update in progress, running for 10 seconds. Okay. So we'll wait for some time, and we'll see so whether successfully we are able to launch our first app on AWS or not. And hopefully we will be. Okay, so environment updated successfully completed. Info, health info. I can try to check. I can try to come over here, and this is the application name. So RAG app Euron, and this is the folder name which I had given, right? So I can try to click on this URL. And this is the final deployed URL. And here I can try to ask a question that who is, right? So I can try to come over here, and then I can try to like ask a question that who is Sudhanshu Kumar. And yes, it should be able to give me an answer. So whatever question which I'm going to ask, because this was a data which was a part of my RAG. So yeah, it's like able to give me all the like output the way I was expecting. Birthplace of Sudhanshu. It will be able to give me a birthplace of Sudhanshu. I can try to ask whatever question in whatever way I want, and it's a LLM based RAG application. So obviously it is going to give me the response. So successfully, finally, we are able to deploy our application inside AWS Elastic Beanstalk. Now, once you are going to deploy, once you are going to test it, so never forget to terminate your environment. So if you are not going to terminate it, you will have to pay the bill. So here you can try to select your environment and then click on terminate environment. And here, so you can try to give your environment name and eventually it is going to terminate it. If you are not doing it, again, I'm warning you. So you are going to pay a bill for that, right? As long as this will be up and running, so you are going to pay a bill for that. So make sure that you are terminating this entire environment after using it. So fine guys, with that, thank you so much. Hope all of you are able to build your very first RAG application. You must be able to deploy it inside a Streamlit, inside a render, as well as inside a AWS environment. And going forward, so we'll try to build a massive application on top of the knowledge that we are trying to get from this entire lecture. Plus, I'll keep on giving you a lot of assignments. So please try to check your assignment directory as well. So your assignment like a section, and just try to complete those assignment in an end-to-end way. It is going to give you a lot of knowledge. Believe me, it is going to give you a lot of knowledge. Plus, in the existing app itself, you can try to do a modification if you want. Again, that is going to enhance your knowledge at the end of the day. With that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so welcome to lecture once again, guys. Now, in this lecture, I'll be talking about a document loading operation with the help of LangChain and a Llama index. Now, to build any kind of a RAG application, obviously, you have to read a data. Now, data will be available in a different file format, maybe into a .txt format, maybe into a JSON format, maybe into a CSV format, maybe into a docs format, maybe into a PDF format. So there can be a variety of like a situation you will get into from where you have to read a data, maybe from some cloud environment, maybe some different app. So how I will be able to load all of these documents? Obviously, I can write a one-by-one custom libraries, or I can try to write my own custom function. And with the help of that, I will be able to read the data. But if I'll talk about a LangChain as a framework or Llama index as a framework, so these frameworks are providing you a simple basic function by which you will be able to load a document in no time. So this is something that I'm going to discuss with all of you in this lecture. So let me share my screen and let's try to open up a VS Code, and one by one, let's start looking into these examples in a complete practical manner. So here I'm going to open up a folder now. So inside this folder, so I can try to create something called as generative_AI_masters doc_load. Okay. Now, so inside this folder, so what I'm going to do, so obviously I'm going to create a Jupyter notebook file. So let's suppose I'm going to create a Jupyter notebook file document_load.ipynb. And inside that, obviously I have to keep a couple of documents. So I have already done some sort of a preparation for all of you. So where I can load a document one by one. So here, as you can see, I'm trying to keep a JSON file, I'm trying to keep a docs file, I'm trying to keep a CSV file, I'm trying to keep a PDF file, I'm trying to keep a TXT file. One by one, with the help of LangChain, I'll try to read it out, and then with the help of Llama index, I'll try to show you that how we can try to read the document. So let's try to select a kernel in a very first place. So here, I have selected the kernel, one of the kernel, or maybe you can try to create a new environment, and then with the help of new environment, you can try to perform the same thing. Now, installation wise, so this installation is must. Apart from that, I'll be doing a couple of more installation, but yeah, this installation is must inside your system. So execute it, right? And in my system, I have already installed it. So it is showing me requirement already satisfied. In your case, obviously, it is going to do the installation, and then you will be able to perform a different kind of a operation. Now, what we are supposed to do is that we have to import all of these libraries. So from LangChain document loader, I'm trying to import a text loader, I'm trying to import a PyMu PDF loader, I'm trying to import a CSV loader. Now, these are not just a loader which is available. So apart from that, you will be able to find out other loaders as well, which is already available. And here in a LangChain documentation, document loader documentation, so you will be able to find out a tons of document loader pre-built function.
And it says that just try to use a library and then try to call a load function, and it will be able to load the document, whether it's a bev, whether it's from a unstructured data, whether it's from a sitemap, or here if you will come little bit down inside this document, so you will be able to find out all document loaders. So just anything and everything that you have heard of with respect to everything, they have given you a function, a inbuilt function. You just have to call this function, and then you will be able to load a data from that particular environment or that particular platform or that particular document or file system. It's very easy, very much easy way they have created each and everything as a wrapper. Now out of this I will be using a couple of things, and then I'm going to show you all of these examples. So let me show you this example, and let me keep this URL even inside this Jupyter notebook so that all of you will be able to refer it in a later stage. Yeah, so this is the URL where you will be able to find out all the document loader function, which is an inbuilt one from a LangChain. Okay, so now once we are able to do this, let's start using a text loader in a very first place. So here I'm going to use a text loader, and I have a text sample. So I have a text sample.txt inside my system, and once I'm going to execute it, it is going to give me an object for this text loader. If I'm going to call .load, so it is going to read the entire data from this particular document. Very simple, right? So here you will be able to find out a page content, and inside page content, whatever I had inside my document, so yes, it is able to read it out. And if I have to extract a data out of this one, so everything is available inside this list at 0th index. So I'll just try to call 0th index and then dot page content, and it is going to give me just a page content. So whatever content which is available, I will be able to read it out if I'm just looking for a page content, if I'm not looking for any kind of a metadata. Okay. Now, similarly, so I have a CSV file over here, a comma separated file over here. So if I have to read a data from this CSV file, I will be able to read out this data from a CSV file as well. So here I can try to call a CSV loader, and I can try to pass my sample.csv, and then I'm going to call load. So it will be able to load a data from a CSV, and there is a lazy load function which is also available. You can try to use it. So yeah, it is able to load a data from a CSV row by row. So row number 0, then 1, then 2, then 3, and so on. So row by row manner from a CSV file, it is able to read the data. Similarly, so if I have to read a data from maybe a PDF file, so here I can try to call PyMuPDF loader, which I have already done as an import. And then I can try to call my sample.pdf, and then I can call load function over here. So it will be able to load a data, right? It will be able to read a data. And again, so whatever meta information which is available, so it is going to load that meta information as well. And in a page by page fashion, so it will be able to load the entire data. So in my document, so I just had only one page. So yes, it is able to read that particular page, as simple as that. Now, so let's suppose if I have to read a document, let me show you that. So let's suppose there is a document available in this way, right? So there is a technical, there is a research paper which is available over here. Now, if I have to read out this particular research paper, so how I will be able to read this particular research paper? Now, to do that, this LangChain is providing you something called as a docling loader. So with the help of docling loader, you will be able to read out even this one. But to make this working, so you have to do an installation in a very first place for a document loader. So this is the installation that you will have to do. Now I'm using the same example which has been given on a LangChain official documentation page. So first of all, you have to do this installation, and once you will be able to do this installation, then with the help of this doclink loader, you will be able to perform this entire operation. So here code wise, you have to call your doclink loader, and then inside this, you can try to provide your file path. So what was my path? So this was my file path. I can try to copy it, and then I can try to pass it over here. So doc link loader. Now here, so I can try to provide my file path, and it will be able to load it. So dot load, you have to call for sure, right? And yeah, so it is able to load a data one by one for you. Simple, right? So this is going to read a data, and then this is going to show you a data. So still it's trying to read. This file is available not in my local system. This file is available somewhere on a this particular platform, this particular place, and it's a huge file. So line by line, it is trying to just read out that particular file. Maybe we can wait for some time. Yeah, so it is taking like a time. Okay, so now as you can see, it is able to read data. It is able to read a data page by page. I'm able to get the content, and everything is available in my system. So like I said, even if it is available on some other platform, maybe on some URL, maybe on some link, I'm able to read out that particular information. Very simple, right? Now I can try to use this doc link loader even to read my doc file, right? So let's suppose I have a doc file in my system. So I have basically querying doc file which is available. So I can try to use this particular function to even read this particular document file. So here this document file is having a lot of information, and page by page it is able to read out even that particular data, as you can see, right? Page by page it is able to read out all of this data along with a meta information you will be able to find out. So very simple and very easy to read all of this document with the help of some of the inbuilt function which is already given to you, right? Which is already given to you. Now, so there is another part you will be able to find out. So let's suppose if I have to read out some of the information from a BIB page, right? So even LangChain is providing you a BIB based loader. So you will be able to read a data from a BIB pages. So to do that, so you have to do some sort of an import. So you have to do LangChain community import. Now from that, so document loader you have to call, and then from there you have to import BIB base loader. So this import is required. This import is required. So once you are able to call this one, then you can try to call BIB based loader, and then inside that try to provide the URL. For example, I'm going to provide maybe a Euron.1 URL, and let's see so what it will be able to read out. So here I'm providing a Euron.1 URL, and if I'm going to execute it, so and then if I'm going to call load, so let's see. So yes, it is able to read some of the information. So title of the page was this, and this was the description which was given on a page. So these basic information, page content, it is able to read out. So anything and everything I will be able to read out with the help of this LangChain thing, because it is one of the richest library you will be able to find out to read out a document or read out any kind of a data from any of this system. And just imagine, so all of these things are given to you. You just have to call one single function, pass your path or maybe a credential, maybe a API sometime, and then you will be able to read out the entire documentation. So it's an amazing thing that has been given to all of us, and with the help of this, you will be able to read out, or you will be able to load anything and everything literally, right? Anything and everything you will be able to read out. Now, so I had basically in my system, I had this JSON file. So how I will be able to read out a JSON file? Let's try to understand that particular part as well. Maybe I can try to use a doc link loader. Just I can try this out, right? So here I can try to pass my document name, which is nosunexport.json. And then if I'm going to call a load, so let's see, it's not able to load this JSON. So maybe I can try something different over here. Okay, so to read this JSON file, so it is not going to support me directly, but what I can do is I can try to write something like this, my own custom function, and I can try to use a document class basically from a LangChain, so that at the end of the day, after reading any of this document, I will be able to, right? I will be able to basically convert it into a LangChain compatible document format. So this is the very simple like operation we have written. So where we are trying to open up a file, and then one by one, we are trying to read out the content, and eventually we are trying to append each and everything inside the document, which is nothing but like a LangChain compatible document format. Simple. So here, if I'm going to call a load notion, and then here, so if I'm going to pass my JSON, so yeah, I'm able to read out this entire document, entire data into a LangChain compatible format. So that's a beauty, guys. That's a beauty. So now once data set is available into a LangChain compatible format, then we can try to use this data for embedding purposes, to store this data into a vector store, to retrieve some sort of a chunks out of it, or maybe to build any kind of a chain out of it. So for any kind of operation, we can try to use this particular data set because now it's available into a LangChain compatible format. Now, so LangChain is one thing. I'll try to show you something with respect to a Llama index as well. So if you remember, from a Llama index, we have done an import of simple directory reader. Yeah, we have done an import of simple directory reader. Now, what I can do is that I can try to call this function called as simple directory reader, and here, so I can try to provide my input files basically, or I can try to provide one single file. I can try to provide a multiple file. That's completely fine. Now here, if I'm going to provide a sample.txt file and execute it, so yeah, it is able to return me a Llama index based object. Yeah, it is able to give me a Llama index based object. Now I can try to call load data with respect to a Llama index, and yes, it is able to give me a meta information, and along with that, so it is able to give me the complete data out of it. So this is giving me a data set which Llama index will be able to compatible with, and Llama index will be able to understand at the end of the day. Now I can try to use a same one. Maybe I can try this out, and I can try to read maybe a document docx file. So QUE, my file name is querying QUERYING dot docs. Now, so yeah, I'm able to read with the same function, right? With the same single function. So I'm able to read basically a doc file. Now, if I can try to read maybe a sample.csv. So yeah, I'm able to read even a CSV file. Now I can try to read maybe a Notion file, which is available into a JSON format, NOTION underscore EXPORT export.json. So here I'm able to read even this particular file, right? I'm even able to read this JSON file. So all this file, I'm able to read it out in a simplest possible manner if I'm using a Llama index based simple directory reader, which is a core of, which is available into a core class of a Llama indexes. So this is how, guys, you will be able to read out a document. And like I said, so try to follow this entire page. So where you will be able to find out all the reader, and you will be able to read the data from any places, any given places. So with that, thank you so much, everyone. Take care, and see you again in my next lecture. Okay, everyone, so welcome back to lecture once again. Now in this lecture, guys, I'm going to discuss about checking, splitting, and adding some sort of a meta information into a existing data set. Now in my previous lecture, I talked about basically how we can load a data. And if I'll talk about a LangChain, so obviously LangChain provides you a huge set of functions or huge set of the library by which you will be able to load a data from anywhere. Now, so in this example, let's talk about a checking, that how we can try to break down those data, and then how we can try to prepare those data for a embeddings or for a next processing, so that I will be able to build a RAG application, because these things are pretty much important in terms of building any kind of a RAG application at the end of the day. So let me share my screen, and let's start doing a coding. So here I will be using this sample.txt file, and here, so I have copy and pasted terms and condition of a Euron. So let me close this part, and we are going to use a same installation that we have done in my previous class as well. Now, first of all, try to load this data loader, a text loader. So I have to read a text file. So I'm just going to call a text loader. Simple. I have already used it even in my previous lecture. Now, so here, once I'm going to call my text loader, so I can try to provide my sample.txt file so that it will be able to load it. So dot load, and it will be able to load this entire document. Yeah, it will be able to load the entire document. Now let's try to store this entire things in a variable called as documents, documents. Yeah. So inside this document, I have this entire data set, right? Entire data set, all of my data set is available inside this one. And I will be using this particular document itself. Now, the very first thing is that let's try to like split a data. So see guys, once I'm able to load a data, now all of this data set is available here as a page content. I can even try to extract just all the page content. That is also possible. So here I can try to write maybe a document of 0 and then dot page content, and I will be able to see just a page content. So whatever content is available, it is going to give it to me. Now this content is very huge, and again in between, so you will be able to find out a lot of different kind of syntaxes like /n or maybe a comma, maybe exclamation marks, a lot of things, right? As a part of this document, you all will be able to find out. Now, so how I will be able to break this data and how I will be able to convert this data into a small pieces in a small chunks. So this is where this splitting of the data comes into a picture. So let's try to understand that how I will be able to split a data, right? How I will be able to split a data. So the very first things which I would like to show you is a recursive character text split over here, right? Now I'll try to show you that how it is going to work and then how it is going to split a data, plus how we are trying to create even a overlap between the data set. Let me show you that. So here I can try to import maybe from LangChain dot text splitter. So import what? So import basically recursive character text splitter. So this is something which I am going to import it. And then once this import is done, recursive character text splitter, so I can try to set a parameter over here. So parameter is what? Chunk size, means like whenever I'm trying to split the data, so what should be the size of the one single chunk. And then I'm going to like give over here that chunk overlap. I'll talk about this, don't worry. I'll even show you the examples over here. So let me keep this chunk size as small so that we can count and we will be able to observe it very clearly. So this is a recursive character text splitter, and let's suppose I'm going to create a variable splitter, spliter splitter variable, and I'm going to store this one into this splitter variable, and I'm going to call a splitter dot split document, and as I have a document over here, and just try to parse this document that you have already loaded. Yeah, now execute it. Now this is the information that you all will be able to get. This is the information that we all are able to get over here. Now, so as you can see that I have given chunk size is equals to 30. Yeah, I have given what? I have given chunk size is equals to 30 over here. Now you will be able to find out that approximately it is trying to hold that much information inside one single chunk. Yeah, one single chunk. So this is one chunk, this is one chunk, this is one chunk, this is another chunk. Now here I have given a chunk overlap is equals to 5. Yeah, I have given chunk overlap is equals to 5. Now, so my expectation was that it is going to create a overlap. Overlap means what? So let's suppose I have given chunk overlap is equal to 5. So 5 character from here should be available in a beginning, so that there will be an overlap between these two sentences. But doesn't looks like everywhere that there is a overlap. Yeah, in some of the places you will be able to see the overlap, or over here and or over here, right? Off over here and off over here. So in some of the places you will be able to see the overlap, and in some of the places you will not be able to. For example, here we are able to see the overlap. Maybe I can try to make overlap is equals to 10 and then show you. So in some of the places you will be able to find out an overlap, and in some of the places you will not be able to find out the overlap. Now, how and why? Why this is not showing you the overlap everywhere? The reason is very simple. See guys, so this function is not doing much. This function is just trying to break your content, right? This is just trying to break your content. So whatever content, whatever document or whatever data that you have, now I can show you this document, right? Terms and condition, and like there is a new line over here. So terms and condition, there is a new line, and then these terms of use, and then this is something that we are able to find out. Yeah, this is something that we are able to find out. And then constitute of enforceable content. And enforceable content. So here you will be able to find out a line break, or you will be able to find out spaces. You will be able to find out maybe without a space over here. And based on each and everything, it is trying to break the entire data set. So here, whenever we are going to call a recursive character text splitter, it always try to break a data based on, based on this one. Always remember, it will try to break a data based on this one. Let me convert this into a markdown. Yeah. So this is a markdown. So it will always try to show you a data in this particular order, or like it will always try to split a data by using a double slash, like a slash n. So one single slash n means new line. So double new line, or maybe a new line, maybe a space, or maybe without a space. So this is something that it is trying to consider, and by doing that, it is trying to split your data set. So wherever it will observe either of this, right? Wherever it is going to observe either of this, it will be able to split the data. Now we can try to hover our mouse over here, and we can try to see a parameter called as separator parameter, right? We can try to like even give a parameter over here. So we can try to maybe create a separator, and we can say that unless and until you are not able to see this one, so don't try to split the data. Now if I'll show you the result, so result will be little bit different over here. So if I'm going to give separator is equals to this one. So these terms of use and terms, and then there is a clear, right? There is a clear overlap I'm able to find out. There is a clear overlap everywhere you will be able to find out in between these two data set. Yeah, these two data set. So here I have strictly mentioned that try to use only this separator, but by default it will be using all of this separator all together to perform this particular operation, and that is the reason. So it was splitting wherever it was able to find out that one. Now, so this is what a recursive character text splitter does. Now what is next, by the way? So next is, let me delete this part. Yeah, it's done. Now, so there is something called as fixed character splitter. So how this is going to work, let me show you that part as well. So first of all, import. So from a text splitter, character text splitter, I'm going to import. Now, so what I can do is I can try to call a character text splitter, and then here, so I can set the parameter. So maybe I can try to like say that separator is like this one. So wherever you are able to find out the single space, separate the data, and then chunk size is equals to, let's suppose I'm going to define maybe 50, and then here chunk overlap I'm going to define is equals to 10. So fine, this is again another splitter I'm able to create. So character underscore sp char splitter I'm able to create. Now I can try to call my char splitter, and then I can try to basically pass a data. So split documents, and then here I can try to pass my documents over here. So here again you will be able to find out that it is trying to split the data. It is trying to split the data. Now, so here what it will do, so it will try to split a data with the help of fixed number of the characters. Yeah, fixed number of the character it is trying to consider. So everywhere you will be able to find out that there is a 50 character it is trying to take, and then based on that it is trying to split the data, and there is a overlap of 10 character it is trying to maintain each and every time. Yeah, overlap of 10. So basically, and here we have mentioned that always try to perform this split operation by a space. So splitter wise I have given this one. So this is again another splitter that you will be able to find out. Now there is another splitter you will be able to find out called as token text splitter. So now let's try to understand how token text splitter works. So here just I import token text splitter from a text splitter, and then here, so token text splitter, and you can try to like set maybe a chunk size, chunk, chunk, size, so size, chunk size, and chunk size, let's suppose I'm going to keep 50, and then chunk overlap, chunk underscore overlap, overlap. So chunk overlap is equal to maybe a 10 I'm going to give. Yeah. And I believe we all understand what is the meaning of chunk size now, and then what is the meaning of a chunk overlap. Now what this token text splitter will do, let me show you that part. Token splitter, token splitter. Now, so I'm going to call my token splitter dot split documents, and I'm going to pass my original documents. So documents I'm going to pass over here. Now what a token text splitter does is that it will try to consider one single, not the whole word, I would say. So it will try to consider approximately 0.75 word, means like a 2/3 of the word as a one single token. And based on that, it will try to split the entire data set. Plus, it will try to even maintain the overlap. So let me reduce the size. So let me keep it 10 and let me keep an overlap of basically 2 in case of a tokens. And then let me show you the final example. Yeah. So here I'm trying to keep chunk size is equals to 10. So 1, 2, 3, 4, 5, 6, 7. So approximately, right? Like I told you that here in case of a token, 0.75, 2/3 of the word is considered as a one single token. This is how like calculation happens for this one. And here, so you will be able to find out obviously, right? You will be able to find out obviously that there is a overlap, right? So we are trying to like keep a chunk overlap is equal to 2. So here with the help of even like a chunk overlap and a token text splitter, I'm able to split the data and I'm able to see the overlap in between the data set. Now, so there are other splitter which is also available, by the way. So there is something called as character text splitter that you will be able to find out. So I think character text splitter we have already discussed. Yeah. So we have already discussed character text splitter over here. Now, so yeah, so we have already discussed about the character text splitter and we have already talked about even a token text splitter. So now let's try to understand something. So we had a document, right? We had a document. Now let's suppose if I have to basically add some sort of information inside this document, means some sort of a meta information if I have to insert inside this document. So how I will be able to do that? As you can see that this is like a list inside the list. So we have this document. So at document 0, so at document 0 at this place, so we have this one. And if I'm going to check what is the type of this, so what is a type of this one? So basically it's a LangChain document that it is talking about, that is trying to tell me. Yeah. Now, so here, so if I have to add maybe a meta information, so let's suppose I'm going to call document documents.me TASTORE. Yeah, so inside this document, if I have to append something, so let's suppose document documents and then append. Maybe I would like to append some more information over here. So append what? So maybe I would like to append this information that creator, right? Creator, and then I can try to mention over here as Dhanshu. Fine. Now, if I'm going to check the document, so inside this document, you will be able to find out one more information. Simple, right? One more information you will be able to find out which is been appended over here. Okay, so it's been appended over here. Now, let's suppose, and this is the separate data which we are trying to append in this particular place. Now, let's suppose I would like to append something in this metadata, right? I would like to maybe like change this metadata. Maybe I would like to add this information into this meta information. So how I can do that? Very simple. So I can try to parse this entire document. So document and then at 0. So this is the information and then I can write maybe a metadata. So I will be able to get this information. Now, if you are going to check that what is a type of this information. So obviously it is going to tell you the dictionary. Yeah. So this is basically trying to represent the dictionary. Simple, right? So we know from our Pythonic class that if there is a dictionary and if I have to maybe change something, so if I have to maybe add even this one inside a meta information itself, how I can do that? Simple. So here I can try to write down that is equal to, right? This metadata is equal to this information is already available. So keep this information and along with this, try to add one more key value pair. So I'm just trying to refresh this entire information and adding this one. Now, if I'm going to show you the document metadata, so obviously you will be able to find out this new information as well. So in this way, I can try to parse any number of a document one by one, one by one, one by one, one by one, because whatever document that I will be able to get, it will be a part of the list. Now, if something is a part of the list, let's suppose if I have to add some more meta information, right? I wanted to add some more meta information. Maybe this meta information is not sufficient for me, or I feel like I have to add something. I can just try to iterate through this entire document one by one, one by one, one by one, and then start calling this particular operation. So start calling this metadata information, and it will be able to basically append each and everything. So just by writing a simple Pythonic function, you all will be able to do it. As simple as that. Now, so let's come to the point, and I would like to discuss something with all of you. So here, yeah, not this one. Yeah. So I would like to discuss this with all of you, that when you are trying to perform a different kind of operation, then what should be the ideal chunk size that you are supposed to create? So in general, so whenever you are trying to build some sort of operation with respect to an RAG search, so in general, this should be your chunk size. So this 300 to 512 token you are supposed to consider. Whenever you are trying to do a summarization task, so again, your chunk size or your token, number of token that you are going to consider should be in between this one. And again, we know that number of token is approximately 0.75 words in general. That's a whole definition. Now, whenever you're trying to build some sort of a document-based Q&A system, so in that case, you have to keep a chunk size equal to 500 to 1000. And whenever you are trying to perform some sort of a classification operation, so at that point of a time, you should keep a chunk size is equal to 100 to 300. So not to remember, not to hard and fast things, but yeah, it's always good to know about this entire things. Yeah, this entire things. So that you all will be able to perform this kind of operations on your own. So hope this is making sense, and hope all of you will be able to split the data. You all will be able to convert a data into a small chunk, and then you all will be able to even add a meta information with respect to the document. With that, thank you so much everyone. Take care, and see you again in my next lecture. Okay everyone, so welcome back to lecture. Now in this lecture guys, so I'm going to talk about embedding, which is one of the simplest one again. So if you are going to use URI, it's a no-brainer job, you will be able to find out. Now why embedding is required? So whenever you're trying to build a RAG kind of application, so unless and until you are not going to store your data into a vector database, you will not be able to do a extraction. Now, so what you are going to store into a vector database? Obviously, some sort of a vector. Now, what is a vector? Numerical representation with a dimension, right? So here, you have to convert your textual information or whatever information that you are trying to hold inside your vector database, right? Inside your vector database into a numerical representation. Now, this is where embedding concept comes into a picture. So that vectors is called as basically embeddings. Now, how we will be able to do our embeddings? It's very simple with respect to URI. So here, if you will come inside the URI and if you will click on available models, you will be able to find out that we are giving you a model from a OpenAI. Yeah, OpenAI, we are already giving you the models. Now, so here we are trying to give you a model called as text embedding 3 small. Now, this is going to help you out in terms of converting your data into a vector representation of dimension 1536. Now, this is again another model that we have given to you. Maybe that will be released in a future. Not now. We have not released it. But yeah, so this is one of the best one that we have given to you so that you all will be able to use it and you will be able to build your application with respect to RAG. Now, so how I will be able to use this one? So we have given you a code example as well. So this is the code example, right? This is the code example. This is the code example you will be able to find out with respect to the embedding. Now, just copy and paste this code. Nothing much you have to do. Just copy and paste. Now, this is the URL which is given to you. Here you have to use your key. So your API key for a URI you have to use. So from where you can get an API key, go to the authentication and just click. It will be copied. And then here you have to just put your own API key. That's it. Own API key you are going to put. And then this is the sentence for which it is going to convert into a embeddings. If you have to customize it, fine, not an issue at all. So just try to parameterize it. But that is the only thing which is required. Apart from that, nothing is required at all. Now here, right. So here, if you are going to execute it and if everything goes well, just try to call a generate embeddings. Just try to call this generate embedding function.
and you will be able to see a complete array. Now, if you're going to check that what is a size of this like embeddings that it has generated. Now, if I'm going to check that what is the length of this embeddings, so generate embeddings it has created. So obviously it is going to be 1536. Yeah, it is going to be 1536. So, and this is the total like this is the total array that you will be able to find out. So it has converted this entire input information, entire text information into its numeric representation. Like I said, I'm trying to use one of the best of best model which is available in a market so far. Now, so you and at the end of the day, you need a model. You need a model which has been like trained on a very huge amount of the data, so that it will be able to understand the data and it will be able to generate a perfect embedding. So I believe to generate a embeddings, nothing is better than URI as of now, right? You can try to use it. Means OpenAI, I'm talking about. Inside URI, obviously we are trying to use a OpenAI, nothing much over here. And apart from that, so let's suppose if you don't want to use this one, then maybe you can go to Hugging Face, and tons of models are already available over there. So you can try to search for EMBE embeddings, and there are like so many models you will be able to find out just with respect to the embeddings, right? So many models you will be able to find out. EMBEDDING. So let's suppose I'm just going to search with respect to embeddings. It has given me embedding. So 2349 models or 39 result. This much of result it is trying to show me just with respect to the models. Yeah, just with respect to the model. This is the total like things that it is trying to showcase. I can try to select any of these models, right? I can try to select any of these model, and they must be giving you the code, and code is nothing. So basically you have to import the model. After doing the import, so you can try to provide your document, and in return, so it is going to give you the document embedding. As simple as that. This is how this things is going to happen. So you can try to use any of this model. You can download it in an offline mode, and then you can try to use it. Otherwise, if you're looking for like a ease of use, so in that case, just go ahead with the URI. Believe me, you will enjoy it. Yeah, you will enjoy it, and it's going to give you one of the best embedding. So with that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so welcome to another lecture, guys. And now in this lecture, I'll be talking about a normalization and a cosine similarity in a theoretical manner as well as in a practical manner. So in my previous class, let me share my screen. So in my previous class, I was talking about embedding. So embedding is nothing but converting any kind of a data, right? We have already seen that, by the way. So embedding is nothing but converting any kind of a data into a high dimension vector space. For example, so if I have maybe a text 1, and text 1 says that my name is Sudhanshu, right? So obviously if you are going to convert this entire data into its embedding, so it is going to give you a high dimension vector, means a number or an array which is eventually going to represent this particular information, this particular data, right? Maybe a textual data, maybe a image data, maybe something else, but yeah, so this embedding or this like a numerical representation, and this vector is going to represent, or this is going to talk about this particular data, obviously with the direction, right? But it is going to be the high dimension. For example, so the URI API that I have used for the embedding, so any given data set, it is going to convert it in a dimension of 1536. So just imagine that it is trying to use this one single data, and it is trying to convert it into its respective embeddings, and it is trying to represent the data by using a dimension of size 1536, a big dimension, right? It is trying to represent. And this is eventually the numbers, and this direction is going to represent a semantic meaning of any of the information that you have given. So happily we were able to convert our data set into a respective embeddings. Now there is no doubt about it, right? Now let's suppose there is a sentence called as text 2, yeah? And this sentence says that Sudhanshu is my name. Yeah. Again, so I will be able to like create a embedding 2 for this one, for this text 2, right? In the same dimension, let's suppose.
Now, if someone is going to ask you a question that how similar these two sentences are, how similar these two sentences are, by the way. So how you will be able to find out that how similar these two sentences are? So we have its vector representation, we have its numerical representation. So I can try to check maybe a distance in between. And there are other methods as well. So I can try to use all of these methods, and with the help of that method, maybe I can check its embeddings, and I will be able to find out that how similar these two sentences are, because that will be important in case of RAG application. So whenever you are going to fire any kind of a query, it will go into your vector database, it will try to extract all the information, and then it will send those information along with the query to a model, to a LLMs, right? To a LLM, so that it will be able to generate the response. So that is important, by the way. Yeah, it's very much important. Now here, right here, so we have a embedding 1, we have a embedding 2. How I will be able to check that how similar these two things are? Now this is where, right, this is where a cosine similarity comes into a picture. So this is where what comes into picture? A cosine similarity. So C-O-S-I-N-E, cosine. So there are other methods as well. Going forward, I'll be talking about it. So this cosine similarity, this cos theta, right? It always says that if I have a vector, right? Let's suppose I have an embedding vector 1, right? I'm going to represent vector in this way, and we have an embedding vector 2, so second vector. So its cosine similarity is going to be embedding vector 1 dot embedding vector 2. So this is the formula for a cosine similarity you will be able to get. And I'm going to show you the calculation, so don't worry about that, right? Practically, I'm going to show you that part. But yeah, so here it may give you a result closer to +1. It may give you a result closer to 0. It may give you result closer to -1, because this is where this cosine is going to fluctuate, -1 to +1. Now, if result is closer to 1, it simply means that there is a very, very high similarity. If it is going to be absolute 1, then perfect similarity. So high similarity. If it is closer to 0, then in that case I can say that okay, so no similarity. And then here, if like it's -1, so I can say that it's completely opposite. It's completely going to be opposite. So this is how you will be able to like check that, okay, so what is basically, because I'm trying to check between two vectors, right? So this is maybe a vector v1, this is maybe a vector v2. So I'm just trying to check a theta in between, a cos theta in between these two vectors, basically. So embedding 1 and embedding 2, between these two. So I'm trying to check with a very high dimension. So here I'm able to represent just with the 2 dimension, but yeah, with a very high dimension. So I'm trying to check with the help of this particular formula. But when you try to check a cosine similarity, so you have to normalize a vector in a very, very first place. Means the embedding 1, embedding 2, which I'm talking about, which is my vector technically, right? So you have to normalize those vector. So normalization always ensures that it will always try to, right? So it will always help you out in terms of like basically stopping a data to create some sort of a skewness in between, right? Skewness in between. So this is where normalization comes into picture. And what is the formula for a normalization? So formula is again very simple for a normalization. So let's suppose we have a vector v, right? Or maybe we have a embedding e1. So if I have to normalize e1, what I can do is, so normalized e1 is going to be basically E1 by E1. Simple. Now, what is this? What is the denominator, by the way? So it's nothing but E1 divided by inside a vector, right? Inside a vector. So I will be having a multiple data, right? For example, if I'll talk about E1. So let's suppose we have A1, we have A2, and so on. These numbers, right? These numbers. So it's nothing but A1 square plus A2 square plus A3 square and so on for all of these dimension. Simple. So this is called as normalized vector, and normalization always try to, right? So normalize always try to scale a vector to have a unit length or magnitude is equals to 1 without changing its direction, right? Without changing its direction, so that it will be able to nullify the magnitude part. So, and it will be able to retain all the meaningful information, as simple as that.
So here, let's try to implement a normalization and let's try to implement like a cosine similarity, and let's try to check that how this is technically going to work with me. So I'll try to open up my VS Code, and here, so I can create a file cosine underscore normalize dot ipynb. Yeah, ipynb. Now I can try to select my kernel over here, and then I can show you that how normalization and how this cosine is going to work. So for normalization, I can try to create my own function. So import numpy as np, fine. And let's try to create a normalization function, normalize, normalize. So if I'm going to provide any kind of a vector, so what it should return, so it should return vector v divided by numpy dot linear algebra dot, there is a direct function which is available, right? There is function which is available, norm. So now this is going to return me the normalize one. Now, so here, if I have to like define the cosine similarity function, so cosine underscore function. So here, let's suppose if I have to check between two vectors, so I can try to pass maybe vector a and vector v, and then it should return me. It should return me what? So numpy dot product of, basically dot product of normalize a and normalize b that I have already created, right? So dot product of basically normalize a and normalize b. So this is supposed to create, and this is going to be my cosine similarity. Simple, right? So cosine similarity over here. Now, so we have this function which is available to me. What I can do is that I can try to create a array over here. So maybe I can try to create my vector. Manually, I can try to create a vector. So vector 1 I can try to create. And vector 1 is basically 1 comma 2 comma 3. And then I'm going to create a vector 2 just for the testing purpose. So again, vector 2 says that I have 2 comma 3 comma 4. And then maybe I can try to create a vector 3 over here, and vector 3 is having, let's suppose, -1 comma -2 comma -3. Yeah, so I have 3 vector over here. Now I have to check what is a similarity score, or how similar this vector 1 and vector 2 is. So simple, I can try to call my cosine function, and here, so I can try to pass my vector 1, and here I can try to pass my vector 2. Now it is giving me a similarity close to 99. So basically close to 1, right? This is what I have written over here. So it's basically coming close to 1. So there is a very high similarity. Now what is a similarity between vector 3 and vector 2? It's negative, right? It's a negative. What is the similarity between vector 3 and a vector 1? So it's basically negative, right? -1. So there is like a almost like a opposite. -1 means absolutely opposite to each other. So this is how cosine similarity is going to work. Now, so here I have given you an example, right? That my name is Danshu. Danshu is my name. So let's do that example now. So here text, yeah. So text and text 1. And I'm going to like store it in this way. So my name is Sudhanshu, fine. And then I'm going to take maybe text 2, and here I can try to write Sudhanshu is my name. Sudhanshu is my name. So I have 2 text. Now what should be the first thing? First thing should be to convert this entire information into an embeddings. Okay, I can do that. So to convert anything into an embeddings, I can try to use a URI API, and with the help of URI, I can try to do that. Yeah. So I have already used it even in my last class. So here, what I can do is that instead of this text 1, so here I can try to, instead of this input, so I can try to provide maybe a text 1. Yeah, text 1 I can try to provide over here. And then, or maybe I can try to parameterize it. That will be much better. So text, and then text will come over here. And let me change the URI API key. So URI API key will be what? So URI API key will be here inside the authentication tab. So here I can try to change the authentication. Okay, change the authentication, fine. So here I have just like made this function a little bit generic, and it is going to hit this like a model, this particular model, and this model is hosted at this particular path, this particular URL, and it is going to give me the response. Yeah, it is going to give me the response. I don't think that these things are important, by the way. So I'm just looking for like a embedding as a result. So maybe just remove everything. Yeah, just remove each and everything. So I just need this much. Nothing much is required. So I just need this much. So numpy.array data 0 embeddings. And okay, so data numpy.array and data, fine. So embeddings. So this is the only things which I need. So fine, let's execute this part. Yeah. And now let's try to call emb d1. So embed 1 is nothing but get embeddings, and then inside that try to pass text 1, fine. And embed 2 embd2 is nothing but generate embeddings function, call once again, and then try to pass text 2 over here. Execute it, and object of type set is JSON not serializable. Okay, so let me check what is the issue. I don't see any kind of a issue so far. But yeah, let me check. Yeah, okay, so the obvious selection was like error because of this curly braces use around the text. So I've just removed that curly braces. Now it's fine. So now let's try to like execute this one, and here, so let's try to call embed1 embd1. So embed1 is this one, and let's try to call embed2, by the way. So embed2 is this one. Now I would like to like know that how similar these two sentences are. I'm able to convert the sentences into embeddings with the help of my embedding API. Now here, so I can try to call my cosine function, and inside that I can try to pass my embed 1, and then I can try to pass my embed 2. And yeah, so it's like a very much similar, right? So this is the result that I'm able to get. So this is the reason. So we are going to use like a this kind of a similarity check, basically, so that it is going to tell me that how similar these two data set is, how similar these two sentences are. So successfully, guys, we are able to learn that how cosine similarity has been implemented even in a mathematical form or even in this way. Plus, I'm able to take my own data. As you can see, I'm able to convert those data into embeddings, and for that data, I'm able to even check that how similar these two data set is. So that's the beauty of embeddings, and again, you guys will keep on using this entire thing. So remember always, right? Remember always. And even in the future, so you all are going to use it. So with that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so welcome to lecture once again, guys. Now in this lecture, I will be talking about a vector database, and I'll be talking about a working mechanism of a vector database, how it is going to store the data, how it is going to perform the indexing operation on top of the data, how it is going to perform a similarity search, or you can say cosine similarity, equivalent distance kind of a things on top of the data set. This part is pretty much important because whenever you are going to build any kind of a system which requires a vector database, for example, a RAG application, if you are going to build, obviously you are going to encounter such things, and obviously you will have to deal with it, and you must be having an idea about the mathematical execution behind the scene, and that is something which I am going to show you, that is something which I am going to explain you now in this particular lecture. So let's try to understand one by one, everything. So here we are going to talk about basically vector database. Yeah, we are going to talk about vector database. Now, what is a vector, by the way? So let's suppose if I am writing a 1 comma 2. So I am trying to say simply that, okay, so there is a entity, and that entity is having maybe 1 along an x-axis, right, magnitude wise, and then 2 along the y-axis. So maybe here this dot is going to represent this entire entity. So where I have x is equals to 1 and y is equals to 2. And this is going to be a vector, right? This is going to be a vector A, let's suppose. This is going to be a vector A.
So an entity which is having a direction as well as which is having a dimension, it's called as vector, right? It's called as vector. Now, so whenever we talk about generative AI, or whenever we talk about like a RAG application, so over there you must have encountered that we are using a vector database, right? We are using a vector database. So what we are trying to achieve with the help of vector database? So we are trying to store our images, we are trying to store our text, we are trying to store our entire like a movie file maybe, or any kind of a data in a form of a vector, means in this particular format with maybe a very high dimension. So maybe with a 1236 or 1536 dimension or something like that, right? Or maybe 1000 plus dimension, maybe a 500 plus dimension, in which we are trying to store this data. Means we are converting eventually a data in a vector form. So whether we have a audio data, whether we have a image data, whether we have a textual information or any other information, so we are converting all of those information in a form of vector, and then we are trying to store it into a vector data. That's completely fine. We'll try to show you that part as well, that how we can try to store, how we can try to convert all such kind of a data in our upcoming lecture. But before that, we have to even understand that when we are trying to store all of this data, right, in a form of vector, how it is going to do a search operation, how it is going to perform like a, because at the end of the day, storing something into a vector DB simply means that it should help me out when I'm trying to search. It should give me a similar kind of a result, right? Then only we are going to use a vector DB. Otherwise, there is no use of like a vector DB. So how it is going to do a search operation, how it is going to perform the indexing operation, that is something which I am going to explain you in this particular lecture. So I'll just try to restrict myself towards these points. Yeah. So let's try to understand, and for that I would like to give you an example. I would like to take the example. So let's suppose we have some of the data set, right? So we have some of the data set over here. Now, what kind of a data set we have? So let's suppose we have a ID of the data, so ID 1, and then we have basically a vector, right? We have a vector. So I'm going to take a two-dimensional vector so that it will be easy for you to do a calculation and even to understand. Now you can extend it till any dimension, right? Or like till any length, that's completely fine. So ID is equals to 1. Let's suppose I have a vector 1 comma 2. Yeah. So ID is equals to 2. Let's suppose I have a vector 2 comma 3. ID is equals to 3, and let's suppose I have a vector 10 comma 10. ID is equals to 4, and I have vector 3 comma 2. Yeah. So let's suppose I'm storing this information, this entire data set information into some of the database. Yeah, I'm storing this entire information into some of the database. That's completely fine. I can try to store it. Then someone is trying to query, someone is trying to basically query with this particular vector. So with this particular vector 2 comma 2, someone is trying to query. Now whenever someone is trying to query with 2 comma 2, so obviously it should search inside this entire vector information which I am trying to store, right? It is supposed to search inside the entire vector information which I am trying to store over here, and it should always give me a similar data which is very much close or very much similar to the query or the question which I am trying to ask. Maybe this is my vector, right? This is my query. So it should always give me a data which is similar, right? Which is similar to this particular query from this entire vector set. So maybe it should give me like a top 2, top 1, top 3, top n, whatever it is, right? So, but it should give me information. Okay. Now, so how it is going to perform this query search operation inside the existing data set that you have? So first of all, what it does is that it is going to store this entire information, right? It is going to store this entire information by creating a indexes. So there is something called as IVF index. There is something called as what happened to my pen? Yeah. So there is something called as IVF index. It is going to create IVF index. Now, what is this IVF index, by the way? So IVF index, if I'm going to talk about a full form, so it's nothing but inverted file index. It's called as inverted file index. Now, how it is going to create this IVF index? So it's very simple. So based on the similarity, based on the clustering, so it is going to basically create the IVF indexes. It is going to keep a data together. For example, in this small data set, which is having just like a 4 example, right? So it is going to create a cluster. Let's suppose it is going to create a cluster, right? So cluster 1 it is going to create, and it is going to create a cluster 2, let's suppose. So in a 2 group, it is going to divide the data, for example. And why we are dividing it, I'll be talking about that as well. Yeah? I'll be talking about that as well. So here it is going to divide a data into 2 clusters. So it looks like that for ID number 1, ID number 2, ID number 4. So these data sets are like very, very close to each other. So maybe I can create a cluster 1, cluster 2 and cluster 3. So where data set is very much like close to each other. And then I can try to create a cluster 2 where I can try to keep ID 3. So ID 1, ID 2, ID 3 comes inside the cluster 1, ID 2 and inside the cluster 2 we have basically ID. Sorry, I think I have done some mistake. So yeah, 1, 2 and 4. 1, 2 and 4 will come inside the cluster 1, as we can see that their data set is pretty much close to each other. And here, so inside ID 3, so I have 10, 10, so which is like a very much distant from all the other data sets. So maybe I can try to keep it here. So ID 3 will go inside a cluster number 2. So I'm trying to divide the original data. Why I'm dividing? I'll try to make a conclusion at the end of this lecture. But yeah, so I have divided this data into 2 clusters. Now, so this is basically we can do it with the help of inverted file indexing. So we are just like dividing this data into 2 clusters. Now, so whenever someone is trying to do a query, 2, 2, right? So it will try to, right? It will try to look into a cluster. So which cluster's data is near? So whether a cluster number 1 data is near or cluster number 2 data is near. Yeah. So whether cluster number 1 data is near or 2 data is near. So obviously a cluster 1 data set is near to this particular query. Yeah. Near to this particular query. So what it will do, it will not even go with the comparison with cluster number 2 data. So whatever data is available inside the cluster number 2, it will not even go and do the comparison. What it will always perform, it will go ahead and will try to do a query with respect to a cluster number 1. Now, so here it will try to do a comparison with 1. It will try to do a comparison with the 2. It will try to do a comparison with the 4, but not with the 3. Now, by doing this one, right, by doing this indexing operation or by doing this indexing partition operation, you can say, so we are trying to make this entire operation faster. As you can see that we have 4 inputs, right? Or we have 4 things inside my database. We have 4 entities inside my database or 4 vectors inside my database. I am able to avoid at least one, right? At least one comparison. So I'm not going to do comparison with respect to cluster number 2. I'm going to do a comparison with respect to only cluster number 1 set of the data. So that is the advantage you will be able to get. And as your data set is going to grow, so obviously you are going to divide a data into a multiple clusters. So you are avoiding a lot of computational overhead over here. Okay, that's cool. So inside a cluster number 1, we have like ID number 1, 2 and 4. Okay, so inside a cluster number 1, we have ID number 1 data, ID number 2 data and ID number 4 data. Technically, we have ID 1 data set is nothing but 1, 2. So 1, 2. ID 2 data set is nothing but 2, 3. So ID 2 data set is nothing but 2, 3. And ID 4 data set is nothing but 3, 2. Yeah. So 3, 2. So these are my data set. These are my 3 like a data set which is available inside my cluster number 1. Okay, cool. And I have a query, and the query says that it's 2, 2. So with this 2, 2, I have to make the comparison and I have to find out the top similar result. Yeah, top similar result. So here I can try to use a cosine similarity, or I can try to use basically a Euclidean distance. First of all, I would like to show you with respect to a cosine similarity over here. Yeah, cosine similarity. So here for if we are trying to calculate a cosine similarity, so cosine similarity is nothing but cosine similarity for between two vectors a comma b is nothing but a dot product of a and b divided by norm of a and b. Simple, right? So this is something that is going to like give you basically this cosine for any vector, any two vector, right? Now why we are even calculating this cosine similarity? What is a meaning of this cosine similarity? Let's try to understand that. Yeah, let's try to understand that. So formula wise, this is the formula that is like a completely fine. So this is the formula that we have for the cosine similarity, where a and b, so in a numerator, so we are trying to perform the dot product of two vectors a and b, and then in a denominator, so we are trying to perform the Euclidean norms, or you can say a length of the vector a and length of the vector b. So we are just trying to like multiply length of the vector a and length of the vector b, so that the entire result will depends upon the angle between two vectors. Now here, so cosine similarity will always try to give you a data, or it is always going to give you output between what? So between -1 to -1 to +1. So in between this, it is going to give you the final output. Now, if output is closer towards or moving towards a +1, right, it simply means that perfectly similar. If it is closer to a 0, the result is closer to a 0, then you can say that vectors are orthogonal, means there is a 90-degree between two vectors, and you can say that no similarity. And if it is -1, you can say that vectors are opposite, right? Opposite to each other. So means two data set which we are trying to do the comparison. So obviously it is going to be opposite to each other. Now angle wise, as we know, so cos theta is nothing but a dot b divided by a length of vector a into length of vector b, right? So here, if angle is 0, angle wise I'm trying to explain. So if theta is equals to 0 degree, so in that case 1. If it is theta is equals to 90 degree, so in that case value is equal to 0. And if theta is going to be 180 degree, in that case it is going to be -1. Simple, right? It is going to be -1 over here. Now, so you may get some sort of a result in between 1 and -1. Every time you will be able to get a result between 1 and -1. Now for our example, the example that we have taken, so what is going to be the result? How we are going to find out the cosine similarity? Let's try to understand. So first of all, what we will do, so we will try to find out a cosine similarity between this query and a data from ID1. Then query ID2, and then query ID3. So that we will try to understand that which one is similar, which one is more similar to the query vector that we have, right? So this is where cosine similarity we are going to use, and this is the calculation we are going to do. A very simple calculation. So like a dot product divided by length of vector A into length of vector B. So now let's try to do the math over here. Math for what? So math for ID1 data, right? Math for ID1 data. So what is the ID1 data, by the way? So ID1 data is 1, 2 versus a query. So what is my query? So query is basically 2, 2. So in between these two, I can try to find out the cosine similarity first, right? We can try to check that whether these two are similar or not. Now to find out a cosine similarity, right, between these two. So let's suppose we have a Q over here, we have a ID1. So we have to find out, I'm assuming that this is A and this is B. So here we have to find out A and we have to find out a B. B is nothing but my query, right? So here B for this one is going to be 2 square plus 2 square is equals to root of 8 is equals to 2.8284. So this is going to be this one. This is going to be for B. Simple, right? For A, so again 1 of a square plus 2 of a square, right? So basically we are trying to find out the magnitude. So 1 of a square and 2 of a square. Now what is going to be the like a 1 square and 2 of a square? So it is going to be root of 5, which is eventually going to be 2.2361. Okay. So we are able to find out this one. Now let's try to find out the cosine similarity. So cosine similarity is nothing but cosine similarity between vector A and B is nothing but a dot product of A and B divided by magnitude of A and into magnitude of B. So this is something called as cosine similarity, right? Now what is the dot product of A and B? Because denominator we are able to find out anyhow, so we can try to put up this denominator. But what is the numerator, by the way? So numerator dot product is nothing but, right? So dot product between 1 and this one. So basically A and B, dot product between A and B is something that we are supposed to find out. So how we can try to find out a dot product in a very first place for this kind of a data, for this ID like 1 comma 2 and query is equals to basically 2 comma 2. Let's try to understand that part. So let me write down that dot product, and many of you may be like aware about it, maybe many of you are not aware about it. So let's suppose we have a vector A and a vector B, right? And a vector A, let me write it down somewhere here formula wise. So let's suppose we have a vector A is nothing but A1 and then A2. Yeah, A1 and A2. And we have a vector B, and vector B value is B1, and let's suppose we have a B2. Yeah. So a dot product of A and B is nothing but, very simple, right? Very simple. So dot product is nothing but A1 into B1 plus A2 into B2. That's it. Yeah, that's it. This is going to be the dot product. Okay, so here we have a vector. So what is going to be the dot product? Let me write it down. So 1 into 2, 1 into 2 plus 2 into 2 divided by what? So divided by magnitude of A, 2.2361 into magnitude of B, so 2.8284. Okay, so if I'm going to do the math, right? If I'm going to do a math over here, I will be able to find out a final value, right? I will be able to find out a final value is equals to 0.949. Now this is the value I will be able to find out between ID1 and query. Yeah. So this is the cosine value between ID1 and basically a query vector. The value is what? Value is 0.949. Okay. So 1 is done. Fine. Now then ID2 and query. So what is a distance cosine similarity between ID2 and a query? So again, similarly, we can try to find out the way we are able to find out this one. So we can try to find out even for ID2 and a query. So that is going to be, cosine similarity is going to be 0.980. So for a second case, then ID3 and a query. So what is the cosine in between? So ID3 and ID not 3, ID4, right? So ID4. So we had basically ID1, 2 and 4, 3 comma 2. So what is a similarity between these two, or what is the cosine similarity between these two? So ID like 4 and query. So ID4 and query cosine similarity is again going to be 0.980. Yeah. So for third one. So we had 3 data, and for all of these 3 data, we are able to do we are able to find out the cosine similarity. Yeah, we are able to find out the cosine similarity. A very simple thing, right? We are able to find out the cosine similarity. So here, right? So here we can try to prepare a chart, ID and then cosine. So this chart wise ID1 and then cosine is basically 0.949, ID2 0.980, and for ID3, so we have, sorry, ID4 we have 0.980. And let's suppose ID3 is not available in this cluster, ID3 is available in some other cluster. So even for ID3, we can try to find out basically a cosine similarity. That's also possible. Yeah, that's also possible for me. So maybe for ID3, it's possible to find out the cosine similarity, but let's suppose I'm not finding it. It's completely fine. Leave it for now. Now, if someone is going to ask you a question, right? If someone is going to ask you a question that give me a top 2 result, yeah, give me a top 2 similar vector. So which vector is going to be a top 2 similar vector? Yeah. So what will be your answer over here? So here cosine similarity is this, this, and this, at least for 3 vector, vector 1, vector 2, and vector 4. When we are doing a comparison, so we have a cosine is equals to 0.949, 0.980, 0.980. So which two or which one is having less distance by the way? Yeah, so less distance by the way. So which one is having a less distance? So here, right? So here we can say that top 2 vector, which is very much near, right, which is very much near to my query vector, is ID2 and ID4, 0.980, 0.980, right? These are the top 2, right? These are the top 2. And again, so if you will look closely into the data, right? If you will look closely into the data, so here we have a query 2, 2. So 2 and 4. So 2, 3, 3, 2. So 1, 2 is not that near. It's little bit far, little bit, right? Not much. But yeah, 2, 3 and 3, 2 is nearest one with respect to this query vector. And this is the conclusion that we are able to find out. This is the conclusion that we were looking for with the help of cosine similarity. So cosine is always going to give you basically what? So cosine always try to give you the similarity search result. And here we are able to find out that ID2 and ID4 is the nearest one. Yeah, ID2 and ID4 is basically a nearest one. So my final answer, so in terms of top 2 search or top K search, we say, right? So we have ID2 and ID4 nearest one for my given query. Yeah. So top 2 result is going to be value which is available at ID2 and value which is available at ID4, as its distance is minimum 1, right? Minimum 1. And again, so you can try to find out a cos theta with respect to this particular value which is available in a radian, and you will be able to even see values. So this is how, right? This is how we always try to find out a similarity. Again, I can try to use a Euclidean distance as well for doing the same operation. But yes, cosine is a widely used things. Plus, one more thing I would like to explain once again, that here we are not doing comparison with the ID number 3, because ID number 3 belongs to another cluster. So we are trying to even avoid lot of computation over here, lot of calculation, because as my data set is going to grow, obviously I will be having n number of clusters, and with all the data I should not do the comparison. So here we had in total 4 data, but we are doing comparison with how many data? Only with 3 data, right? Only with 3 data. We are not even considering the 4th one, because the reason is very simple. That data set is far away, or that data set is available into a different cluster. So that is the advantage of the indexing. That is something called as indexing of the data. So whenever we try to store the data, system is going to call the indexing. So for example, IVF indexing system is going to call, and the system is going to store a data into a different vector space. We say like IVF, right? So IVF is one of the way to do a indexing. So inverted file indexes or inverted file we try to create, where we try to store a different chunk of the data. And then when someone is going to fire a query, we never look into all the data. So we just look into a data where the centroid of the cluster is near to the given query, and that is going to do the calculation, that is going to give you the final result. So hope this entire vector concept and how vector calculation happens internally is clear to all of us. Like I said, so cosine similarity and IVF. So IVF for indexing I talked about, and then cosine similarity for a similarity search I talked about. Now this is not the only combination. Likewise, there are many more other combinations which exist in terms of doing a indexing and in terms of doing a similarity search. And plus, many people gets confused between the indexing and the similarity search. Never get confused between indexing and the similarity search. It's very simple. Indexing means we are trying to divide a data into a different chunks or the clusters. Similarity search means, so inside a particular cluster, we are trying to do the mapping so that I will be able to get a top n number of result, or we say top k result I will be able to get out of it. So with that, thank you so much everyone. Take care and see you again in my next lecture, guys. Okay everyone, so let's try to understand just a cosine similarity, that what is a cosine similarity, how calculation happens, how it is going to work internally. So just by taking some sort of a mathematical calculation. So here, if I have to explain you a cosine similarity, so cosine similarity, so maybe I can try to explain you in this way. So cosine similarity is going to measure an angle between two vector. For example, so we have, let's suppose, a vector A and we have basically a vector B. So at the end of the day, it is going to give me, or it is going to like measure a cos theta between these two, vector A, let's suppose, and a vector B, as simple as that. So this is something that it is going to measure. So the simple point over here is that if angle between these two vectors are small, in that case these two vectors are more similar to each other. And as this angle will widen up, or as this angle will grow between these two vectors, it simply means that dissimilarity between these two vectors are increasing, as simple as that. So angle should be small as possible, so that vectors will be similar. And if angle is far away, so in that case vectors are not similar at all. Many of us must be aware about the vector, by the way, right? So for example, if I'm talking about a vector A, so we can try to represent maybe in this way, right? So on a x-axis we have this, and on a y-axis we have this as a magnitude, and then obviously a direction. And then if we have to represent maybe a vector V, so we can try to represent maybe 2, 3, right? So again x, y, x-axis and y-axis value we can try to represent. So these are the two vector, and then maybe we can try to like find out how like similar these two vectors are just by talking about the angles between these two vectors. And why it is important, where we are going to use it? So we are going to use it for embeddings, because obviously whenever we try to like store embeddings into our vector DB, this is the comparison that we try to do. And maybe for a document similarity check we can try to do, we can try to even build a recommendation system out of this entire things based on the cosine similarity. Now what is the formula, by the way? So cosine similarity formula says that cosine similarity formula for vector A and B is nothing but a dot product of A and B divided by length of A, vector A, and length of vector B. So this is basically a cosine similarity formula, which is very much easy and very much simple. Yeah. So length of the vector A is this, or you can say it's a Euclidean norm, or for A and then Euclidean norm for B, or maybe you can say length of the vector B. Very simple. Now, so here the result wise, right, result wise, so it is going to give you a result between -1 to cosine similarity. So it is going to give you a result between -1 to +1. It is going to give you result in between these two. Now, so if result is coming closer to +1, it simply means that angle between two vectors, vector A and vector B, is closing towards a 0, closing towards a 0. So you can say that it's going to be perfectly similar. If it is closing towards a 0, it simply means that you are going to make an angle. If value is equal to 0, means angle wise it's going to be 90 degree. So no similarity. You are moving towards a no similarity. Okay. If it is going to be a -1, in that case it's going to be angle wise 180 degree. If it is value is tending towards a -1, then it is going to be a 180 degree, and it simply means that we are talking about a complete opposite direction. As simple as that. Yeah, complete opposite direction that we are talking about. Now, so based on this, you can try to say that whether these two data set or data A, data B is similar, data A, data B is not similar, or maybe data A, data B is opposite to each other. Based on this, you can try to make this particular conclusion. Now, let's take one example. And by taking an example, I would like to show it to you. So let's suppose A is equals to 1, 0, and vector B is nothing but, let's suppose, 0, 1. Okay. Now, dot product. So what is the dot product? So dot product is nothing but, dot product of A and B is nothing but 1 into 0, 1 into 0 plus 0 into 1, 0 into 1. So technically it is going to be 0 as a whole. So dot product is going to be 0. Now, so denominator wise, what is a length of vector A? Length of vector A is nothing but 1 square plus 0 square is equals to 1 ultimately. And what is the length of, or like equivalent norms of vector B? So it's nothing but 0 square plus 1 square is equals to again 1. Now, so cosine similarity, if I have to calculate cosine similarity, so dot product of vector A and B divided by A and then B, Euclidean distance, right? Euclidean norms basically. So denominator is going to be 0, numerator is going to be 1, 1. Technically it is going to be 0. So cosine similarity is going to be 0. It simply means that no similarity between vector A and a vector B. Both are perpendicular to each other. So both are going to make a 90 degree. So this is the value. This is not the degree, by the way. This is going to give me a value. This entire equation is going to give me the value. Now, here, if I would like to calculate what is the value of cos 0, right? What is the value of a cos 0? So, or what is the degree for a value cos 0? So, it is going to give me basically a 90 degree, as simple as that. Okay, so cosine similarity 0 means simply means that there is an angle of 90 degree between A and B vectors. So, basically there is no similarity that we are able to find out, right? So, there is no similarity. We can make that as a conclusion that, okay, so angle between vector A and vector B is basically 90 degree, because the cosine similarity value that we are able to observe over here is basically 0. So here I would like to create a chart basically. I would like to basically create a chart. So inside this chart, I would like to write something. So here, angle between vector cosine similarity value and then its meaning. So let's do that. Yeah. So let's suppose angle between vector is basically 0 degree. So cosine similarity value is going to be approximately close to +1. Yeah. So it's, if 0 degree, it simply means that +1. +1 means, so same direction, and maximum, I can say, similarity. Yeah, maximum similarity, because there is angle 0 degree or closing towards a 0 degree. Let's suppose angle is 60 degree, means value will be, cosine similarity value will be closer to or around 0.5, or you can say that moderate similarity. Now, if angle is 90 degree, so you can say that value will be 0. So if cosine similarity value is 0, then angle is going to be 90 degree, means perpendicular to each other. So no similarity, I can say. Similarity. If angle is 120 degree, so it's going to be, value is going to be minus of 0.5, cosine similarity value wise. So you can say that
moderate, opposite, and if angle is 180-degree, value is going to be -1. So I can clearly make a statement that it's completely opposite to each other, right? Completely opposite to each other. So this is where the cosine similarity, like conclusion, you can try to find out, and based on this you can say that whether two vectors are similar to each other, two vectors are not similar to each other. Calculation wise, it's a very easy calculation. You all will be able to find out. It's nothing, right? It's nothing. And majority of database, vector database especially, are going to support this cosine similarity inside a particular cluster. Depends like how they are dividing the data, what it is going to do with respect to the indexing of the data. But yeah, this is something that you all will be able to find out. So hope all of you are able to understand a cosine similarity, how it works actually, and then we are going to see a lot of practical example going forward in my upcoming lecture. With that, thank you so much everyone. Take care and see you again in my lecture. Okay, so welcome back once again, guys. Now in this lecture I'm going to talk about just a small comparison between the most popular vector database which is available as of now in a market. Now these are not the only vector database which is available into a market. There are a lot of other databases also which exist inside a market. You can try to use it for a different purposes, but yeah, these are the most famous one. For example, the very first one is Facebook AI similarity search. The second one is ChromaDB, Pinecone, then BayesVector, and then Quadrant. So these are the databases which can store your vector information, which can try to do indexing inside it, which can try to even do searches inside it, which can try to give you the similar result as per your query, or top case search result it is going to give you as per your query. So one by one we'll try to take a walkthrough. We'll not try to invest much of time, but yeah, just try to take a walkthrough of this entire things in terms of a feature. So type wise, so basically it's a library. ChromaDB is a library plus database. Library means, so basically code is available and you can try to install these libraries, and after installing these libraries you can try to use its functionality. This is what it means. Now ChromaDB library plus database, a proper inbuilt or like a pre-built database is also available. Pinecone is a managed cloud DB, so where you will be able to you can go over a cloud and you can try to access this entire Pinecone. BayesVector comes with a managed plus OSS, and Quadrant also comes with managed plus OSS. Now hosting wise, this is a local one, Facebook AI similarity search. So you can try to host it locally, and then you can try to maybe build your own Docker, and then you can try to make it available on your own cloud platform. Now ChromaDB, same as this Facebook AI similarity search, and then Pinecone cloud only, BayesVector cloud and self-hosting, and Quadrant supports cloud and self-hosting. Persistent storage, no, that you will not be able to get. ChromaDB, yes. Pinecone, yes. BayesVector, yes. And then Quadrant, yes. Scalability, you have to handle it. ChromaDB comes with the limited scalability. Pinecone, as it's a managed one, so it goes for the auto scaling, then auto scaling, then auto scaling. API access, so no REST API, you will be able to access ChromaDB, yes. Python API, that is there. Pinecone, REST APIs and gRPC APIs are available. For BayesVector also it's same, and for Quadrant also it's a same one. Indexing wise, so Facebook AI similarity search supports IVF, HNSW. HNSW is technically for a graph basically. So there is something called as PQ and there is something called as flat. So these are the indexing technique, means dividing a data into the entire databases, but technically creating a small clusters or maybe graphs. This is something like that. ChromaDB, HNSW, and then Pinecone, they have not revealed it, it's a propriety. BayesVector, HNSW, flat and IVF it supports, and then Quadrant it supports HNSW, IVF and a PQ. Then in terms of filtering, so you can try to go ahead with manual filtering, and then metadata filtering wise, inbuilt replication. So you can't create a replica of this Facebook AI semantic search. Again, same for the ChromaDB, but for Pinecone, BayesVector and Quadrant, yes, you can do that. Now embedding storage wise, vector only data it can try to store in terms of a Facebook AI similarity search. And if I'll talk about a ChromaDB, so it can try to store a vector plus metadata, data about a data, and then a document itself it can try to store. And if I'll talk about Pinecone, and if I'll talk about a Bayesian and quadrant, so it can try to store a vector plus meta plus schema it can try to store, and vector plus payload it can try to store. Integration, so you can look for the custom integration. ChromaDB, so with LangChain and Llama index, it provides your integration. Again, Pinecone, LangChain and Llama index. Again, for a Bayesian, LangChain, Llama index, and quadrant, LangChain and Llama index. So they are giving you a inbuilt integration basically. So without any kind of a hassle, you will be able to integrate it. License wise, so it's comes with a free MIT license, Apache 2.0, proprietary SaaS, Apache 2.0, Apache 2.0. And Facebook AI Similarity search, it's good for a local search, fast local search. It's ChromaDB is good for embedding plus metadata search. A Pinecone is good for a production grade SaaS application. Bayesian is good for a knowledge graph and hybrid search, and Quadrant is good for vector search for a filtering. Now, so although this entire points are not that great and important, but sometime, right? Sometime we should be aware about it, and we must have done the comparison so that whenever we are going to do a discussion amongst our team, at least from like this memory, we can try to recall something, and then based on the use cases, we can do a discussion based on the problem that we are trying to solve, maybe for a client, maybe inside a particular project. So we can try to do the comparison, and this is where these things are going to come into a picture. This is going to help you out. That was the whole idea. That was the whole intention behind this particular lecture. There was nothing else, by the way. Yeah, there was nothing else. Now, so this is one of the parts. Second part is these are not the only vector database which is available in a market. Apart from that, there are like a lot of other databases which is also available in a vector database category, which eventually we will try to understand in my upcoming lecture. So with that, thank you so much everyone. Take care and see you again in my next lecture. Okay, so welcome to lecture once again, guys. Now in this lecture, I'll be talking about a Facebook AI similarity search vector database, and I'm going to show you everything in a very practical manner so that all of you will be able to understand about an implementation, how we can try to take a data, how we can try to create a embeddings, how we can try to store the data, how I will be able to do a search, a top case search, how I will be able to do it. All of this operation I'm going to show you in my system, and this file will be available inside your dashboard. So obviously you all will be able to execute it. You all will be able to learn it out of the same thing. Not just that, so to create a embeddings, to create that vector, right, for any kind of a input data, you need an access of an model, a high quality model, which can try to generate a high quality embeddings. And the good news is that that kind of a model access is already available on a Euron platform, so which is going to help you out in terms of creating a high quality embeddings. I will be using even that part. So let me share my screen and let's get started in a step-by-step manner. So first of all, we have to do a couple of installation. So you have to do a pip install Facebook AI Similarity Search CPU and a request library. By default, request library will be available, but yeah, this installation is required. So I'm installing two things over here. One is a Facebook AI Similarity Search CPU, and the second one is basically a request. So just try to execute this part. Once you are going to execute this part, right? Once you are going to execute this part, then you have to import a couple of things. So first of all, import Facebook AI Similarity Search. Then try to import NumPy as np, and then try to import basically a request library. So request library. So these three imports are required. Only this much is required. Apart from that, so I have prepared a data set which is about me. You can try to take your own data set as well. And here is a list of the data set, and I have considered 10 such lines. So 10 such lines I have considered from my own like a journey, or you can say my own personal life. So I have taken this particular data set. You can consider taking some other data set. That's completely fine. That's not an issue at all. So this is my data set. Okay. Now, so data set is completely fine. The very first part that I should know and I should be aware about, that how I can convert this data set into a respective vector, means like a numerical space, how I can try to represent any of this data set in a particular numerical space. And that's pretty much easy. Believe me, it's pretty much easy. How it is going to be easy? So just go to Euron And then here you will be able to find out URI API. Now here you will be able to find out a code example. Now inside a code example, there is a Python tab. And this is for a chat completion, this is for a streaming response, and this is for text embedding and similarity. Copy this one, yeah, copy this particular code, and then I'm going to show you the implementation path. So copy this code, and here you will be able to find out generate embeddings, where you can pass your text, means where you can try to pass your data, and eventually it is going to give you a return. So it is going to give you a return as what? So it is going to give you a return as a embeddings, as simple as that. We have also given you a sample example over here, but you can try to delete this one, right? You can try to delete this one. So just try to use this function. One more thing. So here you have to replace this entire static, keep a bearer as it is, right? So you can try to replace this entire things with a URI API key. So here you have to pass your own API key, and how you will be able to get this API key. So you can get this API key inside the authentication tab. So click on authentication tab. And here, so you will be able to see your API token. So just copy this API token, simple, right? Copy this API token, and then you can try to paste it over here. So this is your API token. Whenever you are trying to do some implementation, try to use your own API key, right? And in authorization tab, you will be able to get it. Now, what kind of a model that we are using and what it is going to give you as a return? Let's try to understand this part a little bit. So available model, go to available model, and for embedding, so we are giving an access of a beautiful model, one of the best model in this world for embeddings from OpenAI, yeah, which is going to produce 1536 dimension vector for every input. Whatever data that you are going to input, it's from OpenAI. It's one of the most standard model. Model name is text embedding 3 small. So this is the model ID, and this is the model access that we have given to you. So whenever you are going to call this function by passing your API key, so it is going to invoke a model from OpenAI, and then it is going to give you a final vector, which is having a dimension of 1536, right? 1536. So execute it, and now I'm going to test it. So how I'm going to test it? So here I can try to call this function. I can try to provide maybe some text. So my name is Sudhanshu Kumar. Let's suppose this is the data that I have, and I have to convert this data into a vector space. Yeah, vector space of dimension 1536, because this is what my model is going to return. So execute, and as a result, you will be able to see the embeddings. What is the shape? So shape is basically 1536. Simple, right? So 1536. Now this is going to represent this particular line. So this is the actual vector which I'm talking about. Yeah. So this is the vector which I'm talking about. Now, so whatever line that we have over here, right? Whatever line that we have over here. So one by one, I can pass this line inside this generate embedding function, and one by one, it is going to give me the embedding, as simple as that. Yeah, it is going to give me the embedding for each and every line. I have already shown you the sample part over here. Okay, so let's do it. So here I'm going to create embeddings and empty list I'm going to create, right? And then I'm going to run a for loop for I in what? The data part that we have. So one by one, I will pass this data, and from this generate embedding, so I will eventually get this entire vector. So for I in dataset means go into a dataset, one by one try to extract the dataset, simple, right? One by one try to extract this dataset, and then try to create its embedding, and after creating a embedding, just try to store it inside this one. Simple, right? So for I in dataset, I can try to call a generate embedding for an I, right? Generate embedding for an I, and here, so I can try to call like this one. So it is going to return me the embeddings, by the way, right? It is going to return me the embeddings. Now out of this, I can try to keep on storing this entire information into my list. This one, yeah, into this particular list, I will keep on storing this entire information. So let's do it, guys. Okay, so let's write just a couple of lines of a code. So let's suppose it is going to return me the embeddings, EMB, it is going to return. Now I will try to append this embeddings into this embeddings, list that I have created. So this dot append and append what? So append emb, as simple as that. So append this one. So here, if I'm going to execute it, and now if I'm going to show you, so it is generating the embeddings. It is calling my API, and one by one, it is trying to generate the embeddings. It will take some time, not much. So just wait for some time, because for 10 dataset, it's calling the API. Okay, this is done. Now I can go and I can try to check that what I'm able to receive. So I'm able to receive a 10 such vector. And now if I'm going to like call embeddings and 0th one out of this. So this is for one. Now if I'm going to check what is the length of this one. So length of this one should be 1536, because this is what it is going to return. And even over here, it's been mentioned SAP is equal to 1536. So it is trying to represent every line into 1536 dimension. Very, very simple. Yeah, very, very simple. Okay, now once we are able to do it, let's try to convert this entire embeddings into a embedding array, by the way. Yeah, into a entire embedding into a embedding array. So to do that, what we can do, we can try to call numpy.vstack, by the way, and inside this, we can try to pass our embeddings. Yeah, so we can try to pass our embeddings, and here, so it is going to return me embeddings underscore array. Okay, now if you are going to check embedding array, so again, it's like a same thing, but yeah, so what I have done, I have just like converted that into a vstack. So here we have an array inside an array with the shape of 10 cross 1536, means we have a 10 data set and with the dimension 1536. This is what it means. Fine. Now, so once we are able to do this kind of a operation, right? Once we are able to do this kind of operation, let's try to extract just a dimension out of it. Dimension is anyhow 1536, so you can even try to hard code it. There is no issue with that. But yeah, programmatically, let's try to find out the dimension. So embedding array dot shape, I can try to call over here, and shape for only one, the very first one. So shape is 1536, and I'm going to store it inside like a variable called as dimension. Why I'm storing this? So you need a dimension to create a Facebook AI similarity similarity search indexes. Unless and until you don't have a dimension, you will not be able to create that. So here I'm going to call Facebook AI similarity search and then dot index index and flat L2. So flat L2 I'm going to call. So basically L2 is nothing but it's been known for a Euclidean distance. So here I'm going to create the indexes. I'm going to pass a dimension over here now. So it is going to return me a index. It is going to return me the indexes. Index. Now, so this index, which I have already created, inside this index, I'm going to store all of my data. Very simple, right? So inside this particular index, I'm going to store my data. So how I will be able to store my data, how I will be able to store the information. So index dot and simple, you have to call add. Add what? So add the entire embedding array that you have created. Very simple, right? So add the entire embeddings array that you have already created. So I'm adding the entire embedding array, right? I'm trying to add the entire embedding array. You can even try to check. So index dot n total. So this is going to give you that how many data you have stored. So I have executed this 2 times. So 20 record has been stored. Now execute once again. Now you can try to check 30 record has been inserted. Execute once again. Now try to check 40 record has been inserted. So I have inserted one record 4 times, by the way, right? So again and again, I have inserted the 4 record. I mean, I'm inserted the same record 4 times, as simple as that. You can try to even insert the single record. You can try to insert maybe like a multiple record. That's completely up to you. So here I have inserted the complete whole record in one single go. For example, if I have to insert only one single record, right? For example, I have like let's suppose I have a text data, right? And my name is Sudhanshu Kumar. I used to teach tech. So let's suppose if I have to insert this particular record. So how I will be able to insert?
Simple. First of all, call generate embeddings, provide a text. So it is going to give you the embeddings. Yeah. So provide a textual information, provide this particular data. So this is going to return you the embeddings. And then once it is going to return you the embeddings, just try to reshape it, right? So that you will be able to do the insertion. So it is generating the embeddings for me. NP array object has reshape, 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 and then try to store this one into a variable. So new data. So inside a new data, I'm trying to store the output. Okay. Okay. So this is how my new data looks like, which is nothing but embeddings into a vector space, as simple as that. And then again, I can try to call index, the index which I have already created with the same dimension, index.add, and add what? Add a new data. So even this will be stored. And now if I'm going to check index dot, so INDEX index dot n total, it is going to give me 41. So previously it was 40. And now I have created one more indexes based on my input data. And this, again, I'm able to store it. Very simple. Yeah. So I'm able to store it right now. So if I would like to persist this indexes physically, see, there is no indexes which it has created so far over here. So everything it is trying to do inside in memory, inside your RAM itself. If I would like to persist the entire indexes, so what I can do, I can try to call Facebook AI semantic similarity search, and then I can try to call write indexes, and then I can try to write the indexes. So which one? The index variable which I have created, where I'm writing each and everything, and then I can try to give my name. So Sudhanshu personal dot FAISS. So with the extension of this, I can try to store it. So here you will be able to see that it has created a file over here, a physical file. Inside that, it is trying to store all the indexes, and it's available into a binary. Yeah, it's available. It's available into a serialized format, basically. So you will not be able to read out this entire information. But successfully, I'm able to persist my indexes. Simple. For a future use case, or maybe if I have to share this with someone, so I can try to use basically this particular indexes. Even though if I'm going to restart my system, this is going to work for me. So insertion of the record is done. Now, so I have to perform a query. Yeah. So I am able to store the information. I'm able to store like this entire information. I'm able to store it, and even the additional information. So that entire information I'm able to store it like 4 times, and this is also I'm able to store. Now let's suppose I have a query. Yeah, I have a query. So QUERY query, and I'm going to like I'm having query who is Sudhanshu Kumar. Yeah, so this is my query. Now, so against this query, what data or what top 2, top 3, or maybe a top 4 data my Facebook AI similarity search is going to give? Let's try to understand that part. So basically, I'm talking about a search operation, because data is stored. Yeah, I'm already able to store the data. Now it's time to perform a search operation, and based on like a similarity search. So I'm going to do it, right? So based on the Euclidean, so anyhow we are trying to do it, because the indexes which I have created, that was a L2 indexes. So L2 is basically known for, like I said, so it's known for Euclidean distance calculation. You can try to go ahead with the cosine similarity as well. So here, this is my query. Now, so I have to convert this query even into embeddings, because this query is available into a string format as of now, right? So how I can try to convert my query? So again, I will call the same embedding function, so which is going to convert my query into 1536 vector dimension. So here I'm going to pass my query, yeah, pass my query, and then reshape reshape 1, -1. Okay, fine. Now, so this is my query underscore vector, let's suppose. So this is going to give me query vector. Query vector, it is going to give it to me. So it is able to generate the embeddings, and now my query vector embeddings are ready. So it's available. This particular sentence is available now into a numerical format. Now I have to do a search, right? I have to do a search. So how I will be able to do a search? It's very easy. So here, indexes that I have already created, the above one, the index which I have already created, dot, just try to call a search. Simple. Just try to call a search and pass your query vector. So embedding for the query that you have created, and then tell them that
what is a top search that you're looking for. So you're looking for a top 2 search, you are looking for a top 4 search, you are looking for a top 5 search. So you can try to mention that part. So maybe I'm looking for a top 2 search. So whatever top 2 sentence which is matching with this particular sentence, give me that. Simple, right? Give me that. So here, here, so it is going to return two things. It is going to return a distance as well as it is going to return the indices. Yeah, so two things it is going to return. So just try to hold it inside some variable, and then let's try to see the distance. So distance was this, and indices it is trying to print. So indices is basically data which is available at indices 0 and data which is available at indices 10, right? So data which is available at indices 0 and data which is available at indices 10. So technically that data is representing, or that data is more closer to this one. Now, so we have 41 data, right? So see, it's just a repetition. It's just a repetition. So 0 and then again 10 means it is trying to give me like a same sentence twice, basically. I'll try to remove that confusion. Don't worry about it. Yeah. But yeah, so here it is trying to give me 0. So what is a data which is available at indices 0? So data set of basically 0. So I have asked a query that who is Sudhanshu Kumar, right? Now with this data, it's having a distance is equals to 0.6490. Yeah, 0.6490. And it is telling who is Sudhanshu Kumar. Sudhanshu Kumar was born in Jamshedpur, Bihar, in India, to the modest family. So this is like a nearest one which it is able to find out with respect to my query. This is the nearest one which it is able to find out based on the who is Sudhanshu Kumar. Now if I'm going to change over here, so here top K, right? So here I'm going to change, and I'm going to say that give me 6, top 6. Yeah, give me top 6. So it is giving me indices 0, then 10, and then it is giving me 20, then 30, and then 40, and then even indices 3. So it's just a repetition. So here I'm going to like pull basically a data set which is available at third indexes. So Sudhanshu earned a computer science and engineering degree. So this is again the second most similar data, second most similar information. And again, even this one. So indices, let me correct the entire indices, guys. Let me do one thing. So I can try to, because I have just inserted the same record multiple times, and that is going to create some sort of a confusion in terms of looking at the data. So what I can do is I can try to delete this indexes, and then I can try to reprocess the entire indexes. So let's delete the indexes in a very first place. So del index index, and it will end up deleting the entire indexes. Now I can try to start from the fresh data set. So again this, it is generating this one. Then it is trying to generate the embeddings once again. Okay, so embeddings is ready. Length of embedding is fine. Total 10. Yeah. Now I'm going to insert one more. So total 11. Now who is Anshu Kumar? Query, 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 query. So these are the top 6 result. It is trying to give it to me. So data set at 0 and then data set at 10. So this is again a part of okay, so data set. Okay, so at 10 there is nothing inside the data set because I have added the additional one, right? So that was basically this data. My name is Danshu Kumar. I used to teach text. So this is basically available at 10 inside the indexes, but inside my data set, so there was no such like a data. So I have added it additionally on top of it. So data set at 3, a data set at 3. So again, this one data set at basically 6. So data set at 6. So again, we have this data, right? So this is the most similar result it is able to give it to me. And again, so you can try to pick maybe like a top 3. You can try to pick top 2. You can try to pick maybe like a top 10, whatever, right? Whatever you want. So based on the distances, because it is showing you even a distance. So based on the distances, you can try to check it. So distance is less, meaning is that most similar. Distance is little bit higher, so less similar than the first one, then less similar than the second one, then less similar than the third one, and so on. So in this way, you can try to select. You can try to select like a top K query result. So this is how this Facebook AI similarity search is going to work. So hope this entire things is clear to all of you. All of you will be able to do the implementation with respect to a Facebook AI similarity search. And again, you have a URI API available to all of you for doing a embedding. So with that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so once again, welcome back to lecture one, guys. And in this lecture, I'll be talking about ChromaDB. So ChromaDB is one of the another vector database where you can try to store a vector, and then you can try to perform update, search, insert, all kind of operations that you can expect from any other vector database. So I'll be doing all of this operation in my local system. So let me share my screen and let me go to a code part. So here, new file CHROMA ChromaDB.ipynb I'm going to create. Now inside this, I'll be like doing all the operations. So let me select my kernel in a very first place, and then in a very first section, you have to do the installation. Yeah, you have to do the installation. So here I can try to call pip install install CHROMADB. So ChromaDB. And yeah, so it is going to like install. So requirement all satisfied, because in my system it's already installed, and in your system, so eventually it is going to do the installation. Once we are able to do the installation, then try to call import CHROMA So import ChromaDB CHROMA DB and no module called as ChromaDB. Let me check. The spelling is correct, it seems, but if there is an issue, I'll try to fix it. Okay, so it worked. Basically, I have just changed my kernel, and I have just downloaded my Python to 3.10, and now it's working. So I'm able to see my ChromaDB over here. As you can see, like our version is 1.0.7. And I am able to do the import with respect to the ChromaDB. So very simple, just go ahead with the Python 3.10, safe and secure way. Now, so once we are able to import this ChromaDB, so I can try to maybe import a couple of more things, CHROMA ChromaDB.utils, and then try to import embedding function. Yeah, so these two imports that we have to do from a ChromaDB. Now, what we are supposed to do? So we are supposed to take embedding APIs so that I will be able to convert my data into a embedding. So just go to a Euron and inside a URI code example, and you will be able to see inside a Python function. So you will be able to see a text embedding and similarity. So just I try to copy this one. Just you need this particular piece of the code, and even my previous lecture. So I have already talked about it. So here, remove this part. So this is going to take input as a text, as you can see. And here you have to replace a static with your own API key. So from where you will be able to get your own API key, go to authentication, click over here. And then from here, so you will be able to get your own API token. So now just replace this with your own API token, as simple as that. And here, so I'm trying to use a model provided by OpenAI itself, which is going to give you a vector of dimension 1536, as simple as that. Okay. So this is a generate embedding function. Input wise, it is going to take a text, and output wise, it is going to give you the vector with a dimension 1536 for a respective text. Execute it, and wherever it will be required, I'm going to call this generate embedding function, as simple as that. Okay. Now, so here embedding function is done. Now what I'm going to do is I'm going to call CHROMA ChromaDB dot. I'm going to create a client for the ChromaDB, and it's a starting point, basically CLIENT client. So let's try to create a client object, and after creating a client object, I can try to call this client, and via client I can try to do anything that I want with respect to the ChromaDB. So it's basically like an entry point, you can say. So here there is a function called as create collection. So I can try to create a collection, means like a indexes that we were trying to create in case of a Facebook AI similarity search. So here I'm going to create a collection. So where I can try to store all my embeddings. So here I can try to give a collection name, and the data set which I'm going to take is with respect to my own journey. So Sudhanshu underscore JOURNEY, Sudhanshu journey. So this is the collection name which I'm going to create. So this client is going to eventually create this collection, and let's try to store it into a variable called as COLLECTION collection variable. Okay. So collection has been created, right? Collection has been created, and the collection name is basically Sudhanshu journey. Now dataset. So same dataset I'm going to consider. So here is my text data, and 10 such data I have considered over here with respect to me, right? So this is a list of the string. Inside that we have 10 lines. So this is a data set which I'm going to consider. Now, once I have this data, so I have to convert this data into a respective embeddings. Yeah. So I have to convert this data into a respective embeddings, and that embedding I'm going to insert inside my ChromaDB. And on top of that, I will be doing all the operations, search operations, right? So to convert this data into its respective embeddings, a function is available to me, a generate embedding function. So I just have to iterate over to this data one by one. So I can try to write for I in this text data. So this text data that I have. So one by one, just try to go through this text data. Let me write down into a list comprehension way. And for all the I, just try to call generate embedding function. So just try to call this generate embedding function. So generate embedding function and try to pass I. Yeah. So try to pass I. So for every I, keep on like doing this, and then try to like convert that into list finally. Fine. I will convert that into a list. So this is going to generate my embeddings by using a URI API key, and every data size or embedding size is going to be 1536, means vector size is going to be 1536 over here. So EMBEDDINGS embeddings. Okay, that's cool. And now it has started calling the API and it started creating the embeddings for me. It will take some time, and then it will be able to convert the whole data into an embeddings. Okay, so this process is done, it seems, and now I have the embedding, so I can go and I can try to check out this embeddings. So as you can see here, we have embeddings for all of these data one by one. I can try to even check that embedding at a 0th place, right? Embedding at a 0th place as is this one, right? And what is the size of this? What is the length of this? I can try to even check the length. So length should be 1536, obviously, right? 1536. So yeah, embedding I'm able to generate for all the 10 records. Now, once I'm able to generate the embeddings, I can try to insert those embeddings into my ChromaDB, right? Which is running in my local system. So collection I have already created. So inside this collection, I'll try to insert all of these embeddings. Let's do it. Yeah. So I'll try to insert the collection as well as I'll try to insert this entire textual information as well altogether. So here, what I can do, I can try to call my collection, and then I can try to call add, and inside this I can try to add it. So documents wise, there is a parameter called as document. So document means all the text information, and then embeddings wise. So try to store all the embeddings, this one that we have created. And then you can try to even assign the IDs over here. So IDs are nothing but, so maybe we can try to give like a particular ID, right, to all of this one. Well, maybe like a record 0, then record 1, record 2, record 3, and so on. So this kind of IDs we can try to give. So maybe we can try to write our own custom functions which will be able to generate the IDs. For I in a range of, I can write maybe a length of the text. Yeah. So this is going to give me 0 to 10, and I'm going to like take that as a IDs. By the way, I'm going to take, so take a formatted string and then give a name record underscore I. Yeah, I. So whatever I that we will be able to get. So record 1, 2, 3, 4. In this way, I'm going to give the IDs. You can try to give IDs in your way. That's completely fine. So this is not a hard and fast. I'm just giving record 0, then record 1, then record 2, record 3. In this way, I'm just trying to give the name over here. Call it. Yeah. So collection.add. So all the collection is added now. Yes, all the collection is added now. Now I can try to call this collection and I can try to do some sort of a cross check. So collection.count now. So count is 10, means inside this collection 10 record is been inserted. Yeah, collection 10 record is been inserted. I can try to even call collection.get. So get means it is going to show me record 0, 1, 2, 3, all the IDs it is trying to show me. Embedding, it will not show, unless I'm not looking for it. And then this is the document, right? So include a metadata document, data none, metadata none, 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 none. So metadata I have not inserted. In a later stage, I'm going to show you that you can try to insert some sort of a meta information as well, whatever meta information that you are looking for. But yeah, as of now, successfully it is able to, insert all the record. This is what I'm able to see inside this get record. Okay, that's cool. Now, so here I'm able to insert some record inside this collection, which is basically a ChromaDB based collection. Now I have to do a query. Let's suppose, right? The very first part is query. How I will be able to do a query? So here, if I have to do a query, for example, query is who is Sudhanshu. This is my query. Now for that, it should give me like all the matching sentences. Yeah, all the matching one. So based on like who is Sudhanshu. So here, right? So here, or maybe like Sudhanshu worked at Wipro, let's suppose. Yeah. So with respect to this, it should give me all the results. So whatever result is going to match, it should give me the result. Now, so for this query, first of all, I have to convert this query into what? So first of all, I have to convert this query into an embedding. So I can try to use same function and then I can try to pass a query over here, QUERY, query over here, and then eventually to list, just to make it compatible. So to list, so here this is going to give me query QUERY embeddings. Yeah, query embeddings. Fine. So this is going to be my query embeddings, by the way. Now if I'm going to show you 1536 query embeddings, this is the query embeddings that I'm able to get. Okay, that's cool. So once I'm able to get the query embeddings, I can try to call my collection, COLL collection, and then last time I have added everything, right? This time I'm going to call query. So this time I'm trying to query my collection and query wise, right? So query wise, I'm going to pass query embeddings over here. Yeah, query embeddings. And what is my query embedding? So query embedding basically is my this one. So the embedding that I have already created. So this is something which I am trying to pass inside this one, query embeddings. And then I can even mention that number of results. So give me top 2 result. This is what it means, top K result, top 2 result, right? So this is going to give you the result. Yeah, this is going to give you a result. Maybe I can try to print this particular result over here. So this is the result. So to record 4 and record 3 is the nearest one ID wise. It is trying to give me embeddings done document. So yeah, document. So he worked at Wipro, Deloitte, Verizon Labs and Ernst & Young. So this was the first nearest matching sentence with respect to my query. What? Sudhanshu worked at Wipro, right? So this is the first nearest one, and then the second nearest one that it is able to find out. So Sudhanshu earned a computer science and engineering degree. So this is the second nearest one that it is able to find out. So first, second, and first one looks like perfect to me, right? Perfect to me. So it is able to like match it, and it is able to give me the top result. It is able to give me the top result. Very simple, right? Very simple, very easy. And I'm able to perform the search operation. Plus it is even talking about the distance. Yeah, distance that. Okay. So with first sentence, distance from query to first sentence was this, and distance from query to second sentence, which it is giving me as an output, is this one. Okay. So pretty much justified. And yeah, so I think we all are feeling happy. We all are able to do a query inside my ChromaDB, and I'm able to even store it as a collection. Everything I'm able to do it, right? Everything I'm able to do it. Now let's talk about updating a record. So let's suppose I would like to like update some of the record. For example, so here I'm going to take maybe a sentence. I'm going to call it as a next sentence. Yeah, I'm going to take it. And here, so sentence says that Sudhanshu Kumar has completed his degree in computer science. Okay, this is my one of the sentence, and I would like to update some of the sentence with this one. So first of all, just try to convert this sentence into a embedding. So here, next sentence I'm going to next sentence I'm going to call to list and new embeddings. So next underscore sentence underscore embed embeddings. Okay, so I'm going to create it, and then I will try to update this embeddings with some existing one. Yeah, existing one. How I can do it? Simple. Collection dot, there is an update function you can try to call, and which one you would like to update. So I would like to update basically record 3, let's suppose. So I would like to replace this record 3 with the new one. So I'm going to give an ID that, okay, so whatever data is available at this ID, just replace it. So what is the document? So document is basically a new, document is basically a next sentence. So this is going to be my document. And what is the embedding, right? So embedding wise, so just try to insert a new, or I have created next sentence embedding. Yeah. So just try to update this document and plus with this embedding at which place? At record 3 place. Simple. So record 3, whatever data is available, it will try to replace it. Maybe we can go and we can cross check. So at record 3, 0, 1, 2, 3, right? So 3. So Sudhanshu earned a computer science and engineering degree. Now I'm replacing this sentence with what? So with Sudhanshu Kumar has completed his degree in computer science. So let's see whether we are going to update it or not. So executed. Now just try to call collection.get and let's see. So Sudhanshu Kumar has completed his degree in computer science. I think this was the sentence with which I have updated. So I can try to even call the update, and I will be able to do whatever I want, right? I will be able to do whatever I want. Now let's suppose if I have to add some sort of a meta information. Yeah. So I have to add some sort of a meta information. How I can try to add meta information? Let me show you that part. So here I can try to call collection.add. Directly I'm going to add it. Yeah. So add what? So first of all, document means data. So data is Sudhanshu Kumar is working with Euron for now. Okay. So this is the data. Now this is the data. Then I have to pass embeddings. So here again list, generate embeddings, and I'm going to pass this data directly. This document and for this respective embeddings. Okay, respective embeddings dot to list, fine. Respective embeddings I'm able to pass directly. I'm trying to update it, and IDs. So I'm going to give a IDs to this one. So ID is going to be record underscore 10, right? This is the name. I'm not keeping it dynamic. I'm just trying to hard code it. And then there is something called as metadatas, right? Metadata. So you can try to add some sort of a meta information, which will help it out in terms of doing some sort of a indexing, and even you can try to search as a search parameter. You can try to pass a meta information. That is also possible. So which is going to narrow down the entire search operation. So here metadata, right? And I can try to maybe add some sort of a key and value pair. Categories, let's suppose should underscore info. So this is the category, and then maybe a year 2024. Yeah, 2024. So this is the year which I'm going to pass. So this is a small meta information. As you can see, I'm trying to add inside my data set a small meta information. So any kind of a meta information that you want, you can try to add it. Now it will help you out to narrow down the search. As simple as that, just to narrow down the search at the end of the day. Simple, right? Execute it. And then if I'm going to call collection.get, so it is going to show me all the data. So it has added this as well as it has added a metadata as well. Yeah, it has added a metadata as well. Now, how I will be able to, right? How I will be able to, do a query while passing a meta information. So to do that, I can try to call collection.query once again. And this time, so what I will do, I'll try to not just pass a query text over here. So query text, let's suppose query text is, Sudhanshu is working with Euron, right? So this is basically like a query text that I have, and I would like to search what is the similar matching things which is available. I can try to control a number of results. So just try to give me a top 2 result, by the way. And here, so there is a parameter called as where, and in this particular place, I can try to give a meta information. So for example, I can try to give a meta information that only try to search in this category, right? Only try to search with whichever data record is having this one, right? Just try to search in that. Don't try to do a search. So in this case, I'm trying to run around the search. I'm trying to make it more efficient, more like a much more faster. So here, if I'm going to execute it, right? So yeah, it is trying to do the operation. Collection expecting embedding with the dimension of 1536 got 384. Oh, so it has went for the direct one. Okay. So what I can do, I can try to make it closer towards the previous one. So let me, okay, just query embeddings. Let me replace this with this one, and here, so I can try to pass basically get embeddings, and the get embeddings wise, give me the embeddings of this, and then that dot to a list, simple. So here I'm just going to provide this embeddings, execute. Okay, so that's cool, right? So here you can see that it is trying to give me only one record, although I have asked for 2 results, right? But it is giving me how many record? Only 1 record. What is the reason? So the reason is very simple. It is trying to do a search only in this category. This is what I was talking about, that if you are going to categorize your data, right? If you are going to add a metadata, so you can try to write a clause with respect to your meta information, and it will just try to search that particular category. So let's suppose you have a multiple departments. You have a HR department, you have a finance department, you have a sales department, you have a marketing department. So maybe you can try to tag all the information with respect to a department. So whenever someone is trying to do a search, a query, maybe they can look into the specific department, unless and until a whole data search is not required. So in this way, you are trying to narrow down, you are trying to minimize your number of searches. So eventually a result is going to be robust and faster. That's the reason. So I have asked for 2 top results, but still it is giving me 1 because there was only 1 result, right? There was only 1 result, and it is trying to search only inside this category. I can try to even give year is equal to 2024, right? I can try to create any other kind of a meta information, and based on that, I can try to perform the exact same thing. Yeah, exact same thing. So very simple, very easy to understand, I would say. Now, so let's suppose if I have to persist this entire collection. So whatever collection that I have created, so what I want is that I should keep it here, maybe for our future purposes. I don't want to execute or re-execute everything, because every time I have to go to URI and then create embeddings, every time I have to run the entire piece of code. But what I want is that, no, just try to persist it. Let's try to persist it in a physical space. How I can do that? So here I can try to call ChromaDB.client, ChromaDB.client, And inside that, I can try to call ChromaDB.config dot settings, right? And inside this, I can try to say persist per persist underscore persist directory, and I can try to give a current directory chroma underscore db. Yeah, so this is something which I can try to create so that it will be able to persist everything to my disk. Yeah, it will try to like persist everything to my disk. Now, so let's call that. So once I'm going to call this one, it is giving me instance of Chroma already existing in the different setting. Okay, so let me check why it is giving me this error. Okay, so it's a client conflict issue. Let me do one thing. Let me restart my kernel, and after restarting, let me execute this first. Okay, so now it's working, and I have just restarted my kernel, so I have to re-execute the entire things. So execute. Client is already created, I believe. Yeah, so client is ChromaDB client, and here, so ChromaDB Stanchu personal fine. Okay, let me call collection ChromaDB client. Instance of ChromaDB already exists for the employee with the different setting. Okay, so client is already available, so I can try to just client is not defined. Okay, so let me do one thing. Let me restart once again. It's a client issue because I have already created a client, so it is like not allowing me to do that. So here, after restarting the kernel, I can try to treat this as a CLI client. Yeah, client. Execute, no error. It is able to create the client. Now I can start like executing everything from top to bottom. Client, this one is not required. So this piece of the code is not required. I can start from here. So this is working, all will work, because if you are creating a client multiple times, then there is a issue. Otherwise, it's completely like fine. So still it is trying to generate the embeddings for me for all these 10 records. Okay, so still it is not showing me a physical file here. What I can do is I can try to give a absolute path. Let me try with that. It should show me the entire ChromaDB file. Let me restart my kernel. Now everything will be gone. And then let's try to create a client, and I will start like executing everything except the client one by one. So my collection is this. Fine. So this is my text information. This is going to take most of the time because it is trying to generate the embeddings for me. Embedding done, this done, collection dot add, then count is done. Get query, still I'm not able to see. Yeah, so everything is working perfectly fine, but the only thing which I'm looking for this ChromaDB directory, so that I will be able to show you that how I'm persisting the entire information but it is not showing me that. I think there is some issue. Let me fix it. Okay, so if I would like to persist my data, so here is a final old style code. So I'm using like a old version, I believe, and because of that, I believe it is not allowing me. Now I'll have to check from my side. But yeah, I have tested with this one, and as you can see, it is able to persist the data. As simple as that. So I will be able to store my entire information even physically. You just have to call persist client, and then you can try to give a directory name of your choice, and it is going to persist the entire information inside this particular directory. Very simple and easy to implement once again. So hope all of you are able to understand the working with ChromaDB, and we are able to create the instance client of the ChromaDB. We are able to take the data, convert that data into a respective embeddings, and again, so we are able to insert the data into the collection. We are able to even perform search operation on top of that. So almost all of these operations we are able to perform with respect to the ChromaVector DB. So with that, guys, thank you so much, everyone. Take care, and see you again in my next lecture. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about Pinecone. So how we can try to perform this insert operation, update operation, search operation with respect to the Pinecone vector database. So let me share my screen, and let's get started. So first of all, Pinecone is a managed database. So you can try to go to Google, and you can try to search for Pinecone, by the way. So Pinecone login or Pinecone, you can try to search, and then you will be able to get into this particular page from where you can try to log in. A vector database for a scale in production. So they are managing the entire database, and you can just try to access this database, and it's online, so you can try to insert the record as per your own will or as per your own need. So first of all, I have to do a login, and you can try to log in it without even adding the card. So you can just go ahead with the Google login over here. Now once you are going to log in, the very first thing that you need is a API key. So just click on API key, create a API key, and then maybe you can try to give a API key name. So I'm going to give API key test1. So here it is going to create my API key, which is important and which is required. So just try to copy this API key, keep it somewhere. Yeah, keep it somewhere. So here I'm going to create a new file called as pinecone.ipynb, and inside this I'm going to keep my API key. Simple. Again, anyhow, I'm going to deactivate this API key after a lecture. So here I'm just trying to keep the API key. Very simple. Yeah. Now, so once I'm able to get this API key, close it. You don't have to do anything, by the way. Database wise, so there is a database which has been created. So one index which has been created. Now I can try to create another index if I want. Yeah. So I can try to create another indexes, and as per my own configuration, so I can try to customize this entire things which like indexes basically, right? So I can try to customize this entire things as per my own need. So here, let's suppose if I'm going to create my own new indexes, so I can try to give over here that Sudhanshu and info, right? So this is the canonical content Sudhanshu info. Yeah. So this is the index name which I'm going to create. Vector type, so let's keep it dense. Interdimension, so 1536, this is the dimension. Matrix, cosine, Euclidean, or dot product, anything I can try to keep. I think I have already discussed about that in my a theoretical lecture. So for the similarity search. Now serverless, okay, so AWS, fine. Now reason, Virginia, this one, and then create indexes. So just click on create the indexes. So fine, it will start creating my indexes as you can see, right? So after creating the indexes, so we have to go for the next part. And so it's very easy to use it, guys, by the way. So everything is online. You don't have to do any kind of a local installation. So as simple as that, you just have to install the client and then kick off. And even over here inside this example, so I'm going to use URI embeddings, by the way. Yeah, so I'm going to use a URI embeddings, and with respect to that URI embeddings, I'm going to show you the entire operation. So index initialization, your index will be ready momentarily. Okay, that's cool. Okay, so it's initializing, and I already have this another index which I have created. So maybe I can try to connect with that. So here I can try to click on connect, and then the very first thing that you have to do is pip install Pinecone. So you have to install a Pinecone client, and then you can start, doing back to back all sort of operation that you are looking for. So let me do that. So I'll go here. I'll try to do like a pip install Pinecone, and yeah, so requirement already satisfied. So I have already installed a Pinecone, and then what I can do, I can try to copy this initialization command, and here so I can try to provide my own API key. So API key which I have already saved, so I can try to copy this Pinecone API key. If not, I can try to create a new API key. That's completely fine. And then my index name is quick start, right? So this is the index which I am trying to connect, quick start, right? Okay. Similarly, I can try to create any number of indexes. As you can see, the Ansho info indexes I'm trying to create, and I can try to even insert the data with that. Now the problem with this index is dimension of this index is only 2, and I will not be able to insert a data into this particular index with dimension is equals to 2, because my data dimension is going to be 1536, because I'm going to use a URI embedding API, and out of that I will be able to get a dimension 1536. That's the reason. So I have created this one. Maybe I don't have any option. I don't see any option in terms of, changing the configuration. So I have to wait for my own indexes to be up and running. So it is taking a lot of time to initialize, by the way. And once this initialization is going to be done, I just have to change my index name, and bingo, I will be able to connect. And after connecting, so I will be able to start using that particular indexes, and it will take some time. So just wait for some time, guys. I'm waiting since last like a 10 minute of time. Yeah. Okay, so now this index is created, and I can try to insert a data into this one. So fine, guys, let's get started. So here I can try to call connect, and pip install Pinecone. I have already done that. So here what we have to do, we have to just replace this quick start with a Sudhanshu info, because that was my index name, right? So that was my index name. So here pinecone.index, and I'm going to replace it with my name. So connect, and it looks like it is able to connect. So IP property is not found. Please update the Jupyter this. Okay, so let me just check index. So yeah, it is able to create a Pinecone indexes. So hopefully I will be able to insert all the information, and then eventually I will be able to do all the other processes. So here let's start doing it, and what I will do is that I will try to take my data. So the same data which I was taking since my last 2 chapters. So this is the textual information, and I will try to convert this entire data into a embedding. So here I can try to write like a for I in this text basically. So just go through this entire textual information, and then on top of this call my generate embeddings. So generate embeddings is going to come from where? So it is going to come from basically a URI, right? It is going to come from a URI. So here I can try to go into a code example, Pythonic based, and from here, so this is the embeddings, and I have been using it since my last 2 classes. So it's nothing new, I believe, if you have watched that previous lecture. So this is my function. So here I'm going to pass my API key. Now my API key is going to be inside the authentication tab. So I can try to copy this API key for generating the embeddings, and I'm going to replace this particular portion with a API key. This is static one with my API key. Okay, that's clean and good, done. Now, so for I in text, I'm just iterating through my textual information, this information one by one. I have a 10 records, and then here, so I'm going to call my generate embeddings, and one by one I will pass my I, and it is going to generate a embeddings for me. Okay. So it will take some time, maybe a couple of seconds, 10, 12 seconds it is going to take. And it's just a one-time process so that it will be able to generate the embeddings for me. Okay, that's cool. So I'm able to generate the embeddings for my data set. Here is a entire embeddings which I'm able to find out. Now what I can do, I can try to insert this record inside my Pinecone. The Pinecone instance that I have created, the Pinecone index that I have created. So inside this index, I can try to add a record. I can even try to add a record with the help of UI, but I don't want that basically. So what I want is that I would like to add a record from a Python code with the help of Python programming. So I would like to insert the record. Okay, so let's go ahead and let's try to insert a record. So here to insert a record, right? To insert a record, so we can try to call index that we have created dot upsert. There is a function called as upsert. Yeah. So upsert, and here, so I can try to give a vectors. Vectors is a parameter, and then I can try to pass the indexes over here. So indexes wise, it is going. So I can try to pass basically a records over here, and record wise, it is going to take a text as well as its embeddings and numbers. Maybe this is something which I would like to insert inside this one. So I'm just going to show you with respect to one single example, and then I'm going to show you that how I can try to insert it in a bulk, all the 10 record at a time, how I can try to insert it. So here, record wise, I can try to take a list, and inside this particular list, I can try to maybe give a record 0, and then I can try to pass a text. So text is nothing but text of 0, and here, so embedding wise, embedding of 0. So this is the information I would like to insert, and let's see so whether I will be able to insert this information or not. So it is giving me a error saying that expected a list or list like data structure, but got this. Okay, so it is expecting some different format. Let me correct this format, by the way. So here, list or list like, this is what it said, by the way. So let me rectify it. Invalid type variable ID, required value type is string, and pass type was int at ID. Okay, so let me keep it this one as a string over here. Invalid type variable 0, required value type float, and pass type was string at value. Okay, so let me rectify this entire error inside this one so that I can insert the record inside my Pinecone. Okay, so let me correct it from the scratch, guys. There was a mistake in terms of a format which I was making. So I have taken a reference of a Pinecone documentation itself. So here, index, I can write dot upsert, and I can try to upsert a data. So where vectors, right? So vector I can try to pass, and a vector as a list I can try to pass, where I can try to give an ID as a string. So this is my ID. Now embeddings, so the very first one, and then to list. So this is something which I'm going to give, and the text information, which is nothing but a meta, let's suppose. So here text is nothing but texts at 0th location. So this is going to be my key, and text at 0th location is going to be my value. So this is the record I would like to insert, only one record at a time as of now. Yeah, and still it is giving me an error, invalid vector value passed, can't interpret the type class string. Okay, so let me check what is the actual issue. Actually, this should work. Okay, so just there is a list, right? So it is considering all 3 items as a separate item. Let me make it one. So yeah, inside this list, I'm trying to pass this entire item and then execute it, and now it's working. So upsorted count is equals to 1. Now if I'll go and if I'll try to check over here that whether we have some sort of a record or not. So I must be able to find out some record after the insertion. So upsorted count is equal to 1. Now let's go to Pinecone, and let me refresh it, And here, so I'm able to find out one record. So Anshu Kumar was born in Jamshedpur, Jharkhand, India, to the modest family. And yes, so this is one of the record on ID 0. It is able to insert. Very, very simple one, right? Very, very simple one. And if I would like to edit this record, this is the like an entire vector of dimension 1536. It is able to store. And if I would like to edit it, I can try to edit it. If I would like to add more meta information over here, I can try to add those information as well. So successfully, I'm able to insert my very first record inside a Pinecone. Okay, that's cool. Now let's try to insert an entire record in a bulk. Yeah, so let's try to insert the entire record into a bulk. And then I will be doing a search operation on top of the exact same thing. One by one, we are going to perform this entire operation. So here, let me write a code. So let me prepare a complete record, records, records. So record is going to be the empty list. And here, so what I will do, so I'll try to prepare my record as per the data which Pinecone is expecting. So here I can try to write for I in, so I, and then like I can write basically text and emb embeddings in enumerate what, so enumerate and zip this. So first of all, zip this data. So text comma embeddings. So zip means, I think we all know, one-to-one mapping it is going to perform, and zip it together. And then enumerate means it is going to give you the numbers. It is going to give you the indexes to each and every information. This is what it's trying to do. So now if you would like to print this information, you can try to print it. It is going to print the ID, it is going to print the text, and it is going to print the embeddings. Now, so here records, the empty list that I have created, dot append I can try to call. And what I am going to append, by the way. So I'm going to append basically this information. So I'm going to append a record number. So here record number, maybe I can try to create in a dynamic manner. So here rec underscore and then I underscore and then placeholder I. So this is going to be my record number. Now embed emb dot to list. So pass that as a list, and then text, pass that as a text. So whatever text that we are getting from here, just try to pass. So this is the format of the data which I have prepared. So that will be available inside the record. And this is the record which I will be inserting. So now if I would like to show you if I have to show the record, this is how my record looks like. So inside this, there will be a number, there will be a embeddings, and there will be a text which will be available. Yeah. So this will be available inside the record for everything. Now I can simply call index dot upsert over here. And in one single go, I can try to insert it. So insert what? Records in one single go, right? So as you can see, it is inserting one by one, one by one, one by one. Now if I'll go and check over here, so it must have inserted this time a multiple record, not just one single record. See, it has inserted all the record for me. And if you will go and check any of this record, right? So like in this embeddings are available inside this particular record. Yeah. So embeddings are available inside this particular record. You will be able to check each and everything. Metadata you will be able to check. You will be able to check values. You will be able to check the IDs that I have given. So each and everything you will be able to check. If you would like to edit the record, you can try to edit the record as well. Okay, so that's cool. I'm able to finally insert a record inside the Pinecone. Very, very easy, right? Now, so after inserting a record, let's suppose if I have to query it, if I have to find out some of the information, how I can do that? Let's try to understand. So here, if I have to check the index stats, so I can try to call maybe a index, and then I can try to call basically describe index stats. This is the inbuilt function, and this is going to give you the description. So dimension is equals to 1536, index fullness is equal to 0.0, matrix similarity matrix is going to be the cosine similarity matrices it is going to take. Total vector count is 11, so total record is equal to 11, vector type is equal to dense, not a sparse one. Okay. Now, so if I would like to fetch some of the information, so index dot fetch, I can try to write. I can try to pass maybe IDs, and based on the IDs, I can try to fetch the entire information. So here, if I'm going to say that, okay, so try to give me maybe like a ID record 3, right? So it is going to fetch an information with respect to record 3 if it is available. Simple, right? If it is available, so it is going to fetch it. Now let's suppose if I have to check the similarity search, and based on the similarity search I have to fetch the information the way we were doing it with respect to all the other vector DB. So I can do that as well. So maybe I can try to create a query text. So query text is Sudhanshu has worked in Wipro, right? Let's suppose I'm going to write this query, and with respect to this query I would like to fetch all the similar kind of a data. So first of all, I have to convert this entire query into an embedding. So I can try to call my generate embeddings, and whatever output that I will get, I can convert that to a list, so which is a compatible format, and this is eventually going to give me query embedding. Yeah, so let's do it. Query, what is the issue? So query embedding, here I'm trying to give a query. Yeah, so embedding, return embeddings. This looks good to me. There should not be any kind of a issue, by the way. So generate embeddings, and yeah, so it's a function as it is. Why it is giving me an error? Okay, so it was giving me an issue because my API key got expired. So I have reached the daily token limit. I have just changed it, and now it's working fine. Now it's working fine for me. So yeah, so here query embeddings I am able to generate, and I have a query. So let me call it query, and this is my query, QUERY, query embedding. So this is my query embedding. So both I am able to get. Now what is next? So now once I have this two, once I have like a query, and if once I have the query embeddings, now what I can do is that I can try to call the search operation. So here index I can try to call, and index dot I can try to call a query, right? Because we are trying to do everything with respect to the indexes. So just try to call index dot query and try to pass all the information. So vector wise it's a query embeddings. This is the vector I will try to pass top k. So top k wise, so give me top 2 result, and then there is a parameter called as include metadata. I can try to make it true true, so that it will be able to even give me the metadata. Now it is trying to perform the search operation, and as you can see, it has given me two records. Record number 4 score is this much, and record number 3 score is this much. Simple, right? So this is a 2 information, and record number 4, which is the first one, looks promising to me, as it is trying to give me he worked at Wipro, Deloitte, Verizon Labs, and Ernst & Young. My query was what? My query was basically Sudhanshu has worked in Wipro, and yeah, with respect to that, it is able to give me the final record. So beautifully, it is able to give me the record, as we all can see, right? As we all can see. And again, just like that, so we can try to query, we can try to update metadata, meta information, and we can try to delete this. Anything that I want and everything that I want, I will be able to do, because these are the inbuilt functions. So with that, hope all of you are able to understand the Pinecone. It's nothing different. It's very, very easy. Log in, create a API key, and then try to create indexes. And with respect to that indexes, do whatever you want. So with that, thank you so much, everyone. Take care, and see you again in my next lecture. Okay, so welcome to lecture once again, guys. Now in this lecture, I'll be talking about Waviate. Waviate is one of the vector database, just like Facebook AI similarity search we have discussed. We have discussed about a ChromaDB. In the similar manner, so you can try to create a database inside Waviate, and you can try to store your vectors. You can try to store your embeddings along with the meta information, and then you can try to go ahead with the search. Now,
So here, let me share my screen, and this is a Bayesian.io. Here you will be able to get this entire cloud platform for a Bayesian database. You don't have to do any kind of a local setup, so it's completely fine. Now I can try to click on try now, and they are going to give you a free tier access as well. So you don't have to add your card. It's completely fine. So try now, and it is going to ask you for a login, but before that, so you have to create an account, you have to verify your email ID. So just do a sign up, and then you will be able to do that. Now, so just try to click on login, and after login, you will be able to land into a Vivian interface. So just wait for a couple of seconds, and it is going to load. Yeah. Okay. So here in a very first place, you will be able to see an option called as cluster. Cluster means you can try to create your own instance, or they're providing you a shared sandbox as well. So in a paid version, so obviously there will be more feature and more resource and more things, many things you will be able to manage. But yeah, so you can try to go ahead with the simple basic shared sandbox as well. So here I can try to click on this plus icon, and I can try to click on create cluster, and it is going to allow me to create a cluster. For serverless and for enterprise, so you have to pay. Unless and until you're not going to pay, you will not be able to get an access. So I'll be going with the sandbox option. Now here, so sandbox option wise, I can try to like create a cluster, and I can try to give a name to it. So maybe I can try to give a name WEV underscore test. So this is the cluster name I'm going to give, fine. And then I can try to select a cloud version. So Web test. So yes, this is something that I'm going to give. Cloud provider is a default one. And rest of the things is going to be default. You just have to check this particular part. So here, they are giving you a vector dimension. So vector dimension is 256 or 768 or 1536. So basically we are going to opt for 1536. A reason is very simple. So I will be using a URI embedding over here, right? I will be using a URI embedding over here, and URI embedding wise, it is going to give you a vector dimension 1536, and that is the reason. So I'm going to select 1536 over here. Now I can try to click on create, and it will take some time, and it is going to create it. So maybe 3 to 4 minutes of time it is going to take, and then only you will be able to see your cluster up and running. You will be able to get a mail notification as well for the same thing. Now, to access a cluster, to access your sandbox, basically you need two things. One, you need a REST endpoint, and you need an API. So unless and until you don't have an API and you don't have a REST endpoint, you will not be able to hit your cluster. You will not be able to perform any operation inside a Waviat. So just wait for a couple of minutes, and then your cluster will be up and running. My another cluster, my another sandbox is already up and running. So maybe I can try to use that, and then I can try to show you all the operations. Yeah, all the operations. So here, this sandbox is already up and running, and to use this sandbox, you have to create your own API key. So you can try to create a API key from here. So create API key, click over here, and then you can try to give a name to your API key. So maybe I can try to give test2 and select a role. So admin is a role I'm going to create, and then I can try to click on create. My API key will be created, and I have to keep this API key somewhere safe. So maybe I can try to keep it here, right? So this is my API key for a Bayesian. Now, what is next? So I'm able to create a sandbox. I'm able to create a API key. Now I have this REST endpoint. So this is a URL. So let's copy this part as well. So let me copy this one over here. Yeah. So I have this one as well as I have this one. So these are the things which is required, by the way, and now I'm good to go, and I can try to connect with my Bayesian, and I will be able to do whatever I want with respect to a Bayesian in terms of inserting a record, in terms of like filing a queries, which will be able to do a match, and then I will be able to get a result. So here, let's start doing it one by one, one by one. So in a local system, right? In a local system, so if you are trying to hit this particular URL with this API key, you have to, right? You have to do a little bit of installation. So you have to do a client installation over here. And I'll suggest everyone to go ahead with this particular version. So not 4.x, but 3.x. Just go ahead with that. This code is going to work. If you are going to install 4.x, then you have to do a modification. So here just try to install it, and in my system it's already installed, and sometime it is not going to work even after installation, or maybe it is it will not be able to recognize. So you can try to click on restart kernel, and then it is going to for sure work for you, right? This particular version. Now, once this particular part is done, now what I have to do? So now I have to create a connect, basically create a connect. So how I will be able to connect and how I will be able to create a BayesVector client? So first of all, you have to do a import for a BayesVector. So import done. And then you have to create a client. Client means a kind of an instance, a kind of an object by which you will be able to hit your BayesVector. So here is my URL, right? And this is my API key. I can try to use my recent API key which I have generated. So here is my API key, right? I can try to use this one, and then I will be able to hit my BayesVector. So let's do it. It's a standard one, obviously, right? So you don't have to worry much about that one. So is it ready? True. So yeah. So client is ready. So now I am able to connect with the BayesVector, and now I will be able to perform all kind of operation with respect to a BayesVector in a easiest possible manner. Very simple, right? Very simple. Okay. So this part is done. So connection with a BayesVector is done. Now what I want to do is that I can go ahead with URI embeddings, and I can try to copy this URI embedding from a Python. So let's try to copy this part, and let's keep it here so that I will be able to use this generate embedding function, and I will be able to generate the embeddings for any kind of a text which I am going to pass, because I am going to use my own embedding model. Yeah, this one. So here you have to pass a API key even for a URI. So let's go back again, click on authentication, and here is your API key. So just try to copy this one and replace this entire static. So replace this entire static with the URI API key. Okay, so two things is done. I'm able to connect with a BayesVector. That's first part, right? That's the first part. Second part is I'm able to call my generate embedding function, and I will be able to use this text embedding 3 small from OpenAI, and I will be able to create embedding, or I will be able to create a vector for any given text, So these two things are pretty much important. Now I'm good to go with a BayesVector. Now, so connection is done, and even for a embedding, so we have a function over here. Now, so whenever we try to store a data into a BayesVector, so first of all, we have to create a schema. Schema means in a SQL system, so we try to create a tables, right? So we say that, okay, fine, this is the table name, and maybe this is the data that I'm going to insert, all sort of a thing. So similar manner, so you can try to create a schema with respect to a BayesVector. And then inside that schema, you can try to insert a record. You can try to insert a data. Okay, that's great. So here, let's try to create a schema. So here, I'm going to give a schema name is equals to Euron, let's suppose. Yeah, so class is equals to Euron. So this is going to be the schema name. Vectorizer is equals to none. Now, what is the meaning of this? So I'm saying that don't vectorize my data. I'm going to vectorize my own data. This is what I'm trying to say, that because BayesVector is going to provide you that service as well, where you can try to use a BayesVector inbuilt like a models or the functions that they are providing you, and you can try to vectorize your data. You can try to create your embeddings, but I'm going to use my own. So obviously they will charge for that, right? Then properties. So here properties wise, so name is equals to text and data type is equals to text. So this is something which I am going to give for a schema, and then I can try to execute, and it is going to create an schema. Now I can come down to a BayesVector and I can try to check. So Sudhanshu, and then over here, so I can try to check maybe my collections. So let's see. Yeah, so for this sandbox, both of my sandbox is ready, by the way. So here, as you can see, so this Euron schema has been created, right? This Euron schema has been created, and one property, single tenant, and 0 objects. As of now, there is no object which is available. If I'm going to click on details, so again, almost like a same thing I will be able to find out. If I'm going to click on view data, so I will not be able to find out anything, by the way, because as of now, I have not inserted any kind of a data. As you can see, there is nothing, right? There is nothing. So view collection detail. So name was Euron. Description I have not given. Multi-tenancy, no. Vectorizer is equals to none because I'm going to vectorize my own data. And then field wise, so name is equals to text I have given and data type is equal to text. This is what I have done. Yeah. So name is equal to text and data type is equal to text. This is something which I have given for a schema. Okay. So this is created. I can try to create more if I want, right? I can try to add more and more properties if I want, and I can even try to modify the same thing. Okay. So here, let's go ahead and let's try to insert some of the record. So here, text-wise, I'm going to create text-wise. So Euron is a company which works for upskilling domain in tech. Okay, fine. So this is a text which I am trying to create. Now what I will do with this text, so I'm going to call my generate embedding, GENERATE, generate embedding. Let me save it, close it and open once again. So that my auto completion is going to work. So Beaviet, this is done. URI is done. Schema I have already created. Now generate embeddings, and I'm going to pass what? I'm going to pass my data. So text I'm going to pass over here. Now it is going to return me embeddings. So let me store it, EMBEDDING embedding. So inside the embedding variable, I'm going to store it. So now execute, and it is going to call my URI API, and now you will be having a embeddings. And if you are going to check what is the size of the embeddings, it's 1536 in which it is available. Okay, that's cool. Now, so this is my data, and for that data, I'm able to create the embeddings. Now I have to insert this record inside a Beaviet. Yeah, because as of now, there is no data. There is no data. So if I'm going to click on view data, there is no data which is available inside this particular sandbox. Okay, so there is no document which is available over here. So I can try to insert the document. So how I will be able to insert the document? So I can try to call my client, the client that I have created, which is responsible for like a connecting data object dot create. So data object dot create, and inside that I'm going to pass my data. So here, as you can see, it is looking for a class name. It is looking for a class name. It is looking for a UUID. It is looking for a vector, all sort of things. So one by one, I can try to basically provide each and everything so that, you know, it will be able to insert a record. So the very first part that it is expecting is a data object. Now, what is the data object? So maybe I can try to provide data object is equals to, so as a dictionary or as a string, I can try to provide as per the nomenclature which has been given. So data object text, so key is a text and value is equals to text, which I'm going to provide. Okay. Now, so the second thing is schema. So here, if I'm going to hover my mouse once again, right? So class name. So what is my class name? So my class name was actually Euron. This is the class name which I have created. So fine, let's try to give a class name over here. Class name is equals to what? So class name is equals to Euron. Okay, EURON. It should be like exact. Fine. So class name I have given, and then there is a vector. So vector is what? Embedding. So this is the embedding which I have created. This is the embedding. So I'm going to provide a data object. That okay, fine. So this is the text data, so that it will be able to insert this data. It will be able to insert inside this class name, and it is going to insert the embeddings. Now execute it. So once you are going to execute it, it is going to return the ID. Now, if I'll go and check once again, so just refresh it. Yeah, refresh it. And after refresh, if I'm trying to check, so yes, UID is this one, which it has returned, right? Which it has returned. So this is the UID, which I'm able to find out. And here is a meta information. So creation time, and then text it is trying to showcase to me, and then it's a vector, right? So dimension of size, this one, and if I'm going to expand, so it is going to show me the vector as well. So vector of dimension 1536, which has been returned by my URI generate embedding function, right? So yes, I'm able to successfully insert one of the record. Very simple, right? I'm able to successfully insert one of the record. Now, likewise,
I can try to insert as many record as possible. Very simple, right? So if I would like to like insert some other records, I can do it in the exact same way. So I can try to provide all of these things. So let's call client object once again. Data object is equals to text. Text wise, here itself I can try to feed. So my name is Sudhanshu. Let's suppose I'm trying to insert that embedding. So generate embedding and then try to pass exact same data which you are trying to keep it as a text. Yeah. So I'm doing everything here itself and inside the class Euron. Now execute. So it is going to call a generate embedding and again this one is inserted. Now maybe I can try to insert over here. I work for Euron. And same data I can try to pass it over here for generate the embeddings. Now insert inside the same class. Now if I'll go and check, I will be able to find out multiple collection, not just one. View data. Yeah. So as you can see, so I'm able to find out my name is Tanshu, I work for Euron and Euron is the company which works for upskilling domain. So these are the record which it is able to insert, right? These are the record which it is able to insert and after like creating its obviously embeddings, right? So along with the embeddings, it is able to insert the record. So insertion wise, I think we are well and good and I can insert as many record as possible. Now I have to check with the query that if I'm going to fire some sort of a query, whether it is going to return me a relevant document or not, or relevant like a text or not, because that's a reason. So we are using our vector DB, right? So here query wise, I can try to create a query over here. Who is maybe Euron is a company. Yeah. So this is a query and I just have to match that this is matching with which one, which data which is available inside my DB, inside my database. So if I have to do a query, right? If I have to do a query, so how I will be able to do a query? So first of all, I have to convert this query into a embeddings. So here I can try to pass my QUERY query and it is going to return me embedding underscore QURY query. Fine. So this is my query embedding vector. It is going to return. Now what I will do, so I'll just try to search this one. I'll try to search this one inside my schema, right? Inside my table. So here again, I can call client dot query dot, there is a function called as get, and inside that I'm going to pass all the details. So I'm going to search inside a Euron. That's the first part. Then I'm saying that okay, so it's a text data which I'm trying to search for now, and then dot with near audio depth length near vector. So I'm trying to like do a search for a vector over here, and here so vector wise I can try to provide VECTOR vector wise. I'm going to provide this one. This vector I'm going to provide that, okay, fine. So just try to give me like a relevant data with respect to this one. And here, so I'm going to mention top case search. So with underscore limit, and I'm saying that give me top 2. So whatever is matching with top 2 and then do it. Yeah, do it. So this is going to give you the final result. So this is going to give you a top 2 result. So top 1 result is Euron is a company which works for the upskilling domain in a tech. And then second one is I work for Euron, which is the nearest one to this query. Yeah. So successfully I'm able to even find, or I'm able to like, do a search. I can try to like give a limit over here, maybe 5, 10, whatever I want. So top case search, it is going to give it to you. So this is how guys you will be able to create, or you will be able to connect with Bayesviet, and then you will be able to insert the record. You can try to insert a record in a bulk. That's also possible, right? So I think that's pretty much normal for all of us. And this is what we do with respect to all the other databases which is available out there.
So now we are able to connect, we are able to insert the record, we are able to convert our record into our own embeddings, and then we are able to even perform a search operation. Now, this BayesVector is going to do a similarity search, just like a Facebook AI similarity search. It is also going to do a semantic search. Semantic search means, so it is going to understand the grammars, meanings, right? Based on the data, so it is going to give you both. But yeah, so as of now, so we are like doing a similarity search over here, and based out of this we are able to get our result. So hope this part is pretty much clear to all of us. So with that, thank you so much everyone, take care, and see you again in my upcoming lectures. Okay, so welcome back once again, guys. Now in this lecture I'll be talking about another vector DB, which is called as Quadrant, one of the again popular database which you all will be able to find out. So let me share my screen, and Quadrant says that it's a high performance vector search at scale for an enterprise grade application. You can try to like go into their documentation, you can try to explore more. But yeah, so what we are going to do, so quickly we are going to see a practical over here. So first of all, I can try to click on login, and it is going to log me in inside a Quadrant. It is also like allowing you to log in through your Google sign up. So that's completely fine. Within a second, you will be able to log in. Now this is the interface that you all will be able to find out. Now here, so they're giving you an option to create a cluster. So first of all, you have to make your instance up and running. So here, don't go for the dedicated one. If you're going for the dedicated one, then you have to like add your card. So here I'm going to give my cluster name Euron, let's suppose, and again, so rest of the things is completely fine. They're giving me one node, disk is 4 gigabytes, and then RAM is 1 gigabytes, and virtual core CPU is 0.5. Now click on create a free cluster. So it is going to take a couple of minutes of time for me. And yeah, so it has given me my API keys as well. So I can try to copy this API key and keep it somewhere safe. So let me keep it here. Yeah. So this is my API key. Just keep it here for now. Fine. Now, so after that, once my API key I have, so then I can maybe try to click on this Python, and here, so it is giving me a URL and it is giving me a API key. So I can try to copy this code snippet, which is going to help me out to create a client. Eventually, I will be able to connect with my Quadrant database. So here I can try to copy and paste, and Quadrant client I have now. So I have to do an installation of the Quadrant client in my local system. Unless I'm not doing that, I will not be able to invoke this part. So first of all, select a kernel, and after selecting a kernel, we have to install a Quadrant client. So pip install Quadrant client, and if everything is going to be fine, then I will be able to do the operations. So okay, this is installed. Now let's try to create a client over here. So okay, so this is going to fail. Let me fix this issue, guys. Okay, so it was not an issue at all. Same thing, but yeah, so it was trying to access this particular DNS, and it was not able to do it. Because of that, it was giving me an error. After some time, so I have just executed it and it worked. So again, if I'm going to execute, it is going to work. So no changes means literally no changes has been required over here. Now Quadrant client is a point for me by which I will be able to connect with the Quadrant cloud. Now, so let's do it one by one. So let's try to do some sort of operations over here. Now, to do any kind of operation, I have to convert my data into an embeddings. Now here, so just like before, my URI embedding will come into a picture. So let's go to the get embedding tab, and here, so I'm going to copy this function, and this part I'm going to replace it with the URI API key. Let's do it. So here, click on authentication inside this URI, and then just try to copy your API token, and just try to replace this entire static part with the API key. Okay, so that's cool, and it's done. So I will be able to now generate the embeddings. These things are unnecessary. It's just an example which we have given. So execute it and keep it as it is.
So my embedding function is up and running and it's ready, right? My client for a quadrant is ready, right? With the API key and this particular DNS, a URL. So these two things are required. These two things are required to do any kind of a insertion or updation, or maybe to perform any kind of a search operation. Now here, even inside a quadrant, you can try to create a collection, just like we were doing it in a Bayesviet, right? We were trying to create a schema. So here you can try to create a collection. So here I'm going to create a collection, and collection name, and collection name is going to be Euron. Let's suppose I'm going to give collection name is equals to Euron, simple variable, and I have just passed the Euron over here. Now, so quadrant client dot I can try to call recreate collection. So recreate collection, and I'm going to say that, okay, so just try to create a collection with the collection name is equals to collection name. Yeah, so collection name is equal to Euron. You can directly pass a data over here. That's also fine, not an issue at all. Okay, so collection name I have given. Then I have to give a parameter for a vector configuration, means whatever embedding that we are going to store. So we have to provide some of the parameter. Now, what are those parameter? The very first parameter is size. In case of Bayesviet, if you remember, so at the time of creation of cluster or sandbox itself, we have given the size. But here, so you can try to give a size based on the collections. So 1536, because that's the embedding size that I'm going to get from my URI. And here, so you have to even give like for a similarity search, what is a distance parameter it should consider. So distance, DISTNC, distance. So I'm looking for like all the result based on the cosine similarity. So COSINE, cosine similarity. So this is the distance. These are the two parameters that you are supposed to set. So distance, okay, that's cool. Now, so collection name I have given and vector configuration I have given over here. Now, let's try to execute it. So crashed, and then again, this is going to give me a response handling issue. Deprecation warning, recreation is deprecated. Okay. Method is deprecated and will be removed in the future. Use collection exist to check a collection existence and create collection instead of. Okay. So maybe create collection I can try to use, and now it's done. So I'm able to create a collection. So the previous one was deprecated, and I have just called a create collection, and now it's working for me. The previous one was working in my previous code base. Now it's working in the latest one. I can go now and I can try to check that whether this collection has been created or not. Yeah. So whether this collection is created or not. So maybe I can try to like click on this cluster UI, and let's see. So here I have to provide my API key. So let me pass this key. Apply, and now it is going to help me out in terms of accessing it. Now here you must be able to see that it has created a cluster Euron. Yeah. So it has basically created a cluster called as Euron. I can try to click on this one, and this is basically a configuration. So name is default, and then size is equals to 1536, and distance matching is going to be cosine. Now, so inside this collection, I can try to insert a data. And again, they are given you a multiple options over here. So we can try to access all of these options going forward. Fine. Apart from that, so they are giving you like a dataset option. They are giving you a tutorial option. So load the content, a full text searching, multi-vector search, a sparse vector, hybrid search, all these options they have given to you. But yeah, not to worry about this. First of all, we have to insert something inside this particular collection. Now, so how I will be able to insert? Let's try to understand that part. So collection is created. Now we are good with this. Now, so here record wise, so I'm going to create a text, and Euron is a company for AI upskilling. Now this is the record that I would like to insert. So this is my text, by the way. Yeah. Now I can try to convert this text into embeddings. So I can try to call my generate embeddings and I can try to pass my text over here. So eventually it is going to give me a embeddings or vector of 1536 size. Fine. So now embedding is ready and my text information is ready. So my embedding is ready over here. Now here, so if I have to insert a record, so I can try to call basically a quadrant client dot absurd, right? So absurd is a function I'm going to call, and inside that I'm going to pass my entire things which I would like to store. So first of all, if you are going to hover your mouse on absurd, it is going to give you basically all the parameters which is required. So the very first parameter which is required is a collection name. So what is my collection name, by the way? So my collection name is this collection name Euron, or you can try to like directly pass it, or maybe from a variable you can try to pass it. So collection name was Euron. So inside this collection I'm trying to insert the data. Now so then you have to basically provide a points basically. So here inside this list you can try to provide this dictionary. So here I'm going to pass id is equals to 1, let's suppose. I'm going to keep, then I'm going to provide a vector vector vector, and vector is nothing but the embeddings. This is the embeddings which I have already generated. So this I'm going to insert, and then I'm going to define a payload. Now payload wise, the textual information. So what is my text? So text is basically text, this data I'm going to insert. So here I'm just giving the ID, I'm giving basically a vector embeddings, and then I'm going to pass the payload. Now if I'm going to execute it, it is going to insert. So again, this has failed. Let me check what is the actual issue. Link things looks fine to me. Embeddings is fine. Payload text is fine. So I don't see any problem. Collection is already available. Error gated data info fail. Okay, so let me debug this one. So actually there was no issue, and I have not done any kind of a modification. Quadrant is failing again and again. I think for a free tier, it's not that stable in terms of a connection, and because of that it is failing. But yeah, so there is no changes which I have made. It's exact same thing. So everything was okay, by the way. Now here I can come and I can try to like check once again. So I can try to click on collection. I can try to click on Euron basically, and inside that I will be able to find out my data. So 0.1, so I am able to find out the data. Length is basically 1.36. I can try to click on open graph, and yeah, so this is the graph that it has created. So internally it is trying to create basically a graph, and based on graph, so it will try to do the distance matching or like a similarity search it is going to perform. Now let me insert a multiple records. I can even click on visualize, same thing it is going to return. So it is going to return like a graph for you. So here let me go back, and back to back, let me insert couple of more record into the same collection. So vector wise, ID wise, let's suppose I'm going to give 2 embeddings. So generate embeddings, and I'm going to insert my name is Sudhanshu. Payload text wise, so same data. So this is again a second insertion which I'm trying to do. Failed again, wait for some time, and then insert again. It will work. See, inserted, right? Status completed. Now Sudhanshu works for Euron. So get embeddings, and then even text wise. So this is the textual information. ID wise, it should be 3. Yeah.
So insert. Okay, so now no error. It will not give you error, don't worry. Is having its own AI system for chat and API. So this is the another record, the fourth one. Okay, fine. Execute. So just execute after some time, within like a couple of seconds. Everything is fine, so it is not going to fail. Yeah, like I said, so it is going to work. It is giving me an issue like frequently nowadays. So when I'm trying to insert the new records. Okay, so now go to quadrant and then click on collections. Click on your Euron, and 4 points you have already inserted, right? So click on this Euron, and here, so point number 1, point number 2, point number 3, point number 4, all of this information you will be able to find out. Yeah, all of this information. Now you can try to click on even visualize, and it is going to visualize. It is like taking quite some time for me. Yeah, so for if I'm going to click on one, it was trying able to create a graph automatically, but yeah, so see, this is representing. So this is how this graph is like it is showing you. Let me go back once again, open graph, and here, so this is my very first data. Now my name is Tanshu. This is the second data. Now Euron is having its own AI system for this one. So this is my Euron is a company. So this is the central node. And again with this graph, so things are connected. Sudhanshu works for Euron. Euron is having its own AI system. And then my name is Sudhanshu. So this is a kind of a similarity graph that it has created internally. And you are able to visualize it. Now let me insert some record which is not even relevant with Sudhanshu or Euron. I am learning data science. Execute. Execute after some time. Once again, it will work. Okay. Now, so let's try to refresh it, or maybe click on collection. Collection is Euron. And here, so I'm learning data science, open graph. I'm learning data science. So yeah, it is able to like create a connection basically. And here, so you will be able to find out even a distance. So if you are going to hover your mouse on the edges, so you will be able to find out the distance. As you can see, with I'm learning data science, so it is having distance is equals to 1. So it simply, and with all of this, it is having a less distance, as simple as that. Yeah. So here I'm able to create a graph, I'm able to insert a record, I'm able to convert my data by using my embeddings. All of these things I'm able to perform. Now let's try to do some sort of a search operation. So already data is available, so I will be able to do a cosine similarity search, and obviously it should give me like the matching data out of it. So I can try to search even over here. I can try to search, find similarity with this one, but I can try to search it even programmatically. So programmatically, if I have to search, so maybe I can try to create my query text, QUERY query text, and query text is, so the answer is mentor at Euron. Yeah, so this is my query, and I would like to know that which one is closest with this particular sentence. So which two is the closest sentence that I have inside my DB, which is like near to. So the answer is a mentor at Euron. So to do that, maybe for a query, we can try to call a generate embeddings. So query generate embeddings and emb underscore query is the name I'm going to give. And then I'm going to like a call quadrant client dot search. Yeah, search. Now here, so search wise, I can try to give a collection name, that in which collection I am trying to search. So inside Euron, I'm trying to search Euron collection, and then query vector basically. So query vector is my embedded query, this one. And then I can try to like say that top 2 or top k. So I can try to say that, okay, fine. So try to give me top k basically. Yeah, top k over here. Now, if I'm going to execute once again, it's like deprecated search method. So query points instead of, okay, let me try once again. Now I'm able to get the data. I have not changed anything, guys, although it was giving me a deprecated warning, but that was just a warning, right? So nothing is going to change for me. So now here I'm able to like get ID3, and ID3 says that the Sanshu work for Euron, which is our nearest one with respect to my query. And yeah, it looks like it's the nearest one, right? Even as a human being, so we can try to interpret, and it looks like it's the nearest one. Then the second nearest one, right? The second nearest one is my name is Sudhanshu. So again, that looks okay to me. So I'm able to search something from my quadrant database. Very simple, right? I'm able to search something from the quadrant database. Now, so if I would like to like, list all the record which is available inside this collection, I can do that as well. So here, QD quadrant client dot, there is a function called as scroll. I can try to call, and then I can try to provide my collection name. So let's suppose I'm providing collection name is equals to Euron, and limit is equals to 10. Fine, limit is equals to 10. So it will give me a 10 record from my quadrant database. So execute, and yeah, so I had this record 1, 2, 3, 4, 5. So it is giving me all the records. Very simple, right? It is giving me all the records over here. So I can try to, list down all the records. I can just try to increase or decrease this number, and accordingly it will try to fetch that many number of records. I have given 10, but yeah, there was only 5 records. So it has given me all the 5 records. Now, if I would like to delete some records, so I can do that as well. So here QD quadrant client dot, there is a function called as delete, and here, so I can try to provide my collection name. So from Euron, I'm trying to delete, and then which point. So I can try to give points over here. So point number 1, point number 2, point number 3. So which points I would like to delete, because this is how it is showing you the data, right? So point number 1, point number 2, point number 3, and so on. So here, right? So here I can try to give my points. So here I can say that point selector, and inside this point selector, I can try to pass as a dictionary. So point, and which point I would like to delete. So maybe I can give delete point number 1. I can give multiple as well. Now here, execute once again. Error is fine. Unsupported point selector type class dictionary. Okay, so points key and then list. Looks fine to me, by the way. Unsupported point selector type class dictionary. So point selector, it is fine. So 1. Okay, let me check with its documentation. So what is there inside the actual documentation for a delete? Let me check that. Okay, so as per the latest documentation, it says that I should call basically models dot. So it keeps on changing because library is evolving, right? The entire platform is evolving. So from quadrant client dot http import model, and then here point selector wise I should write model, it should be models. Yeah,
So models dot nt point id list, this one, and then inside that I have to pass my points, points, and then I can try to provide the list of the points. This is the syntax as per the latest documentation. So now I think it's going to work, and yeah, so it is going to delete point number 1. Now if I'll go and check this point number 1, Euron is a company for AI upskilling. Now if I'm going to refresh it, so click on collection, come back to collection once again. So that is gone, right? Point number 1 is gone. We have point number 2. So this is how you will be able to delete it. If I would like to delete the entire collection, again, that is possible. So I can try to call my quadrant client dot delete collection. And then inside that, I can try to give my collection name. So collection name is equals to what? Euron. So it is going to delete the entire collection. I can go and I can try to check that out. So collection and no collection at present. Yeah, there is no collection at all. So I am able to delete my collection as well. So likewise, there are like everything that you can do it. Just go through this documentation. Inside this documentation, everything is mentioned in a very simple way. And with the help of that, you will be able to do each and everything inside the quadrant. So I believe you all are able to get a proper introduction of the quadrant. Now we know that how to deal with a quadrant, how to connect with a quadrant, and how to like insert the record, how to even update the record, how to search inside the record, how to delete the record, each and everything, right? We are able to understand. So with that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so welcome to lecture once again, guys. Now in this lecture, I'll be talking about a LangChain, not just a LangChain basic I will be talking about, but I'm going to talk about a LangChain end-to-end application with respect to a LangChain plus RAG plus tools plus agent and providing a memory to my agent. All of these things I'm going to discuss in a detailed way into a practical manner while showing you a code. So let me share my screen, and like I said, so I'm going to talk about basically a LangChain. I'm going to talk about RAG with respect to a LangChain, how we can try to create a tool inside a LangChain, how we can try to give an access of a tool to an agent, and how we can try to provide a memory to an agent. And all together, it will be able to give an answer from a particular data. So obviously with the help of RAG, so it will be able to give an answer for a particular data, a private data you can say. So the data which belongs to me and a data about which LLM is having no idea. And obviously we need a LLM over here. So I'm going to use a URI, as URI is going to provide me an API access for multiple models. And apart from that, so I need embeddings as well, because whenever I'm going to talk about a RAG application, so obviously I have to store all of my data as a embeddings, then only I will be able to perform a RAG application. So for embeddings, again, I'm going to use a URI. So where I have an API access for OpenAI embedding models with a length of 1536 with a vector dimension of 1536. And I hope we all understand what is the meaning of a RAG. And obviously we don't know what is the meaning of a tool, what is the meaning of an agent, what is the meaning of a memory, or maybe a LangChain, but at least I'm assuming that we all have an idea about a RAG, because this is what I have discussed a lot in this entire series, in this entire sequence. Now, just to recap this RAG concept in a layman way, so RAG is nothing but, so whenever you are going to ask a question, right? Whenever you are going to ask a question, so let's suppose I have my own database, and inside my database there is a information about me is available, right? Information about me is available. Now let's suppose if I'm going to ask a question to my LLMs, so obviously LLM will not be having any kind of a idea. So those data, a private data, is available inside my own database or maybe inside my own file system. So whenever I'm going to fire a query, right? Whenever I'm going to fire a query, so it should get a data from my database, right? And then it should append this query. So query plus the data which it is going to retrieve, the data it is going to retrieve, and send this entire information combinedly to a LLMs, right? To a LLMs, and LLMs is going to generate or produce a result for me. So this is where this RAG comes into a picture in a simple manner, right? If you have to understand this RAG in a detail, in a practical manner, so I have already taken a lot of classes on that. So please try to follow that particular part. Then I will be talking about tools over here. I'll be talking about agents in a practical manner. But yeah, so definition wise, if I have to talk about agents, so agents are nothing but an employee, or you can say an intelligent employee who can try to take their own decision that what to do for what, right? For example, so if I'm going to ask anyone to create a landing page, right? Landing page of a Euron. So obviously my designer will go, they will try to do a research, they will try to do a competitor analysis, they will try to understand the product, they will try to ask a couple of questions, and after that they will start designing this entire page, right? This entire page. So before that, so obviously they have to do a lot of like a groundwork. So similarly, my agents, right? So it is basically an intelligent employee. It will be able to take a decision on its own that what to do in this situation or what to do in that kind of a situation. And when I'm going to explain you in a practical manner, you will be able to understand it in a much better way. Plus, I'm going to give a memory that whatever conversation or whatever things that we have done in a past, agent will be able to remember, or next time whenever agent will try to give me a response, it will try to consider memory part as well, just like a human being. And here there is a tool. So tool is nothing but a couple of functions, right? Not couple of functions. One function is called as tool, by the way. So a functional access we can try to give to the agents. Because let's suppose if I'm like asking my designer to design a particular page, so obviously my designer needs a lot of things. Maybe to do a research, they need some portal access. Maybe to do a design, they need a Figma access, or maybe a Photoshop access, or maybe to access some of the elements, they need some other platform access. So similarly, this tool is going to work for me. So where one tool will be responsible for doing one particular task, and technically it's a function that we are going to create inside this entire system setup. Okay, so without wasting time, let's quickly jump into this entire implementation, end-to-end implementation, and where I'm going to take my own data, right? I'm going to consider my own data. I'm going to build a RAG application with the help of LangChain. I will be invoking an agents, and agents will be having a memory access as well as agent will be having a tool access. And then you will be able to see end-to-end application. So whenever I'm going to ask a question, so obviously it will look into my private data and accordingly it is going to give me the answer. Now, so first of all, just open up your VS Code, right? VS Code. And here, so let's try to open up a folder. Now, inside this folder, LangChain underscore demo is a folder I'm going to create. And inside that, I have to do a couple of things, right? So what things? So first of all, I have to do a project setup. So maybe I can try to like create a couple of files over here. The very first file which I'm going to create over here is requirements, requirements requirements.txt. So where I'm going to keep all the things which I'm going to install, requirements. Yeah, that's correct. Then there is, okay, so I think I have created a folder requirements.txt. Okay, so this is the file which I will be using. So where I'm going to keep all the dependencies, then I'm going to like write all the logic. So inside a main.py file, and then I'm going to provide a data. So data folder, and inside this data folder, so I'm going to create a file called as founder, FOUNDER founder story.txt. So where I'm going to keep my private data. Now private data can exist inside the txt file, inside a PDF file, inside some databases. You just have to read it out. That's it. You just have to read it out. Okay. Now inside this requirement.txt, let's try to keep a requirement that we have. So we are going to keep a LangChain because this entire things, this entire RAG application with the agents, we are going to create with the help of LangChain framework. Now, those who are not aware about a LangChain framework, let me give you a little bit of an idea that what LangChain is. So LangChain is basically a platform, or you can say it provides you a library by which you will be able to build, or by using that, you will be able to build any kind of a LLM based, large language model based application. So maybe a chatbot you will be able to build, a memory based chatbot you will be able to build, a single agent you will be able to build, multiple agents you will be able to build, tool you will be able to build, RAG based application you will be able to build. And by doing that, you can solve a problem for a multiple domain. Again, it is going to provide you a beautiful library. And now LangChain is one of the most prominent and beautiful platform which is available out there. Then we are going to use our Facebook AI similarity search. Now here, this will be used to store my vector data. So whatever data which I'm going to keep it over here, I'm going to use a Facebook AI similarity search. You can try to use a ChromaDB, you can try to use a Quadrant, you can try to use a Waviate, you can try to use a Pinecone. I have already discussed all of these databases in my previous lectures as well, right? So please go and refer it if you would like to change your database. But at the end of the day, it's a database where I'm going to store my embeddings, means like a vector of the information, I'm going to store it. Then request, TikTok token, Wikipedia. So all of these things I will be using it now. So close it. And then let's do one thing. So let's try to create a fresh new environment. So I'll go into my command prompt and here, so conda create -n, and I'm going to give a environment name is equal to lang, right? So lang and then Python, right? Python. So conda create -n Python version wise 3.12 I can try to give, latest one, and keep it all yes. So it will be able to create an environment called as lang for me. And inside this environment, I will be doing all the relevant installation. So which I'm keeping inside the requirement.txt file. Okay, so this is done. Now I can try to activate this environment. So now environment activation is done. As you can see, lang over here. Let me do CLS, clean the screen. And here, so I can try to do Python install, pip install -r requirements.txt. So whatever I have inside my requirement.txt, it is going to install, right? It is going to install. It will take a couple of like a second of time, maybe not minute of time it should take. Depends upon the system configuration. So yeah, all is done, right? All is done. Maybe I can try to check my installation. So I can try to write pip and then show LangChain. So I just wanted to understand that what is the version of the LangChain which it has installed. So version of LangChain is 3.26. Okay, that's cool. So we are able to do the system setup. All the installation are done and LangChain is available over here. Okay, now close it. Yeah, close it. Now inside this main.py file, I'm going to write all the code in a sequential manner, one by one. I'm going to write a code. So first of all, I have to import all the libraries which I'm going to use it inside this particular class. So here from a LangChain vector store, so I'm trying to import a Facebook AI similarity search library. So this I'm going to use it to store my data into this vector database. Simple. Now, so what kind of a data I'm going to store? So first of all, I have to even create a data for me. So here I have this founder story page. So you will be able to find out founder story page, and here there is a data available about me. So just copy this particular data. This is a raw data I'm going to consider and paste it as it is inside .txt. No need to do any kind of a formatting or anything. It's completely fine. Going forward, even I'm going to show you that how to read a PDF, but as of now, let's try to talk about the TXT. I just need a data. That's it. So data can come from maybe a S3 bucket, maybe from a Azure blob, maybe from my TXT file, PDF file, Excel sheet, or anywhere. That's completely okay to me. So here is my data. Now, so this data, the data which I have taken, so I'm going to convert that data into a vector or into a embeddings, and then I'm going to store it inside a Facebook AI similarity search. Okay. So rest of the things I'll be talking about it one by one. So as I'm going to progress, yeah, as I'm going to progress. Now, so you need a couple of things, guys. So like I said in my diagram that you need a LLM, right? And you need a embedding. So you need a embedding models and you need a LLMs, because unless and until you don't have a LLMs, you will not be able to build RAG application. Even your LangChain requires LLM access. So you can try to provide any LLMs which is available out there. That's completely fine. and then you need an embedding so that you will be able to convert your own data into a embedding format. Now, so to do that, I will be using basically URI API. So I will be using URI API. So here, URI API is more than sufficient enough to give me all of these things. So it is having a multiple models. So I can try to use any models for a chat completion. Plus it is giving me embedding models as well. And that too a best one from OpenAI. So this is the model with the vector dimension is equal to 1536, which is a good one, right? It is giving me. So how I will be able to access this? So here we have already given you a code example in a Python as well as in a JavaScript, right? So here, this is the piece of the code I'm going to use for LLM access. So where this is the chat completion URL, means this is the URL where you are hitting the URI basically, and you have to provide your API key, by the way, and then you can try to write any kind of a prompt, and accordingly it is going to give you the response. Now, similarly for like a embedding, so we have given you a function over here. You can try to provide any kind of a text, and in return, it is going to give you a vector. It is going to give you the embedding of size 1536. Yeah, 1536. And that too by using a text embedding 3 small model, which is coming from OpenAI itself. So here you have to write these two things, and I have already prepared my function. So no need to like write live, because these functions are basically a static one. So this function, as you can see, so this is a function so which I have created for a embedding. So here you can try to pass your data, your text information, and it is going to return you embedding. Simple. So it will take input as a text data, and then it is going to give you the embedding. Simple. So this is one of the function which I am going to use. Apart from that, so I need a LLM access, which is technically a chat completion, right? So URI chat, you can try to provide a message, whatever message you are going to provide to the LLMs. It is going to give you a response. You can adjust your temperature as well as you can try to adjust your maximum number of token in terms of a response. So temperature means, so temperature is going to control basically a randomness of the output. So if temperature is less, output will be more accurate. If temperature is more, it is going to be more random. So it should always vary in between 0 to 1. So you can try to change this one. Maximum token means the token, a number of like a token as an output, it is going to give it to you. So this is going to give you a response for any kind of a messages that you are going to put up. And here I have already applied my API key. So you can try to change this with your own API key. Keep bearer as it is. Just you have to change this particular part, this entire part you have to change with your own API key. Now model wise, you can try to use this model, and apart from that, so there are other 10 models which we have given to you. So you can try to use other model as well. So it's not like you have to use GPT 4.1 Nano itself. So here you have an access of multiple models, right? You have an access of Quen, you have access of DeepSeek R170 billion parameter, Gemini 2.0 Flash, Gemini 2.5 Pro Preview, and Gemini Flash Preview, Llama series you have an access of, Mistral series you have an access of, OpenAI wise, so GPT 4.1 Nano, Mini, so all these models you will be able to use it. You just have to replace with the model ID. So ID is given with respect to all the models. So just have to change with the model ID, this one, this particular part, this is the model ID, and then it is going to give you a response out of that. So these two things are fine. Right? These two things are fine. And in all my LangChain lectures or maybe a Llama index lecture, I'm going to use the same thing, same kind of a functions everywhere I'm going to use it. So these functions are basically a static function. Now, so whenever we are talking about whenever we are talking about basically this LangChain, so it requires access of your LLM. So obviously this is going to give me a chat completion, means whatever message or whatever prompt which I am going to pass, obviously it is going to give me the response. It is going to give me the response out of that. But for LangChain, so you have to provide this LLMs in a LangChain compatible version. Unless and until it will not be able to get a LangChain compatible version, it is not going to give you a response. So LangChain requires LLMs. Now, so I'm using my own API, right? I'm using a URI API, by the way. So which is like not registered with the LangChain. So LangChain is not going to provide you any kind of a direct LLM access or direct functionalities for that or direct classes for that. So to do that, I have created my own custom, right? So I have created my own custom, I would say, a class. So again, this is going to be the static one. No need to understand this part. This is like a I have created just to make URI LLM, right? So just to make URI LLM accessible by a LangChain, just to make it compatible. So these are just a boilerplate code, you can say, right? So like here it is trying to invoke a URI chat, as you can see. So this URI chat has been invoked by this particular class. And here, so I can try to create an object of this class. I can just try to provide, because this is the type, or this is the format which will be required by a LangChain, because every framework will be having its own requirement. Yeah, again, if you're going to use a OpenAI, then they are going to provide you a direct OpenAI class, compatible class for that one. But yeah, URI is my own custom, like a LLM provider. So for that, I have to make it compatible. So that's the reason. So this is the code. So these are the boilerplate code. You can like keep it and leave it as it is, which I'm going to use it in a future, right? In a future. Now, so now let's start talking about the entire process. Yeah, entire process one by one, one by one. So now let's first try to start with the data. So here is my data, right? Here is my data. So what I will do in a very first place, so let me create a flow over here. So I have my data, right? So I have my data over here, right? My story data, by the way. So I'm going to read this data. I'm going to do what? So I'm going to read this data. Now, after reading this data, I'm going to store this data into Facebook AI Similarity Search DB. So database, which is nothing but a vector DB for me, vector DB for me. So inside this, I'm going to store this data. So this is the process that I have to do. Now, after reading this data, in between, so I have to break down a data into a chunk, into a small pieces, because that's my raw data, right? So like all the scrap data I have just put up inside one thing. And then this chunk I'm supposed to provide to my, or this chunk I have to convert it. I have to convert it into basically embeddings with the help of what? So with the help of in between, I would say. So I have to convert it into embeddings, I would say, embeddings, with the help of what? So here with the help of URI, right? With the help of URI. So I have to convert this into an embeddings, and finally I will try to store it inside my vector database. Yeah, vector database. So let's do it one by one, Let's try to do this operation. So here, like I said, first of all, I have to read a data. So to read a data, my function is going to be very simple. So with open, inside this data folder, I have a founder story, right? So founder story.txt, I'm trying to open up into a read mode as a English data, by the way, UTF-8 encoding. And then this text is going to return me the entire textual information. So whatever data is available, whatever raw data is available, it is going to return me that part. This text is going to return me that particular part. Now, once it is going to return this data, right? Once it is going to return this data. So like I said that I have to break it down into a chunks, because as of now, it is going to read the whole data, right? It is going to read the whole data. Now, so I have to basically, right? I have to basically break it down into a chunks. Maybe I can try to show you that part. So till this point, I can try to like execute. So here I can write print text. Okay. In a later stage, I'm going to remove it. So here Python main.py file. So no module name, module not found, error. So LangChain community. Okay, so let me pip install LangChain community. And let me mention this one. I think I forgot to mention that here into my requirement.txt. Okay, so LangChain community is installed. Let's do a CLS over here. And inside this, let's try to run Python main.py file. So as you can see that it is trying to read the data. Whatever data is available. So it is trying to read it out. Fine. So I think we are able to read the data clearly. Yeah. So these are the data. Now you can try to keep as much data as possible. So I'm able to read the data. Now remove this print unnecessary. It will try to like increase the output length. Now, so after reading a data, what we have to do? So we have to split this data, right? We have to split this data into a small chunks. Yeah, into a small chunks. So here I can try to do this one. So split a data into a chunks. Now what I'm trying to do, so for I in a range of 0 till a text length with a jump of 500, means 500, 500, 500. So this is what I'm trying to like do it as a chunk, right? This is what I'm trying to do it as a chunk at the end of the day. So 500, then 500, then 500, and then 500. So in this way, I'm trying to create a chunks, and then I'm trying to call this document import, which I have done, right? This document import, which I have done from a LangChain doc store document itself. Now what it will do, so it will try to convert this entire chunk. So it is trying to take this chunk one by one. So chunks in a chunk, because I will be having a multiple chunks, right? And it is going to convert it into a LangChain compatible document format. So I can try to even print documents, as well as I can try to print over here a chunks. So chunks is nothing but just a size of the data with 500. So here CLS, and now so there is a document, as you can see, document, so page content. So this is the entire document which I am able to print, and then here we have a chunk of the data. So here we have a chunk of the data, and in between, so you will be able to find out, or here if I have to show you maybe just a chunk. Yeah, so this is basically a chunk that I have created, and every chunk is having a size is equals to 500, right? 500. And then eventually I'm trying to convert it into a LangChain compatible document format, so that I will be able to pass this data to my LangChain. Okay, now once I'm able to do this, means I'm able to create a chunks, and then I'm able to like convert it into a LangChain compatible format by using a document. Then what I can do, then I have to, right? I have to convert this entire data as a embeddings, and that embeddings I have to store it inside a Facebook AI Similarity Search Vector DB. With the help of URI, I will be doing that. Yeah. So with the help of URI. Now to do that, right? To do that here, so what you have to do, so you have to call basically this piece of the code. So here I'm trying to call LangChain embedding base import embedding. Now, so to make any external embedding things compatible, right? Compatible with the custom embedding one, right? With the custom, because here I'm using a custom embedding query, right? Custom embedding query, and this is nothing but a function which, so URI chat and URI embedding. URI embedding is something which I'm trying to use, which is my own custom one, right? So here I'm trying to use my URI embedding, which is not compatible by default with a LangChain. So just to make a compatible with this one, I have created URI embedding class. And inside that, I'm trying to call URI embedding, because this is again required. This is very much required if you are using URI in that situation. So here I'm trying to create an object of this URI embedding class, which is eventually calling a URI embed, right? URI embed. And again, so you don't have to change this part of a code at any point of a time. It's going to be same as it is. You can try to change this data, and then you can try to pass any kind of a data. Maybe you are reading a data from some other sources. So in that case, just change this piece of the code. That's it, right? That's it. So URI embedding class I'm trying to call, and then I'm trying to call a Facebook AI similarity search from text. So this is the function which is available inside the FISS basically. And I'm trying to provide my document, a document which I have already created. Yeah. So which is a LangChain compatible document, which I have already created. And one by one, right? So one by one, I'm trying to pass it over here. And along with this, I'm trying to pass the embedding models. So here it will try to create a Facebook AI similarity search indexes automatically. I believe we all are aware about the indexes, because I have already discussed about the Facebook AI similarity search in my previous lectures. That how Facebook AI similarity search is going to store the data, how it is going to create the indexes. So here I'm just trying to use this library with respect to a LangChain compatibility. So here you can try to use any other vector DB as well. That's completely fine. That's completely okay. So this is something which I have created, which is going to convert my document by using this embedding model. Embedding model is nothing but it's an object of like a URI embedding class, which is using URI embedding, right? And it is going to store it inside a Facebook AI similarity search indexes. And then I'm trying to create a retriever object. Retriever object means, so whenever I'm going to pass something, so it is going to retrieve a relevant data. So with the help of this retriever object, I will be able to do that. Okay, so that's cool. So till this point is like a done. Then, so till this part, it's done. I'm able to do it. Then what we are going to do, so we are now going to create a tools. We are now going to create a tools. So till this part, it's done. So tools is nothing but multiple functions I'm going to create. So maybe a function 1, function 2, function 3, function 4. So multiple functions I'm going to create. And then eventually I'm going to expose this entire function as a tool to my like a LangChain, the sequence that we are going to create, right? So here tool is nothing but, many people generally gets confused with respect to the tool, but no, you should not get confused with this things, because these things are nothing but just a simple basic function which I'm talking about. For example, I'll show you one example, right? A simple one. So I'm going to create a calculator, CLCULATUR, calculator underscore tool. This is the function, a plain basic function, which is going to take a query. Yeah, it is going to take the query. And what it is going to do, so it is going to evaluate the arithmetic. So docstring is pretty much important whenever you are trying to create a tool, otherwise it is going to give you an error sometime. And then here, so we can try to write my like exception handling, try and return what? So evaluate the query and return it to me as a str in a string. So this is a basic tool which is going to take your plain query and then it is going to evaluate it, and finally it is going to give you this one. So query, I should like make it here like this. Okay, query, and then I can try to write except. So except exception as E, and a return in case of a error. So formatting a string ERROR error, and just try to like return me E, simple, right, with error. Okay, so this is one of the tool, a basic tool. So whenever I'm going to provide the arithmetic expression, so it is going to like invoke this particular tool, and agent is going to decide to call any kind of a tool automatically. Now the next question you are going to ask me over here, that you are trying to like build a RAG, so where you are giving a founder story, and obviously anyone is going to ask a question with respect to this founder story, then why you are writing this calculator kind of a things over here, right? Calculator kind of a things. So maybe, right, maybe I can like I'm chatting with my this LangChain, and in between, if I had to like do some sort of a math, right, I can try to call this one. I'm not going to call this one, by the way. So eventually this agent is going to call this tool automatically. Yeah, this agent is going to call this tool automatically. This is what I mean over here. Okay, so I'll be talking about that more and more. So let me try to create another tool. So I'll try to create a multiple tools over here. So this is again like a summarizer tool. Tool means as of now consider it as a function. So as of now it's a plain function. I'll try to convert it, or I'll try to treat it as a tool going forward. So here summarization tools, so summary, any kind of a text. So whatever text that you are going to like give, it is going to provide it to a URI chat. So URI chat, so it is going to provide that as a message, and then it is going to like summarize the entire thing. So whenever like something has to like summarize, it is going to call this summarize tool automatically, or summarize function automatically. Then maybe something we have to search from a Wikipedia, right? So I can try to use this function. Yeah, not I. So when I say I, means my agent, right? My agent, my intelligent agent is going to use it. So Wikipedia, that's completely fine. Then there is something called as a translation tool I have created for all of you. Translation means one language to another language. So here again, it is going to like create a prompt automatically, and then it is going to invoke the model, and with the help of this, it is going to translate. So one language to another language, it will be able to translate it. So one is a translation tool, and then another tool I'm going to create called as basically explain code tool. So let's suppose if I had to ask maybe a code explanation, so it is going to invoke this particular tool. Now every tool I have created based on the LLMs, right? Based on the LLMs, I have created all of these particular tools. So you can try to create not just one, two, but you can try to create hundreds of such functions, and you can all together, you can try to give an access of all of these functions to your, right, to your chain or to your agent that you are going to create, because agent needs some sort of agent will be very much intelligent when it will be having access of lot of tools, lot of functionalities, and automatically it is going to invoke, automatically it is going to decide that which one I'm supposed to use at what point of a time. So here a lot of functions I have created. I'm not going to use it now. So this is just a plain function. How it is going to treat, or how it will be converted into a tools, by the way. So here I'm going to create a tool variable, and inside that I'm going to create a tool variable, as you can see, and I have created a list, and this tool function, now this is going to help me out. This is going to help me out to convert a function into a tool, whether I have one, whether I have 100, doesn't matter at all. So here I'm trying to give a name, calculator, then function, and then description, right? Description. Then tool, summarizer, I'm trying to call like a function, summarizer function over here, right? Just a function name. So here I'm converting a function as a tool. So list of multiple tools, I'm going to give it to my agents automatically. So it's very easy to convert any function into a tool. So just create a function and then call it over here. So this function again, function again, function again. So just in this way, you will be able to convert everything as a tools. So I'm trying to use this LangChain tools to convert my function into a tools. Very simple, right? Very simple. Now, so once I'm able to create a tools, I have 5 tools in total. 1, 2, 3, 4, 5. So basically one for calculation, one for summarization, one for searching something in a Wikipedia, one for like a translation, one for coding explanation. Yeah, code explanation. So I have a tools over here. Now, so let me come over here. So I am going to provide a tool access. I'm going to provide a tool access to my intelligent agent, Along with that, to my agent, I'm going to provide even a memory, right? So I can try to provide this memory to my agent so that whatever discussion that has happened, it will be able to remember it. I'll even show you that what is able to remember. It will be able to remember it. And then whenever you are going to, ask a question which was relevant to my previous conversation, it will be able to understand from the memory, and then it is going to give you the answer. Yeah. So tool, I'm giving an access to an agent. Memory, I'm giving access to an agent. As simple as that. So how I'm going to create a memory over here? So here I can try to use basically this part, a conversation buffer memory, right? Conversation buffer memory, which is already available inside a LangChain memory. So this is one of the memory. So conversation buffer memory, I'm going to give an access. How? So I'm just going to create a memory variable, and conversation buffer memory, chat history, return message is equal to true. So this is how I'm going to create the memory. And all of this, see, as of now, everything is separate. So tool is separate, right? Memory is separate. Everything is separate. When I will create an agent, then I will end up giving an access to it. Yeah, I will end up giving an access to it. Okay. So let's start creating my intelligent agent. So my intelligent agent, so I'm going to give an tool access to an agent. I'm going to give a memory access to an agent. I'm going to give memory access, tool access, LLM access. Yeah. So I'm going to give a LLM access to a agent, by the way. So here to create an agent, which is a main part, first of all, I have to give a LLM access. So LLM access, I'm going to give it with the help of URI LLM class. Yeah. So URI LLM class I have already created. If you remember, this is my URI LLM class. This is just a wrapper I have created, guys, by the way, right? This is just a wrapper. So whenever you have to use URI or URI like external system, you have to create a wrapper, by the way. So I have created that wrapper. So here LLM, right? Now I'm going to create an agent. So how I'm going to create an agent? So this is how I can try to call the agent. Sorry, my bad. Yeah. So initialize agent is a function. I'm going to give a tool access. Tool means this one, where I have 5 different functions with a different like a use cases. LLM access. So yeah, URI LLM access I'm going to give to my agent. So to my agent, I'm going to give LLM. So basically it's a URI LLM access I'm going to give to the agent. Memory access I have to give to the agent. So yeah, memory variable I have created. So I'm going to give that access to the agent, and then tool access I'm going to give the agent. And then here, so I'm trying to create a agent, and this agent is having a type. So there are different type of the agent that you will be able to create. Now, what is the meaning of conversational React description over here, right? So what is the meaning of this particular agent? Let's try to understand that part as well, because that is important, right? So whenever you are trying to create an agent, you should always know and you should always understand that what kind of an agent you should create for what particular purposes. So here, conversational, so I believe we all are able to understand. So conversational means it is going to maintain a memory of your chat. That is something called as conversation, a very first word, right? A very first word. Conversational means it is going to maintain the memory of your chat. React means reactive basically. So it is going to use a reasoning plus acting to plan steps. Means whenever I'm going to perform some sort of task, so how I'm going to break it down into a small one, and then how one by one I'm going to execute it. And the description, so it always try to leverages the tool description to decide which tool I'm supposed to use basically. So here with respect to a tool, I have given the description, right? With the tool, I have given the description over here. So it is going to leverage this description to decide that what tool I should use. So let's suppose I'm doing a summarization, right? So it will be able to understand that, okay, so this tool is going to do a summarization. So let's use this tool automatically. If I'm looking for a calculation, so based on this description, it will be able to understand that, okay, so this tool I'm supposed to call. So this is the meaning of conversational reactive descriptive agent. So this is the agent type I have given. And yeah. So let's move ahead. So this is the agent I will be able to create. Now, once I'm able to create an agent, an intelligent one, which is having a tool access, which is having like tool means all the functionality access. So an intelligent person I'm trying to create, which is having all the functionality access, which is having the complete LLM access, which is having a memory access basically. So what has happened, and which is having like a verbose. Verbose means whatever it will do, it will try to print it. So once this agent is been created, so now I have to, right? Now I have to basically call the entire chain, right? So now what kind of a chain I'm talking about? So I'm talking about a retrieval QA, question and answer kind of a chain. Retrieval means whenever I'm going to ask some question, it should retrieve some sort of information from somewhere. It should use a retriever basically. It should use LLMs. It should use basically a agent which I have created, and automatically it should decide that one to do what. So here, if I have to create a retrieval QA chain, so I can try to call this one from chain. I can try to provide the LLM access. I can try to provide the retriever access. Retriever is nothing but this one, right? Which can help me out to retrieve information from my vector database. Simple. So retriever access I'm going to provide, and then the return source document is equal to true. So it will return something to you. Okay. So agent is done, and then this chain I'm able to create. This chain I'm able to create. So here, right? So here now we have to run the agent. Yep. Now we have to run the agent. Now, whenever we are going to run the agent, so it should be able to retrieve some sort of information. Agent should be able to retrieve some sort of information, maybe with the help of this one. Yeah, with the help of QA chain. And then eventually it should give you the output. So here is my final piece of the code in a loop. So here, while true, which will be true all the time. So user is going to give the input, right? User is going to give the input. And here I have written the condition that if user input is exit or quit, so break it, break the loop, means don't run it. Otherwise, do one thing. So take an input from the user. So user input, and then pass that input inside the QA chain. QA chain means whenever. Now let's come to the last part. So how it is going to like work technically. So here, what I'm trying to say that take a input right? Once you have an input, now pass this entire input to a QA retriever. Yeah. So it is going to retrieve some sort of information from your vector DB. Yeah, which is nothing but my Facebook AI similarity search. So it is going to retrieve some sort of information from a vector DB Facebook AI similarity search. Now, once that is done, right? Once that is done, so once it will be able to retrieve the information along with the user input, and then it is like going to retrieve the answer. Then what we are supposed to do? So we are supposed to combine the user input and retrieved answer from my document for my Facebook AI semantic search. So combine the user input and the retrieve answer, and then pass that inside the agent. Agent is what? Agent is this. So a agent, an intelligent person which is having a tool access, LLM access, and a memory access, right? So pass this information. So what I'm trying to say over here, that try to combine this one and the output that we are able to get and pass this to a agent. Now this agent is having a tool access. This agent is having a memory, right? And this agent is having a LLM access. And now this agent is having a user input as well as extracted data from my vector database, right? From my vector database, it is having an access of extracted data as well. Now this agent, the intelligent one, it is going to decide automatically that, okay, based on the user query, what I'm supposed to do based on the memory, based on the tools access, based on the LLM access, what I'm supposed to do, which tool I'm supposed to call, or like what kind of an answer user is expecting, or if I have to like take some sort of an input from the memory. So this is called as chain, right? So agent will be able to decide all of these things one by one, one by one, one by one, one by one automatically. So now here, right? So here it is going to give you the final response. So I'm trying to print a final response from a bot. Now in between, so I'm trying to print you even a memory. So chat memory message. So whatever memory it is going to like hold, it is going to store. So just to show you that, okay, fine. So this is the memory. It is like a holding just for the debugging purpose. So when I was doing a coding, so I have done this just for the showcasing purpose, so that you will be able to even see that, okay, this is the memory that it is able to build internally. Okay, that's cool. Now everything looks fine to me. Yeah, everything looks fine to me. So now let's try to test it. Let's try to test it. So here I have to call Python main.py file. And if everything is going to work, then it's fine. Otherwise I'll have to debug it. Maximum retry exceeded. Okay, so caused by name resolution object failed to resolve. API Euron. HTTP connection pool, host port number. So let me check what is the issue. Okay, so it's a DNS issue, it looks like. Let me run once again. Name calculator tool is not defined. So DNS issue was like it's like based on the URL which I'm trying to hit, which is from a Euron. So calculator tool I have created. Yeah, so I think there is a name mismatch. Calculator tool. So let me like change a name. Calculator tool. Yeah, so now there is no name mismatch. Fine. So now let me rerun CLS python main.py file. Okay, so see, I'm able to run it. Yeah, I'm able to run it. Now here, so I'm going to ask a question that who is Sudhanshu? Yeah, if I'm going to ask a question, so now it will try to prepare an answer for me. So entering a, so here you must be able to see that entering a new agent execution chain. Thought, do I need to use a tool, right? So it is trying to think just like a human being, right? that do I need to use a tool? Because is this tool is going to help me out? The answer is no. So agent is deciding automatically that no, I'm not supposed to use any kind of a tool. If I have asked any kind of a question, then go to the document, retrieve it, and then based on that, give the answer. So here is the answer, right? And then I'm trying to print a memory into a debug mode. So who is the answer? This is what I have asked. And it has retrieved this information, right? It has retrieved this information. And then finally, it is giving me this entire answer. So this is the answer which I'm able to get. So this is something which system has retrieved, and with the help of LLM, so it has made it precise, made it concise, and then ultimately I'm able to get the answer. Now I have to test a memory, whether it is able to memorize something or not, right? So tell me his work. Yeah, tell me his work. Now I'm telling his, right? So obviously it should be able to understand that what is the meaning of this his over here. I'm not telling, or I'm not giving a name, any kind of a name over here, right? So tell me his work, or tell me about his work. So let's see. So whether it will be able to understand it or not. So yeah, it looks like it is able to understand that, right? So it is able to understand, and it is able. Do I need to use a tool? No. And this is the answer. It is able to give it to me. Lanshu work involved in educating and empowering learners to make a complex subject such as big data science and all those things, right? So it is able to understand his. It is able to understand his. This is what I wanted to show you. Means it is able to understand something from the memory. It is able to memorize something, and that is clearly visible even over here, right? That is clearly visible over here, that what it is trying to memorize. Okay. Now, so let me ask that. Tell me what is 3 into 9, right? So 3 into 9, or 3 into 8, let's suppose. Yeah, I have typed 3 into 8. So what is 3 into 8? So obviously when I'm asking 3 into 8, it is able to give me the answer, right? Now, do I need to use a tool? No. So it should have used a calculator kind of a tool, but it is trying to use a LLM, it seems. The result of 3 multiplied by 8 is 24. And now if I'm going to ask that what is 2 plus 3? Let's see whether it is able to invoke my tool or not. So the sum of 2 plus 3 is 5. Let me use some description. Input should be like 2 plus. Okay, so if I'm going to ask a question that do this math calculation, 4 plus 6. Okay, so it has given me an answer. Thought, do I need to use a tool? So still it is thinking that no, it should not use it. It's better to use LLMs, by the way. And see, it is still building the memory, right? Still building the memory. Now, so if I'm going to ask a question that my name is Sudhanshu. Now, translate it in Hindi. Let's see whether it is able to do a tool calling or not. Yeah. So no, आपका ना AI आपका नाम सुधांशु है. So it is. Okay, so my name is Sudanshu. So it is able to translate, by the way, right? It is able to translate all the time. So yeah, we are able to do a couple of things over here. We are able to let me call this one. Give me a summary of this entire document. So summary it has given to me. Yeah, summary it has given to me. So this is basically a summary of this entire document, and it is able to build the complete memory. So translation is done. For I in range of 10, print I. Explain me this code. So yeah, it is giving me a very clear explanation that what this code is going to perform, and along with that, so it is going to build a memory as well. So this is the answer. This Python code is a loop that runs 10 times for I in this one. Part create a loop that iterates with I, taking a value from 0 to 9. During each iteration, print I, display the current value of I. When you run this code, it will print the number 0 through 9 each on a new line. Yep. So successfully it is able to give me this entire result. Okay, so that looks cool to me. Now, so as we can see that it is not calling a tool automatically. So every time it is trying to give me no. Now the next question is that why? Just to answer to this question, so you have to make this description more detailed. That's the first answer I can give. The second answer is the LLM which I'm using. So LLM itself is like a sufficient in terms of giving you the answer, whatever answer which I'm looking for, right? So that's the reason. So it is giving me like every time no. Maybe what I can do, so I can try to say that, okay, just try to explain this code by using a tool code explainer that I have given to you. Yeah, so I'm forcing it. I'm basically saying that try to use a code explainer, and then so now you will be able to see that yes, it is trying to use a tool, right? Now it is trying to use a tool because I have forced basically, right? I have basically forced. Now, so in this way, basically I can try to force and I can say that, okay, fine, just like use this one and then try to run this entire operation. So then now it became, do I need to use the tool? Yes, you have to use the tool basically. So observation, certainly the code does this and this, and then eventually it is trying to call my tool over here. As simple as that. Just try to make it more descriptive. This one, try to use some weak LLM over here, or here I'm trying to use basically, where is my agent? So yeah, so I'm trying to use agent type conversational React descriptive. So instead of that, I can try to use a zero sort React description. So if I'm going to use a zero sort means with no example. So here CLS and then python main.py file, just run it once again. And let's see. So with zero sort, whether it is able to invoke a tool automatically or not without even forcing it. If I'm going to force it, obviously it is going to use it. So do this calculation 4 plus 5. Let's see whether it is able to invoke a tool or not. Okay, so here, if I'll go and check the entire answer, so entering a new agent executor, LangChain core, question was this, thought I need to perform the calculation 4 by 5 to find the answer, action calculator. So yeah, now it is trying to like action is calculator. It is able to decide, then input is this, observation is 9, and thought is basically I now know the final answer 9, and it is eventually giving me this one. Yeah, it is giving me this one. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about a multi-agent system. Again, self-routing system for a multiple agent with the help of LangChain framework. Not just that, so basically I have done the implementation of an RAG as well, and here so I'm going to show you even that example. And if you have watched my previous lecture, so this lecture is going to be an extension of a previous lecture. So in my previous lecture I talked about RAG framework with the help of LangChain, tool system plus agent. But here so we are going to talk about multiple tools, multiple agents, and self-routing agents as well, so that agent will be able to access multiple tools
depends upon the query that you are going to fire, and eventually it is going to solve your problem. Plus RAG we have attached into this one. So let me share my screen, and first of all, let's talk about a little bit of architecture, because that is important, and hope you all will be able to understand it after going through this particular architecture. So here we are going to talk about a multiple agent. So now in this particular project, what I'm going to show you, that there will be a agent, right? So let's suppose we have a agent 1, and let's suppose we have a agent 2, and I have already given you the definition of agents, right? That agent is nothing but just like your employee or your virtual workforce, so which is going to do some sort of a task, and when they are going to do some sort of a task, they are going to invoke a tool. Tools are nothing but eventually a functional access, or a functional access that you are going to give to your agent. So here we have a multiple agents, and parallelly, so we have multiple tools, let's suppose multiple tools, let's suppose. So we have a tool 1, we have a tool 2, and we have a tool 3. Now this agent will be able to access all of these tools as per the question that you are going to fire. Again, this agent will be able to access all of these tools as per the question that you are going to fire over here. Now, so as an entry point, so it is going to hit my agent. It is going to invoke my agents. Now, so whether it should use a agent number 1 or it should use a agent number 2, for that there will be a routing that we are going to talk about. So ROUTE. So depends upon the question, it may select this agent number 1 or it may select a agent number 2. Depends upon the question that you are going to ask. And we have configured that in such a way that it is going to decide automatically. You are not supposed to take any kind of a decision, and eventually my agents will be able to call tool number 1, tool number 2, tool number 3. So whatever number of the tool which I am going to create. Plus, not just that, you will be able to create not just agent number 1 or 2, you will be able to create hundreds of agent over here. You will be able to create hundreds of tool over here. And on top of each and everything, to access an LM, because when we are talking about LangChain kind of a framework, so obviously it requires an access of LLMs. So my agent need an access of a LLM so that it will be able to give you a complete formatted outcome. Depends upon the task that you are going to provide, so that human will be able to understand. So here we are going to use, so LLM wise, we are going to use URI LLM. So URI is providing you an access of 12 models, including a embedding model, chat completion model, and a streaming model. So if we will be using a URI LLM to give an access to my agent or to entire framework, you can say. So now code wise, let me explain you this particular code. Code wise, it's very easy. It's not difficult to understand. Everything is configurable. So as per your need, you can try to do a configuration of each and everything. And yeah, so let's try to understand. Now, like I said, so I have already discussed about this project in my previous lecture. So you can try to follow a previous lecture to get a basic of this one, and then you can jump into this particular part. So here we are just trying to do an import. Not just that, so we are going to, right, we are going to provide our own document as well. So this is my founder story basically, and I have used the same document in my previous chapter as well. So it will be able to access this particular document whenever it is required. So basically I'm going to show you RAG application. So RAG means Retrieval-Augmented Generation. My agent is going to decide whenever you are going to ask any kind of a question with respect to me, that okay, look into this particular document, try to perform a Retrieval-Augmented Generation and then give an answer. If you are going to ask some sort of a question which is not a part of this particular document, in that situation it is going to call a LLM access and it is going to give you an answer. It is going to give you a response with a knowledge that LLM will be having. Okay, so here we are trying to do all of these imports. I have also attached a requirement.txt file. I have already shown you that how to configure your entire environment setup, or how you will be able to run this entire requirement.txt by creating a separate environment. I have already shown you that part. So maybe even in this lecture, I'm going to show you the exact same thing. there is only one file which I have attached, and in one single file, so you will be able to find out the entire code base. So let's try to talk about it. So here, first of all, I'm going to use a framework wise LangChain framework, because with the help of LangChain framework, I can create a multiple agent, I can create a multiple tool, I can even try to give a memory to a agent, by the way, or maybe attach this entire memory concept to my tools as well. Apart from that, so here we are going to use a URI API. Now, so to access or to build any such kind of a system, obviously you need a API key of a model. Now, keeping that in a mind, if you will go to Euron platform, so let's suppose I'm going to Euron platform. Now here you will be able to find out a URI API, right? So just click over here, and available model wise, you will be able to see a 12 model. So we are giving you a Quen model access, DeepSeek model access, Gemini series access. We are giving you basically a Llama series access from Meta. We are giving you a Mistral series access, and we are giving you even a GPT access from OpenAI, so that you all will be able to use it. Now here, you will be able to find out a model ID. So whenever you are going to change a model ID, just with one single API key you have to use. So you have to change just a model ID, and it will start responding you back. So even over here, so we have attached a code example for each and everything inside a Python, inside a JavaScript, or maybe in a console if you would like to access it. Now here, so API key wise, you can come over here and you can try to create your own API key. So create API, you can try to give a name, maybe a test2 I'm giving over here, and it will end up generating a API key. You can just copy this API key and you can try to use it. You can activate, you can deactivate your previous API key. All of these things are already attached over here. Fine. Now, so you will be able to even track uses of your API key. So here, as you can see, I have already consumed my 28% of the API quota for today. So daily 100K token limit you have for all the model combined. So all this 12 model you will be able to access, and 100K token you all will be able to access on a daily basis, right? On a daily basis. So we need a API key, and I can try to generate my API key from here itself. So that is something which I have done. So I have attached my API key over here, and then I have attached my base URL. Now, so here, for embedding, so there is a function which is already available. So I'm just using a same function which is available on Euron platform. I have used it even before in my previous lecture. So these are just a boilerplate code, you can say. Yeah, just a boilerplate code. Here you can try to change your model ID, and you will end up using a different model ID. Very simple once again. And this is again a boilerplate code. You can try to control your temperature. You can try to control a maximum token in terms of an output of your particular hit. Now, so tool wise, right? So tool wise, so I have created a multiple function. So separate function. So one is a calculator tool, so which is going to do some sort of a calculation. One is a summarization tool, so which is going to take some sort of a text as an input, and then it is going to do a summarization. We have attached a Wikipedia tool, so it may decide that, okay, fine, so let's go and search over a Wikipedia. And here, so I have attached a RAG tool, so where I'm trying to use a retrieval QA, and I'm trying to give an access of a URI LLM to this RAG tool, so that it will be able to perform all this retrieval augmented generation operation based on the document which I am providing. So this founder story I am providing, but it will decide automatically. You don't have to do anything. So these are the four separate function I have created. Yeah, separate function I have created. Now, this is again a wrapper class. I'm just loading a document over here, and everything I have discussed in my step-by-step manner in my previous lecture. So please try to follow a previous lecture. This is again a wrapper class. Now, so till this point, so we are just trying to do the old stuff, the wrapping, right? So everywhere, whenever you are trying to create it, so you will end up using the same thing. Main work, we are going to start from here. So as per the diagram, I can create as many tools as possible as per this particular diagram. So this is something which I'm trying to do. So I'm trying to create a list of the tool, and here, so I'm trying to call my function, right? So calculator tool, so I'm trying to give a name as a calculator as a tool, summarization function which I have created, Wikipedia tool or RAG tool, and everywhere, so I have given a precise description then when to use which tool, which is going to help my agent to decide which tool I'm supposed to use at what point of a time, because it has to make a decision, right? It has to make a decision that, okay, so I have a multiple tool access, that's completely fine. I have a calculator tool access, I have a summarization tool access, I have a Wikipedia tool access, plus I am giving a document access as well. So for example, let's talk about the RAG function that I have created. So here, because this entire agent routing or this tool routing depends upon the description that you have given. If you are not giving a description in a proper way, so LLM will try to answer from its own knowledge base. And if you are trying to ask something which is not a part of its knowledge base, in that case, it is not going to give you the proper result or the proper response. Now here, so if I'll talk about a RAG tool, so I have clearly mentioned that only use this tool for question about the Sudhanshu, Euron or founder story. This tool searches the local founder story.txt document for an answer. For all the other topic, use other tool or your own knowledge. This is the very, very clear description I have mentioned over there, that whenever someone is going to ask a question about me, only in that situation, only in that particular case, try to use my RAG. Apart from that, so try to use some other tool. So these are the tool access. And what is tool? So I have already explained you, right? It's just a function. So you can try to create hundreds of function and you can connect with any of the system that you have. And then you can try to give a clear description, because depends upon the description, your agent is going to behave. So fine, this tool is completely fine. Even in my previous lecture, so I have already created a multiple tools. Now coming to the next part. So here I have created my own custom class. Now what this custom class is going to do, so this custom class is going to help me out to create any number of a agent. Means I can try to create an object of this class, so a special agent. So I'm going to create an object or variable of this particular class, and then I can try to eventually create an agent which will be having all of these capacities. So I just have to pass a name and I just have to pass the system prompt. Simple as that, right? So name, and every agent will be having its conversation buffer memory. This is what I have attached. Every agent will be having a URI LLM access, every agent, right? And every agent will be having a tool access as well. So here I'm trying to initialize the agent. So every agent will be having a tool access. Every agent will be having a URI LLM access. All the models, means whatever model ID that you are going to use, every model or every agent, right? So every agent will be having this reasoning plus acting access. Simple. So agent type is going to be a conversational React description agent, which is nothing but a reasoning plus a acting React. This is what it's called, right? So every like agent will be having this particular access. Now, so this is a agent class. Now with the help of this agent class, by calling this agent class, I will end up creating anything, and then it is having all the tool access, as simple as that. So I'm trying to provide this entire tools to this particular agent that you are going to create with the help of this class. Now, the next class which I have created, right? The next class which I have created is a routing agent. So let's suppose I have created a multiple agents, right? I have created basically a multiple agents. Now, so whenever I'm going to ask a question, so it should use a agent number 1, means worker number 1, or it should use a worker number 2, or maybe like a 10 worker I have created. So which worker it is supposed to use? This is what I'm trying to do with the help of this particular class, routing an agent, and it will be having a URI LLM access. It will be having all the agent access, whatever agent you are going to create, and based on your system prompt, so it is going to decide that, okay, so I should use this tool or that tool. For example, I have clearly written over there that you are a routing agent. So given a user query, decide which agent should handle a particular situation. For example, so let's suppose if I'm going to create a researcher agent and a teacher agent. So researcher agent, so whenever for a factual research or data question, so just try to use a researcher agent. Now teacher agent, you can try to use it for explanation, learning, or for a teaching purpose. So whenever I'm going to ask a question that explain me this, explain me that, it should go ahead with the teacher agent. And whenever I'm going to ask something based on the data, so it should go ahead and use a researcher agent, as simple as that. So this is where it will decide that which agent it is supposed to route, agent number 1 or maybe agent number 2. Very simple. Once again, the entire world of agentic AI is simple, by the way. It's not at all a difficult one, by the way. So, okay, now here, so I'm just trying to like mention that if agent name not in this agent, so just try to go ahead with the teacher agent, simple, right? And then I have given the chat. Okay, now, so agent wise, I'm just trying to create an object of my specialized agent class. as you can see. Yeah, so I'm just trying to create a object of the specialized agent class. I'm trying to give a name to an agent. You can give your own name, that's completely fine. Even over here you can try to give to your own name, and system prompt is very much important. So as per your system prompt, it is going to give you a response. So here multiple agent I have created, and all of these agent I'm trying to pass inside my router. Simple, all of these agent, so that it will decide. So I'm just going ahead with this diagram which I have drawn. So router, now router will decide agent number 1, agent number 2. Now agent will decide tool number 1, tool number 2, or tool number 3 I'm supposed to use, and everyone is having an access of the LLMs. Simple, right? Okay. So whenever I will try to start the chat, right? Whenever I'll try to start the chat, so it is okay. So let me. Okay. So here I will try to start the chat. So I will try to give a user input over here, right? And then the entire thing is going to go through a router, because router is calling my agents. My agents is having an access of all the tool just in this way, just as per the diagram. It is going to move and it is going to give you the final response. Okay, so let's start talking about this. Let's start testing this particular things. So here, just to execute it, I'm going to execute a Python main.py file, and I'll just try to chat with this one, right? And let's see so whether it is able to give me an answer or not. So here I'm going to ask a question that tell me about Sudhanshu Kumar. Let's see so whether it is going to answer from a Wikipedia or whether it is going to answer from a RAG. So here it is trying to decide. So it is having a thoughts over here that do I need to use a tool? So answer is yes, right? It is thinking by itself. So action wise, so it is trying to call a document Q&A. Now what is there inside this document Q&A? Let me talk about that first. Yeah, so let me talk about that. Now here, right? So here, if you will go and check this document QA, so it is going to come into a picture. Our system will try to invoke this particular one when you are going to ask a question about me, right? Or maybe Euron. So it is going to give an answer from a founder story.txt, as simple as that. So it is going to technically call this function. Yeah, it is trying to call this particular function, as simple as that. So this is what it is trying to do. And as you can see, tell me about Sudhanshu Kumar. So it is trying to give you the entire answer, right? It is going to give you the entire answer from a document which I have uploaded over here. So it is trying to perform the RAG Q&A operation, and then out of that, it is going to give me the answer. Now, so let me talk about, tell me more about him, right? See, I'm not taking a name, right? I'm not taking a name, but here, so do I need to use a tool? No. Could you please specify who are you referring to when you say him? That way I can provide you with most accurate answer. So it is trying to route to my teacher, right? So more about Sudhanshu, if I'm going to ask. So it is trying to call again document Q&A, right? And yeah, it is trying to process the thoughts, and then eventually it is trying to give me the answer back to back, as we can see. And all of these answers are coming from, right? All of these answers are coming from my document. Technically, it is trying to, or it is able to perform the RAG operation. And out of this RAG operation, it is giving me all the answer. Okay, now, so again, I'm going to ask a question that tell me about Elon Musk. So let's see. So which tool it is going to, do I need to use a tool? So it is saying no, and based on the LM understanding or LM access itself, it is trying to give me the answer. Now tell me about Sudhanshu, P-A-N-D-E-Y, Pandey, not Kumar. Yeah, so it's not me, by the way. So let's see. So which tool it is going to invoke? Sudhanshu Pandey. So it looks like it got confused. I don't have information on Sudhanshu Pandey in a current context. Okay, so do one thing. Tell me about Sudhanshu Pandey from Wikipedia. So now let's see. So now it is trying to call my Wikipedia tool. So my agent is going to call, and now it is trying to invoke what? It is trying to invoke a researcher agent, right? So it is trying to invoke basically a researcher agent. Now, so here I'm going to ask a question that give me an explanation. Give me an explanation for I in a range of basically 60. Let's see. So which agent it is going to call? So most probably a teacher agent it should call, by the way. So as you can see, it is automatically routing to a teacher agent. So sometime it is routing to a researcher agent, sometime it is routing to a teacher agent, and everything is happening automatically, right? Everything is happening automatically. So this is how this entire multi-agent system with a self-routing, and every agent have a access of a multiple tools. So system itself can decide which one to use when. We can try to make it better and better. Obviously, there is a lot of like a scope you will be able to find it over here. But I believe this is one of the best example you can see with respect to a RAG, with respect to a multiple agents, with respect to a multiple tools. Integration of LLMs, by the way, doing an embedding, because we are trying to use our document, we are trying to use our Facebook AI similarity search for doing embeddings, storing data into a vector space. So all of this example you will be able to find out all together, and most of the code which I have shared with you. So let me call exit over here. So most of the things or code that we have written over here, it's a boilerplate code, right? For example, this URI embedding is not going to change. URI chat is not going to change. Tools, yes, obviously it is going to change all the time. Now, so like here embeddings are not going to change. Simple, right? Embeddings are not going to change. So here you are trying to retrieve a document. So obviously you can try to change a document. You can try to create a different kind of a chunks. Here I'm trying to use a Facebook AI similarity search. You can try to use maybe some other vector databases, maybe a ChromaDB, maybe a Quadrant, maybe a Pinecone, whatever you want. And this part is not going to change, which is helping me out in terms of accessing the URI LLM. This is just a custom wrapper for a LangChain that we have created. Now, rest of the things is configurable, right? You can try to create as many tools as possible. You can try to, create as many agents. So again, this is not going to change. If you would like to add more capabilities to an agent, you can just add it here itself, right? You can just add it here itself. You don't have to like worry much about it at all, right? You don't have to worry much about it. Now, so router, so again, this is not going to change. Yeah. So if you would like to like give some sort of a different kind of a system prompt, you can try to go ahead with this one once again, right? Once again. So in this way, you can try to create a multiple agent. You can try to create a multiple tools. You can try to give an access, and then you can just call a router, bingo, and work done, right? So hope all of you are able to understand this entire example, guys, and hope all of you are going to implement it, trial it, and test it. And don't forget to change your own URI API key, because that key will be deactivated after this class. So try to use your own URI API key. It's already available, and it's the most affordable ecosystem you will be able to find out in this entire world. With that, thank you so much, everyone. Take care, and see you again in my next lecture. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about LCEL, LangChain Expression Language. It's a very simple way to invoke multiple things at a time, and you will be able to create a chain in a easiest possible manner. So let me show you with the help of example. So here, guys, what we have to do is that I'm going to enter any kind of a sentence, right? And system is supposed to give me a review. So maybe a positive, maybe a negative, maybe a neutral, whatever it is. So it should be able to give it to me. I can try to, create a lot of things on top of this, but in a simplest possible manner, I tried to do the exact same thing. So here I'm trying to use a LangChain expression language, and it is going to allow me to configure multiple processes all together just with the help of this pipe, only with the help of this pipe. For example, if I'm talking about this one, so here you will be able to find out that I'm going to enter a review. Fine. So maybe I'm going to enter Euron is best, something like that. So what it will do, so it will try to call a sentiment chain dot invoke, and it is going to pass the review. It is going to pass the review over here. Now, what this sentiment chain is doing, by the way, what this sentiment chain is going to do. So it is trying to take an input of prompt,
after taking an input of prompt in a sequence again, yeah, in a sequence. So after taking an input of the prompt, it is calling a LLMs. Now after LLM will be called, it is going to return me some sort of output. Now I'm trying to use a parser so that I will be able to get a formatted output, because LLMs are going to provide you an output in a form of JSON, right? And I'm not looking for that data. I'm just looking for a plain string, positive, negative, or maybe a neutral or something like that. So this is basically a LCEL chain, LangChain expression language, where I'm just trying to use this pipe, right? This pipe and this pipe, and based on that, I'm able to configure this entire process. And it's very easy and very intuitive and beautiful manner. You will be able, in a very simplest way, right? You will be able to call it. Now here, so when I'm trying to call this one, so review will go to a prompt. So it is, first of all, it is trying to invoke a prompt, right? Invoke a prompt, and then it is trying to pass my data. So whatever text which I'm going to provide as a review, it is trying to pass. And inside this prompt template, I have written clearly that classify the sentiment of this review. Now, whatever you want, you can try to write it down. It will act accordingly, right? So classify the sentiment of this review as a positive, negative, or neutral, and this review will be passed over here, right? I'm storing it into a text. So first prompt will be taken, and it is going to create this one. It is going to create this entire prompt with my text, with my input, and then it is going to call my LLM. So I'm trying to use a URI LLM. You can try to use any LLMs out there, and LangChain provides many like an inbuilt configuration as well for other LLMs, but here, so I'm using a URI LLM. So what I have done, I have created my own custom class for a URI LLM just to make it compatible, with the LangChain, because I'm not using some of the inbuilt or like a pre-supported LLMs over here by a LangChain. I'm using my own custom one, right? Although it's a like a GPT or Mistral or Llama I can try to use, but yeah, I'm trying to use my own custom API, my own custom LLMs, as simple as that. So here I have just created a wrapper class, which I'm using in every classes of a LangChain, by the way. So this is just a template, and this template is going to call this one, as simple as that, right? And here you have to change just your URI API key. So just your URI API key, and from where you will be able to get your URI API key, come to a Euron, come to a URI API. So let me show you the process once again. So come to Euron, come to this place, URI API, click over here. Now go to an API key. You can even track the uses. So how many tokens you have used today, and you can try to click on API key, create API key, give a name of the API key, whatever you want, and then click on create. So within no time, it is going to create your API key, and you will be able to use this API key with all the 12 model, including embedding models as well. Single API key for everything. Yeah. So here you have to change your API key. Otherwise, it is not going to work. And like I'm just trying to do this one. The above part is just a boilerplate code. Yeah. So you don't have to worry anything about that one. So wherever you are going to use URI AI, so everywhere you have to invoke LLMs, and just use above class, and you will be able to invoke the LLMs. I'm just trying to make it compatible. Yeah. Just trying to make it compatible. So here it will be able to take a prompt. It is going to pass that prompt to a LLMs, and then once LLM is going to give a response in a JSON format. Yeah, JSON format. So I'm trying to use a parser over here. So parser is nothing but I'm trying to use a string output parser, so which is going to, give me a result in a proper way, the way I am looking for. For example, not in a JSON format, but as a positive or a negative. So here, this is the only thing, and this is called as LangChain expression language, where I'm using a pipe and I'm going to configure a multiple processes one after another. So it is going to run as a pipe over here, right? As a pipe over here. So now let me execute this one and let me show you the final result. So here, if I'm going to execute this one, Python URI LCLE sentiment analysis, and here if I'm going to pass my data that India is a great country, right? So now let's see, positive, right? I am not feeling good. So see, anyhow, what happened? Okay, so I have to execute it, right? Okay, so I am not feeling good. I can run it inside the while loop so that it will keep on asking me the question, but yeah, I have not done that. So negative. So here, as we can see, that it is able to give me a negative and positive, but that is not a big deal at all. That is not a big deal at all. So what I'm trying to explain you is that how you can try to create your own LangChain expression language, how you can try to configure one process after the another processes in a simplest possible manner. This is what I'm trying to teach you in this particular lecture. So hope you all have liked it. Hope all of you are going to use it. And with that, thank you so much, everyone. Take care and see you again in my next lecture. Okay, so welcome to Euron, everyone. Now in this lecture, I'll be talking about agent creation. So obviously agent you can try to create with the help of multiple framework, not just one. And there are so many beautiful framework which is available in a market. You can try to use any of these framework. That's completely fine. But in this lecture, I'll be talking about agent creation with the help of LangGraph. So how you can try to leverage a LangGraph framework. So there is a LangChain, there is a LangGraph, there is a Llama Index. There is a Crew AI, N8N, and then we have Microsoft AutoGen. So likewise, we have so many different kind of a platform, and all of these platforms are going to help you out in terms of creating a smart system. Down the line or under the hood, you can say that which is going to leverage power of LLMs, whatever LLMs which is available in a market. So in today's lecture, this is something which I am going to discuss with you, and practically we are going to create an agent. And the amazing thing is that I'm not going to use a OpenAI API. I'm going to use a URI API, and I'm going to use a URI LangGraph wrapper for, or you can say a URI LangGraph SDK for the same purpose. So let me share my screen quickly, and let's get started, and let's try to understand that what we are going to do in a very first place. So guys, like I said that I'm going to show you that how you can try to create a agent. But to create any agent in this entire world without having an access of LLMs, you will not be able to create any kind of an agent, because agent always needs a tool. It needs a function, right? And so that it will be able to make a smart decision. And when we talk about these tools, so sometime, yes, we can try to write a rule-based tools, which I'm going to show you in this lecture. But most of the times you will find out that it requires an access of LLM, so large language model, for a different purposes, so that it can go out, it can do a research, it can try to do a real-time search, it can generate something, it can do the embeddings, many things, right? Many things which rounds or which revolves around it basically. So without an access of LLMs, you will not be able to build any kind of agentic system. Doesn't matter which framework you are going to use. Now this is where obviously URI API comes into a picture. And here, so for all the AI frameworks, so we have given you all the implementation. Now let's talk about a LangGraph. So here, even for a LangGraph, we have given you an implementation. So where you just have to copy and paste your API key, and then you are done. Even for an API key creation, so if I'm going to talk about an API key creation, so API key creation is very simple. So click over here, API key, create a API key, and then maybe you can try to give a name, and you will end up creating the API key. And with the help of this, you will be able to access not just one or two, but a 25 model, right? 25 model, and 25 model from all the categories. So just name any kind of any popular provider, and we have a model for that, right? We have a model inside this particular ecosystem, and this is something that we all are going to use it, even inside a class and even inside this particular lecture. Plus, you will be able to track all your consumption on a daily basis. You will be able to check a model status. You will be able to even check a logs. So it's a complete international grade platform that we have created. So where you will be able to do each and everything. Yeah, you will be able to do each and everything. And then you will be able to track all the records as well. So everything is like coming with a pure transparency, by the way. And per day, we are giving you a 1 lakh token limit. So with 1 year of access, obviously you are going to get a 365 lakh of token. And with that token, you can try to use a image-based model. You can try to use a speech-based model. You can try to use an embedding-based model. You can try to use a streaming model. You can try to use a chat completion model, whatever you want, up to you, whatever you are building, just go ahead and try to use it. Okay. So now coming back to a LangGraph, like I said, that without having an access of, right? So without having an access of these models, which I'm talking about, you will not be able to do any kind of a agentic AI operation, and you will end up revolving around a different platform. So maybe sometime you will end up paying for that. Maybe sometime you will end up like, using it just for free.
up to you, right? Up to you, up to your consumption. But yeah, so everything is available in one single platform, and that platform is called as Euron. Inside that, we have a product called as URI API. Okay, now, so let's move ahead and let's try to talk about agent by the way. Yeah, so let's try to talk about the agent by the way, because we are going to create an agent inside a LangChain. Now, so many people feel confused with respect to an agent. So when I talk about agent, and when I say when people like discuss about the agent, they literally feel confused, and I have felt these things so many times. But believe me, guys, it's not that difficult to understand. In a layman way, if I have to explain you that what is agent, I will say that a kind of a smart worker or a kind of a smart employee, you can say, right, who will be able to take a decision automatically. Obviously, this is what employee does, right? This is what employee does. For example, right? For example, so let's suppose if I have called one of my colleague, one of my employee, and I have asked that okay, so try to build a maybe LMS system for me, a learning management system for me, right? Now, so that employee will go automatically. They will that employee will try to do a research. They will try to identify that which database I am supposed to use, how we are going to maintain a content delivery, basically how we are going to upload the video, which service I am going to use for that, how we are going to maintain the messaging, what kind of a messaging. So all of these things around a LMS, that person will start deciding automatically. This is what your lead must be doing it. This is what your manager or someone must be doing it, right, for a specific task. So basically that person is an intelligent one, and that person is trying to understand the problem first of all, and after understanding the problem, so basically it is trying to find out the solution, and whatever access, right, whatever access, basically whatever privilege that particular person have, so based on that, that person is trying to basically solve the problem. So here in a core, if I'm going to ask someone to design the LMS, so design a LMS, so obviously I need a databases, I need to create maybe a infra over here, right? So I have to think about a CDN, I have to basically think about a video upload. So one task, so I'm just talking about the very high level task over here, by the way. I can give you another 10,000 example for the for the same kind of interpretation, but yeah. So here if I'm asking someone that okay fine, try to create a LMS, so obviously there are so many things which is required to create a LMS, a learning management system, which you are able to see here and everywhere, right? It requires a lot of things basically. So there must be a lead who is going to take a decision automatically that okay fine, and it is going to assign even the task that okay fine, so someone is going to do this, someone is going to do this, someone is going to do this, someone is going to do this. So agent on a very high level is that employee or that lead or that manager, by the way, so who try to break down the problem, who try to understand the things, and automatically that particular agent is going to call resources, right? Resources in terms of a tools, we say function or tools, right? So tools, it is going to call automatically, it is going to call LLMs automatically, right? Depends upon the task. So that is something called as agent. So agent is nothing but a modern way of doing an smart automation. So I would say a modern way of doing a smart automation. So even it's not like we have started talking about this kind of agent nowadays. So yeah, agents are very recent, obviously, in terms of this term called as agent. But we have been doing automation, I believe, since a decade. Now we are just trying to add the capability. We are just trying to add more intelligence towards it. Previously, it was a rule-based or maybe algorithm-based, maybe ML or DL algorithm-based. But now we are trying to make it more intelligent because we have a powerful LLM systems now, right, in a place. So this is where agents comes into a picture. Now, if I'll talk about a Lang graph, right? So if I'll talk about a Lang graph specifically, so let's go ahead and let's try to talk about it. So Lang graph basically is a part of a LangChain ecosystem. So here, as you can see, so there is a framework called as Lang graph. Now Lang graph gives you a flexibility. LangGraph gives you basically a power by which you will be able to build a agent. You will be able to basically give a power. You can try to give an access to a different kind of tools and LLMs, basically functions and the LLMs. And when we talk about a Lang graph, so basically it try to treat each and everything as a graph. Graph means what? So I believe in a childhood, we all have gone through a graph. And I say childhood, maybe during engineering or like your graduation. So as we know that inside a graph, there will be a node, right? So there will be a node and these nodes will be connected. These nodes will be connected to each other in a certain order to perform the certain task. So maybe a node 1, maybe a node 2, maybe a node 3, maybe a node 4, and we can even try to give a direction that okay fine, so first start from here, then go here, then go here, then go here, and technically what this node is doing, some task, right? So maybe this is going to retrieve the data, this is going to basically find out some sort of a research, this is going to do some sort of like a things on over the internet, this is going to do the summarization, and finally you will be able to get some sort of a output, right? Output. So never get overwhelmed by this term called as graph. It's a very simple thing, by the way, right? It's a very simple thing. And here these nodes, and this line which is connecting these nodes, this line is basically called as EDGE edge, right? So we can try to define that what this unit will do. This unit could be a function, very simple, right? So just as a pictorial representation, I'm trying to represent this part, but yeah. So this could be a agent, this could be a tool, this could be a function. Very simple, right? And so it is going to execute something, right? And then it is going to give a control to the next one. So basically it is going to maintain the states, and everyone will be having an idea that what has happened before. So it is going to maintain the states, right? In a stateful manner, it is going to do this task. So with the edge, so let's suppose if I have directed in this way that okay fine, so after doing this, do this, means whatever function that I have written, whatever agent which I have deployed over here, try to execute that, then come over here, then come over here, and then finally give me the output. Now that's a whole idea. So those who thinks that LangGraph or all these kind of agents are a difficult system, I don't see a reason for that, basically. So once you will go with this one, this kind of approach, I don't think that you will not be able to understand. I believe all of you will be able to understand in the easiest possible manner. It's a very easy thing, basically, by the way. Yeah. So LangGraph, right? So this LangGraph is using a graph approach, and inside this graph approach, so obviously we will be having a node, we'll be having a edges. And in this way, the entire process will be connected one by one, one by one, one by one. It will try to execute itself. And finally, it is going to give me the data. Simple. Yeah. Finally, it is going to give me the data at the end of the day. And fundamentally, this is what LangGraph is going to perform. Fundamentally, this is what LangGraph is going to do. Okay. Now that's cool. Now, so I'll not take much of your time in terms of like explaining your theory. So it's better to write one of the agent or maybe a multiple agents, and then try to understand the same thing. Yeah. So then try to understand the same thing. So to do that, maybe we can try to open up a VS Code, and we can try to create a file folder over here, and we can try to say that LangGraph practical. Okay. So this is the folder I have created. Now let's set up the environment. So let's set up the fresh environment where I'm going to install a URI AI, and I'm going to install a LangGraph and all the dependencies. So here, if I have to set the fresh environment, so how I can do it? I think I have already taught you hundreds of times. So conda create create -n, and give the environment name. So lang_graph graph Python is equals to 3.10. Okay, fine. So it is going to like commence an environment for me. Yes, do all the installation. Okay, so this lang_graph environment is ready. I am using 3.10. 3.10 is the safest version of the Python to use with all the framework out there. Otherwise, it will give you some issues. So it's better to use 3.10, by the way. My recommendation, as simple as that. So I'm able to activate the environment. So conda activate my environment, and yes, I can see this environment has been activated. Now, once this environment has been activated, so just try to install a URI. So pip install URI AI. Yeah, URI AI. SDK is already available. So if you will go and check, let me show you that part as well. So if you will go and check, so SDK is already available, and SDK is available basically for So if you are going to click over here, so view on PyPy, so 1.0.26 package, and we are continuously updating it. We are continuously updating it, right? So if you would like to install just a LangGraph, you can call this one, you can call Llama Index, you can call Small Agent, you can call LangChain, you can call URI, Crew AI, you can call AutoGen. So everything is available. If you're installing just this one, all will be installed automatically. Otherwise, you can try to install independently. That is also possible. Plus, we have given you a code sample. Everything is given to you, by the way. Yeah, everything is given to you. So in a proper standard way, so we are trying to maintain each and everything so that you should not face any kind of a issue. And we have clearly mentioned that it should work for like version 3.6, more than 3.6. And yeah, so it is going to work for all of these framework, by the way. Now, so if you have to install, simple, pip install URI AI. Yeah, pip install URI AI. So let me go and install it, pip install URI AI. It's a very easy peasy kind of a things. And it is going to install the URI AI so that you all will be able to use it. Okay, all these things are done. Now clean it. Now, so as we are doing a LangGraph, so pip install LangGraph, LangGraph. So install a URI AI, install LangGraph, because LangGraph is a framework that we are going to use. Now CLS pip show URI AI. So 1.0.26, fine. That's cool. And author is tech@Euron.1. So we are basically the author for that one. And pip show LangGraph. So this is my LangGraph version, by the way, 0.5.4. So this is the LangGraph version that we are using. So both of these things are available over here. That looks cool. Now let's try to create one file, Jupyter Notebook file, LangGraph practical.ipynb. Okay. And here, so first of all, I'm going to select my environment. So LangGraph, lang_graph is the environment which I have created. So fine, selected this kernel. And then over here, so you have to do the import, right? You have to do the import, and you have to use basically a URI AI. So in a very first place, what you can do, guys, that you can try to, execute some of the sample like that we have given to you. So maybe you can try to come over here, click on AI framework. As you can see, AI framework, we have already given you a lot of code over here. So even for a LangGraph, basic setup we have given to you. So I'll try to explain you that part. Multi-model support, async operation, workflow pattern, error handling, users tracking, advanced feature. So we have given you even a lot of examples, right? Lot of examples, but just to test it. So just go over here, click on basic setup, copy this one, and then try to execute this. Yeah, try to execute this. But before that, you have to keep your API key over here. How you will be able to get the API key? I believe I already taught you that part. So how to get an API key? So API key wise, click over here, and then, so if it is the old one, maybe I can delete. Not required, but yeah, it's better to delete the old API key so that no one will burn out your token. And create API key. I can create as many API key as I want. So I can give a name, and this is a new API key which has been created. Now I can just copy this API key and just replace it over here. Very simple, nothing. Yeah. Now default model is GPT 4.1.nano. This is the default model which we are using. But let's suppose if you are trying to do a web search, if you're trying to generate the images or some other processes, right? You can change the model ID. So this is the default model ID. Now from where you will be able to get a model ID? Let me show you that part as well. Very simple again. So here available models, and here, so you will be able to see a model ID. Yeah, you will be able to see a model ID. Now, even in the introduction section, so let me go ahead with the introduction section, by the way, URI API. Now here, so if I'm going to click on OpenAI, so from OpenAI, there are 3 models which is available. So this is the model ID. Everywhere we have mentioned the model ID. Yeah. From Google, so there are like 8 model which is available. So everywhere you will be able to find out the model ID. If you are going ahead with the detail, you will be able to find out details as well in the available model section. So it will give you like a complete detail about it, basically. Yeah. So hope you will enjoy this one. And obviously, like this is how this was the purpose behind creating this one. So I can try to change a different model. That's completely fine. So this is required. See, whenever I'm trying to talk about the LangGraph, right? So obviously, without giving a LLM access, it will not be able to do a work. LangGraph, LangChain, all of these framework requires a LLM access by default. So we have made this URI LangGraph package so that you don't have to struggle at all. Just call a URI LangGraph, right, from a URI AI LangGraph package. So just try to call a URI LangGraph, pass a API key, give a model, and then your graph object will be ready. Now, once this graph object will be ready, because that is the entry point for a LangGraph. Similarly for a LangChain, right, and other framework. So this is the entry point, guys. Once this graph is ready, right, once this graph is ready, then you can try to create any number of a node. You can try to set an entry point, whatever you want. You can do it with a ease, by the way. Yeah, you can do it with the ease. So here, what I'm trying to do, so I'm trying to create a graph with a single node, right, with a single node. So see here, this is basically a LangGraph URI object. This is the entry point. This is what? Entry point. Entry point. Entry point. Simple, right? This is basically a entry point. Now, so this object is required. Without this object, you will not be able to do anything. And that's the reason. So URI is required. URI LangGraph is required. If you're going ahead with the OpenAI, in that case, obviously OpenAI instance is required. If you're going ahead with some other LLM provider, that will be required. But in case of Euron, so this is required, by the way. Now, once this graph object is done, I'm creating a node, right? I'm creating a node. How I'm creating the node? So I'm trying to call graph.addAI node. So this is the function which is already available inside the LangGraph, right? LangGraph framework. So add AI node. So I'm saying that okay, I'm trying to add a AI node. I can try to add a node which will just execute a function, right? I'm saying that, okay, I'm trying to add a AI node. Means this node will be having a LLM access. This is what it means. Very simple, right? This is what it means. And I'm going to name it as a processor. So process and enhance this text. So whatever input it will get, whatever input this node will get. So with the help of LLM, right? And from where it is getting the LLM? So we have already provided at the time of creation of this graph object itself. So it will try to process it. It will try to basically execute this part. Which part? So process and enhance this text, whatever text you are going to give as an input. Yeah. Now, so this is just a node. This is how we are creating what? This is how we are creating basically a node. I'm doing a lot of rough over here. I believe, hope you all will be able to manage. So this is how I'm creating a node. So this will create the node. Now, so for this, I just have only one node, single agent you can say as of now, right? This is what agent is, which can take an intelligent decision. Now here, so graph.set entry point. So again, for this graph object that I have created, set entry point. So when system will start executing, so what should be the entry point? So this node, the processor node, I have already given the name. If you would like to change this name, if you would like to give this name as a Sudhanshu, you can give a Sudhanshu. If you would like to give your own name, give your own name. So every node you can try to name it, right? Just like you name a human being, by the way. So set entry point processor. So, okay, set entry point processor means this node itself will be the entry point, and set finish point again. So this is only going to be the finish point. So entry point is also this one, finish point is also this one. Technically, it means one single node, right? One single node. Okay. So we are trying to set it. So first of all, we have created the instance. Then we are trying to set the entry point and exit point or finish point. And then we are calling a graph object that, okay, fine, run it, right? Run it. So obviously while running, I have to give an input. I have to give the input. So I'm giving input is equal to hello world, whatever result it will give. I'll try to show you that particular result. So what is the result we are expecting? So whatever input which I am giving inside this node, what is the responsibility of this node? So process and enhance this text. So if I'm giving hello world, it will try to process it, enhance it. That is something that it is going to perform. Very simple operation, and one single agent node we have created. This is the only node that we have created, the highlighted one. Yeah. And this is the object. This is required. If you are using URI AI, then in case of that, URI is required. Otherwise, you can try to go ahead with some other provider. So execute now. Okay, so it is asking me for Jupyter installation. Just do it every time whenever I create a new environment. It's mandatory. It will not take more than 30 seconds of time. So this is a single agent that we are trying to create. Single agent means one single node that we are trying to create, an intelligent system. So which will try to take an input and then eventually it will try to give you some sort of a output, right? Okay. So my input was basically hello world, and what this agent is supposed to do. So basically this agent is supposed to process and enhance this text. Let's see the output, by the way. So input was hello world, right? Workflow completed in 1.46 second. Process output is certainly here is a enhanced and more polished version of the hello world. Hello, would you like to style a different or integrated into the specific context? Process raw response, certainly here is an enhanced polished version of this one, hello world. Would you like to style a specific this one or integrated in this one? So basically this is like a graph compiled successfully, value updated, value hello world, certainly here is this one. So this is kind of an output which I am receiving from this. Now let me change this input, right? Let me change this input. So maybe tell me about data science process, and here, so I'm trying to give a, let me give a prompt. Process, give me a details about input. Fine. So whatever input I'm going to give, it will try to give me the detail about it, right? This is what the node is. And obviously it's a smart, intelligent one because it is a AI node. AI node means it is trying to take access of these models, and based on that, it will try to give me, tell me about data science. I have given process output. Certainly here is the overview of the data science. So data science is the field that combines a technique from the statistics, mathematics, computer science, and domain expertise. All these details it is able to give it to me, right? Data cleaning, processing. So yeah, it is working like properly, I believe, right? It is working well for me. So I have an intelligent node. I am just trying to give the input. Now, as of now, I'm trying to give an input from this one this way. Maybe I can try to create a UI, and with the help of UI, I can try to give the input, and then it is going to give me the output. And eventually that will become a chat system, right? Eventually that will become the chat system. So I'm going to give the input, I'm going to ask something, and then it is going to respond with something based on the node. So here I'm able to create one intelligent agent, simple one intelligent agent, and which is going to give me a final output as per my need, as per my specification, which I'm going to give it to me. And this is how simple it is. And again, with the URI, right? With the URI, it's very, very simple, very, very amazing. It's no hustle kind of a things that you will be able to find out. Okay, so that looks cool. Now let me show you something. So you can try to call graph dot get graph structure. Yeah, graph structure. So this is going to give you the graph structure. So what is the node? The node name was only one node, right? Only one node was there. Only one node was there. And what is the name of this node? Processor. I have just given that. Maybe I can try to give Sudhanshu as a name of the node. How many AI node we have? Processor. How many edges we have? Nothing. There was only one node, right? Conditional edges? Nothing I have. Entry point was this processor itself. A finish point was processor itself. So you will be able to see even a complete graph structure. You will be able to see the complete graph structure as well. So when I'm going to create a multiple node, even at that point of a time, you will be able to do the exact same thing. Yeah, you will be able to do the exact same thing. Give me a user's status. So total run 1, total node execution 0, average execution duration, API call, successful run, AI node processor, total call, total token, error. It's not giving me the total token. I can try to track my token even from here. So uses and see, I can track my token. I can track my token from here. So total 9 requests I have done today, 5% utilization for today, right? So this is the total number of the token which I have basically like used over here, right? Whether it's an input token, output token. This is the model which I have used. So yeah, I'm able to see everything, right? I'm able to see everything. And if I have received any error, so far no error, by the way. Even I can go and check my logs. So I can try to check. Hopefully this is mine. Yeah. So this is my log, right? So this is my log. Simple. So I can go ahead and I can try to check my log. So everything is available in a neat and clean way, which you will be able to track. And if you have any kind of a suggestion, so please try to put up your suggestion. We'll try to enhance this entire system. But yeah, this is what we are doing. Now, so single agent system, we are able to create it. Now, so how we can try to create a multi-agent system? Yeah, how we can try to create a multi-agent system? Let's talk about that in my immediately next lecture. Yeah, so in an immediate next lecture, I'm going to talk about, but yeah, Before that, please try to look into the URI and then all the associated AI framework that we have given to you, so that it is going to give you a capability. It is going to give you the power to understand the things. So in our next lecture, immediate next lecture, so I'm going to talk about a multi-agent. So how I can try to create a multiple agent, how I can try to give a multiple like a nodes to a multiple tool access, everything I'll be talking about. So with that, thank you so much everyone. Take care. Hope all of you are enjoying your life and lecture. And with that, see you again in my next session. Okay everyone, so welcome to lecture once again. Now in my previous lecture, as we were able to create a single agent, and we now know that how we can try to use a URI API and its entire ecosystem to access the model or maybe to track the uses. So now it's time to create a multi-agent system. So multi-agent means multiple node. We are going to create a multiple smart node, I would say, which will be having a LLM access, and eventually all of these nodes will be able to take some sort of a decision. It is going to do some sort of a task automatically. That is something that we are going to discuss. So let me share my screen, and yeah, so let me create a new file, a lang graph underscore multi agent.ipynb. Fine. Okay. So let's get started, and I'm going to select the same kernel. So the kernel which I was using, so where my URI is installed and where my lang graph is also installed. Now here, so what we can do, so we can start doing a particular task. Now, what is the task that I will be doing? So first of all, guys, try to do some sort of an import from URI AI dot lang graph, import basically URI AI lang graph. So this is the first import that you have to do, and execute. So yes, we are able to import it. It simply means that I will be able to create a graph instances. And then let's try to create a graph instance. So to create a graph instance with the help of URI graph, so you have to give a API key. I believe we all know from where I can get the API key. Let me show you once again. So to get the API key, come over here and click on create API key, give a name, and then it will end up creating your API key. Simple, right? So very simple. We have done that hundreds of times. So just replace this API key with that one. Simple. If you have to change the model, so because we have a 25 plus model for a different purposes, you can change the model as well. So this is the entry point. This is the basically graph object that we are able to create for a lang graph. Yeah, for the lang graph with the help of URI lang graph SDK, or you can say a package. Now what is next and what we are trying to achieve over here? So basically, here, so I will try to create a multiple node. Let me show you that part. First of all, in a theory, that what we will try to perform as a part of this whole example, and that will be very quick, by the way. So we are going to create a 4 node. The very first node is, let's suppose, a researcher node. Researcher node. The second node that we are going to create is maybe a synthesizer node. I can try to give any name that I want. Synthesizer node. The third node that we are going to create is classifier node. And the fourth node that I'm going to create is a finalizer node. Finalizer node. F-I-N-A. Yeah. Finalizer node. So these are the node. Node number 1, node number 2, let's suppose, node number 3, and node number 4. So these are the 4 different kind of a node I'm going to create. This node will do some task, this node will do some task, this node will do some task, and this node will do some task. So every node is going to do some sort of a specific task automatically. Yeah. And then obviously there will be an edge by which we are going to connect each and every node. There will be a edge, let's suppose 1, edge 2, edge 3. As of now, I'm just trying to give a symbolic name. And there will be maybe input. So there will be an entry point, right? So entry point, and then maybe a output point, right? So everyone is going to do a task in a sequence, and everyone must be aware about the task that they are doing and the task which has been done by other node. So basically, it's a stateful transaction that we are talking about over here, right? A stateful transaction. Now, some of the node can be a AI node and some of the node can be a non-AI node. What is the meaning of AI node? AI node simply means that they are going to use a LLM directly, right? So here we are going to see even a AI node, and then non-AI node. Non-AI node means Non-AI node means. So maybe I'm going to write a certain function and they're going to call some sort of a functions, right? A static function or maybe some sort of a dynamic function. I'm going to call it eventually. So this is the kind of a graph that we are talking about. And with the help of this, we will try to solve a certain problem. For example, so if I'm going to give an input, right? So if I'm going to give an input saying that, okay, so just try to do one thing. If I'm going to ask a question, tell me about a generative AI or tell me about a Lang graph. So maybe it will go do a research. If there is an internal document, so from internal document, it will try to fetch some sort of a data, and then finally it will send to the synthesizer. It will try to send to the classifier that, okay, fine. So this entire question falls under this particular category, and then it is going to finalize the result and give it to me, right? Give it to me. So there can be a infinite number of different things which I can do and I can try to process. But I will be picking up a very simple one. I'll be picking up the very simple one. So here, the flow which I would like to create is that we are going to create a little bit of flavor of RAG as well. So let's suppose here I have a file called as RAG underscore context.txt. So this is the file which I'm trying to keep, and inside this file, let's suppose I'm keeping some information about the Lang graph. That Lang graph is an open source Python framework for stateful transaction, composable and observable LLM workflow. So there are some detail which I have mentioned over here, right? So you can build a multi-agent pipeline with the memory, retrieval tools, streaming output. URI AI integrates by powering each node with a real-time inferences using a model like GPT, basically GPT 4.1 nano. So this is the very small document which I'm trying to keep. Yeah, very small document I'm trying to keep. Now, so the flow which I'm trying to teach you over here, that whenever I'm going to ask a question, right? Whenever I'm going to ask a question, so first of all, it should go and it should basically check that, okay, so do we have some record which is available? Do we have some sort of a data internally which is available? I can add one txt file. Maybe I can try to add hundreds of PDF over here. That's completely fine. So first of all, it should go and check. For example, if I have to create a flow for this one, so whenever I'm going to ask a question, so means wherever there will be a input. Let's think in this way. Wherever there will be an input, so what it should do in a very first place, check internal docs. Maybe docs are available into a PDF format, maybe into a TXT format. And if there is a data which is available inside this particular document, right? So this particular document, in that case, what it should do, so it should try to consider that particular data, right? It should try to consider that particular data, and it should try to summarize those data, basically, right? It should summarize those data and then pass it on to the next node, that, okay, I have certain information which is available even internally. So that I'm not I'll not go and I'll just try to rely on a LLM. This is what I'm trying to say. Yeah, this is what I'm trying to say. So let me do that part first in terms of code. So here, first of all, what we will do, so we can try to write a function, external function, by the way. So maybe I can try to give a name as a def researcher node function. Yeah, function. Now what it will take, so it will take, let's suppose, a state as an input. So here state, and it is going to take input, let's suppose input input, state of input, and this I'm going to label it as a query. Yeah, this I'm label it as a query. Now, so here I'm going to give a file underscore path, and let's suppose file is rag content.txt. So this is basically a file for me. This is basically a file for me. Now, so what it will do, so it will try to, right? So it will try to go to a file and it will try to read a data. So here path. So I have to do an import to get a path variable, path function. So from path lib import path. Yeah.
So here what it will do, so it will try to like read a data. So I can try to read a data with open command as well. I can try to even use this one to read the data path, and inside that we can try to provide a file path, and I can say that load basically, or there is a function called as read_text read text. So this is going to read a data. The path should be P capital. Yeah. So I'm trying to say that, okay, fine. So try to read a data out of this one. So it will try to read a data, and I'm going to name it as a context, by the way. Yeah, I'm going to name it as a context. Now, so here, once we are able to read data, and I'm just trying to name it as a context, by the way. So let's try to return the output of this function. So what this function will try to return? So this function will try to return query is equals to query. So whatever input that anyone is going to give, and then this function is going to return technically a context. Yeah, context context. So these two things this function is going to return. Context is nothing but a data which is coming from the, and I can say that till 3000 is the limit, or 30,000 is a limit. So here this is going to return the query. So this is going to return the query, by the way. I'm just trying to pass a state. A state means because the entire graph is a stateful process, right? So it knows that, okay, fine. So what is happening where? So whatever state it is going to come, it will try to take input. So let's suppose if I'm trying to provide the input here, right? So at this state, I'm going to provide the input over here. It will try to take the input, and based on the and that will become a query, right? That will become a query, and it will go to my file as well, and it will try to read the data, and that I'm calling as a context. So query and context. So now if I'll talk about this mode, so this is going to give me a return of what? Query and context. Query is coming from user input, right? Or I can say user input, and context is coming from where? So file dump. I can just name it as a file dump. So whatever file that we have given, so from there we are getting the context. Now this is the state. This is one of the state that we can say. So this is a independent isolated function as of now. I have not attached this function to anywhere. So just execute it and leave it. So this is one of the independent function I have created. Yeah, independent function I have created. Now, so I have to basically add this function as a node inside a graph. So this is my graph object, right? So I can call it in this way, graph, the graph object that I have already created. So graph dot add, and here, so you will be able to see a multiple options. So add AI node, add condition node, conditional edge, conditional load, add a functional node. So I believe now you will be able to guess that what kind of a node I'm trying to add. So basically this is the node which will take a user input. It will try to like consider the user input, plus it will go and check the file. It will try to read the data from the file, and it will try to return just that much, right? So now if I have to add this as a node, so obviously it's a functional node. It's not an AI node. So functional node wise, I can try to give a name that, okay, extraction and query, extraction underscore and underscore query, just for the clarity. And this node is going to call what? So this node is going to call research node function, which is trying to extract the data, and it is trying to like take the query. That's it. Yeah. And I have just attached this function to this one. So this is how I'm using this function. Now one element is added inside the graph. So added a function node. Now if I'll go and check graph graph dot get graph structure, you will be able to find out that one node is been added. Yeah. One node is been added. And what is the name I have given? I have given this name. You can try to give any name that you want. But yeah, one node is added. Do we have any AI node? No. Do we have any kind of a edge? No. Do we have any conditional edge? No. Entry point, have I set entry point? None. Finish point? None. As of now, I have just added the node. Simple. One node I have been added. Now, so one node, this node I have already added, let's suppose. So one node is done. One node is done. So node one, let's suppose. Okay, cool. Now the next node I can try to create for maybe a separate task. So here graph dot add, this time I'm going to create an AI node, let's suppose. AI node means it will be having a LLM access. And for an AI node, I can try to give a name that, okay, so this node I'm going to call it as Synthesizer, Synthesizer, Synthesizer. I'm just giving a name to it. You can try to like do whatever you want. And here, so it is going to take basically a prompt, let's suppose. So it's a LLM node, right? So obviously I can write a prompt. So prompt, prompt template. So prompt template is equal to what? So prompt template is equal to, I can try to write over here, summarize the following document input that I have given to you in very, very detail, right? So what document input, by the way, I'm going to give? So I'm going to give basically a context. Yeah, context. Now from where this context is coming, by the way, /n, let's like do it in this way. So context. So what this context, from where this context will come? Obviously this context will come from here, because this is going to return me context, right? And what is context technically? Context is nothing but the data which is available over here. So I'm saying that okay, so whatever like data that we are able to get inside the context, do one thing, summarize it. Maybe there is 100 lines, thousands of lines inside my document. I don't want to, use that 100 and 1000 line. I just wanted to use like a summary of it. Simple, right? Summary of it. I would like to use it for the further process. So, okay, synthesizer and this context. So basically it is going to take this context. So now I have another node number two, and this is going to basically do what? So whatever data input, I have not connected yet, but yeah, I'll connect in some time. But yes, what I'm assuming that node number two, whatever data it is trying to read from the file, it will try to summarize it. Simple. So, okay, this will do automatically. Now execute it for now. And now if you are going to check graph.get graph structure, you will be able to find out two nodes. One is this AI node, synthesizer. This is the very first AI node I have created. This node is technically a function node. Yeah. So two different kind of a node I'm dealing with as of now. Fine. So this is also done. Now, so now just try to like create one more function, right? One more function. It's a classified topics. So a state context, just try to like keep all the context into a lower. And if LLM in text, then LLM workflow, RAG in text, RAG pipeline. Means I'm just trying to do the classification of whatever data which I'm trying to read from the context, which is available at the particular state, right? It's a state process, right? A stateful process. So whatever is available at the particular state, just try to classify it. Okay. So this is another independent function. And I can try to like maybe use this add function node, right? Add a function node. And here, so this will be classifier, and which will classify topic function. So this is another node I have added. Now, if you are going to check, so get graph structure, you will be able to find out three node now. This. Out of three, one is a AI node and two is a functional node, right? Two is a functional node. Very simple. Okay, fine. So this we are able to add. Now the fourth node. So till this point, I'm able to create a third node number 3. So which will try to do classification, by the way. Okay, so 1, 2, 3, I'm able to create 2 functional and 1 AI node so far. Now I can try to call graph.add AI node, and I'm going to give this node as a name as a finalizer, Finalizer, finalizer. So which will finalize the entire things. So here finalizer will take a prompt template. Now what kind of a prompt I'm going to give basically? So I'm trying to give, like, let's suppose this kind of a prompt. So I'm saying that do one thing, try to take query, try to take topics, which is coming from here, from this node, try to take the context, which is coming from like the very first function, right? So use query in topics, context summary, basically context, answer the clearly using all the context above. So this is going to finalize and this is going to give me the final output basically. Now if I'm going to show you graph.get graph structure, sorry, my bad. So get graph structure, you will be able to find out 4 node now, right? 4 node now. So technically we have a 4 node over here. So N4. So in a graph, we are able to create basically 4 node. So 4 node is done. Now we have to set which one is going to be the entry point, which one is going to be the finish point basically, and how all of these 4 node will be connected amongst each other. So how I can set it? Let's do it then. So graph dot, you can call set entry point first of all. So who is going to my entry point? So let's suppose I'm trying to give the very first one. You can try to give anyone as an entry point. That's up to you, right? That's up to you. So extraction and query as an entry point. So I'm saying that okay. So try to consider extraction and query node. That was the node name. So that as an entry point. Set, done, right? Now graph 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 dot add add edge. Yeah, edge means now node 1. This was the node 1, by the way. Yeah, this one basically a node 1. Now so add edge. Yes, add edge. So here we can try to add a edge from this to the next one. I'm just trying to draw the line. So here add edge wise, let's suppose this is my node. This is my node. And I'm going to add a edge from this node to the next one. So maybe my next one was synthesizer. So to a synthesizer, I will try to add the edge. Add the edge. Now what it will do, by the way. So let me add edge, extraction and query to the synthesizer. This is what it has done. It simply means that this was the extraction node. This was the synthesizer node. I have added a edge from here to here. This is something which I have done. This is the something called as edge. And this I have labeled as a entry point. Entry point. So I have my entry point with node 1 and then I have a edge over here. EDGE. This is how these two are connected, by the way. So I have connected. Now, so next one, graph dot add. Again, I can try to call add edge, right? So this time I'll connect synthesizer with the next one. I can connect in any order, that depends upon me, by the way. So synthesizer, and I'm going to add synthesizer to the classifier node. So which is going to classify the entire topic. Synthesizer to a classifier node. So again, add edge. Now what will happen? See, synthesizer to classifier. So simple. Node 2 to node 3. Node 2 was synthesizer, node 3 was classifier. So node 2 to node 3. So again, we have created the edge. We have connected. So this. So I'm just trying to like add or connect the graphs, by the way. Okay, now, so again, we can try to call graph dot add edge over here, right? Add edge over here. And this time, so I'm going to add a edge from classifier to the finalizer, the final one, right? The final one that I've created. So this is the name. This was the name. So I just have to give a node name, finalizer. Okay, fine. Classifier to finalizer. It simply means that now I have connected even this to this. Simple, right? This to this in this direction. I have connected. Now, once this entire things is done, I have to do graph dot set finish point. Entry point I have already set, and finish point. So finish point, whatever result which I will get from the finalizer, I'm considering that as a finish point. Again, not hard and fast. You can try to set any node as a finish point. That's up to you, right? So finish point. So okay, this is also done. Now, if I'm going to show you graph dot get graph structure, right? So see, I had a 4 node. Out of that, 2 node is AI node. I have a edges. So basically, this to this one edge, this to this one edge, this to this one edge, right? This to this one edge. So even edge I'm able to create 1, 2, 3. We had 3 edges, right? We had 3 edges. Then we have basically an entry point and we have a finish point. So now everything I'm able to see inside my graph structure. Simple, right? So this is the graph structure I have created, and every node is trying to do something, right? Every node is trying to do basically something out of it. That looks cool. Now how I will be able to execute it, because graph creation is done. I am able to give an LLM access to my model. All these things are done. So how I will be able to run it? So maybe if I have to run it, so maybe I can try to call graph.run, right? Graph.run. And whenever I'm trying to run a graph, so obviously I have to give an input, right? Because that was the entry point. I had to give the input, right? I had to give the input, by the way. So from the state, it will take the input.
So input was the key. So I have to give a input value. So means query basically. So input input in sorry input in my bad input, right? So I can try to give a input from a UI. I can try to give a input over here. That's up to me, right? That's up to me, by the way. So here I can try to write maybe a query that how can I can try to write a query that how can the line graph and URI be used to build a multi-agent RAG system. Fine. So this is my query. Now, once I'm going to give a query, it will go to the entry point. So I'm giving my input. It will go to this one. What this will do, this will try to take the input as well as it will try to extract the data. Extract the data from the document which I had. For that, I have already given the access. I can give access of hundreds of other documents as well. It will try to create the context. Then this is going to do the summarization. Now this is going to divide my topic, right? Divide my topic into a different classes basically. And then finally it is going to use the AI LLMs and then it is going to give me the result. This is what I have built. So here just execute it and graph compile successfully. Update, so extraction and query how lang graph this one, context. So context it is trying to pick from open source Python framework building the stateful. So this is trying to pick it from this one. Now if I have to do the complete analysis, right? So maybe I can try to copy this one and I can try to paste it over here, right? So many things it has done, by the way. So many things it has done. So many things, right? So here, if you have to you have given this particular query, it is trying to extract the context. It is trying to synthesize the output, synthesize raw responses, topic LLM workflow. Yeah, so topic was LLM workflow, by the way. So it is able to do the classification, finalize error, set object has no attribute, format, error handle, false, build a multi-agent context, this. There is some issue I can see. LangGraph is open source deployed in Python designed for specifically the too long output. The framework also support the streaming output and the real-time inferences by application, lightweight. Okay, so finalizer set object has no attribute. So there is a minor error which I can see over here. Let me fix that part. It's just a formatting error. So graph dot run. This is basically a key value that looks good. Maybe let me save it as a result and print it. A final output, and basically that is a result. So let's see. So it's calling all the node one by one automatically. Yeah, so final output basically LangGraph. Yeah, so I'm able to see the final output. See, so context was this one, and
Yeah, so I can see the output. I can see the output which is not available in my system. It is trying to use the LLMs clearly, and I can see that it is trying to give me the output, synthesizer output, and here. So yes, all the output it is trying to give. So here we are able to create a graph. Technically, this particular graph we are able to create. Now, if I'll talk about the agent, so all of this node is working as a agent, working as a agent. So agent 1, node 1, agent 2, node 2, agent 3, node 3, agent 4, node 4. And as we can see that it's not like I'm trying to use a AI every time. So sometime I'm trying to use my own function which I have written, and sometime I'm trying to use basically a LLMs, right? So AI node. So this is how with the help of AI, with the help of LangGraph, I'm able to create a multiple agent. I'm able to connect it all together. I'm even able to perform a little bit of RAG operation, not much, not a hard-coded RAG. So basically, RAG retrieval-wise, I'm just trying to I'm not using a vector over here. I'm just trying to store the data, and directly I'm trying to use that particular data while reading the data. So we have basically a finalizer agent, we have basically a classifier agent, we have basically a synthesizer agent, and we have basically a extractor and input taker agent, right? So these are the agent that we are able to create, which is a goal specific agent, which will be able to take a decision automatically that what we are supposed to do in which particular state. And yeah, so all of these agents are connected, and all of these agents are trying to work together. So this is all about a multiple agent, guys. So if we can create this, we can create another thousands of other agents as well. Depends upon my task, depends upon the things which I'm trying to build or I'm trying to perform, which I'm going to show you a lot of times, many times, by the way. Yeah. So with that, thank you so much, everyone. Take care. Hope all of you are enjoying your life and lecture, both. With that, thank you so much. Take care, everyone. Okay, so welcome back to another lecture, guys. Now in this lecture, I'll be talking about prompting. So whenever you are trying to build a RAG application, or maybe you are trying to use a LLM with respect to any framework, for example, a LangChain, LangGraph, Llama indexes, anything, prompting always plays an important role. So whenever you are trying to give an instruction, or even when you are trying to chat with a ChatGPT or maybe a Gemini or any other LLM on any other platform, so prompting always going to play a very, very crucial role. So if you are not going to give a prompting in a correct manner, so obviously your result is going to hallucinate and you will end up getting a random result. We as a human being have a tendency to ask a question directly without giving a context, but ideally that should not happen. So ideally that should not happen. So now let's try to understand that how we can try to give a correct prompting and what is the difference between good and bad prompting. Now, to show you this example, I will be using a URI ecosystem, because URI ecosystem is going to give me API access for a 25 plus model. And here we have a code example for a chat completion. Simply means that I can try to give a prompt over here and eventually it will try to give me the output. With respect to simple RAG application, I'll try to show you this particular one. So fine, let's get started. So here, what I will do is that let me show you one very simple example. So here, let's suppose I have a retrieve document. So this is a document. So where I have mentioned a little bit about a lang graph. Fine. A little bit about a lang graph I have mentioned over here. And I'm trying to use this generate completion with the context. So this is a simple custom method which I have created. Ultimately, I'm trying to use this URL. So which is going to give me an access of a URI API ecosystem, by the way. And here, so I have to place my URI API key. So let's go ahead and try to create an API key. It's very, very simple. So click on create API key, a test, and any name you can try to give. And in a fraction of a second, it will try to create the API key. So which is going to give me an access of 25 plus models. Okay. So I have just replaced it. Now here is my document. Ideally, we keep this document inside any of the vector database. And I have already discussed about it multiple times, that how you can try to store this entire document as a vector into a FAISS or maybe into a ChromaDB, maybe into a Pinecone, Quadrant, or any other vector database. I have already discussed about it. And I believe if you are able to go till this point, you must be aware about a vector database and how RAG application actually works. We all are aware about it. So technically, I'm going to focus on a prompting side of it. So this is my document, for example. Yeah, I'm just trying to keep it here. I'm not converting into a vector DB because we all know how to do it. And then I'm trying to prepare the prompt. I'm saying that you are a helpful assistance based on the following retrieve document, means whatever document which I'm trying to give. Answer the user question truthfully and only using the provided context. Context means the document, right? The document which I'm trying to talk about. So here, context wise, clearly I have mentioned that try to use the retrieve document, this document, yeah, the data set that I have provided. And then this is my question, that what is a lang graph? It will go over here inside a payload and it will try to give a prompt, and I'm using a model called as GPT-4.1 Nano. Maximum token output is equal to 500 and temperature I'm going to set is equal to 0.5. So temperature should vary between 0 to 1. So closer to 0 means less hallucinating answer, and closer to 1 means obviously a more hallucinating answer. And then I'm trying to hit this particular URL. So URL means the above one where we have hosted a URI API, and this one is a payload, a JSON payload we are trying to pass. So this particular payload I'm going to pass, so where prompt is already attached. Fine. And inside a prompt, we are saying that try to take this particular context. As simple as that. It simply means that I'm providing this particular document. Okay, fine. Now what is next? Okay, so now this looks like a good prompting strategy to me, because I have given all the instruction clearly to this particular model. Now, if I'm going to execute it, obviously it should give me an output with respect to the document which I have provided as per my instruction, right? As per my instruction. That LangGraph is a Python framework designed for building a stateful multi-step AI agent using a graph-based architecture. And yeah, so it looks like it is able to provide me. You can try this out, yeah, and it is trying to provide me all the answer based on this particular document, yeah. Now, so this is a good prompting strategy. Now, what is called as bad prompting strategy, by the way? Yeah, so what is called as bad prompting strategy? So here, I'll try to copy the same code, and okay, I think I was not able to copy. Same code, and here, so prompt wise, I'm going to give what is LangGraph. I'm not giving any kind of a context. I'm not saying that try to take a context. So context is completely missing, by the way. So it will not even look into this retrieve document. Context I have not given. And this is the prompt I am sending over here. Right now, if I'm going to execute it, let's see. So how my previous answer and this answer is different. So LangGraph is a machine learning framework designed for a natural language processing. It leverages graph-based representation to model linguistic structures such as syntax, semantics, disclosure relation, enabling more effective understanding of processing language data by representing a language element. And this is nowhere close to the document, because I have not given a context. So what I'm trying to prove over here is that whenever you are trying to do a prompting with respect to, because you have to give a prompting, right? You have to include a context. You have to control a maximum token output. You have to control a temperature. If you are not doing that, right? If you are not doing that, then that's a bad idea, the way I have done that. And this is a hallucinating result for me. And obviously it is not able to ingest this one, because nowhere this one is available in my prompt, right? Nowhere this one is available in my prompt at all. So this is called as good prompting and bad prompting with respect to the RAG application. So simple instruction to all of you, that whenever you are trying to build a RAG application, try to give as much useful or closer context as possible. Otherwise, it will not be able to work for you. Hope this makes sense to all of us, and hope all of you are going to experiment it a lot with all the permutation and combination. And then eventually you will get to know the final result. With that, thank you so much, everyone. Take care and see you again in my next lecture. As a prompting strategy, guys, so there are a different kind of a prompting strategy that you all will be able to find out. So whenever you are dealing with the LLM, so the very first prompting strategy which I will be talking about, which is again a continuation of the previous lecture, is called as system instruction prompt. Yeah, system instruction prompt. and what it does, by the way. So what this system instruction prompt does. So whenever you are trying to give, I'll just try to show you a couple of examples over here. So whenever you are trying to give a prompt, so if you are trying to say that you are an helpful assistant, only use a provided context to answer the question. Do not rely on prior knowledge. So if I'm trying to use this kind of a prompt, so obviously I'm trying to say, or I'm trying to give a very, very clear instruction to my LLM. So whenever it will try to generate an answer, that only use a provided context to answer the question. Do not rely on the prior knowledge. So whatever knowledge that you have, because LLM will be having a entire world's information, entire world's knowledge, because this is how it has been trained. But if I'm going to give this instruction, so what it will do, so I have to attach this instruction where? So I have to attach this instruction technically over here, right? Over here, that do not rely on your prior knowledge at all. So whatever you are trying to do, so do it with my document, my understanding, or my knowledge. So this is called as system instruction prompt. So where we are trying to define a role of the model. So what is the meaning of system instruction prompt? A system instruction prompt says that you have to define a model role and you have to define a scope clearly. So here I'm trying to define a role clearly, that you are a helpful assistant. Apart from that, I'm trying to define a scope clearly, that do not rely on your knowledge. Whatever output that you are trying to bring, you are trying to give, always try to give me an answer based on the context. Context means the document which I have provided, right? The access which I have provided to you. Based on that, just try to give me the answer. I'll show you another example. So here is the another example. So instead of that message, so let's suppose if I'm trying to say that act as a legal advisor. So simply I'm trying to define the role of the model, that okay, so try to act as a legal AI advisor. Use only a retrieve legal document to answer the query, citing the context explicitly. It's explicit. So in this way, again, I'm defining a role clearly. I'm trying to define the scope clearly. This is just a prompt, guys, just a English, but yeah, so it matters a lot with respect to the LLM. Now, there is another example I would like to give you with respect to a system instruction prompt. So I'm trying to say that role, you are a technical product assistant. Yeah, you are technical product assistant. Explain the concept using only a document retrieved. Avoid assumptions or guesses. So again, I'm trying to define a role over here and then a scope over here. So role in this place I'm trying to define, and a scope in this particular place I'm trying to define. And this is called as system instruction prompt. So where you are going to define a role. Let me write it down here. So you are going to define a role, so model role plus scope clearly, and this is called as system instruction prompt. So hope all of you are able to understand that what is the meaning of a system instruction prompt. With that, thank you so much everyone. Take care and see you again in my upcoming lecture. Okay, so in this lecture, again, I'm going to talk about a prompting strategy. There is something called as few short prompting with a context. So here, as I have mentioned the topic name, so I'm going to talk about a few short prompting. Again, not tough to understand. It's a very, very easy to understand. So let's suppose I'm working with this example, the example which I have already shown it to you. So let me copy this cell and here, so let me paste it, right? So it's a same example, let's suppose I'm talking about. Let me convert this into a Python. Yeah. So, so here, this is basically a prompt which I'm trying to give. I can try to give a prompt with an example. This is the meaning of a few short prompting. Few short prompting means, so basically you are trying to add an example Q&A based on the similar retrieval. So you are trying to give an example that, okay, fine, so try to give me an answer, but consider this particular example and then only try to give me the answer. For example, so here, maybe I can try to add this one inside my prompt. Let me show you separately. So maybe I can try to add this particular part inside the prompt. And let me close it with a triple quote. Yeah. So here, okay. So this is a new kind of a prompt which I have built. So here, context, document, LangGraph allows building a agentic workflow using a graph technology. Again, question, what is LangGraph? LangGraph is a Python library for building an agent based on the state machine from a LLM. Now, what does LangGraph enable? So it enables a structured agent workflow. Now answer, how is LangGraph different from a LangChain, right? So here, as you can see that I'm trying to give a question and I'm trying to give an answer. And I'm trying to say that, okay, try to consider this as an example. And again, in the exact similar manner, try to give me an output. Whenever you're trying to chat with a ChatGPT or maybe any other LLM provider, you can try to experiment even this particular part, that whenever you are trying to send a prompt, always and always try to give some sort of an example that I'm looking for this kind of output, I'm looking for that kind of output. For example, so here maybe I can try to show you with respect to the URI API system. Let me open up my URI chat system basically. Yeah. So here maybe I'm going to ask some question. So give me an example of Python calculator implementation. Yeah, implementation. So obviously it is going to give me like a output with respect to the Python calculator, a simple calculator, right? Now, so in the same prompt, maybe I can try to give a couple of instruction that try to give me this function in this way, that function in that way, and that will become a few short prompting. So this is just a plain simple question which I have asked, and yeah, it has given me the answer. But let's suppose if I'm going to ask that give me this implementation with maybe I can say that give me this implementation with modular code and keep all the file separate, maybe something like this. I've just given a little bit of more instruction. So now it will start giving me a modular code, as you can see. So it has created a main.py, operator.py, calculator.py. It is trying to separate all of my code. So my prompt is going to change a lot. The way we are extracting an answer, the way we are extracting an output, it depends, or it depends a lot on the prompting strategy that we are going to adopt. Doesn't matter whether we are going to generate an image. So let's suppose if I'm trying to generate an image, right? I'm going to write over here that try to generate an image. So I've selected the image part and give me a YouTube thumbnail for RAG application building, right? RAG application building, and use a theme, use a flavor of Netflix. So let's see, right? So it is going to generate a YouTube thumbnail for me, and obviously I'm expecting that it should use a Netflix kind of a theme. So I'm trying to give an example that, okay, fine. So try to take a reference of this, reference of that, and then try to give me the final output. So even in, so it will try to take some time and it will generate the image. I'll come back to this part. But here, so this is something which I'm trying to give. So I'm trying to give a question, I'm trying to give an answer. So more example, if you are going to give, so more exact and more accurate your final outcome is going to be. Let me show you a couple of more example with respect to the same thing. Yeah. So here, let's suppose I'm going to write something like this. Question. Yeah. So context, what is the goal of a system? To generate a structured answer for a document. How are the document used? They are used to ground the response. And again, question, what happens if the document are irrelevant? So I'm trying to give some example, right? I'm trying to give an example of a question and answer. And I'm saying that, okay, fine, this is my question. Now try to give me an answer. So obviously, if I'm trying to suggest, if I'm trying to give some sort of a instruction with respect to an example, that is something called as few short prompting. Yeah, few short prompting. And when I'm talking about the RAG application, so yeah, see, it has given me a image, right? It has given me a image, build a React app. Okay. So RAG I have mentioned, but maybe it was not able to understand. But yes, it is trying to use a Netflix theme, and based on the Netflix theme, it is trying to give me an answer. So I have just simply given the example. If I'm like the video on RAG, the image has generated. You can view thumbnail to video on RAG application building. It's not RAG, by the way. It's a React app. It has mentioned, but yeah, maybe I'll have to like give some sort of a detailed prompt, then only it will be able to generate a proper answer. But what I'm trying to teach you over here is that what is the meaning of a few short prompting. And few short prompting simply means that give everything with the example. Simple. And if I'm talking about the RAG application, obviously context must be mentioned. Context means whatever document that I'm trying to retrieve, that must be mentioned. So hope all of you are able to understand what is the meaning of a few short prompting. This is again one of the strategy that we all try to follow while doing a prompting to a LLM. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about another prompting strategy. So let me share my screen. Again, it's a continuation of the previous lecture itself. So if you have not watched the previous lecture, so please go ahead and watch it and then come over here. So here there is another prompting strategy called as output format instruction. So as its name suggests, output format means you are supposed to give, or you are supposed to mention a very, very clear instruction that give me an output only with this kind of a format. For example, so if I'm trying to say that answer in 3 bullet points, each no more than 20 words. So give me an answer, but with only 3 bullet points. I can just try to use maybe a URI, and I can try to ask this question. So give me a for loop example, only 2 example, and make sure that number of line of code should not cross 2 lines. Yeah. So I have clearly mentioned that, okay, fine. So only in this manner, I'm expecting the output. So this is called as output format instruction. If I'm going to ask a system to generate, okay, it has started generating the image. My bad. My image was on. So maybe I can try to use a new. And yeah, so I have given a very, very clear instruction that it should not cross more than 2 lines. And I believe it is obeying my instruction, right? So it is able to obey my instruction. So it has given me 2 example. And again, so I don't think that it is crossing a 2 line of a code, as simple as that. Now, generate a data for me for a movie review and give me output sample data in JSON format. So I've clearly mentioned that, okay, so give me a data, but it should be available in a JSON format. And as you can see, it is generating a data as a JSON format. Simple, right? So this is called as output format instruction. And when you are trying to do a prompting based on the expectation that you have, based on the result that you are looking for, always try to give a clear instruction that what kind of output that you are looking for, even though you are working with the frameworks or maybe with the RAG or maybe with respect to any LLM with which you are going to chat, right? And it is going to follow the instruction and it is going to give you the output. Maybe if I'm going to ask that, give me a response with respect to a CSV, or maybe give me a response with respect to a tabular format. Again, with respect to the image, I can say that generate an image with this particular flavor, that particular flavor, or maybe try to use a font with this size. It is going to obey. But yes, you have to clearly mention those part. Otherwise, system will go like and it will try to hallucinate you, by the way. So this is something called as output format, and you can try to define that what kind of output that you are looking for. So this is another strategy that we try to follow in terms of a prompting. So hope all of you are able to understand that how this output format instruction is going to work, and you are going to follow along going forward. Yeah. So with that, thank you so much, everyone. Take care and see you again in my upcoming lecture. Okay, so welcome back to another lecture of prompting, guys. Now in this lecture, I'll be talking about a prompting strategy called as chain of thoughts, COT. So let's try to understand that how chain of thought is going to work. And with the help of example, I'm going to explain you this particular part where I'm going to use a URI API key, by the way. So let me convert this to Python and chain of thought prompting. Now, what is the meaning of chain of thought prompting? So for example, this is my document. Yeah, this is my document. And I'm trying to write a prompt that you are a helpful assistant based on the following context. Answer the user question truthfully using the step-by-step reasoning. Fine. Now, so here I have given my document access, for example, for RAG application. So here I have given my document access. And this is my question that what is LangGraph and how it is useful for building an agent. And I have mentioned these 4 instructions. This is called as chain of thought, COT. So I'm saying that think step by step, first of all. Firstly, identify what LangGraph is based on the context, then explain how its feature related to the agent-based system. And then I'm saying that conclude with a clear answer grounded in a given information. So these are the things which I have mentioned as an instruction, which is a part of my simple prompt, right? Which is a part of my simple prompt. So now you will be able to see that it is going to generate an output in a bit different manner. But to do that, I need my API key. So let me copy this API key and here. So I'm going to place it and then execute it. And let's see. So what is the output I'm going to receive? So here chain of thought response, which I have received. So LangGraph is a Python framework designed for creating a stateful multi-AI agent, usually utilizing a graph-based architecture based on the context. It extends the capability of a LangChain. So here, if you will go and read your instruction clearly, step by step, think step by step. Firstly, identify what LangGraph is based on the context. Context means the document which I have provided, this document which I have provided. So firstly, try to identify what LangGraph is based on the context. Let's see. So whether it is able to identify or not. So LangGraph is a Python framework designed for creating a stateful multi-step AI utilizing a graph-based architecture. So based on the context, it extends the capability of a, so based on the context, right? It is trying to give me the answer. It extends the capability of a LangChain by enabling a developer to define a node which can be a function, LLM, or maybe edges between these nodes. Now, so then explain how it's feature related to a agent-based system. This was my instruction, chain of thought, right? Then explain how it's feature related to a agent-based system. So here its feature include a support for looping, branching, conditional logic, and shared memory. These feature allow a complex, right? This feature allow a complex flow of dynamics. So yes, it is able to obey. And then conclude with a clear answer grounded in the given information. So now conclusion. So conclusion wise, so in a summary, LangGraph is a powerful. So it is able to give me a conclusion. So here chain of thought wise, maybe I can try to give over here instruction number 5 that give me all the outputs with bullet point with numbering. Now let's execute it. So this is the step which I have given, another chain of thought, so that it will be able to format my output. So here it is able to give me that identify what is LangGraph is, determine its core architecture, feature that supports a complex workflow, integration and extensibility, how this feature related to the agent-based system, and then finally a conclusion and final answer. So as you are able to see that I have just changed one single line, right? I have just changed one single line and my entire output has changed. It's the same system, right? It's the same LLM, it's the same document or context, I can say, which I'm trying to provide. But as my prompting has changed, right? As my prompting has changed, my final output has changed completely. Now it's more meaningful as compared to the previous output, which I was expecting. So like I said, prompting matters a lot. So whenever you are trying to do a prompting, you should be aware about your business, the outcome that you are looking for, the instruction that you should give, all these things. Then only you will be able to generate a better and better outcome. And obviously LLM is going to work for you in a better direction. So hope all of you are able to understand that what is the meaning of a chain of thought. And it's a plain English, right? In which I'm writing, which is a part of my prompt. Simple. But yes, it matters a lot. It makes a lots and lots of changes for me. So hope all of you are able to understand a COT, chain of thought. With that, thank you so much everyone. Take care and see you again. Okay, so welcome back to lecture once again, guys. Now, in this lecture, I will be talking about another prompting strategy called as explicit anchoring. Now, what is the meaning of this explicit anchoring? Let's try to understand. So, I have already mentioned the topic name over here. Now, explicit anchoring simply means that refer to a particular source, the document that you're trying to provide, the context that you're trying to provide, or a position in a particular document explicitly. And this is called as explicit anchoring. So let me explain you this part in a example, by the way. So let me convert my markdown to Python. Okay. Now, so here we have a document. We have a paragraph 1, we have a paragraph 2, and we have a paragraph 3. Now, so what is the meaning of explicit prompting? So just try to focus on this particular prompt part. So you are a helpful assistant. So I'm trying to define the role. Read the following context. And context means this particular document. Read it out, fine. And instruction wise, I have given an instruction that in a paragraph 2 means I'm trying to mention explicitly a source or a position. So I'm saying that from a paragraph 2 only 2, right? So paragraph 2 of the retrieved document, it says LangGraph supports agent collaboration by enabling a multi-node agent to share a memory and a coordinate via transition. Explain this statement in a simple term that beginners can understand. So this is my output formatting, by the way. And here, so I'm trying to give a explicit, right, anchoring, where I'm trying to say that only from this document, this particular, inside this document, inside this context, only from this paragraph, try to explain me this one, not from anything else, right? Now, if I'm going to give a API key over here, let me give a API key. So if I'm going to give a API key over here, and if I'm going to execute it, so explicit anchoring, sure, this statement means that in a LangGraph. Now, what is the statement? LangGraph supports agent collaboration by enabling a multi-node agent, shared memory, and this. Okay, fine. So now just try to see the answer. This statement means that LangGraph different parts called agent can work together. They can remember information, they share with each other and communicate by moving from one step to another. This helps them to work as a team to a complete task. Now, what was the instruction? I said that look into the paragraph 2. And then I said that explain me in such a way that even beginner can understand. And yes, this entire output looks like that any beginner will be able to understand. And if I'm going to ask that, okay, fine, so try to give me a 10-20 example, it will be able to give me. But what is the meaning of this explicit anchoring? Explicit anchoring means I'm trying to give basically a source or maybe a position. I'm clearly defining that just look into the paragraph 2. Do not look into the paragraph number 3 or a paragraph number 1. This is something called as explicit anchoring. So where I'm trying to define a position in a context explicitly. That okay, just focus on this particular part. So this is again another prompting strategy that you will be able to find out. So hope all of you are able to understand explicit prompting strategy. With that, thank you so much everyone. Take care and see you again in my upcoming lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'm going to show you that how we can try to evaluate a RAG pipeline. So when we talk about RAG, so it's all about retrieving a document. Maybe I'm going to store a document into a vector database and then generating a response, generating an answer out of that. And then we can try to evaluate that how good our retriever is and how good our generation is, by the way. So here I'm going to take two variables. So one is a ground truth, which is going to represent basically the correct chunks or a correct document that is going to contain the answer based on the user query, because this is what we do with respect to RAG. And then let's suppose this is the correct chunk, this is the truth, and this is something that we are able to retrieve, for example. So this was actually a truth which it was supposed to give with respect to my question, and this is something that system has given to me with respect to my question. Now, how I will be able to evaluate that how accurate my entire RAG is. Now, to do that, so first of all, we have to find out a true positive. True positive is nothing but it's an intersection of a ground truth and a retrieve one. So if I'm going to execute and if I'm going to show you, so what is a intersection between these two? Ground truth, which is actually holding my answer, and the retrieved one, so which I am able to retrieve with the help of my RAG pipeline. So here,
My true positive is basically document number 1 and document number 3, which is available in ground truth as well as inside the retrieved one. So document number 1 available in both the places and document number 3 available in both the places. And as you can see that in my ground truth with respect to a query, I have a document number 5, but it was not able to extract that document number 5 when I have asked for a retrieval. So it is able to retrieve maybe some different document, which is a document number 2. So my true positive is basically this one. Yeah, my true positive is basically this one. Now, based on this, I can try to calculate a precision basically. So this is something that we try to use with respect to a classification. So here I can try to do a calculation with respect to a precision, and precision is nothing but, right? So precision is nothing but my true positive divided by my retrieve. So what is my true positive? 2 document. And what is my retrieved one? So basically a 3 document over here. So here I'm going to take a modulus. Modulus simply means that I'm going to take the length of this one. So here precision, if I'm going to calculate, so maybe a length of, I can say that length of like a true positive. So true positive and divided by a length of basically a retrieved. So this precision is going to be 0.66, right? This is the this number is basically 0.66. So now it is telling me that 67% of the retrieved chunk, the chunk that we are able to retrieve, so 66% of the retrieved chunk, or you can say approximately 67% of the retrieved chunk were actually relevant. Simple. So this is what precision is going to talk about. Now there is another parameter called as recall. You will be able to find out. So recall is nothing but true positive divided by the total ground truth. So now if I'm going to do the calculation, do the math for a recall. So here again I can try to maybe do a math. So length of basically true positive and divided by a length of basically this ground truth. So this ground truth over here. So again, it is going to be 0.666, which is approximately 67%. So now it is telling me that 67% of all the retrieved chunk were, or 67% of all the retrieved chunk were successfully retrieved out of the entire document. So this is what it is trying to talk about. And then there is something called as F1 score. So F1 score is nothing but, precision into a recall divided by precision plus a recall. So it is nothing but it's a harmonic mean of a precision and recall, and it is going to balance both precision and recall. So ideally F1 score should be the final parameter for me. Now here, so if I have to calculate a F1 score, it's going to be very, very easy. So I can try to execute it, and F1 score is technically 0.66. So again, it's going to be same. And now it is telling me that, okay, so the retrieved document that we are able to see. So basically it's a 67% of relevance that I'm able to get, as simple as that. So here we have a precision and we have a recall and we have a F1 score, and based on that we can try to do the evaluation. So for example, if our retrieved document is document number 1, document number 3 and document number 5, and our ground truth, right? Our ground truth is again document number 1, document number 3 and document number 5. Now in this way I can say that I have a perfect match, means whatever ground truth was and whatever document that we have retrieved, actually it's same. So my RAG is technically correct. And in other case, let's suppose I have a retrieved document number 7 and document number 8. And now my ground truth is basically document number 1, document number 3 and document number 5. So in this way I can say that my precision is going to be 0, my recall is going to be 0, my F1 score technically is going to be 0. So I can say that my RAG pipeline has completely failed and it was not able to retrieve the document which I was actually looking for. So in this manner, you can try to calculate a precision, you can try to calculate a recall, you can try to calculate a F1 score, and you can say that, or you can claim technically, you can claim that okay, so this is how accurate my entire RAG pipeline is at the end of the day in terms of evaluating it. So hope all of you are able to understand that how we can try to check or how we can try to test basically a RAG pipeline at the end of the day. So with that, thank you so much everyone. Take care and see you again in my upcoming lecture. Okay everyone, so welcome back to lecture once again, and in this lecture I'll be talking about a two term called as faithfulness and a relevance. So these two terms are technically used when we are going to evaluate a RAG pipeline or any kind of a RAG operations. So here there is a two term called as faithfulness and relevance, which I have already mentioned. So let's try to understand theoretically that what is a faithfulness and what is a relevance. But again, I'm going to show you an example for the same thing, a practical example by the way. So faithfulness always try to measure that whether the generated content or the response that we are trying to generate is factually consistent or not with respect to the retrieved context, in whatever context that we are trying to retrieve the data. And when we are talking about a relevance, so relevance always try to measure that whether the generated response is focused on topic and addresses a user query or not. Just go after the word called as relevance, means whatever response that we are trying to generate, so basically that response is aligned with my topic or a user query or not. So this is something a relevance always talks about. And faithfulness means, so we are going to measure that a generated response is factually consistent or not with respect to my context. And we can try to do a math, we can try to do a calculation. But yeah, so if my generation is not faithful, so in that case model will end up hallucinating if it is not faithful. And if my generation is not relevant, so in that case it will end up generating some off topic or maybe something it will generate with respect to my context, but it is going to be off topic, means I'm going to ask maybe with respect to my document, but it is going to give me a response with respect to something else. Something else means on the same topic, but in a different term, it is going to give me the response. Now, to best way to understand this entire things is to go ahead with the practical operation. So here, what I will do guys, that I'm going to use a URI API, URI Embedding API we already have. And here, so you will be able to find out a code example for a embedding. We have been using it since a very, very long time. Right, I just have to replace this one with my API key. So here I can try to generate my API key. So let me generate some API key over here so that I will be able to use this entire function. So I have just replaced it with my API key. Now it is going to take input as a text. Yeah, it is going to take an input as a text, and eventually it is going to give me the output of the embedding. So in terms of an embedding, it is going to give me the output. So here, let's try to keep it this generate embedding function. And then I'm going to use a cosine similarity. I have already discussed about cosine similarity. So those who have not gone through a cosine similarity, so please try to go ahead with the cosine similarity. It's basically try to match two vectors, and then it is going to like tell you that how close these two vectors are. This is something that cosine similarity is going to do. In detail, I have already explained previously. So fine, this is my cosine similarity function where I'm going to pass a two vector. Now how I will be able to generate two vectors? So basically with the help of my embeddings, with the help of my embedding function, I will end up generating it. Now let's talk about the data. So let's suppose I have a query that what is LangChain, what is a Lang graph used for in a LangChain. So this is my actual query. And let's suppose it is trying to retrieve data. It is trying to retrieve a data. So LangGraph is a stateful orchestration framework in a LangChain that helps to build a multi-agent workflow using a graph-based execution engine. So this is basically my retrieved context. So I had this particular query, right? And this is able to generate or this is able to retrieve this particular context. And then finally, so when I'm trying to pass my data, so this is the generated response, means this was the query, user query. This is the document which it is able to retrieve from the RAG or whatever data that we are trying to store inside a vector database, right? Vector database. So this is something that it is able to retrieve as a context. This is what we try to call as a context. And then when I'm trying to pass this query and this retrieved context inside my LLM, so this is the final generated output. Now we have to calculate that what is the faithfulness or what is a relevance. So how I will be able to calculate this one? To calculate a faithfulness score and to calculate a relevance score, first of all, I have to convert these three things into a vector. So generate embedding function I'm going to call, and I'm going to pass query. Yeah, going to pass query. So it will generate a vector of size 1536. So now here is my vector for a query, only for a query, right? Only for a query. Okay, so this is something that I'm able to generate. Now, same thing I will end up doing for a retrieved context, the context which it is able to retrieve maybe from a vector DB, for example. As of now, I'm not using any vector DB to show you example, but yeah. So for an embedding context, I am able to generate this vector of same size, and then the response, right? The final response which I'm able to get. So even I'm trying to convert that one into a vector space. So all three things, the user query, the retrieval document from a vector DB or by RAG, and the final response, right? This is the final response. So all three things I'm able to convert it into a vector. Yeah, vector. Now what I will do, so I will try to check what is a faithfulness score. So I will be using a cosine similarity, and here, so I'm going to pass embedding response, the final output which I have received, and the embedding context. And this is what I believe a faithfulness is. As I have given you an example, or as I have given you a definition, that faithfulness always try to measure the generated response. This one is a generated response is factually consistent with the relevant context or not. I think this is the definition which I have talked about. So basically, this is something which is going to give you a faithfulness score. Now, if I'm going to print over here that what is a faithfulness score, so it is telling me that it's a 88.13. Yeah, it is basically 88.13. Similarly, so I can try to generate a relevance score. Now, as per the definition, what was the relevance score? So relevance score is going to measure that whether the generated response is focused, right? Generated response is focused on a topic or not, or user query or not. So here generated response divided by, or generated response with respect to the embedding query. So here my relevance score is a 77.79%. So this entire generation is 88.13 as a faithfulness score. And in terms of a relevance, basically it's a 77.7%. So wherever you are going to get a score above, I would say a 90%. So it's an acceptable one, or you can say it's an excellent score that we are able to generate. And whenever we say that we have a score in between a 70% to a 90% or 89%, so I can say that it's a good one. It's a good one. So we are falling in a range of a good generation, or you can say a good retrieval. And here the whole idea behind showing you this one, to do a calculation with respect to the faithfulness score and with respect to the relevance score. So relevancy wise, it's a 77 point relevant, and faithfulness wise, so it's a 88.1% faithfulness that we are able to get. So hope all of you are able to understand that how we can do a math with respect to the faithfulness score and with respect to the relevance score. So with that, thank you so much everyone. Take care and see you again in my upcoming chapters. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about a scoring technique, and there is something called as BM25, a best matching 25 scoring technique, by which you will be able to give a ranking to a retrieval. For example, so whenever we try to perform RAG, right? So you must have seen that we try to retrieve a top K document. So obviously based on the query. So I'm going to insert my query, and there is a document which will be available by default. So as per the query which I'm going to send, it is going to retrieve the document, but with ranking that, okay, so this is a top first one, second one, third one, and so on. So it try to give you a like a complete ranking order for a retrieved document. So how generally this ranking will be calculated based on the things that we are going to pass. This is something that we are going to see. And this is one of the approach. There are multiple other approaches as well. So there is something called as BM25, so best matching 25, and internally it is going to use a lexical approach. So technically it is using a term frequency inverse document frequency that we have already studied in my TF-IDF class. So based on the TF-IDF, it is going to give you a final score. As an input, it is going to take a document and then a query. So you are having a document, a multiple document, you are sending a query. Now it will try to give a ranking based on the query that, okay, fine. So for this particular query, this is the document which is relevant, or this is the top one, this is the top second, this is the top third, this is the top fourth. And this calculation is going to happen with respect to this particular formula. Now let me show you all these things with respect to the practical implementation. Now to do that, you have to install rank BM25. So unless and until this is not installed, you will not be able to use it. And then try to do the import.
import of this BM25 250 KPI. So just try to import it, and let's suppose I have these documents. So I have basically 4 documents, 1, 2, 3, 4. These are the 4 documents that I have. So I'm going to pass a query with respect to this 4 document. For example, let's suppose this query, this document is available inside my vector database, and I'm going to write a query, and query is going to give me like a relevant document. Yeah, relevant document. So here, just to do a calculation with respect to BM25, so I have to convert this entire query into a token. So nothing but list of the strings, right? List of the or list of the words, you can say. So this is what this tokenized corpus is going to do. It is going to give me the complete data, but as a list, and it is going to break down all of these words into a small one single string, simple inside the list. Fine. So this is my actual document which is required for a BM25 calculation. Now I'm going to create a BM25 object over here, and here I'm going to pass my corpus, the original data. Yeah, the original data, I'm going to pass it over here. So this is the object of BM25 I'm able to create. Now let's suppose user is going to ask this query, right? User is going to ask this query with respect to this document, Now which document it is supposed to return, which like document number 1, 2, 3, 4, and what should be the rank? What should be the top matching document with respect to this query? So this is something that we are supposed to find out with respect to a BM25 scoring. So let's try to tokenize this query as well. So here it is going to give you the list of the strings, right? List of the words, basically with respect to this query, simple. And then we are going to call a score. So a score is bm25.getScore, and now try to pass a query. It is already having your corpus, already having all the data. So this is something that we have done. Yeah, this is something that we have done. So now it is going to give me the score, and it is telling me that here is the score. So it is telling me that a score for the very first one is 2.82 with respect to the query. Obviously, if you are going to change the query, this score is not going to be same, right? Because with respect to the query, it is trying to perform the TF-IDF operation, right? So here, with respect to the query, the first document is having 2.82 score. Second document is having a 0.73 score. Third document is having 0 score, and fourth document is having a 0 score. As simple as that. So top K means top 2 if I'm looking for. So top 1 will be this, and top 2 will be this. As simple as that. So in a complete formatted way, if I have to show you the response, so ranked is this one. So it is trying to give me the rank. I'm just trying to attach the thing. I'm just trying to GPify the rank. So rank for this line is this one, 2.82. Rank for second line is basically 0.73, and so on. And if I have to show you in a more beautiful manner, so maybe I can try to show you even over here. That okay. So with respect to the the query that I have asked, so the very first document is having 2.82. Second document is having a score is equal to 0.74. Third document is having a score is equal to 0. Fourth document is having a score is equals to 0. So this is how it is going to give our ranking. So rank 1, 2, 3, 4, and so on. Now, so let me change my query. So here AI assistance for a document retrieval. Let me check my corpus. So here I'm going to mention that URI will help me out. URI will help me out with my query. Now let's see. So what is the score that we are able to see? So score is 0.0000 for this entire one. Yeah, the score is going to be 0.00 for the entire one. Maybe I can try to pass URI helps in question using the context. So this is the query. Obviously, I'm going to get okay. So here the rank for this fourth document is 5.08, and for rest of the document it's going to be 0.0000. So the top K match is basically the fourth document, and in that way I'm able to get my result. As simple as that. So like I said, BM25 is going to help you out in terms of finding out, or in terms of ranking a document or the retrieval with respect to my query, and I believe we all are able to see the answer. Like I said, guys, so this is one of the approach, right? One of the approach. This is not the final one, by the way. This is not the ultimate one that we will end up using all the time, but this is one of the approach by which, yes, you all will be able to do the calculation, you all will be able to do the math, and you all will be able to do a ranking of your retrieved document or top K document. So with that, thank you so much everyone. Take care and see you again in my upcoming lecture. Okay guys, so welcome back to lecture once again, and in this lecture I'll be talking about how we can try to do a re-ranking. So in my previous lecture I have already talked about a ranking with the help of a BM25. You can try to use maybe some other technique to do a ranking, that's completely fine, but there is a concept called as re-ranking that we try to talk about with respect to a RAG operation. So first of all, we all have to understand that why do we talk about re-ranking and what is the advantage of this re-ranking. You will be able to see, because ranking anyhow we are doing it, right? So while retrieving the document with respect to my query, anyhow we are doing a ranking, and based on the rank, so it is going to give me the top K result or top K searches. So sometime what happens is that you have retrieved something which is maybe irrelevant, or maybe which is like a generic top chunks based on the query. That is the possibility, right? Because at the end of the day, if I'm trying to store a data into a Facebook AI similarity search, it is going to do a cosine similarity, right? So it's a vector to vector, basically like a distance or cosine it is going to check, and based on that it is going to give you the final outcome. Or maybe when you are trying to use a LLM, so you want to feed basically a best context, a best outcome. And this is where the concept of re-ranking comes into a picture. So I'll try to teach you this entire re-ranking concept in a complete practical manner. So let's start doing it. And here, so I will be using a heavily URI API, and I'll be using even a SDK, a URI SDK, by the way, for a LangChain. So first of all, you have to install a LangChain Facebook AI similarity search CPU request and NumPy. So this is something that you have to install, and not just that. So you have to install even a LangChain community. So just these two things you have to install. In my system, it's already installed, so I can simply go ahead and I can try to use it. That's completely fine. Now, so once we are able to do this installation, so we have to call a URI embedding. Now, URI embedding is already available, where we are giving you a text embedding 3 a small model from OpenAI itself at this particular endpoint. So this is a generic code, so which is where you are going to call this class, and then you will be able to generate the embedding. So nothing to understand in this one. More than hundreds of times we have used it, right? So this is my embedding class. That's completely fine from a URI, which is coming from the URI. Now let's try to do a main stuff over here. So here from a LangChain, I'm trying to import a Facebook AI similarity search, and then I'm trying to import a document. So here, this is my document. These are my data, by the way. So first data is URI provide AI API for a developer. Then LangChain integrates LLM with the tool, memory, and agents. The weather is sunny today. Facebook AI similarity search is used for a vector similarity search. URI embedding API returns a dense vector representation. So this is my raw document, and I'm trying to align it with respect to the LangChain compatible format. Simple, right? LangChain compatible format. That's the reason. So I'm using this document structure. Okay. Now I'm trying to call my URI embedding, the above class, right? URI embedding. I'm trying to pass the API key. So you can go ahead with the URI and you can generate the API key. I believe we all know how to generate the API key now. And then Facebook AI similarity search I'm trying to call, and I'm trying to pass my document. I'm trying to pass this entire document, and then I'm trying to pass the URI embedder. So this URI embedder, so it is going to basically store the document, and then I'm trying to call the retriever. So retrieve top 3. Simple. So it is going to call a URI API. It is going to convert my entire data as a embedding, and then eventually it is going to, it is going to like keep all this data into the vector space of Facebook AI similarity search. Simple. So this is again a simple operation that we have done. Now, so once we are able to do this, let's try to perform a query operation. So let's suppose if I'm trying to perform a query, what is the use of a URI in AI? So obviously it should give me a document, right? It should give me a document. It should give me the output basically based on my query. So it should give me the relevant document. And here, so if I'm going to show you the received document, so this is the document that it has given to me. So URI provide AI API for a developer, then this, and then this. So in this manner, it is going to give me the final output. But here you will see, so it is trying to do the ordering as per the similarity search, as per the matches. And it is trying to give me a document based on the similarity search, which I have basically asked for. So it is trying to give me a top 4 document, as we can see. Now, so we are able to see this document, but what I would like to do is that I would like to re-rank this document. So I just wanted to make this entire retrieval better and better before sending this document for a final query or the final result. I would like to re-rank it. Means this is the rank which I'm able to receive with respect to my query. That's completely fine. But how we can try to re-rank it, where I can try to say that try to take a relevancy score for this query with respect to this document, so that my entire data or my entire context, because this document is representing technically a context. So my entire context will be pretty much relevant, right? Pretty much relevant. So let me show you. So I'm going to use a URI basically for even a re-ranking over here. So let me show you this particular part, how we can try to do a re-ranking. So I have prepared a code for this one. Code is very simple. So we are trying to call a URI LangChain. So we already have a URI LangChain. If I would like to show you, so maybe I can go here and AI framework inside this LangChain view example, and we have this create a chat model. Means it will be able to generate the response. Simple. So this is something that we already have inside a URI with respect to the LangChain. Now what I can do, so I'm going to just call it, pass my URI API key, temperature, and a model. So this is my chat model object which I'm able to create. Now re-rank with the URI. So I'm trying to pass my query. I'm trying to pass my query that I have, this particular one. And then I'm trying to pass my document, right? I'm trying to pass my document. I'm trying to give a prompt that, okay, so rate the relevance 0 to 10 for this document. So whatever document which I'm going to pass with respect to the query, with respect to the original document, and answer only with the numbers. Okay, fine. So this is something that this re-ranker function is going to do. So it is going to help me out in terms of re-ranking the entire things. So here, if I'll try to call this one re-rank with URI, so here it is going to process it, and re-ranked docs, if I'm going to execute, it is going to give me the re-ranked docs. So now it has re-ranked the docs. Maybe it is going to be same, right? Because if my previous outcome was good, so obviously it is going to give me the exact same result. So this is my re-ranked docs. And then I'm going to create basically a context, and I will be looking for the final outcome. So here, let's try to create the final context with the re-ranked docs. So I'm not trying to pass the original docs which I have retrieved. So I'm just trying to pass a middleware in between, and I'm trying to say that try to do a re-ranking, and then once you are able to do a re-ranking, then consider that as a context, and then try to pass that context along with the query, so that I will be able to get the result. Now, the idea is very simple over here. The idea is to make my context even more stable, or you can say even more relevant with respect to my query. And that is the reason. So we are trying to call a re-ranking with respect to our URI. So we are trying to simply write a prompt, and we are going to ask that, okay, fine, re-rank it. Simple. Give a score, give a rank, right? Give a rank to this one. And based on the rank, so just I'm going to pass this re-ranked document in terms of building the context, and then this is a final context which I'm trying to give inside my LLM, and now LLM will be able to generate my final response, which will be pretty much relevant, more relevant I would say, as compared to a direct generation. So this is where, guys, re-ranking always comes into a picture. So where you are going to re-rank your entire retrieval, just try to make it more context familiar. You can try to remove all the irrelevant stuff that you are able to get in terms of document retrieval, and yeah, so your final generation is going to be better than before. And this is how we do a re-ranking. Yeah, so with that, thank you so much everyone, take care, and see you again in my upcoming lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about one of the amazing project, which is going to be a combination of RAG, LangChain, Hugging Face, Facebook AI Similarity Search, and many more things. So where it is going to take any number of document as an input, and you will be able to chat with all of these documents. So I'm trying to prepare this project with respect to medical use cases. So where you can try to pass basically a medical record of any number of patient, maybe hundreds of patient, maybe millions of patient. That's completely fine. And this chatbot in a real time is going to help you out with all of these documents. You don't have to open up and go through all of these documents. Maybe you can try to just ask that list all the patient from all the document, maybe like give me a detail about this particular patient or that particular patient, or maybe tell me what was the diagnosis which was mentioned inside that particular document, and maybe just you can ask that what is the cure, what is the solution for this patient, what is the recommendation for this patient. So each and everything this system is going to respond you back in a real time with respect to a UI. So it is going to be a proper chat system that we are going to see. So here, just to give you a little bit of glimpse, because once I'm going to show you the final execution, you will be able to see a real wow. But as of now, yeah, this is the BD Chat Pro, and on this side, I'm going to upload any number of a document that I want, and I will be able to chat with the system in a real time. That is a project which I'm going to show you. Now, so let me talk about a little bit of this architecture. So what we are going to do, so let's suppose I have n number of a document with me, so which is available as a PDF, right? So I have n number of a document. Now what I will do with this document, so I'm going to pass this document, I'm going to store this document, all of this document, I'm going to store it into a vector database called as Facebook AI Similarity Search. So FAISS. After converting, so first of all, I'll have to read. So I'll have to read all of this document. So let's suppose all of this document is available in a PDF format. So I'm going to use some of the PDF reader library, and after reading this entire PDF data, so maybe 1, 2, 3, 4, 5, or maybe n number of the data, after reading it, so I'll try to convert this entire data into a vector space, or we all understand that what is the meaning of vector. Now to convert this data into a vector space, I'm going to use a Hugging Face model. So one of the model from the Hugging Face, because Hugging Face is basically a complete repository for variety of the model, not just for the embedding, but yeah, for an embedding. So I'm going to use a Hugging Face model, and finally I will try to store all of those data into a Facebook AI Similarity Search database. Now, once I will be able to store this entire data into a Facebook AI Similarity Search, then what I will have to do after processing it, obviously, so I have to process all of those documents. Then what I'm going to do, so then I'm going to invoke my chat interface. So let's suppose this is my chat interface, and I'm going to just divide it. So here we can try to upload a document, we can try to process a document, and let's suppose here we have a chat interface, right? So we have a chat interface, so where I can try to like write my query that give me a detail about this patient, or give me a list of all the patient for which you have a data, for which you have a document, give me a cure about this, and it will end up generating all of these things over here in a real time. So in this particular place, what I'm going to do, so I'm going to use basically a LangChain. So LangChain over here. Why I'm going to use a LangChain? Because as we all know that LangChain is one of the popular framework by which you will be able to invoke an agents, right? You will be able to invoke an agent. You can try to pass a context. You can try to pass a query over here. So obviously I'm going to pass a query over here. It is going to bring a context from the uploaded document. And then my LLM, right? So my LLM, so technically URI API, URI LLM, which I'm going to use. Inside that we have a multiple model access. So with the help of LangChain, I'm going to invoke those LLMs. Inside that LLMs, I'm going to pass my context. I'm going to pass my query. And eventually it is going to give me a response in a real time. So the response I will be able to see in this particular interface. So response I will be able to see in this particular interface. And then in a later stage, obviously I can go ahead with the deployment. So I can try to Dockerize this entire solution. I can try to deploy this entire solution on a Streamlit cloud or in a multiple places. So here tech wise, so for a UI interface, I'm going to use Streamlit, and then database wise, vector database wise, so I'm going to use a Facebook AI Similarity Search database over here for a vector storage. Now, so to convert our data, right, to convert our data into an embeddings or into a vector, basically into that numbers, basically we are going to use one of the model from a Hugging Face we are going to use over here. Now So we are going to use a PDF library. So any of the PDF library we are going to use so that I will be able to read this entire PDF. So these are the things that we are going to use throughout the lecture. And then the fifth part is obviously I'm going to use a LangChain framework. And again, I'm going to use a LangChain framework, which will be compatible with the URI. So we already have like a SDK for that. So we are going to use that particular part. And the sixth, last but not the least, so we are going to use a complete URI API ecosystem. So whether we have to invoke a LLM model, so obviously I'm going to use a URI API, or whether I have to use a LangChain framework. So I'm going to use a URI API compatible LangChain framework over there. So that it is not going to give me any kind of an issue. And with the minimalistic code, I will be able to build this entire project. So code wise, like I said, it is going to be a super minimalistic, and anyone, even if you're coming from a background where you have just a basic understanding about the Python, you will be able to understand this project. You will be able to implement this particular project in a modular fashion. I have designed this entire project for all of you. So this project is not tough, but yeah, so it's very effective. Now in a later stage, you can try to modify this project for any kind of a use cases. So wherever you have to do a chatting with the millions of a document in your own domain. So as of now, I'm considering only a medical, but yeah, it's not specific to just a medical. You can try to use any document out there, and in a real time, you will be able to chat with this one. Even you can try to make it compatible with respect to an Excel sheet. So you can try to upload maybe a Excel, maybe a JSON, maybe a XML file, any kind of file that you want. You just have to add one more extension over there. That's it. So let's get started with this MediChat Pro solution, guys. And one by one, so we are going to build each and every solution for all of us. So first of all, try to open up a VS Code. That's a very first part. Now, once you are going to open up a VS Code, so let's try to create a fresh folder over here. So here I'm going to name it as a MediChat Pro. So MediChat Pro is a folder name. Now, so once I'm able to create this folder, now step by step, let's start building this entire project. But before that, let me even show you that how my PDF or how my sample document actually looks like. So I have prepared a couple of documents. So if I'm going to open up my document number 1, so this is how it will look like. So there is a patient, there is a age of this patient, there is a history of this patient, there is a allergies which is mentioned, and then medication which is mentioned, surgery which is mentioned, and notes which is mentioned, right? So likewise, I have a multiple document with me, and you will be able to chat with this document. So maybe you can try to mention more and more. That's completely fine. But yeah, these are the sample documents, 6 documents which I have prepared for this particular use cases. You can try to prepare maybe, or you can try to dump your own medical history, medical record, and you will be able to chat with this one. So these are the document that we have. So as I have shown you that we have a multiple PDF right over here. So yeah, we do have a multiple PDF available with me. Now, coming back to our VS Code. So here, first of all, we have to do a project setup. So unless and until we are not able to do a project setup, I will not be able to perform any of the operation. So here, first of all, I'll try to write a requirements requirements.txt file in this particular place. And inside this requirement.txt file, so we have to place all of these libraries. So Streamlit, FPDF, PyPDF, Facebook AI semantic search, Similarity search, LangChain, and URI AI. So URI AI you have to install. So these are the installation that we need. Yeah, these are the installation that we need inside this particular project. Now, how to do an installation? Very simple. So first of all, let's go ahead and let's try to create a separate environment, a complete separate virtual environment. Let's try to create it for this particular project only. So conda create -n and MediChat, right? So this is the environment which I'm going to create, and Python wise, just try to install Python 3.10. It's one of the stable one and the compatible one with all the library out there. Don't install a latest one. It is going to give you some sort of a issue. There is a chance, right? Maybe you will end up getting no issues, but there is a chance. So let's try to do the installation, and you all will enjoy this project. Don't believe me. So here, let's try to activate this environment. So once this MediChat environment is activated, clean my screen, and then just try to do pip install -r and then requirements.txt. Okay. So now it's installing all the libraries, including my URI AI, by the way. It will take a couple of minutes of time, depends upon my system and my internet speed, because it is supposed to download all the dependent libraries. Okay, so looks like all the installation is done. So whatever I have mentioned inside my requirement.txt file. So let's clean this screen and let's close it for now. Let's close even this one for now. And inside this MIDI chat, let's create a folder called as app. Without even folder, it's completely fine. But yeah, let's create it so that we can try to do this entire coding in a modular fashion. And let's try to create __init__dot.py file. Keep it blank, so that it will be able to recognize all the packages which I'm going to create inside this library. So let's close it. Yeah. Okay. Now, the very first thing that we have to write over here is config. So config dot py file. Why? So because I'm going to keep basically a URI API key inside this one. So I'm going to keep a URI API key inside this one. Now, how I will be able to get a URI API key? Now, to get a URI API key, you just have to go to a Euron platform, right? Now, come over here inside this URI API, as you can see, and we have used it multiple times, right? So URI API, and then there is an option called as URI API key. Now here in this option, I have created tons of APIs. I am going to create one more. So here for a MIDI chat. So let's try to create one API key. So within a fraction of a second, it is going to give you an API key, and one API key will give you an access of 25 plus model. So for an image model, or maybe an audio model, text to speech model, or maybe a chat completion model, maybe a stream model, for all of these model, it is going to give you the access. So let's copy this API key, and you can even track a users. So whatever users that you are going to do, so it will be able to track even that particular part. So here, just copy this URI API key, and let's keep it inside this configuration file. So whenever you are executing it, so please try to change this URI API key with your own API key. Then only it is going to work, because I'm going to delete my own API key. So just keep it as it is, config.py file, and leave it. Fine. So this step is done. Now what we are supposed to do. So let's start from the first step. So first we will try to read what? First we'll try to read the PDF file. So we have to write a code which will be able to read my PDF file. Just a raw PDF file, it is supposed to read out whatever PDF file which I am going to pass. So here I'm going to write, or I'm going to create a file called as PDF_utils, PDF_utils.py file. So let's try to create a PDF_utils.py file, and inside this, try to keep this simple code. What this code is trying to do. So this code is going to take an input as a file. PDF reader it is going to call, because PyPDF is something that we have already installed. In my requirement.txt, I had a PyPDF, right? So this is going to help me out in terms of reading out the PDF. So it is going to take an input of a file. So whatever file that you are going to input, and it is going to call a PDF reader from a PyPDF. And then one by one, page by page, it is going to read it out, and then it is going to return you the final text. So whatever data is available inside the PDF, so this is going to give you this PyPDF utils that I'm trying to create, this PDF utils. So this module is going to read the PDF. Very simple, right? Like I said, I'm going to write all the code into a modular fashion. So that you will be able to understand, and it will be maintainable. You can try to mention something in a later stage. If you have to enhance this module, you can try to enhance it, close it. So we are able to read a PDF file. So once we are able to read a PDF file, then what we are supposed to do? So then we are supposed to basically convert this PDF, after reading this PDF, convert this PDF into a vector, right? Into a vector, and then store it inside a Facebook AI Similarity Search database. This is the requirement. Yeah, this is the requirement. So, okay, coming to a step number 2, and let's try to create a file over here called as vector vector store vector store _utils.py file. So vector store utils.py file. Now what we are going to keep inside this one? So we are going to keep this particular piece of the code. Now what this piece of code is trying to do? It is trying to call LangChain community, and from there I am trying to invoke my Facebook AI Similarity Search database. Fine. Then the second one is, so I'm trying to use a Hugging Face embedding. You can go ahead and you can try to use even a URI embedding. We have an option, but I have already used URI embedding so many times. So in this project, I thought of using some of the open source model from a Hugging Face. So this is what I'm trying to do. So I'm trying to use a LangChain, and inside the LangChain, there is a library which will help me out in terms of loading all of those model. So here, Hugging Face, and I'm trying to provide a model name. This is one of the model name. Now, this is not the only model, by the way. You can try to use some other model as well for embedding, but yeah, I'm trying to use this particular model. And this one is going to help me out in terms of converting my data into an embeddings, into a vector space, a numerical data. And then here, so Facebook as similarity search from a text. So we are trying to populate the indexes. Indexes means we are trying to store the data. So this is what this function will do. A very simple function, plain and easy and quick, right? So we are trying to pass a text and we are trying to pass the generated embedding. So whatever embedding it is going to generate for the respective text. Now there is a second function. So this function will try to do what? So this function will help me out. So whenever I would like to retrieve a document. So let's suppose if I'm trying to fire some sort of a query, right? So whenever I'm going to fire some sort of a query, so it will look into a Facebook AI similarity search based on the similarity. So it will try to populate a context. Context means, so whatever data that we are going to store, it is going to fetch it. Means a document, it is going to fetch it based on the query. So whatever data will be similar to the query, so it is going to fetch a top K result. I believe I have already talked about that part in my previous lecture so many times. So this is what it is going to do. So top K. So top 3 a record, or top 3 most relevant record based on the query that we are going to pass. It will try to fetch it from a vector store, technically a Facebook AI similarity search. So this is what it is going to do. So storing and retrieving. So both part is done over here. Now, once this part is done, so once I'm able to store, and then based on my query, once I'm able to fetch it, again, easy peasy kind of a function, right? Very easy. So once I will be able to retrieve it, then what? Then what is next? So PDF. So till this point, we are able to complete it. So we are able to store our data into a Facebook AI similarity search, right? We are able to write the function for this one. Now, what is next step that we have to take, by the way? So the next step that we have to take in this particular place is this one. So there is something called as in a UI, right? So in a user interface, we have to give an option to upload a PDF over here. So we have to give an option so that people will be able to upload a PDF. So let's try to create a function for that one, so that in a Streamlit, people will be able to upload this particular PDF. So here to do that, I'm going to create UI.py file. So just a supporting function. And inside that, I'm going to keep a Streamlit function called as PDF uploader. So this will try to call file upload the file PDF, type is equal to PDF. You can try to allow multiple file type upload. That's completely fine. So this is going to help me out in terms of uploading the PDF. Once this PDF will be uploaded, and once this PDF will be processed, once this PDF will be uploaded and it will be processed. So we are going to give a process button over here. So once it will be processed means it is able to store the data into a Facebook AI similarity search vector database, right? Then what we have to do? So we can start writing a query. So we can start giving a query. Now this query will try to look into a vector database, and it will try to fetch the context. Context means a relevant document, a top K document. For example, in our cases, top 3 document with respect to the query, it will try to fetch. And here, so we are going to use what? We are going to use basically a LangChain. We are going to use what? We are going to use basically a LangChain, because we know that LangChain provides you an agentic approach. To do that, so we can try to create a function over here. Inside this folder, chat underscore UTI ls chat utils.py file. Okay, chat utils.py file. Now what we are going to keep inside this one? So here, let's go back once again to a URI. So here inside a URI, if you will come, Euron and then URI API. And once you are going to click on AI framework, right? Click on AI framework. So you will be able to find out all the compatible AI frameworks. So we have already built the SDK. you can try to use any framework in this world, right? Because we have like given you the URL and we have given you the authentication for that, a key for that. But we have built our own SDK, URI SDK, URI AI SDK, you can say. So which is going to make your life even more simpler and even more easier. So without writing much of code or copy pasting much of code, you will be able to invoke LLMs. You will be able to invoke a LangChain. So for LangChain inside a URI AI, there is a create chat model. So which is going to invoke a LangChain automatically, right? Which is going to invoke a LangChain and you will be able to use a LangChain to chat. You can try to provide the context or prompt, whatever you want, and you will be able to chat. So in this way, with the help of URI AI, you will be able to use a LangChain. So let's do it. Let's do it, right? So here I'm going to invoke, let me explain you this part. So URI AI, and from there I'm trying to invoke a LangChain, and here, so this is going to give me a get chat model. So here I'm just trying to use a create chat model. It is going to return a create chat model from a LangChain, right? So where it will take a API key, which I'm trying to read. It is going to take a model I can try to change. So if I don't want this GPT 4.1 nano, I have 25, or for a text generation, at least I have a 20 plus model access, right? I have a 20 plus model access. I can try to use it. I can try to control the temperature. So this is going to invoke a LangChain chat module in a precise way. And then it is going to ask a chat model, and this one is going to give you the response as a content. So based on the chat model is coming from, means this is the object of the LangChain. This is going to return the object of the LangChain, which will come over here, and then eventually you will try to pass the prompt and it is going to give you the response in an agentic way, right? It will try to take the decision and it will try to give you the final output. So this is where this LangChain comes into a picture. So now if I'll come back to my picture, so here is my LangChain, and so LangChain I'm able to integrate. Now, so coming to the final part. So all these supporting files are available to me. Now coming to a main part, by the way. So coming to a main part, by the way, when I'm able to create all the supporting things. Let me keep config.py into an app. Yeah. So now coming to the supporting part. So supporting part is done. So coming to the main part. So let's try to create a main.py file. So where I'm going to keep the entire UI interface. The UI interface that I have already discussed. So this particular part, call everything. So call this, everything. Just try to call it inside one single file, and let's try to build the final project, right? Let's try to build the final project. So here, first of all, I'm going to do the import of all of these required libraries. So as you can see, I'm trying to import a PDF loader, extract text from PDF. I'm trying to store this, create fast indexes, retrieve relevant document, get chat model, ask chat model, and from the config, I'm trying to import even a URI API key. And here, so text splitter, so recursive character text splitter, and import time. So all of these things I'm trying to import in my main file. Now, once I'm able to import, let's try to create a page layout. So page layout. So page layout is nothing but this page layout, which I have shown you in a beginning itself. So this is the page layout which I'm trying to create. This is the page layout. So on my left hand side, document upload, and then here is a chat window for me. So I'll just try to create this particular layout out of this entire things. So medical chat pro, medical document assistance, and page icon I'm trying to give. Layout is wide, and then initial sidebar is going to be the expanded one. Okay, that's cool. Now, once this is done, so let's try to put some sort of a CSS over here. So CSS is going to help me out in terms of beautifying the entire project. So this is just a color theme and button, and then background color, foreground color, all those things I'm trying to set up over here. Nothing much. Yeah, nothing much. Now, after this, so let's try to initialize the session state. So this is again like something which I'm doing in terms of building the final application, a final app, by the way. So here I'm trying to say that, okay, so if message is not in session, then return me the empty one. If vector store is not in the session state, then return the none. If chat model is not available, return the none. So just I'm trying to give a checkpoint over here, nothing much. So once this is done, now let me load a complete project in one go. And like I said, this project is not at all difficult. It's a very, very easy one. for any one of us, by the way. Yeah. So now let me explain you that how this project is going to work. So see guys, in a sidebar, So in a sidebar, I'm going to give you an option to upload a PDF, as well as I'm going to give you an option to process the PDF as per my image. So this is my image. So upload PDF option I'm going to give you. So this option for upload PDF, and this one for process PDF. Process means convert all the data into a vector space or store it into a Facebook AI similarity search database, a vector database, right? So upload means just upload the simple plain PDF, whatever PDF that you have, whatever data that you have in one go. So in a sidebar, these are the two options which I'm going to give it to you. Now, so this is what we are trying to call. So upload a file and extract text from the PDF. And this function we have already discussed, right? So this function is already here, a simple function, right? Which is going to extract all the data. Now, once we are going to do that, right? So we are going to split those data into a chunks, as you can see. And after doing that, so we are trying to call a create Facebook AI similarity search indexes. So in a vector space, it is going to store this entire data into the entire data. So it is going to store this data. And then we are trying to initialize a chat model with the help of URI API Key. So where it is going to invoke my LangChain. And with the help of that, I will be able to chat. So this is one part for one sidebar. Fine. Now, when I will start chatting, so it is going to show me that ask about a medical document, and then I will start chatting by passing a prompt. So role is going to be the user, and then I'm going to pass a prompt, and it is going to take a timestamp automatically from the current time. It is going to take the timestamp. And then it is going to, I'm just trying to show you even a user message. So this is something which is going to show you a user message into a chat window, by the way, into a chat window. And main thing, it is going to do it in just a couple of steps. So whenever I'm going to pass my data, I'm going to pass my prompt. So it is going to call retrieve relevant document. So based on my prompt, based on my query, so it is going to retrieve a top K result from where? From a vector DB. So as per this image, whenever I'm going to give a prompt over here, so this will try to retrieve a data, a top K data from this particular vector space. It will try to retrieve those data. So here, this is something which it is trying to do. So it will try to retrieve the data. So once it is able to retrieve the document, we are trying to build a context. Context means whatever document that it has retrieved based on that. And then we are trying to pass this context into my prompt. This is my final prompt, which will go inside the LangChain. So we are trying to pass the context and we are trying to pass the prompt. So whatever prompt that you have inserted, whatever like a question that you have asked, so it will try to go over there. So by building a complete system prompt. So in a system prompt, we have a context, we have a prompt, plus we have an instruction that you are a MediChat Pro, an intelligent medical document assistance based on the following medical document, provide the accurate and helpful answer. If the information is not available in a document, clearly state that. You can try to change your instruction. That's completely fine. But this is the final prompt. This is the final prompt that we are building. And we are trying to send this prompt inside ask chat model, which is going to invoke what? Internally, chat model. Chat model is what? A LangChain. It is trying to invoke internally. And it is going to give you a response. So when it is going to give you a response, I'm just trying to append those into a current session. So current Streamlit session, chat session. And I'm just trying to show you those responses. That's it. Yeah, that's it. So this is something that I'm trying to do over here. Okay, so that's cool. Now let's go ahead and let's try to execute this project and let's see that whether this project is working or not. But like I said, this project is going to be easy, but it's going to be a lethal and very much effective for all of us. So to execute this project, what I can do, I can try to call a Streamlit run, and then I can try to call main.py file. Click on this allow. And it is telling me that module not found LangChain community. Okay, no issue. I forgot to mention this LangChain community. And let me terminate this part. Yeah, so let me close this. Let me close this. And here, so pip install LangChain community. in this environment. And I have already mentioned that LangChain community inside my requirement.txt file as well. So LangChain community is installed. Now execute the same thing once again, Streamlit run main.py. And yeah, so this is the interface that I'm able to see, powered by URI AI and LangChain medical document intelligence. And now I can try to, right? Now I can try to browse my file. So let's try to browse my file. So I have 6 files over here. In one single go, I'll try to select all the file and dump it. So 6 document uploaded. It is showing me 6 document uploaded, as you can see, 654 and then 321. So 6 document has been uploaded over here. Now I can try to click on process the document. So now again, I have received issue, could not import a sentence transformer package. Please install with the pip install sentence transformer. So even this package was missing. Okay, so let me terminate this part. Okay, and now let's try to do a pip install sentence transformer and mention this one into a requirement.txt so that it will help me out in terms of deployment. Just install. It will take maybe a couple of seconds for me. Okay, so looks like it's done. Clean it and again rerun your application. So again, try to upload all the document, open, and then process the document. And this time, hopefully it should not give me any kind of a issue. And it looks like it's trying to process my document. Yeah. Which looks amazing to me. So we have like a 6 document. Even if I have a thousands of document, it's just a matter of my resources. I can try to execute it. Yeah, so document processed successfully and balloon, like bingo, things I'm able to get it, right? So document is processed with the help of this particular Hugging Face embedding model. I can try to use even a URI embedding, but like I said, I have already used a URI embedding multiple times. So that's the reason I thought of showing you some different approach in this one. URI embedding is also an easy approach. Now I can start chatting with my chat bot. So I can say that give me a name of all the patients. Yeah. So just see the name of all the patient is John Doe, Carlos Montes, John Smith. Okay. So what was a age of Jane Smith? Yeah. So Jane Smith was 60-year-old. Now I can go ahead and I can try to check that whether my, let me, so it's available here. So I can go ahead and I can try to cross check. So here John Doe and then John Smith, and age is basically 60 year, as you can see, right? And correctly it is able to identify. So in a correct manner it is able to identify. So what was a surgery? What kind of surgery he has gone through? So based on the provided medication, John Doe has undergo the, okay, so I have not added a memory over here. So basically I have to give a name. So Jane Smith. If I'm going to give a memory, so in that case, it will be able to remember. So John Smith underwent a left knee replacement surgery in 2020. I can go ahead and I can try to cross check. So he has gone through a left knee replacement in 2020. So yes, it is able to retrieve the data, right? Now tell me about Priya Patel. Yeah. So here, this is Priya Patel is 40-year-old female with a medical history. This. So yes, it is able to give me the response. Maybe I can try to ask a question with respect to some other document. So Carlos, C-A-R-L-O-S, Carlos. So what was an issue Carlos was facing, right? Based on the medical document provided, there is no information indicating that Carlos was facing any specific issue beyond his known health condition. He was a chronic kidney disease stage through. Okay, so yeah, it is able to fetch the detail, and maybe I can say that suggest me some maybe like advice. Give me some advice for Carlos, basically. So yeah, so it is able to give some sort of advice as well. So like I said, this project is an amazing one, and you can keep on chatting with this one. You can try to add a memory as a next step, which is again adding one single line of a code so that it will be able to remember a previous chat as well. And you can try to upload thousands and thousands of documents, and you don't have to go through all the document, just chat, and then it is going to give you the responses. So this is how effective this entire project is. So hope all of you have liked this particular project. In our next step, so I'm going to show you how to do a deployment of the same project inside a Streamlit cloud. So with that, thank you so much everyone. Take care and see you again. Okay, so now as we are able to build this entire project, so now let's talk about the deployment. So to do a deployment, first of all, you have to push your entire code base into a GitHub repository. And once you will be able to push your entire code base into a GitHub repository, then obviously you can do a deployment. Now to push any code base into a GitHub repository, I believe we all are aware about things. So let me do one thing. So let me go to my GitHub and then try to create a repository, a new repository, a brand new. So here I'm going to create a repository called as medichat underscore pro. So this is the repository which I'm going to create, and click on create a repository. Now once this is done, so I can try to call get init. I have already actually pushed it, so I'm going to show you the steps once again. So get init, so get init, and then like you can try to do get add, and then you can try to do get commit with a message. So medichat pro code first time. And once you are going to do that, then get branch -main, right? And then after that, so you have to basically add your current branch. So I have already added the branch, so that's the reason it is going to tell me that the branch origin, some of the branch is already added. So I have to basically remove this particular branch, and then I have to add the new one. I have already added. So technically I have to do basically get remote remove origin. Sorry, my bad. Okay, so origin, and then try to add a new origin. So try to add a new branch over here. So now it will work. And then try to push your entire code base inside this one. So let's push this entire code base inside this one. So okay, I'm able to push the entire code into my GitHub repository, and I believe we have done this process again hundreds of times in my past. Now if I'm going to refresh it, so the entire code will be available here. As you can see, entire code is available over here. Now what I'm supposed to do, so I can try to go to Google, and then I can try to like call Streamlit Cloud, Community Cloud, and then here, so I can try to click on free. I'm looking for a free deployment, And here, so there is an option after login called as create app. So click on create app, deploy a public app from GitHub, click over here. And then from here, so you can try to search your GitHub repo. So MediChat Pro is my GitHub repo. Branch is main, master, that's completely fine. Advanced setting wise, I can try to change if I want. Python version wise, let's suppose if I'm looking for 3.10, I can try to select this part, click on save. And then there is a main.py. So my file name is basically main.py file. So this is the file which is available, main.py file, which is the main file for me. So I'm going to select that main file and then click on deploy. If everything is going to work fine, then this will be deployed and I will be able to, test the entire application. So just wait for a couple of minutes so that Streamlit will be able to deploy it. It will not take more than like a 2 minutes of time. So my app is in oven. It's trying to cook my entire app. Okay, so looks like my app has been deployed and this is the public URL as you can see. And yeah, so I'm able to get a proper interface, browse the file, upload all of these files, and then try to click on process document. And yeah, so it has started processing my document, by the way. Okay, so it seems my document processing is done. And now I can start chatting, right? I can start chatting with this one. So here, tell me a medical history of John Doe. So searching my document and within a fraction of a second, it should give me the output. Okay, so John Doe is 45-year-old male and any recommendation for John Doe. So I can simply chat, right? And yeah, so things are working pretty much fine for me and it is able to give me all these things. The way it was working in my local system, so in the similar manner, it is working even over here and it is able to give me all the responses the way I was expecting. So hope all of you will enjoy this project. So where we have used multiple things, not just one thing, but multiple things, and each and everything we are able to achieve with the help of this particular project. So with that, thank you so much everyone. Take care and see you again in my upcoming lecture. Okay, so welcome to Euron everyone. Now in this lecture, I'm going to talk about again another amazing project. A simple one, but yes, amazing project. So where you will be able to pass any kind of a CSV with the data, or maybe you can try to pass any kind of a URL which you can try to scrap, and then you will be able to call your LangGraph agent, and with the help of that you will be able to ask any kind of a question with respect to your CSV data, or with respect to the URL that you are trying to scrap. So let's try to understand this project, guys. So here we are going to start the project. So basically this is going to be a chatbot with a CSV capability and a URL. So you can try to pass a CSV, or you can try to pass a website URL, and you will be able to chat it. So here how this flow is going to work. So let's suppose I have a simple interface. Now in this interface, you can try to pass basically a CSV record. So CSV record, or you can try to pass a website URL that you would like to scrap. And here, so it is going to fetch all of this data. And after fetching this data, so as a user, you will be able to chat with it. So as a user, you will be able to chat with this particular data set. And in a backend, what it is going to do, so basically it is going to invoke a agent from a LangGraph, and basically what this LangGraph is going to do, so this is a single node system, so which is going to, so there will be a single node inside a LangGraph, because as we know that LangGraph always try to works with respect to a nodes. So single node LangGraph we are going to create, and this agent, this single node agent is going to understand this particular data, and then it is going to answer all the user query. And UI wise, so we are going to use a Streamlit over here. So it's a basic project, but again, it is going to give you a lot of understanding with respect to a RAG, with respect to a LangGraph, and whatever we have discussed in a past, you will be able to like relate it, and you will be able to build this entire things. So let me open up a VS Code in a very first place. And after opening up a VS Code, so let's try to create a folder. So here I'm going to create a folder chatbot with a CSV and a URL. Fine, CSV and a URL. Now, so a very first thing that we'll have to do is that we have to create a requirement.txt file, requirements requirements.txt file over here. And inside that, let's try to keep all the requirements. So here I'm going to use a URI API. So an URI API, and especially I'm going to use a LangGraph a framework over here inside a URI AI. So we are trying to keep a URI AI over here, Streamlit over here, a beautiful soap, so that I can try to scrap a data, and then I can try to beautify it, and then eventually a LangGraph to create an agent. So this is something which I'm going to keep. And then let's try to create an environment over here. So let me open up my command prompt, and here so I'm going to create a conda create -n lang chat bot. So lang underscore chat underscore bot, and then Python version is equals to 3.10, install each and everything. Fine. So let's hit enter, and let's see. Conda create -n conda create -n, and then this is the name, Python 3.10. I think I have not made any kind of a mistake. Okay, so now it's working. Fine. So it has created an environment for me, as we can see, and let me activate this environment. So this environment LangChain has been activated. Clean the environment, and then try to do pip install -r requirements.txt, and whatever I have mentioned inside my requirement.txt, it is going to install each and everything. Okay, so everything is installed, and now let's go ahead and let's try to create a very first file called as backend file. So where we are going to keep a backend logic, backend.py file. And in this file, so I'm going to keep all of my backend logic, by the way. So here, step by step, let me explain you the code base that what we are trying to do. So first of all, we are trying to do all the import, and especially this import is required. So URI lang graph. So if you'll go inside a URI API system, so let me give you a walkthrough of that. So Euron, and inside that, if you'll go inside the URI API system, and if you'll go inside the AI framework, you will be able to find out a lang graph. Now we are trying to use this particular part, so that I will be able to create a agent, one single agent with respect to a lang graph. And for that, so you need a URI lang graph installation, which we have already done, and we are able to import this one. Then you have to keep a URI API key. So how you will be able to create a URI API key? It's again very simple. So go to a URI API key, and then here, so create API, give any kind of a name, and then it will be able to create a API key for you. And just try to keep this API key over here. So you have to create your own API key, by the way, because this API key will be deactivated. And with the help of this one, so we are trying to create an instance of a lang graph. So we are trying to create an object of the lang graph where we can try to pass a URI API key, and then we can try to pass a model. Model wise, we can try to pass not just this model, we can try to pass any number of a model that we want. Now, so the very first part is that we can try to ingest a CSV. So here we have written a function, so which will try to accept a CSV, and I'm using a pandas over here, so that it will be able to perform a read operation. Yeah, so that it will be able to perform the read operation. In my requirement.txt file, let me mention pandas as well, because in my base environment it's installed, but when we are trying to do a deployment, it may give you an issue. So I'm keeping a pandas over here. Okay, so this will try to read the CSV file if there is a CSV file you are going to pass, and this is going to, so whatever URL you are going to pass, so with the help of a beautiful soap, so basically it is going to read that URL, and it is going to parse that HTML with the help of a beautiful soap, and it is going to return all the data which is available inside the URL. So this is something that will help me out in terms of reading out the website, if website is crawlable. If not, then obviously it is going to give you an issue. Then in a third part, so we are trying to create a lang graph object, and with the help of lang graph object, we are trying to create a AI node, so which will try to take any kind of a query, and based on the query that you are going to pass, and based on the data that you are going to pass, so it will try to process it with the help of a LLMs, basically. Yeah, with the help of LLM, it is going to parse it. So this is my backend file, which is a very, very simple one. Now the second file that I have to create over here is called as app.py file. So app.py file, so where I'm going to keep all the code, all the logic with respect to my Streamlit. So here, if you will look into this code, so majorly this code is filled with all the UI part, so you don't have to worry about that part basically. So here we are trying to create a page title called as document chat, layout is equal to centered, and then this is just for the beautification. This part is just for the beautification, and this is my title which I'm trying to give for a chatbot. And here, so in a side tab, you will be able to find out a data ingestion tab. So you can try to ingest your CSV file with this one, or you can try to enter a website URL. So whatever suits you, you will be able to put all of these things. So these two things basically. So either CSV or maybe a URL. So both of these things you will be able to update it, right? And same will be updated inside the session itself. Now, so once you will be able to like upload a file. So let's suppose if I'm uploading a file over here, so it is going to call my to CSV, and it is going to read this entire CSV file. And then it will try to detect a shape and the column, and then it is going to give you the preview after uploading the file, and it is going to tell you that CSV file uploaded, and basically it's been indexed successfully. If you are going to enter a URL, right? If you are going to enter a URL, so it is going to call a crawl website function from this backend, crawl website function, and then it is going to crawl this entire website. It is going to hold all the data, all the information, and then it is going to show you a message that website crawl and index successfully. So in this way, you will be able to ingest your CSV as well as you will be able to ingest your URL. Now coming to the final part basically, so where it will try to respond back with the chat that you have basically. So here, just to respond back with your chat, so we are trying to maintain a session over here so that it will be able to remember each and everything. that you are going to pass, and then what it will do, so then it will try to call basically your graph. So the graph or index data that we are trying to keep over here, so it is going to call the index data, it is going to pass your index data, and after passing your index data, so it is going to give you the final response. So let's try to understand this index data type part. So as you can see over here that whatever chat input that you are going to give, so it will go inside the index data with the content. So with the content that you have uploaded, and obviously it is going to invoke the LLM access. And once it is going to invoke a LLM access, so basically what it will do, so it will try to give an answer based on the node that we have created, a lang graph node, because that lang graph node will be having a data access as well as it will be having basically a query access basically. So both of these things we are trying to pass inside my like a chat window. So now let's try to execute it. This project is very simple, by the way. This is literally a very simple project, and it is going to give me an AI response, and same response I am going to showcase. So let me execute this entire project. To execute this entire project, I just have to do Streamlit, S-T-R-E-A-M-L-I-T, Streamlit, run, and then I can try to give app.py file name. So it is going to ask me for allow, and once I'm going to allow, so now I'm able to see this kind of a interface. Now in this interface, I can try to upload a CSV, or I can try to basically pass a website URL. So website URL wise, let me pass one of the website URL which I have already selected for this particular session. So this is basically a NBA football website, and what we are going to do, so maybe I can try to click on any of this link, and maybe I can try to copy this particular link, and I can try to pass this particular link over here, right? I can try to pass my link over here, and once I'm going to pass this particular link in this particular place, so it will start crawling data, and it is telling me that there is some issue. HTTPS connection object failed to resolve as sportingnews.com, sportingnews.com. Okay, so let me check with the URL. Maybe I can try to use this URL. And yeah, so it is able to fetch some sort of a record from this URL. Now, if I'm going to ask that, give me a summary of this data. So my AI will work, and max retries. Let me try once again, because I have used my URI API so many times. So now AI is typing, and here, so it is going to give me a summary. So if I'm going to ask that, give me a summary in point wise manner. So let's see, so whether it is able to give me a summary in a point wise manner or not. So yeah, it is able to give me a summary in a point wise manner. So technically it is able to scrap all the data, and it is able to give me a summary in a point wise manner. So it's working fine for me, right? So it is able to scrap the website. I'm able to see the scrapped data over here, and I can do whatever I want with this data. And then on top of this, I'm able to ask any kind of a question. And here, technically, my LangGraph agent, which is a single node agent I have created, which is having access of AI, it is working for me. Apart from that, so I can try to click on browse file, and I can try to upload some of the file, and it is going to give me like a result. So let's see. So here I have just uploaded this particular file. Yeah, this particular file, and we have basically 92 records inside this file, 12 column we have. So it is showing me a CSV shape, and then it is showing me this particular data set as well. Now, if I'm going to ask a question that give me a summary of CSV data that I have passed in point wise manner. So now let's see. So my AI is started working, and it should give me some response. A good one, by the way. So yeah, it is able to give me a response. Total entry is equal to 92 record. Custom ID range is from this to this. Customer name is basically this one. Contact name, phone number, address, city. So yeah, my AI is working perfectly well, and I'm able to test it with respect to my URL as well as with respect to my CSV data. So pretty much amazing, right? Pretty much amazing. Just with the help of a natural language, I'm able to do my job, I'm able to do my work. Okay, so this actually looks cool to me, right? This actually looks cool to me. Now let's suppose if I have to deploy this solution, so how I will be able to deploy it? To deploy this solution, first of all, I have to push my entire code inside a GitHub repository. So once I will be able to push this code inside the GitHub repository, then obviously I will be able to deploy it. So let me open up my GitHub, and inside GitHub, I'll go to my repository and I'll try to create a new repository, lang graph chat. So this is the repository I'm going to create. Now, so I have to push my code inside this particular repository. So let's do it. Let me terminate this one. I think we have already tested it. Okay. Clean the screen and then just do git init. So initialize it. And then I can write git add and then dot, then git commit -m message and lang graph chat bot with CSV and URL. Okay, fine. So it's added, and then what we can do, so then we can try to call git branch -main. So this is done. Then we can try to add this remote URL, so where I'm going to push my code. So it's done. And the final step, right? So where I can try to push the code, a final code basically. So, okay, push the code. Okay, all well. And now I will be able to see my code here. So now I'm able to see my app.py, backend.py and requirement.txt over here. Now I can try to call my Streamlit cloud, and once after a login, so let me click on this free, and yeah, so here I can see an option called as create app. So click on this create app, deploy from a public app GitHub. Okay, and then try to search for your repo. So lang graph chat, this is the repo, branch main, and my app name is basically app.py. Yeah, app.py. So this is my app.py, which is a Streamlit file which I have created. So app.py. Advanced settings, so I can try to select a Python version. So maybe I can go ahead with the 3.10 and click on save and then click on deploy. So once I'm going to click on deploy, it will take a couple of minutes of time, maybe 2-3 minutes of time for deployment, because it is going to install all the dependencies, whatever I have mentioned inside my requirement.txt file, and then eventually it is going to deploy it. Yeah, and we'll be able to see a public live link for this particular project. This project was small, but again, you will be able to learn a lang graph. I have already taught you lang graph in my a previous lecture. So you will be able to see that anyhow. So yeah, my everything is live, and now let's try to test it. So here I'm going to pass the URL. Let's see so whether it is able to fetch data or not. So yeah, it is able to fetch the data. Now I'm going to ask you that pointer wise, give me all the highlights, and my AI started working. Basically, it's a URI AI with respect to a lang graph. It is working, and point wise, it is able to give me a summary. So looks cool to me, right? Looks cool to me. I can try to browse a file. I can try to upload a file over here. Maybe this time sales data I can try to pass in this place, and I can see my sales data over here, right? I can see the sales data. Now I can ask a question that give me all the column name from this data. So let's see. So yes, it is able to fetch all the column name which was available in my data set. Show me 5 sample record. Sample record. Too much of use. Again, Let me ask the same question. It's failing from a URI, and I think I have exhausted my. Okay, so maybe I'll just have to change my URI API because it was working here, right? It was able to fetch the data, so there is nothing wrong. But yeah, so it will work. It will work um, in some time. So yeah, now it looks like no. 403 client error. Summary of record. Okay, so I'm getting this error because my daily token limit has exhausted. So whatever token quota that I have for today, so I have already like surpassed that quota, and because of that, so it is giving me that issue. There is no other issue, by the way. Yeah. So if you have a token limit, obviously you all will be able to use it, and you can check your uses by coming into the users tab as well. Otherwise, obviously, it is going to work for me. So hope all of you are going to like this project. All of you are going to build this project. And yes, please try to use your own URI API key so that it is going to work. And if you're going to exhaust the quota limit, then you need a different account. As simple as that. So with that, thank you so much, everyone. Take care and see you again in my upcoming lecture.